Greetings to both new and returning IT enthusiasts. Certification Cynergy is excited to introduce yet another comprehensive IT training course just for you. Whether you are continuing with us after moving on from our CompTIA A Plus Core 1 training, or you are discovering us for the first time, welcome to Certification Cynergy. By clicking on this video, you've unlocked access to our complete CompTIA A Plus Core 2 training course. And the best part? It's absolutely free. That's right. This full-length course won't cost you a dime. No hidden fees, no additional content charges, just pure, focused knowledge designed to prepare you thoroughly for the CompTIA A Plus Core 2 certification exam. With that in mind, we're thrilled that you've chosen us to be your guide as you prepare for the CompTIA A Plus Core 2 certification exam. We truly appreciate the chance to share our expertise with you. And just to reiterate, in case you missed it earlier, this comprehensive training course is entirely free and self-paced, available for everyone's benefit. So what makes Certification Cynergy the best IT training in town? Easy. Besides our strategic and orderly presentation of exam topics, we make learning feel like a walk in the park. You can expect to learn from vivid, comprehensible video segments, all seasoned with a dash of humor, to keep the experience lively. This course isn't just a learning pathway, it's a guided experience. If you are still listening, it is now time to get down to business and discuss what this certification is all about. Now we will explore what makes an ideal candidate for the CompTIA A Plus certification and this training course. This certification is for entry-level problem solvers and innovative thinkers. If you have a solid grasp of IT basics, presumably from the CompTIA Tech Plus certification, and a zest for turning technological puzzles into triumphs, this is your call to action. The A Plus journey welcomes those who are ready and willing to bridge the gap between users and the magic of tech. Whether you're dreaming of being the tech wizard everyone relies on, or you envision a future crafting cutting-edge solutions, the CompTIA A Plus certification is the logical next step following the Foundational Tech Plus certification. So how do you become CompTIA A Plus certified? It is important to know that this widely recognized credential requires you to successfully pass two separate exams, known as the Core 1 and the Core 2 exams. Each of these exams dives into distinct yet complementary domains of IT knowledge. Core 1 focuses on the essentials of hardware and networking, while Core 2 dives deeper into operating systems, security, and operational procedures. Together, these exams validate the dual spectrum of practical and theoretical expertise that is essential for entry-level IT professionals. Achieving a passing score on both exams is a necessary component to obtaining the CompTIA A Plus certification. As for this course, I will be covering every topic needed to pass the Core 2 part of this two-headed certification beast. Taking a step back, let's understand the overall path to IT foundational mastery. If you are here, ideally you have earned your CompTIA Tech Plus certification, or you have at least acquired comparable foundational IT skills, priming you for this A Plus Core 2 course. As your guide and educator for this leg of the journey, I will help you build upon your already strong foundational knowledge, equipping you with the expertise needed to tackle and succeed in subsequent certifications, such as the CompTIA Network Plus and the CompTIA Security Plus. This course is designed to be a stepping stone, helping you to grow, while progressively expanding on your IT capabilities. Next, you need to know what IT concepts will be taught in this course. The CompTIA A Plus Core 2 certification exam focuses on the essential IT skills and knowledge needed to complete tasks commonly performed by entry-level IT professionals. To pass, you will need to have the knowledge and skills required to understand operating systems, security concepts, software applications, and operational procedures. Additionally, this exam will assess your knowledge of troubleshooting scenarios related to these topics. Moving on with our introduction, we come to the exam details. The current version of the CompTIA A Plus Core 2 exam, officially known as 220-1202, was released on March of 2025. This version reflects the most up-to-date expectations for entry-level IT professionals, so everything you'll be learning in this course is aligned with the skills the industry values today. When you sit for the exam, you will be presented with up to 90 multiple-choice questions, along with a few performance-based questions, lovingly referred to as PBQs. You will have a total of 90 minutes to complete the test, which means time management will be important. The passing score is 700, and the exam is scored on a scale that goes all the way up to 900. Now, the scoring system for the CompTIA A Plus Core 2 exam might seem a little confusing at first, especially since it's based on a scale that goes up to 900. So, to make things clearer, here is a helpful breakdown we use at Certification Cynergy. If your score falls below 500, it simply means you need a bit more time with the material, and that's okay. Everyone starts somewhere, and progress is part of the process. If you score between 500 and 699, you're getting really close. A few more focused study sessions, and you'll be ready to go. If you score between 700 and 749, congratulations! That means you've officially passed your CompTIA A Plus Core 2 exam. If you land in the 750 to 799 range, it shows that you've mastered most of the material and really know your stuff. And if you score 800 or higher, well, you didn't just pass. You crushed it. And finally, if you happen to earn a perfect 900, contact us immediately. We want to hire you. Just kidding. But in all seriousness, be proud. Even seasoned IT professionals rarely achieve a perfect score. Next, here is something every test taker should know. And trust me, it's a game changer. When it comes to preparing for your A Plus Core 2 exam, the CompTIA exam objectives are your absolute best friend. This document is not just a general overview, it's a detailed guide that outlines everything you need to know before exam day. It breaks down how many questions to expect, what types of questions you'll see, like multiple choice, and most importantly, the exact topics you're expected to understand. Think of it like your official study roadmap. It tells you what to focus on, how the content is organized, and where to spend your time. It's almost like having a cheat sheet, but completely legal, because it comes straight from CompTIA themselves. Many students skip over this resource, but those who take the time to review it carefully usually feel much more confident walking into the exam. So don't treat it like optional reading, treat it like your secret weapon for passing. According to the exam objectives I just mentioned, the A Plus Core 2 exam is structured around 4 core domains, each representing a major area of knowledge that you'll need to understand. These domains aren't just random categories, they help shape the exam itself. Each one is assigned a specific percentage, which tells you how much of the exam is focused on that area. For example, operating systems makes up 28% of the A Plus Core 2 exam. Next, we have security, which makes up another 28%. Then there is software troubleshooting, which makes up 23%. And finally, we have operational procedures, which consists of the last 21%. Together, these 4 domains give you a complete picture of what to expect, and knowing how they're weighted can help you study smarter, not harder. Once you're familiar with the 4 A Plus Core 2 exam domains, the next step is to understand how each domain is organized. Every domain is broken down into exam objectives, and these objectives outline the specific knowledge and skills you're expected to master. Think of the domains as chapters, and the objectives as the lessons inside each chapter. Let's look at Domain 1 as an example. This domain is labeled Operating Systems, and it kicks off with Objective 1.1, Explain common operating system types and their purposes. Within this objective, we have a series of key ideas, or topics. Now, if any of these topics feel unfamiliar, don't worry. That's exactly why this course exists. We will take our time walking through each topic in a way that's clear, approachable, and focused on your success. So, why are we putting so much emphasis on the exam objectives before getting into the technical topics? Because they truly matter. They're one of the most valuable tools you have when preparing for the CompTIA A Plus Core 2 exam. While they're often overlooked, the exam objectives provide the clearest and most direct path to success. They outline exactly what you need to know, so you're not wasting time guessing what might be on the test. You can use them to guide your study as you move through the course, and once you've finished, come back to them as a final checklist. A last-minute review of the objectives can help you focus your thoughts and spot any weak areas before test day. To help you get started, you can download the official exam objectives using the link we provided in the video description below. Now, here's how to get the most out of this course. Watch each video segment at your own pace. Pause when you need to. Rewind if something doesn't quite click the first time. And feel free to revisit any topic as many times as it takes to feel confident. This course is here for you, whenever and however you need it. And while you're here, go ahead and hit that subscribe button. That way, you'll always know where to find us, and you'll stay up to date with all the free training content we're constantly adding. Countless learners just like you have already used certification Cynergy to kickstart their IT careers. And now, it's your turn. You've taken the first step, so let's dive into the first lesson and get you certified. Exam Objective 1.1 Explain common operating system types and their purposes. Operating system types. To begin our CompTIA A Plus Core 2 training, we have Exam Objective 1.1, which covers some basic information about operating systems. An operating system, or OS for short, is the fundamental software program that serves as the backbone of a computer or any other computing device. It has the primary job of being the intermediary between the hardware components of the computer and the applications or software running on it. More simply put, an operating system is like the boss of a computer, coordinating all its tasks and making sure everything runs smoothly. Or it is like a conductor, who leads an orchestra, ensuring all the musicians play together in harmony to create beautiful music. When it comes to operating system types, there are many to choose from, and each is designed for a specific use case. Now, I have laid out a few icons behind me. How many do you recognize? Most of us are familiar with Apple, represented by the Apple icon, and no doubt you have spotted the Microsoft Windows icon behind me too. The penguin on the left, whose name is Tux, is the universal symbol for the Linux OS, and on the right we have the icons for Google's Chrome OS and Android. Next I will present some use cases, and list appropriate operating systems for each. I will start with workstation OSs. A workstation OS is designed to provide a user-friendly and feature-rich environment for individual users, often emphasizing multimedia capabilities, productivity tools, and personal customization options. So which operating systems apply to this scenario? First we have Linux. Linux has many different distributions, some of which are open source, meaning they allow users to have access to the operating system's source code, while also helping users to avoid licensing fees. Next we have Apple and Microsoft. Apple's workstation OS is Mac OS, while Microsoft offers Windows 10 and Windows 11. Unlike Linux, these are proprietary operating systems, meaning access to the OS source code will be restricted. The last OS I will mention here is Google's Chrome OS. This OS is a little less known, but has the advantage of being a lightweight option for workstations that need an easy-to-use, browser-based interface. Servers have operating systems that are very similar to a workstation OS, but they are likely to be optimized for robustness, security, and stability to efficiently manage and serve resources and services to multiple clients in networked environments. They may also come in command line-only variants, meaning no graphical user interface, or GUI. Server environments are an area where Linux excels. Many of the Linux distributions have been purpose-built for server environments. Windows also has server-specific operating systems, with the most recent versions being Windows Server 2025 and 2022. Moving on, we have mobile device OSs. Mobile device operating systems are fairly different than workstations and servers, as these OSs must be tailored for the constraints of smartphones and tablets, prioritizing items such as touch-based interfaces, virtual keyboards, power efficiency, and ARM processor compatibility. Currently, the mobile device market is dominated by two main OS options. They are Android and Apple iOS, or Apple iPad OS, if you happen to have an Apple iPad. Last up, we have embedded operating systems. These are specialized OSs, designed to run on resource-constrained devices with specific functions, providing real-time capabilities, minimal resource requirements, and efficient power management, making them suitable for a wide range of embedded systems like IoT devices and gaming consoles. They often provide high reliability for static environments where regular updates are not required. Interesting enough, most embedded OSs are derived from Linux, or run a stripped-down version of a Linux distribution. Exam Objective 1.1 Explain common operating system types and their purposes. File system types. In this video segment, we will cover what a file system is, and some of the more common file system types. So let's start with a basic definition. A file system in the context of computing is a method of organizing and storing data on a computer or storage device. It provides a structured way to manage and access data efficiently. For an analogy, think of a file system as a digital filing cabinet. Just like you use a physical filing cabinet to organize and store your documents, a file system does the same for your digital files on a computer. It ensures that your files are neatly arranged and easily accessible, making it simpler for you to find and use the information you need. Now, let's explore some key file system types that are available for use by the various OS types. First, we have the New Technology File System, abbreviated as NTFS. NTFS is a proprietary file system developed by Microsoft and is the native file system for newer Windows operating systems. It supports advanced features such as file compression and encryption, while also providing robust permissions and access control to files and folders. Additionally, NTFS includes journaling capabilities, which helps maintain file system integrity. Another file system developed by Microsoft is the Resilient File System, or REFS. REFS is designed with data integrity and fault tolerance in mind, and is primarily used in Windows Server environments. It does not support file compression or encryption like NTFS, but it does support permissions. Additionally, REFS does not rely on journaling. Instead, it uses built-in integrity checking to detect data corruption and automatically repairs corrupted data. REFS is optimized for handling large volumes of data and works well in environments where redundancy and reliability are critical. For this reason, it is often thought of as a successor to NTFS, at least in the realm of servers. Next, let's talk about File Allocation Table 32, or the FAT32 file system. This file system is known for its compatibility with various devices and operating systems, including multiple Windows generations, Linux, and Mac OS. FAT32 is commonly used to manage data on storage devices, such as portable hard drives, USB flash drives, and memory cards because it can be read and written across multiple operating system types. However, FAT32 does not support file compression, encryption, or advanced permissions. It also lacks journaling, making it less reliable for data integrity compared to more modern file systems. Moving on, we have the fourth Extended File System, or ext4. ext4 is a common file system used in modern Linux-based operating systems, and is known for its performance, reliability, and support for large file sizes. It includes journaling to help protect against data corruption, and supports file permissions. However, it does not natively include file compression or encryption features. Another file system commonly used in Linux environments is XFS, which stands for Extended File System. XFS is designed for high performance and scalability, especially when working with large files and large storage systems. Interestingly enough, even though XFS is older than ext4, it is still widely used today, particularly in enterprise environments where performance is critical. XFS supports journaling and file permissions, but like ext4, it does not natively support file compression or encryption. Because of its ability to efficiently handle large amounts of data, XFS is often chosen for servers and high-performance systems where speed and reliability are key. For Mac OS users, we have the Apple File System, abbreviated APFS. This file system was developed by Apple and is used as the primary file system for newer Macintosh computers. APFS is optimized for solid-state drives, offering high performance and strong encryption capabilities. It supports file and volume encryption, as well as snapshot and cloning features. APFS does not natively support file compression, but does support permissions and journaling. Lastly, we have the Extensible File Allocation Table, or exFAT. exFAT is a newer file system used to manage data on storage devices, such as portable hard drives, USB flash drives, and memory cards. It supports large files and is compatible with Windows, Mac OS, and Linux. exFAT does not support file compression, encryption, or advanced permissions. It also lacks journaling, making it very similar to FAT32. But unlike FAT32, exFAT is an excellent choice for transferring large files between different operating systems. It supports files larger than 4 GB, which was the maximum file size limit of the older FAT32 file system. Exam Objective 1.1 Explain common operating system types and their purposes. End of life. Vendor lifecycle limitations can significantly impact your IT environment. In this section, we will focus on two key topics: end of life and update limitations. End of life, or EOL, occurs when a vendor stops supporting a product or service. Once a system reaches this point, it no longer receives updates, patches, or technical support. At that stage, you're essentially on your own. Running EOL software increases security risks because any newly discovered vulnerabilities will remain unpatched, leaving your system exposed to potential attacks. The risks associated with EOL are serious. Without security updates, bug fixes, or performance improvements, systems become less stable and more vulnerable over time. Attackers often target known weaknesses in outdated systems, making EOL software an easy entry point. In addition, hardware and newer applications may no longer function properly with an unsupported operating system, further limiting what you can do with the system. Compliance is another important concern. Many industries require organizations to use supported and up-to-date systems to protect sensitive data. Using EOL software can result in compliance violations, failed audits, and potential legal or financial penalties. Think of it like ignoring an expiration date. You might get away with it for a short time, but eventually, it will cause problems. One way organizations deal with EOL systems and compatibility issues is through virtualization. Virtualization allows you to run an older or unsupported operating system inside a virtual machine on a newer, supported system. This can be useful for maintaining access to legacy applications that won't run on modern operating systems. However, while virtualization can help isolate and contain risk, it does not eliminate the security concerns of running an unsupported OS. Proper precautions, such as limiting network access, are still necessary. Exam Objective 1.1 Explain common operating system types and their purposes. OS compatibility concerns. Compatibility concerns between operating systems can create real challenges in IT environments, especially when upgrading systems or working across multiple platforms. Not all applications, hardware, or drivers are designed to work with every operating system, and failing to consider compatibility can quickly lead to system issues. At a basic level, different operating systems use different architectures, file systems, and software frameworks. Because of this, an application built for one OS may not work on another. For example, a program designed specifically for Windows may not run on macOS or Linux without additional tools, or may not run at all. This is especially common with specialized or legacy software. Hardware compatibility is another important factor. Devices such as printers, scanners, or graphics cards rely on drivers to communicate with the operating system. If a driver is not available for a specific OS, the device may not function properly, or at all. This becomes a common issue when upgrading to a newer operating system, where older hardware may no longer be supported. Operating system upgrades can also introduce compatibility problems. Newer OS versions may remove support for older applications or drivers, which can break critical functionality. Imagine upgrading your system, only to discover that a key business application no longer works. Now you're faced with either rolling back the upgrade or finding a replacement solution, neither of which is ideal. To avoid these issues, IT professionals should always verify compatibility before making changes. This includes checking application requirements, confirming driver availability, and reviewing hardware support for the target operating system. Testing in a controlled environment before full deployment is also a best practice. Exam Objective 1.2 Given a scenario, perform OS installations and upgrades in a diverse environment. Boot methods. When installing or upgrading an operating system, one of the first things we need to understand is how that operating system actually gets onto the device. This process starts with something known as a boot method. A boot method is simply the way in which the setup program and operating system files, or system image, are loaded onto the target device. In other words, it determines how the system begins the installation process. Depending on the situation, there are several different boot methods that can be used. One of the most common approaches is using removable media. This refers to any storage device that can be connected to a system and used to load installation files. The most widely used example is a USB flash drive. Bootable USB flash drives are fast, portable, and easy to create, making them a go-to option for technicians. Removable media can also include external or hot-swappable drives, such as external hard drives or SSDs, which are useful for carrying larger system images or recovery tools. The key idea is simple: if you can plug it in and boot from it, it falls into this category. Another option is booting from an internal hard drive partition. Some systems include a dedicated partition that contains installation or recovery files. This allows the operating system to be repaired or reinstalled without needing any external media. It's like having a built-in backup plan sitting quietly on the drive, ready to step in when things go wrong. In larger environments, network booting is often used. This method allows a system to boot from a server instead of local storage. A common example of network booting is Pre-boot Execution Environment, or PXE boot. With PXE boot, the device connects to a network server during startup and downloads the necessary installation files. This is especially useful in enterprise environments, where multiple systems need to be deployed quickly and consistently, without manually setting up each one. Building on the idea of network booting, some systems also support internet-based booting, where installation files are retrieved directly from an online source rather than a local network server. This eliminates the need for physical media and can simplify deployments in certain scenarios. However, because everything relies on connectivity, a stable and reliable network connection is critical. This method is commonly used with lightweight devices or built-in recovery options provided by operating system vendors. Finally, we have the concept of multi-boot. This is slightly different from the other methods, as it refers to having multiple operating systems installed on the same device. When the system starts, the user is given a choice of which operating system to load. This can be useful for testing, development, or situations where different operating systems are needed for different tasks. Exam Objective 1.2. Given a scenario, perform OS installations and upgrades in a diverse environment. Installation types. When it comes to installing or upgrading an operating system, there isn't just one way to get the job done. In fact, the method you choose can have a big impact on everything from setup time to system performance and even long-term stability. Whether you're working on a single home computer or deploying hundreds of systems across an organization, selecting the right installation type is a critical first step. Each installation method is designed for a specific purpose. Some prioritize speed and convenience, while others focus on stability, consistency, or troubleshooting. For example, you might choose one method to fix a broken system, and a completely different method when setting up brand new devices for a company. Let's take a closer look at each of these, starting with a clean install. A clean install wipes the slate completely clean and starts fresh with a new OS installation. This is often the best choice when a system is experiencing major issues, such as malware infections, performance problems, or instability. It's also commonly used when repurposing a device or preparing it for a new user. The trade-off is that all data, applications, and settings are removed, so backups are critical before performing this type of installation. From there, another common approach to OS installation is the in-place upgrade. Instead of starting over, this method upgrades the current OS to a newer version while keeping files, user preferences, and third-party device drivers intact. This makes it a faster and more convenient option, especially in environments where minimizing downtime is important. For example, upgrading a system from Windows 10 to Windows 11 can often be done using an in-place upgrade, allowing the user to continue working with minimal disruption. However, because everything is carried over, any existing issues may remain after the upgrade. If the system had performance problems, misconfigurations, or even hidden malware, those issues can persist in the upgraded environment. This means that while an in-place upgrade is efficient, it's not always the best choice for systems that are already experiencing significant problems. For that reason, IT professionals often evaluate the condition of the system before choosing this method. If the system is stable and functioning properly, an in-place upgrade can save time and effort. But if there are underlying issues, a clean install may be the better long-term solution. Next, we have a repair installation. A repair installation is your go-to when the OS is acting up but you don't want to start from scratch. This installation type reinstalls the OS without affecting user data and applications. It's perfect for fixing system issues, like corrupted files or problematic updates. Imagine your system is running slow due to a recent failed update. A repair installation can replace corrupted OS files, bringing your system back to life without losing your precious data. It's like giving your OS a much-needed tune-up, ensuring everything runs smoothly again. One crucial tool often utilized during a repair installation is the recovery partition. This hidden partition on the internal hard drive contains the OS setup files and tools needed to restore the system. Think of it as having a built-in safety net. If your system becomes unusable, you can boot into the recovery partition and initiate a repair installation. When working with multiple systems, organizations often turn to image deployment. This method involves creating a standardized system image or snapshot that includes the operating system, applications, settings, and configurations. That image is then deployed to multiple devices, allowing each system to be set up in the same way. This helps ensure consistency across all machines and significantly reduces setup time compared to configuring each device individually. For example, instead of installing Windows, configuring settings, and installing applications on 50 computers one by one, an administrator can create one properly configured master image and deploy it to all 50 systems. This not only saves time, but also reduces the chance of configuration errors. Closely related to this is a remote network installation. With this approach, the operating system is installed over a network connection rather than from local media like a USB drive. The device connects to a server and retrieves the installation files during the setup process. This allows IT teams to manage installations centrally and eliminates the need to physically interact with each device. This method is especially useful in larger environments where systems may be located in different rooms, buildings, or even geographic locations. As long as the system can connect to the network, the installation can be initiated and completed remotely. Taking this concept even further, we have zero-touch deployment. Zero-touch deployment automates the entire installation and configuration process. A device can be powered on, connected to the network, and automatically receive its operating system, applications, settings, and policies, often without any manual input from a technician. This is commonly used in large organizations where devices are shipped directly to end users. The user simply connects the device to the network, and the system configures itself based on predefined settings. This reduces setup time, minimizes human error, and allows IT teams to deploy systems at scale much more efficiently. Finally, there are other installation considerations, such as third-party drivers. As outlined in the CompTIA A Plus exam objectives, third-party drivers are an important factor when performing OS installations in real-world environments. Not all hardware is fully supported by an operating system during installation. In some cases, the OS may not include the necessary drivers for certain components, such as storage controllers, network adapters, graphics cards, or other specialized hardware. When this happens, you may need to manually provide the correct drivers during or after the installation process to ensure the system functions properly. These drivers can be obtained from several reliable sources. The most common and recommended source is the hardware manufacturer's official website, where you can download the latest, compatible drivers for your specific device model and operating system. Exam Objective 1.2. Given a scenario, perform OS installations and upgrades in a diverse environment. Partitioning. In the previous two video segments, we covered the essentials of boot methods, which involve the various ways to load an operating system onto a target device, such as via USB or network connection. We've also explored installation types, ranging from in-place upgrades and clean installs to repair installations and image deployments, each with its unique benefits and use cases. Now, let's move on to our next topic, partitioning. Partitioning a physical hard drive involves dividing it into distinct sections, each functioning as a separate logical drive. This process is essential for organizing data and managing storage efficiently. When you partition a drive, you're working at the drive level, creating a partition table that keeps track of the locations and sizes of each partition. Two primary partitioning schemes are the master boot record, or MBR, and the GUID partition table, or GPT. Master boot record, or MBR, is the older of the two partitioning schemes and has been around since the early days of personal computing. An MBR partitioning scheme supports up to 4 primary partitions or 3 primary partitions plus 1 extended partition, which can contain multiple logical drives. A primary partition is a bootable partition that can contain an operating system, while an extended partition is a non-bootable partition, usually used for additional data storage. Each partition can be up to 2 terabytes in size. MBR is suitable for older systems or those still running legacy software that doesn't support GPT. It's also a straightforward choice if you don't need more than 4 partitions or require partitions larger than 2 terabytes. On the other hand, GUID partition table, or GPT, is the modern replacement for MBR, offering several advantages. A GPT partitioning scheme supports an almost unlimited number of partitions, but most operating systems impose a practical limit of 128. Each partition can be up to 18 exabytes in size, which is astronomically larger than the 2 terabyte limit of MBR. Therefore, GPT is ideal for modern drives larger than 2 terabytes and systems requiring more than 4 partitions. Additionally, systems using UEFI, rather than the older BIOS, will require GPT. Exam Objective 1.2 Given a scenario, perform OS installations and upgrades in a diverse environment. Drive formatting. After installing a new storage device, there are a few important steps required before it can be used. The first step is initializing the drive. Initializing a drive is the process of preparing a disk so the operating system can recognize it, by defining its partition style. A partition style determines how the drive organizes partition information, with the two most common options being MBR, or Master Boot Record, and GPT, or GUID partition table. Without initialization, the operating system cannot properly interact with the disk. Once a drive has been initialized, the next step is partitioning, which is the process of dividing the drive into one or more usable sections, called partitions. Each partition acts like its own separate storage space, allowing the operating system to organize data more efficiently. We actually covered partitioning in detail in a previous video segment, where we explored concepts like MBR and GPT, as well as how partitions are structured. But it's worth briefly revisiting here, because partitioning plays a critical role in preparing a drive for formatting. Without at least one partition, there would be no defined space for the operating system or files to exist. After a drive has been initialized and partitioned, the next step is formatting. Formatting is the process of preparing a partition for use by creating a file system so the operating system can store, organize, and retrieve data. At this point, it's helpful to briefly revisit the concept of a file system. A file system is the method an operating system uses to manage data on a storage device, including how files are named, stored, and accessed. As covered in Exam Objective 1.1, different file system types exist, but the key idea here is that formatting applies one of those file systems to the partition so it becomes usable. Without formatting, a partition technically exists, but it cannot store data in a meaningful way. It would be like having an empty filing cabinet with no folders or labels. There is space available, but no system in place to organize or retrieve anything. There are also different types of formatting, but we will cover those in more detail later in the course when we discuss low-level and standard formatting. For now, just understand that formatting is the step that makes a partition functional and ready for use by the operating system. Exam Objective 1.2 Given a scenario, perform OS installations and upgrades in a diverse environment. Upgrade considerations. When preparing to upgrade an operating system, it's important to understand that the process involves more than just running an installer. Upgrade considerations are the factors you evaluate before starting an upgrade to ensure the process is successful and does not result in data loss, compatibility issues, or system instability. One of the most important considerations is backing up files and user preferences. A backup is a copy of data stored separately from the original system so it can be restored if something goes wrong. This includes documents, photos, and any important files, as well as user preferences, which are personalized settings such as desktop layouts, application configurations, and saved profiles. Even though many upgrades are designed to preserve data, there is always a risk of failure, so having a reliable backup ensures you can recover quickly if needed. Another key consideration is application and driver support. An application is a software program designed to perform specific tasks for the user, such as word processing, web browsing, or accounting. A driver is specialized software that allows the operating system to communicate with hardware devices, such as printers, graphics cards, or network adapters. During an upgrade, not all applications or drivers may be compatible with the new operating system. This can result in programs failing to install, crashing, or hardware devices not functioning properly. Before performing an upgrade, it is important to verify that critical applications and hardware components have supported versions available to ensure system stability and functionality. Backward compatibility is another important concept to understand during an operating system upgrade. Backward compatibility refers to the ability of newer software or operating systems to support and run older applications or drivers that were designed for previous versions. While many modern operating systems attempt to maintain backward compatibility, it is not always guaranteed. Some operating systems provide features like compatibility mode, which allows older applications to run as if they were on a previous version of the operating system, helping resolve some compatibility issues. However, this does not work in all cases. Some older software may rely on outdated features or system components that are no longer supported, which can lead to errors or complete failure to run. Ensuring backward compatibility helps reduce disruptions, especially in environments that rely on legacy applications or specialized hardware. The final major consideration is hardware compatibility. Hardware compatibility refers to whether the physical components of a computer system meet the requirements of the new operating system. This includes components such as the processor, memory, storage devices, and firmware. Newer operating systems often have higher system requirements or may require specific features. For example, Windows 11 introduced stricter hardware requirements compared to Windows 10, including the need for a TPM version 2.0, UEFI firmware with secure boot capability, and a supported 64-bit processor. In contrast, Windows 10 can run on older systems without a TPM and with legacy BIOS firmware, making it more compatible with older hardware. If the hardware does not meet OS requirements, the operating system may not install, or it may not function properly after installation. Therefore, verifying hardware compatibility ahead of time helps ensure a smooth upgrade process and prevents unexpected issues. Exam Objective 1.2. Given a scenario, perform OS installations and upgrades in a diverse environment. Feature updates. Feature updates are another important part of operating system management and are closely tied to the product lifecycle. A feature update is a major update to an operating system that introduces new functionality, performance improvements, and sometimes noticeable changes to the user interface. Unlike regular updates, which typically focus on security patches and bug fixes, feature updates can significantly change how the operating system looks and behaves. For example, a feature update might introduce a redesigned start menu, improved system tools, or better support for newer hardware. These updates are usually released on a scheduled basis, depending on the operating system vendor. In business environments, these updates are often tested before deployment to ensure they do not disrupt existing systems or applications. This leads directly into the concept of the product lifecycle. The product lifecycle refers to the different stages an operating system goes through from the time it is released until it is no longer supported. These stages help organizations understand how long an operating system will receive updates and when it may need to be replaced. The first stage is typically mainstream support. During this phase, the operating system receives regular feature updates, security updates, and full support from the vendor. This is when the OS is actively developed and improved. After that comes extended support. In this phase, the operating system continues to receive critical security updates, but feature updates are usually no longer provided. The focus shifts from adding new functionality to maintaining stability and protecting against security threats. Eventually, the operating system reaches end of life, often abbreviated as EOL. End of life means the vendor no longer provides updates, including security patches. At this point, continuing to use the operating system can become a serious risk, especially in business environments, because newly discovered vulnerabilities will not be fixed. Feature updates play an important role throughout this life cycle. They help keep systems current, improve performance, and ensure compatibility with new applications and hardware. However, they can also introduce changes that require user training or additional testing, so they must be managed carefully. In real-world scenarios, IT professionals must balance stability and innovation. Applying feature updates too quickly can cause compatibility issues, while delaying them too long can lead to security vulnerabilities or unsupported systems. By understanding both feature updates and the product life cycle, you can make informed decisions about when to update, when to upgrade, and how to maintain systems in a secure and efficient state. Exam Objective 1.3 Compare and contrast basic features of Microsoft Windows Editions. Windows Editions. Exam Objective 1.3 focuses on comparing and contrasting the basic features of Microsoft Windows Editions. Microsoft offers several versions of Windows to meet the needs of different users and environments. For Windows 10, the main editions include Home, Pro, Pro for Workstations, and Enterprise, while Windows 11 editions include Home, Pro, and Enterprise. Each edition is designed with a specific audience in mind, ranging from everyday home users to large organizations with advanced IT requirements. As we go through these editions, you will hear terms such as Workgroup, BitLocker, Remote Desktop Protocol, Domain Join, and Group Policy. If these concepts are new to you, don't worry, these features will be explained in detail in the next video segment. For now, the goal is simply to understand which editions include these capabilities and how they differentiate one version of Windows from another. Starting with Windows 10 Home, this edition is specifically designed for personal and home use. It is well suited for individuals and families who use their computers for daily activities such as internet browsing, media consumption, social networking, and casual gaming. Students also find Windows 10 Home ideal for schoolwork, research, and online classes. In terms of features, Windows 10 Home supports workgroup configurations but does not support BitLocker encryption, does not allow Remote Desktop Protocol, or RDP hosting, and cannot join a domain. It also does not include group policy management tools. Overall, it provides a user-friendly and reliable environment for general productivity tasks. Building on this foundation, Windows 10 Pro is designed for professionals and small businesses that require more advanced functionality. In addition to everything included in the Home Edition, Windows 10 Pro offers enhanced security features such as BitLocker encryption. It also supports Remote Desktop Protocol, allowing the system to act as a remote host, and can join a domain, making it suitable for business networks. Windows 10 Pro also includes group policy management, giving administrators greater control over system settings. Like all editions, it supports workgroup configurations as well, making it flexible for both home and business use. For users who need even greater performance, Windows 10 Pro for Workstations is designed for high-end systems and specialized workloads. This edition supports more powerful hardware, including advanced multiprocessor configurations and larger amounts of memory, making it suitable for resource-intensive tasks. This is in addition to all the features found in Windows 10 Pro. It also includes support for the Resilient File System, or REFS, which is designed to improve data integrity and help protect against data corruption, especially when working with large volumes of data. These enhancements make Windows 10 Pro for Workstations ideal for professionals involved in data analysis, engineering, scientific computing, and 3D rendering. At the top of the Windows 10 lineup is Windows 10 Enterprise, which is intended for large organizations and corporate environments. It includes all the features of Windows 10 Pro, along with additional tools for centralized management and advanced security. This edition supports BitLocker, Remote Desktop Protocol hosting, Domain Join, and Group Policy Management, as well as workgroup configurations. It is best suited for environments where security, scalability, and administrative control are essential. Moving into Windows 11, the Home Edition continues to focus on personal and everyday use, but with a refreshed design and improved user experience. Windows 11 Home is ideal for tasks such as web browsing, streaming, gaming, and schoolwork. Like its Windows 10 counterpart, it supports workgroup configurations but does not support BitLocker, does not allow remote desktop protocol hosting, and cannot join a domain. It also does not include group policy management tools, keeping the experience simple for general users. Next, Windows 11 Pro expands on the Home Edition by adding features designed for professional and business use. It includes BitLocker encryption for data protection, supports remote desktop protocol hosting, and allows systems to join a domain. It also includes group policy management for centralized control. In addition, it supports workgroup configurations, making it suitable for a wide range of environments from small businesses to advanced users. At the enterprise level, Windows 11 Enterprise is designed for large organizations that require advanced security and centralized management. It builds on the Pro Edition by including all of its core features, such as BitLocker, remote desktop protocol hosting, domain join, and group policy management, along with workgroup support. This edition is ideal for corporate environments where managing large numbers of devices securely and efficiently is critical. Finally, there are Windows N versions, which are special editions available in certain regions to meet regulatory requirements. These versions are designed to comply with laws that promote competition by requiring Microsoft to remove certain bundled media technologies. Windows N editions are otherwise functionally equivalent to their standard counterparts, meaning they still support features such as BitLocker, remote desktop protocol, domain join, and group policy, depending on the specific edition, whether it is Home, Pro, or Enterprise. The key difference is that Windows N versions do not include built-in media features such as Windows Media Player, media playback capabilities, and certain audio and video codecs. As a result, users may find that some applications that rely on these components, such as video playback, voice recording, or certain web-based media features, may not function as expected out of the box. Exam Objective 1.3 – Compare and contrast basic features of Microsoft Windows editions. Windows features. In this video segment, we will cover just a few of the many key features Windows has to offer. My goal is to give you a basic understanding of each feature listed in the CompTIA A Plus, Core 2, exam objectives. The specific features we will cover are Windows Workgroup, Domain Access, Remote Desktop Protocol, BitLocker, and the Group Policy Editor. We will also discuss Windows OS RAM limitations across Windows editions. Let's begin with the concept of a Windows Workgroup. A workgroup is a simple network model where computers are connected together, but each system manages its own users, passwords, and settings independently. There is no central authority controlling the network. This setup is commonly used in home environments or small offices because it is easy to configure and does not require a server. However, because each system is managed individually, maintaining consistency and security across multiple devices can become difficult as the network grows. Building on this concept, we also have domain access. A domain is a network model where computers connect to a central server that manages user accounts, security settings, and system policies. In this type of environment, computers connect to that central server, allowing administrators to control multiple systems from a single location rather than configuring each machine individually. This centralized approach provides several advantages. Administrators can enforce consistent security settings, deploy software, and manage user permissions across the entire network. For example, if a company needs to update password policies or restrict access to certain applications, those changes can be applied to all systems at once, through the domain. It also simplifies user management, since employees can log into any computer within the domain using the same credentials and access their assigned resources. Domains are commonly used in business environments where centralized management, security, and scalability are essential. As organizations grow, managing systems individually becomes inefficient, and a domain-based approach helps streamline administration while maintaining tighter control over the network. Next, let's look at Remote Desktop Protocol, or RDP. RDP is a feature that allows a user to remotely connect to, and control, another computer over a network connection, through a graphical user interface, or GUI, just as if they were sitting in front of that system. This is especially useful for IT support, remote work, or accessing systems without being physically present. In this scenario, the system initiating the connection is called the client, while the system being controlled is called the host. It's important to note that not all Windows editions support RDP in the same way. Home editions can act as a client, meaning they can connect to another system, but they cannot act as a host. Pro and Enterprise editions, however, can function as both a client and a host, allowing them to both initiate and receive remote connections. Next, we have BitLocker, a Windows security feature designed to protect your data. BitLocker is a full disk encryption feature that helps secure your information by encrypting the entire drive. BitLocker primarily protects data when it is in a locked state, also known as data at rest. This means that if a device is powered off, lost, or stolen, the data remains unreadable without the proper decryption key. Once the system is authenticated and running, the drive enters an unlocked state, allowing authorized users to access their files normally without noticing the encryption in the background. Unfortunately, Windows Home Editions does not include BitLocker. So, if you are a single user who wants to encrypt their entire hard drive with BitLocker, you might need to upgrade to a Windows Pro or Enterprise Edition. Next, we have Group Policy, a feature that allows administrators to control and configure operating system settings and user environments. Group Policy is commonly used in domain environments, where settings are managed centrally from a server, referred to as a domain controller. This allows IT administrators to enforce security policies, manage user permissions, control system behavior, and ensure consistency across multiple computers within an organization. For example, an administrator can require strong passwords, restrict access to certain features, or deploy configurations to many systems at once. Closely related to this is the Local Group Policy Editor, which is accessed using the command gpedit.msc. This tool is a feature that allows administrators to control and configure operating system settings and user environments locally on a single system. It provides a graphical interface for managing many of the same types of settings found in domain-based group policy, such as security options, administrative templates, and user restrictions. This is especially useful for standalone systems or small environments that are not part of a domain. It's important to note that while group policy in a domain environment requires Windows Server infrastructure, the Local Group Policy Editor is available on individual systems running Windows Pro and Enterprise editions. Windows Home editions do not include the Local Group Policy Editor. Now let's discuss RAM limitations. RAM, or Random Access Memory, is the system's short-term memory used to store data that is actively being used. Different Windows editions support different maximum amounts of RAM. Home editions typically support less RAM, making them suitable for everyday tasks, while Pro and Enterprise editions support significantly larger amounts of memory for high-performance workloads such as virtualization, data processing, and professional applications. Before we break down the editions, it's important to understand the difference between 32-bit and 64-bit operating systems. A 32-bit version of Windows is limited to addressing 4 GB of RAM. This limitation exists because a 32-bit system can only create a finite number of memory addresses, due to the numerical limitations of a 32-bit binary number. In contrast, 64-bit operating systems can support much larger amounts of RAM because they use a vastly larger address space. For modern systems, 64-bit Windows is the standard and is required to take advantage of higher RAM capacities. Starting with Windows 10 editions, Windows 10 is available in both 32-bit and 64-bit versions. However, to take advantage of higher RAM capacities, a 64-bit version must be used. Windows 10 Home supports up to 128 GB of RAM, which is more than enough for most personal and home users. Windows 10 Pro increases this limit significantly, supporting up to 2 TB of RAM, making it suitable for more demanding tasks and professional environments. Windows 10 Pro for workstations goes even further, supporting up to 6 TB of RAM, which is designed for high-end systems used in data-intensive fields such as engineering, scientific computing, and large-scale virtualization. Windows 10 Enterprise also supports up to 6 TB of RAM and includes additional features designed for large organizations and advanced IT management. Moving on to Windows 11 editions, Windows 11 is a 64-bit only operating system, meaning there is no 32-bit version available. This reflects the industry's shift toward modern hardware and the need to support larger amounts of memory and improved system performance. As with Windows 10, RAM support varies by edition. Windows 11 Home supports up to 128 GB of RAM, making it suitable for everyday personal use. For users who need more performance, Windows 11 Pro increases this limit significantly, supporting up to 2 TB of RAM, which is ideal for professional environments and more demanding workloads. For large organizations and advanced computing environments, Windows 11 Enterprise goes even further, supporting up to 6 TB of RAM. This higher capacity is designed for systems that require maximum performance, scalability, and the ability to handle highly resource-intensive applications. Exam Objective 1.3 – Compare and contrast basic features of Microsoft Windows editions. Upgrade paths. When discussing Windows installation methods, it's essential to understand the differences between an in-place upgrade and a clean install, as both have distinct advantages and are used in different scenarios. An in-place upgrade is the process of installing a new version of Windows over an existing installation while keeping your files, applications, and system settings intact. This makes it a convenient option for users who want to upgrade their operating system without starting from scratch. Because everything is preserved, it significantly reduces setup time and allows users to continue working with minimal disruption. However, since the existing system is carried forward, any underlying issues, such as system errors, misconfigurations, malware, or corrupted files, may also persist after the upgrade. On the other hand, a clean install involves completely erasing the existing operating system and installing Windows from scratch. This method provides a fresh start, removing any unwanted files, software issues, or hidden problems from the previous installation. As a result, clean installs often lead to better system performance and improved stability. This approach is commonly used when setting up a new computer, repurposing a device, or troubleshooting persistent system issues. However, it is more time-consuming and requires careful preparation, including backing up all important files and reinstalling applications afterward. Understanding when to use each method is important. An in-place upgrade is ideal when you want a quick transition with minimal disruption, while a clean install is better when you need a stable, optimized system or are dealing with ongoing issues. Now let's look at upgrade paths between Windows editions. Within Windows, it is possible to move from one edition to another using an in-place upgrade, depending on the specific editions involved. This process allows you to move to a higher edition such as from Home to Pro without reinstalling the operating system. The upgrade is typically completed by entering a valid product key or applying a new license, and it preserves personal files, system settings, and applications. This makes it a quick and efficient way to unlock additional features like BitLocker, remote desktop hosting, and domain access. As shown in the chart, not all upward upgrades are supported directly. For example, while moving from Home to Pro is supported as an in-place upgrade, moving from Home directly to Enterprise is not supported and would require first upgrading to Pro or performing a clean install. When moving to a lower edition such as from Pro to Home, the process is considered a downgrade. In this case, personal files are typically maintained, but applications and system settings are removed during the transition. Additionally, some transitions, especially those involving higher-level editions like Enterprise, may require a clean install. This means the system must be wiped and reinstalled, and all files and applications must be restored from backup. Understanding these upgrade paths helps ensure you choose the correct method when changing Windows editions while minimizing data loss and system disruption. Now let's take a look at Windows hardware requirements by comparing Windows 10 and Windows 11 side by side. As shown in the chart, Windows 10 supports both 32-bit and 64-bit architectures, while Windows 11 is 64-bit only. This means older 32-bit systems cannot run Windows 11. Looking at the processor requirements, both operating systems require at least a 1 GHz processor, but Windows 11 also requires a minimum of 2 cores, reflecting its focus on more modern hardware. For memory and storage, Windows 10 has lower requirements, with 1 GB of RAM being the minimum for a 32-bit system along with a need for 32 GB of storage. Windows 11 increases these requirements to at least 4 GB of RAM and 64 GB of storage. When it comes to firmware, Windows 10 can run on systems using either BIOS or UEFI. Windows 11, however, requires UEFI with Secure Boot, which provides improved system security during startup. Finally, the requirement for a Trusted Platform Module, or TPM, is a major difference between the two. Windows 10 does not require a TPM, while Windows 11 requires a TPM version 2.0. This hardware-based security feature helps protect sensitive data and supports modern security functions. Because of these stricter requirements, not all systems that run Windows 10 will be able to upgrade to Windows 11. As such, verifying hardware compatibility ahead of time is essential to ensure a smooth and successful upgrade. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Task Manager. Task Manager is one of the most powerful and commonly used system tools in Windows. It allows users to view and manage running applications, processes, and system performance all in one place. Whether you are closing a frozen app, analyzing system performance, or optimizing startup programs, Task Manager is a tool every technician should be comfortable using. Accessing Task Manager is quick and easy. You can right-click the taskbar and select Task Manager, use the keyboard shortcut, Ctrl+Shift+Escape for direct access, or press Ctrl+Alt+Delete and choose Task Manager from the menu. Once Task Manager is open, you will see several tabs that provide different views into your system. Let's move through some of these tabs and break down the most important items you will need to know, for both the exam and for real-world use. First up, we have the Processes tab. This tab is where you will spend most of your time. Think of this as your real-time dashboard of everything running on the system. It displays applications, background processes, and Windows processes, along with their current CPU, memory, disk, and network usage. This makes it incredibly useful for identifying resource-heavy applications that may be slowing the system down. If a program freezes or becomes unresponsive, you can select it and click End Task to force it to close. Next is the Performance tab, which provides a live, graphical view of system resources. You can monitor CPU usage, memory consumption, disk activity, and network performance. This tab is extremely valuable when diagnosing performance issues. For example, if a user reports a slow system, you can quickly determine whether the issue is caused by high CPU usage, low available memory, or heavy disk activity. Moving over to the Startup tab, this is your go-to location for improving boot performance. This tab lists all applications configured to launch when Windows starts. Disabling unnecessary startup programs can significantly reduce boot time and improve overall system responsiveness. In older versions of Windows, this required using msconfig, but in Windows 11, Task Manager provides a much more streamlined and accessible solution. Next, we have the Users tab. This tab shows all users currently logged into the system, along with the resources each user is consuming. For each user, you can view their CPU, memory, disk, and network usage, giving you a clear picture of how system resources are being distributed. This is especially useful in shared or enterprise environments where multiple users may be signed in at the same time, such as on a server, shared workstation, or through a remote desktop service. If one user is consuming excessive resources, you can quickly identify it here and determine whether their activity is impacting overall system performance. You also have the ability to manage user sessions directly from this tab. By right-clicking on a user, you can disconnect their session or sign them out entirely. This can be helpful if a user has left a session running that is consuming resources, or if troubleshooting requires resetting their session. Finally, the Services tab displays Windows services and their current status, such as running or stopped. Services are background processes that support critical system functions. From this tab, you can start, stop, or restart services as needed. For example, if audio is not working, restarting the Windows Audio service could resolve the issue. Suffice it to say, Task Manager is not just a monitoring tool. It is a troubleshooting powerhouse. It allows you to quickly identify performance bottlenecks, manage applications and services, and optimize system startup. For the exam, focus on knowing what each tab is used for and when you would apply it in a real-world scenario. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Event Viewer. Event Viewer is a Microsoft Windows utility that is used to view and analyze various events that occur within the operating system. An event refers to any significant action, change, or issue recorded by the operating system or an application. These events are stored in logs, which are organized into categories such as system, application, and security. To better understand how Event Viewer is used, it's important to know what each of these logs represents. The system log contains events related to the operating system itself, including hardware issues, driver problems, and service failures. The application log records events generated by installed programs, such as application errors or successful operations. The security log tracks security-related events, including login attempts, access to resources, and audit results. Each event is also assigned a severity level to help prioritize troubleshooting. Critical events indicate serious issues like system crashes or hardware failures. Error events highlight significant problems, such as applications crashing or services failing to start. Warning events point to potential issues that may lead to errors if not addressed, while information events provide general details about normal system activity. Additionally, audit success and audit failure events are used specifically for security tracking. Understanding how these logs and event types work together allows technicians to quickly identify and diagnose problems. Instead of guessing, you can use Event Viewer to trace issues back to their source, making it an essential tool for troubleshooting system errors, service interruptions, and stability problems. Now that you understand how events are categorized, let's look at how to access Event Viewer. To open Event Viewer using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type eventvwr.msc and click OK. This command launches Event Viewer, where you can begin analyzing system logs. Once Event Viewer is open, the next step is knowing where to look. Focus on the appropriate log category depending on the issue. The system log is commonly used for hardware problems, driver issues, and service failures. The application log contains events related to installed software, while the security log records login attempts and access-related events. Finally, it's important to understand why this tool matters in an IT environment. Event Viewer allows technicians to move beyond symptoms and identify the actual source of a problem. By analyzing logs, event IDs, and recurring patterns, you can diagnose issues such as unexpected shutdowns, failed updates, or system instability. For the exam, remember that Event Viewer is the primary tool used to investigate system errors, service failures, and crash-related issues, making it essential for effective troubleshooting. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Disk Management. Disk Management is a Microsoft Windows utility that is used to view and manage storage devices and disk volumes within the operating system. A disk volume refers to a formatted section of a storage device that can store data and be assigned a drive letter. These volumes are organized on physical disks and can include partitions such as primary partitions, extended partitions, and logical drives. To better understand how disk management is used, it's important to know what types of tasks it allows you to perform. Disk management enables you to initialize new disks, create and delete partitions, format volumes, and assign or change drive letters. It also allows you to extend or shrink volumes to adjust storage space as needed. Additionally, disk management supports different file systems, such as NTFS and FAT32, which determine how data is stored and accessed. Within disk management, each disk and volume is displayed with a status that helps identify its current condition. For example, a disk may be shown as online or offline, while a volume may be labeled as healthy or unallocated. A healthy status indicates normal operation, while unallocated space represents unused disk space that has not yet been configured. Understanding these statuses helps technicians quickly identify storage issues. Understanding how these components work together allows technicians to efficiently manage storage and troubleshoot disk-related problems. Instead of relying on guesswork, you can use disk management to configure drives, recover unused space, and resolve issues such as missing drive letters or improperly formatted disks. Now that you understand how disk management is used, let's look at how to access it. To open disk management using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type diskmgmt.msc and click OK. This command launches disk management, where you can view and manage disks and volumes. Once disk management is open, the next step is knowing where to look. Focus on the graphical view and volume list to identify the state of each disk and partition. You can right-click a disk or volume to access options such as formatting, extending, shrinking, or assigning drive letters. This is especially useful when configuring new drives or troubleshooting storage issues. Finally, it's important to understand why this tool matters in an IT environment. Disk management allows technicians to configure and maintain storage systems efficiently. By using this tool, you can resolve issues such as unrecognized drives, insufficient disk space, or partitioning errors. For the exam, remember that disk management is the primary tool used to manage disks, partitions, and volumes, making it essential for storage configuration and troubleshooting. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Task Scheduler. Task Scheduler is a Microsoft Windows utility that is used to automate the execution of tasks based on specific triggers or schedules. A task refers to an action performed by the system, such as running a program, executing a script, or launching a command at a defined time or event. These tasks are organized within the Task Scheduler library and can be configured to run automatically without user intervention. To better understand how Task Scheduler is used, it's important to know what components make up a task. Each task includes a trigger, which determines when the task runs, such as at a specific time, during system startup, or when a user logs in. It also includes an action, which defines what the task does, such as starting an application or running a script. Understanding how these components work together allows technicians to automate routine processes and diagnose scheduling issues. Instead of manually performing repetitive actions, you can use Task Scheduler to streamline system maintenance, updates, and administrative tasks. Now that you understand how Task Scheduler is used, let's look at how to access it. To open Task Scheduler using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type task.schd.msc and click OK. This command launches Task Scheduler, where you can view, create, and manage scheduled tasks. Once Task Scheduler is open, the next step is knowing where to look. Focus on the Task Scheduler library, where tasks are organized in folders. Selecting a task allows you to view its triggers, actions, conditions, and history. You can also create new tasks or modify existing ones to meet specific requirements. Finally, it's important to understand why this tool matters in an IT environment. Task Scheduler allows technicians to automate administrative and maintenance tasks, improving efficiency and consistency. It can also be used to troubleshoot issues where scheduled processes fail to run or complete properly. For the exam, remember that Task Scheduler is the primary tool used to automate tasks and manage scheduled processes, making it essential for system maintenance and troubleshooting. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Device Manager. Device Manager is a Microsoft Windows utility that is used to view and manage hardware devices installed on a computer. A device refers to any hardware component connected to the system, such as a keyboard, network adapter, display adapter, or storage controller. In Device Manager, these devices are organized into categories, allowing technicians to easily locate and manage specific hardware components. To better understand how Device Manager is used, it's important to know what actions can be performed on devices. Device Manager allows you to install, update, roll back, enable, disable, and uninstall device drivers. Drivers are software components that allow the operating system to communicate with hardware. If a device is not functioning properly, updating or reinstalling its driver can often resolve the issue. Each device is also assigned a status that helps identify whether it is working correctly. A device with no icon is functioning normally with no issues. A yellow triangle with an exclamation mark indicates a problem, such as a missing, corrupted, or incompatible driver. A black, downward-facing arrow shows that the device is disabled and not currently in use. An unknown device, often displayed with a question mark or generic icon, means Windows cannot identify the device, usually due to missing drivers. Viewing the device properties can also provide additional details, including error codes that can be used for troubleshooting. Now that you understand how Device Manager is used, let's look at how to access it. To open Device Manager using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type devmgmt.msc and click OK. This command launches Device Manager, where you can view and manage hardware devices. Once Device Manager is open, the next step is knowing where to look. Focus on the device categories and expand them to locate specific hardware components. Right-clicking a device provides access to options such as updating drivers, disabling devices, or viewing properties. This is especially useful when troubleshooting hardware issues or installing new devices. Finally, it's important to understand why this tool matters in an IT environment. Device Manager allows technicians to manage hardware and ensure that all devices are functioning correctly. It is commonly used to resolve driver issues, identify hardware conflicts, and verify proper device operation. For the exam, remember that Device Manager is the primary tool used to manage hardware devices and drivers, making it essential for troubleshooting hardware-related issues. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Certificate Manager. Certificate Manager is a Microsoft Windows utility used to view, manage, and organize digital certificates on a computer. A digital certificate is like a digital ID card that proves the identity of a user, device, or website, and helps keep data secure through encryption. These certificates are stored in different locations called certificate stores, such as personal, trusted root certification authorities, and intermediate certification authorities. To better understand how Certificate Manager is used, it's important to know what each of these stores represents. The personal store contains certificates assigned to the current user or computer, which are often used for authentication or secure communication. The Trusted Root Certification Authorities store contains certificates from trusted organizations that your system relies on to verify identities. The Intermediate Certification Authorities store helps connect certificates back to a trusted source, forming what is known as a chain of trust. Now that you understand how certificates are stored, it's helpful to understand the system that makes all of this possible. Understanding Public Key Infrastructure, or PKI, is a prerequisite to working with Certificate Manager, so let's break it down in a simple way. PKI is a framework that uses two keys, a public key and a private key, to secure data and verify identity. The public key is shared openly, while the private key is kept secret. To tie this all together, think of digital certificates like passports. A passport proves who you are and is issued by a trusted authority, like a government. In the same way, certificates are issued by trusted organizations called certificate authorities, or CAs. These CAs act like passport offices, verifying identities before issuing certificates. For example, when a website requests a certificate, the CA verifies its identity and ownership. Once verified, the CA issues a certificate that includes the website's public key and identifying information. Understanding how certificate stores and PKI work together allows technicians to verify trust and secure communication. Certificate Manager provides a centralized place to view certificates, confirm they are valid, and troubleshoot issues such as expired certificates or broken trust chains. Now that you understand how Certificate Manager is used, let's look at how to access it. To open Certificate Manager using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type certmgr.msc, and click OK. This command launches Certificate Manager, where you can begin viewing and managing certificates. Once Certificate Manager is open, the next step is knowing where to look. Focus on the appropriate certificate store depending on the task. The Personal Store is commonly used for user or device certificates, the Trusted Root Store is used to verify trusted issuers, and the Intermediate Store helps maintain the chain of trust. Finally, it's important to understand why this tool matters in an IT environment. Certificate Manager allows technicians to manage digital identities and maintain secure communications across systems and networks. By reviewing certificate details, expiration dates, and trust relationships, you can diagnose issues such as authentication failures, secure website errors, or encryption problems. For the exam, remember that Certificate Manager is the primary tool used to view and manage digital certificates, making it essential for working with authentication, encryption, and secure communications. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Local Users and Groups. Local Users and Groups is a Microsoft Windows utility that is used to manage user accounts and groups on a local computer. A user account represents an individual who can log into the system, while a group is a collection of users that share the same permissions. This utility allows administrators to control access to resources, enforce security, and manage user environments. To better understand how this tool is used, it's important to look at the two main components, users and groups. User accounts are created for individuals and can be configured with passwords, account restrictions, and permissions. Groups, on the other hand, simplify management by allowing administrators to assign permissions to multiple users at once. Instead of configuring each user individually, users are added to groups, and those groups are assigned specific access rights. A helpful way to think about this is through a real-world analogy. Imagine a company office building. Each employee has their own ID badge, which represents their user account. Instead of giving each employee separate permissions for every room, employees are placed into groups such as HR, IT, or management. Each group is then granted access to certain areas. This makes managing access much more efficient and consistent. Now that you understand how local users and groups is used, let's look at how to access it. To open local users and groups using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type lusrmgr.msc and click OK. This command launches the Local Users and Groups console. Once the console is open, the next step is knowing where to look. The Users section displays all local user accounts on the system. Additionally, the Groups section shows all local groups, such as administrators, users, and guests. From here, you can create new users, reset passwords, disable accounts, rename accounts, or add users to groups. In real-world scenarios, administrators often use this tool to make quick account changes. For example, an administrator may need to rename the built-in administrator account on a Windows system to improve security. This can be done directly within the Local Users and Groups utility by modifying the account properties. Finally, it's important to understand why this tool matters in an IT environment. Local Users and Groups allows technicians to manage access control and enforce security policies at the local level. By properly organizing users and groups, you can reduce administrative overhead and improve system security. For the exam, remember that Local Users and Groups is used to manage user accounts and group memberships, making it essential for controlling access and permissions on a Windows system. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Local Group Policy Editor. Local Group Policy Editor is a Microsoft Windows utility that is used to configure and enforce system-wide and user-specific settings on a local computer. These settings control how the operating system behaves, including security options, user permissions, and system policies. These policies are organized into two main categories: computer configuration, which applies settings to the system as a whole, and user configuration, which applies settings to user accounts. Within these categories, policies are further grouped into folders such as software settings, Windows settings, and administrative templates. To better understand how this tool works, it helps to think of it as defining rules rather than managing users directly. Administrators use group policy to control what users can and cannot do within the system. For example, policies can be used to enforce password requirements, restrict access to certain system features, or prevent users from installing software. At this point, it's important to distinguish this tool from local users and groups. While local users and groups is used to create and manage user accounts and group memberships, local group policy editor is used to control what those users and groups are allowed to do. In other words, local users and groups defines who has access, while group policy defines what they can do with that access. Now that you understand how local group policy editor is used, let's look at how to access it. To open local group policy editor using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type gpedit.msc and click OK. This command launches the local group policy editor. Once opened, the local group policy editor window displays a structured layout that makes it easy to navigate and manage policies. On the left-hand side, you will see a hierarchical tree that organizes policies into computer configuration and user configuration. Expanding these sections reveals additional categories such as Windows settings and administrative templates. To modify a policy, you simply navigate to the appropriate setting and open it. Most policies provide 3 configuration options: not configured, enabled, or disabled. These options determine whether the policy is applied and how it affects the system or user. Finally, it's important to understand why this tool matters in an IT environment. Local Group Policy Editor allows administrators to enforce security settings and system rules across a computer without needing to configure each user individually. By applying policies at the system or user level, administrators can maintain consistency, improve security, and reduce the risk of misconfiguration. For the exam, remember that Local Group Policy Editor is used to control what users and systems are allowed to do by applying policies, making it essential for enforcing security settings and managing system behavior on a Windows machine. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Performance Monitor. Performance Monitor is a Microsoft Windows utility that is used to track and analyze system performance over time. It collects data related to system resources such as the processor, memory, disk, and network usage. These measurements help identify how efficiently a system is operating and whether any components are becoming a bottleneck. To better understand how Performance Monitor works in practice, it helps to first understand how performance data is measured. The tool uses counters, which are specific metrics that track system activity. For example, processor counters measure CPU usage, memory counters track available and used RAM, and disk counters monitor read and write activity. These counters provide real-time insight into how system resources are being used. In addition to real-time monitoring, Performance Monitor also allows you to collect data over time using data collector sets. These enable you to record performance metrics and review them later, which is especially useful for diagnosing intermittent issues that may not occur consistently. Instead of trying to catch a problem as it happens, you can analyze trends and patterns after the fact. With both counters and data collection in mind, you can start to see how everything works together. Performance Monitor provides a centralized way to observe system behavior, compare resource usage, and identify abnormal activity. This makes it easier to pinpoint the root cause of issues such as slow performance, system lag, or resource exhaustion. Now that you understand how Performance Monitor is used, let's look at how to access it. To open Performance Monitor using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type perfmon.msc and click OK. This command launches Performance Monitor, where you can begin viewing and collecting performance data. After opening Performance Monitor, the next step is knowing where to focus your attention. Depending on the issue, you will add and monitor specific counters. For example, High CPU usage may indicate a process consuming too many resources, low available memory may point to insufficient RAM, and heavy disk activity could signal storage performance issues. Selecting the appropriate counters helps narrow down the root cause. Finally, it's important to understand why performance monitor matters in an IT environment. It allows technicians to move beyond guesswork and use real data to diagnose performance issues. By analyzing system metrics and trends, you can identify bottlenecks, validate system performance, and make informed decisions about troubleshooting or upgrades. For the exam, remember that Performance Monitor is used to track system performance metrics and identify resource bottlenecks, making it essential for diagnosing slow or unstable systems. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Resource Monitor. Resource Monitor is a Microsoft Windows utility that is used to view detailed, real-time information about how system resources are being used. It provides insight into CPU, memory, disk, and network activity at a more granular level than other tools. This allows technicians to see exactly which processes are consuming resources and how they are interacting with the system. To better understand how Resource Monitor works in practice, it helps to first understand how the data is organized. The tool is divided into 4 main sections: CPU, memory, disk, and network. Each section displays real-time activity along with a list of processes and their resource usage. For example, the CPU tab shows which processes are actively using processor time, while the memory tab displays how RAM is allocated and whether the system is under memory pressure. At this point, it's important to distinguish Resource Monitor from Performance Monitor. While both tools deal with system performance, they serve different purposes. Resource Monitor focuses on real-time, process-level activity, allowing you to see exactly which applications are using system resources at that moment. In contrast, Performance Monitor is more focused on long-term tracking and data collection, using counters and logs to analyze trends over time. In simpler terms, Resource Monitor answers the question, "What is happening right now?" while Performance Monitor helps answer what has been happening over time. Now that you understand how Resource Monitor is used, let's look at how to access it. To open Resource Monitor using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type resmon.exe and click OK. This command launches Resource Monitor, where you can begin analyzing system activity in real time. After opening Resource Monitor, the next step is knowing where to focus your attention. Depending on the issue, you will examine the relevant tab. For example, if a system is running slowly, check the CPU and memory tabs. If files are taking a long time to open or save, review the Disk tab. If there are connectivity or bandwidth concerns, the Network tab will provide useful insights. Finally, it's important to understand why Resource Monitor matters in an IT environment. It allows technicians to identify exactly which processes are using system resources and how they are impacting performance. This makes it an essential tool for troubleshooting performance issues, diagnosing resource contention, and analyzing real-time system behavior. For the exam, remember that Resource Monitor is used to view detailed, real-time resource usage by process, making it especially useful for identifying which applications are causing performance issues. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. System Information. System Information is a Microsoft Windows utility that is used to view detailed information about a computer's hardware, system components, and software environment. It provides a centralized location where technicians can quickly gather important system details such as the operating system version, installed hardware, BIOS or UEFI information, and system resources. To better understand how system information is organized, it helps to look at its main sections. The system summary provides a high-level overview of the system, including the OS version, processor, installed memory, and system type. The Hardware Resources section shows how system resources like memory addresses and interrupts are allocated. Components provides detailed information about installed hardware such as storage devices, network adapters, and display components. Finally, the software environment section includes details about running processes, services, drivers, and system variables. This organization makes it easy to locate specific information when troubleshooting or verifying system configurations. For example, a technician can use System Summary to confirm whether a system meets upgrade requirements, or check components to identify hardware details such as network adapter models or storage devices. Now that you understand how system information is structured, let's look at how to access it. To open system information using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type msinfo32.exe and click OK. This command launches system information, where you can begin reviewing system details. After opening system information, the next step is knowing where to focus your attention. If you need a quick overview, start with System Summary. For resource allocation concerns, review hardware resources. If you are troubleshooting hardware issues, navigate to Components, and for software or process-related issues, check the Software Environment section. Finally, it's important to understand why system information matters in an IT environment. It allows technicians to quickly gather accurate system details without needing to open multiple tools. This is especially useful for verifying system specifications, troubleshooting hardware and software issues, and ensuring compatibility with upgrades or applications. For the exam, remember that system information is used to view detailed hardware and system configuration data, making it a key tool for system analysis and troubleshooting. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. System configuration. System configuration is a Microsoft Windows utility that is used to manage startup settings and troubleshoot system boot issues. It allows technicians to control how Windows starts, which services and applications run at startup, and to isolate problems that may be preventing the system from operating normally. To better understand how system configuration works in practice, it helps to look at its main tabs. The General tab allows you to choose how Windows starts, including Normal Startup, Diagnostic Startup, and Selective Startup. Diagnostic Startup loads only basic devices and services, while Selective Startup allows you to control which services and startup items are enabled. The Boot tab provides options related to how the operating system starts. From here, you can enable safe mode, adjust boot parameters, and configure advanced boot options. This tab is especially useful when troubleshooting systems that fail to boot properly. The Services tab displays all system and third-party services. From this tab, you can enable or disable services to help isolate issues. For example, disabling non-Microsoft services can help determine if a third-party application is causing system instability. The Startup tab, which now redirects you to Task Manager in newer versions of Windows, was once used to manage startup applications. Disabling unnecessary startup programs can improve system performance and reduce boot times. Now that you understand how system configuration is used, let's look at how to access it. To open system configuration using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type msconfig.exe and click OK. This command launches system configuration, where you can begin adjusting startup and service settings. After opening system configuration, the next step is knowing where to focus your attention. If the system is experiencing boot issues, start with the Boot tab. If you suspect a service or application conflict, use the Services tab and Selective Startup options. For performance concerns related to startup programs, review the Startup tab within Task Manager. Finally, it's important to understand why system configuration matters in an IT environment. It allows technicians to isolate and troubleshoot startup-related issues by controlling which components load during boot. This makes it a powerful tool for diagnosing system instability, boot failures, and performance problems. For the exam, remember that system configuration is used to manage startup settings and troubleshoot boot issues, making it essential for isolating system problems and improving startup performance. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Disk Cleanup. Disk Cleanup is a Microsoft Windows utility that is used to free up storage space by removing unnecessary files from a system. These files can include temporary files, system cache, recycle bin contents, and other items that are no longer needed but still occupy valuable disk space. To better understand how disk cleanup works in practice, it helps to look at the types of files it targets. Temporary files are created by the operating system and applications during normal operation and are often left behind after use. System files, such as Windows Update leftovers or error reports, can also accumulate over time. Additionally, files in the recycle bin and temporary internet files can take up significant space if not regularly cleared. With these items in mind, you can start to see how disk cleanup helps maintain system performance by reducing clutter and freeing up disk space, which can improve overall system responsiveness and ensure there is enough space for updates and applications. Now that you understand how disk cleanup is used, let's look at how to access it. To open disk cleanup using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type cleanmgr.exe and click OK. This command launches disk cleanup, where you can select a drive and choose which files to remove. After opening disk cleanup, the next step is knowing where to focus your attention. Review the list of file categories and select those that are safe to delete, such as temporary files, recycle bin contents, and cached data. If additional space is needed, use the System Files Cleanup option to remove larger items like previous Windows installations. Finally, it's important to understand why disk cleanup matters in an IT environment. It allows technicians to quickly reclaim disk space, improve system performance, and prevent issues related to low storage capacity. For the exam, remember that disk cleanup is used to remove unnecessary files and free up disk space, making it an essential tool for maintaining system performance and storage efficiency. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Optimize drives. Optimize drives, formerly known as Disk Defragmenter, is a Microsoft Windows utility that is used to improve storage performance by reorganizing data on a drive. Over time, files on traditional hard disk drives can become fragmented, meaning pieces of a file are stored in different locations on the disk. This can slow down read and write operations because the system must work harder to access the entire file. To better understand how this tool works, it helps to understand fragmentation. On a traditional hard disk drive, data is stored on spinning platters. When files are saved, they may not always be written in one continuous block. As files are modified or deleted, gaps form, and new data is written into these spaces. This leads to fragmentation, where a single file is scattered across multiple locations on the disk. Optimized drives resolves this issue by reorganizing fragmented data so that files are stored more contiguously. This reduces the time it takes for the drive to access data, improving overall system performance. However, it's important to note that this process primarily benefits traditional hard disk drives, or HDDs. Now that you understand how optimized drives is used, let's look at how to access it. To open optimized drives using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type dfr.gui.exe and click OK. This command launches the Optimize Drives utility, where you can view the status of your drives and manually start optimization. After opening the tool, the next step is knowing where to focus your attention. Begin by reviewing the current status column for each drive to determine whether optimization is needed. Drives marked as OK are functioning properly, while those showing needs optimization may be fragmented. If a drive requires attention, you can manually select it and choose Analyze or Optimize to run the process immediately. For ongoing maintenance, it is best practice to configure a schedule so that Windows automatically analyzes and optimizes drives on a regular basis. This helps maintain system performance without requiring manual intervention. Finally, it's important to understand why the Optimize Drives utility matters in an IT environment. It helps maintain storage performance, especially on systems using traditional hard disk drives, and ensures that SSDs continue to operate efficiently through proper maintenance. For the exam, remember that Optimize Drives is used to improve storage performance by defragmenting HDDs and optimizing SSDs, making it an important tool for maintaining system efficiency. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. Registry Editor. Registry Editor is a Microsoft Windows utility that is used to view and modify the Windows registry, which is a centralized database that stores configuration settings for the operating system, hardware, and installed applications. These settings control how the system behaves, including user preferences, system policies, and application configurations. The Registry Editor can be used to tweak settings that aren't accessible through the standard Windows interface. It provides direct access to the underlying configuration database that controls how Windows and many applications operate. This makes it a powerful tool for enabling hidden features, resolving stubborn issues that other tools can't fix, and fine-tuning system behavior beyond what is available in normal settings menus. However, because the registry directly affects how the operating system functions, even a small mistake can have significant consequences. Deleting or modifying the wrong key can lead to system instability, application failures, or even prevent Windows from booting. Just remember, with great power comes great responsibility. Always back up the registry before making changes and proceed carefully. To better understand how this tool works, it helps to look at how the Windows registry is organized. The registry uses a hierarchical structure made up of keys and values, similar to folders and files. Keys contain subkeys and values, and each value stores specific configuration data. This structure allows Windows and applications to quickly retrieve the settings they need to function properly. With this structure in mind, you can start to see how Registry Editor works in practice. It allows you to navigate through the registry, view configuration data, and make changes when necessary. Because of its low-level access, it is typically used for advanced troubleshooting when other tools or settings have not resolved an issue. Now that you understand how Registry Editor is used, let's look at how to access it. To open Registry Editor using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type regedit.exe and click OK. This command launches the Registry Editor utility, where you can browse and modify registry settings. After opening the tool, the next step is knowing where to focus your attention. The main sections of the registry are called root keys, such as HKey current user, HKey local machine, and HKey users. These root keys organize different types of configuration data. For example, HKey current user contains settings specific to the currently logged in user, while HKey local machine stores system-wide settings that apply to the entire computer. HKey users includes profiles for all user accounts on the system. As you navigate through the registry, you can expand keys to explore deeper levels of the hierarchy. The left pane displays the structure of keys and subkeys, while the right pane shows the associated values and their data. Each value represents a specific configuration setting, such as a path, flag, or parameter used by the system or an application. Finally, it's important to understand why Registry Editor matters in an IT environment. It provides access to low-level system settings that are not available through standard tools, making it essential for advanced troubleshooting and system customization. For the exam, remember that Registry Editor is used to view and modify the Windows registry, making it a powerful but potentially risky tool that should be used carefully when troubleshooting or configuring system settings. Exam Objective 1.4, given a scenario, use Microsoft Windows operating system features and tools. MMC. At this point, you've seen a wide range of Windows administrative tools, and while they may seem separate, many of them are actually built on the same underlying framework, the Microsoft Management Console, or MMC. MMC is a framework in Windows that allows administrators to load and manage various administrative tools, known as snap-ins, from a single interface. Tools such as Device Manager, disk management, event viewer, certificate manager, and local users and groups can all be accessed as MMC snap-ins. Rather than opening each tool individually, MMC allows you to bring multiple tools together into one centralized console. For example, a system administrator could create a custom console that includes event viewer, device manager, and local users and groups, making it easier to manage and troubleshoot a system without switching between multiple windows. Now that you understand how MMC is used, let's look at how to access it. To open MMC using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type MMC, and click OK. This command will open a blank console window. From there, select File, then add Remove Snap-in, and choose from a list of available administrative tools to add to your console. Once added, these snap-ins appear in a single interface, allowing you to switch between tools quickly and efficiently. You can also save these customized consoles for future use, which is especially helpful in enterprise environments where administrators perform repetitive tasks. Bringing this all together, MMC serves as the foundation for many of the administrative tools covered in this section. While you may typically launch tools individually, understanding MMC helps you see how these tools are connected and how they can be managed more efficiently. For the exam, remember that Microsoft Management Console is used to host and organize administrative tools through snap-ins, making it a centralized and customizable management framework in Windows. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Command line navigation. Navigating the Windows command line interface, or CLI for short, is an essential skill for IT professionals because, believe it or not, sometimes you won't have the luxury of a graphical user interface. Picture it like this: the CLI is your backstage pass to the inner workings of your computer. Thus, a bit of CLI knowledge goes a long way. In this video segment, we will cover some basic commands that will significantly enhance your ability to navigate and manage files and folders from within the CLI. So let's dive in and become command line wizards. Before we start working with commands, let's take a quick moment to understand what the command line interface, or CLI, actually is. The CLI, short for Command Line Interface, is a text-based way to interact with your operating system. Instead of clicking icons and menus like you would in a graphical user interface, or GUI, you type commands to tell the system exactly what to do. Now here's an important concept to understand. Even when you're using a GUI, like clicking through File Explorer, the system is still running commands in the background. The GUI acts as a middleman, translating your clicks into commands the operating system can understand. By using the CLI, you remove that visual layer and gain direct control over the system. This makes it especially useful for troubleshooting, automating tasks, and working in environments where a graphical interface may not be available. In Windows, the two main CLI tools you'll encounter are Command Prompt and PowerShell. Command Prompt is the traditional tool that has been part of Windows for many years and is commonly used for basic file navigation and system tasks, like the commands we'll be covering in this video segment. PowerShell builds on that foundation and provides more advanced capabilities. It is designed with system administrators in mind and allows for more powerful command execution, scripting, and automation. For example, while Command Prompt focuses on simple, text-based commands, PowerShell can work with scripts and structured data, making it much more flexible for managing systems at scale. For the purposes of this video segment, the commands we are learning can be used in both Command Prompt and PowerShell, so the skills you build here will apply across both tools. Now that you understand what the CLI is, and how it works, let's look at how to access these tools. To open Command Prompt or PowerShell using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, you can type CMD to launch Command Prompt, or type PowerShell to launch PowerShell, then click OK. Either command will open a command line interface where you can begin entering commands and interacting directly with the system. With that foundation in place, let's take a look at some basic commands that will help us navigate the file system from within the CLI. First up, we have the dir or command, which is used to list the contents of the current directory, displaying subdirectories and files within it. This command is particularly useful for quickly viewing the contents of a directory and obtaining information about the subdirectories and files stored there. When you type dir and hit enter, you'll see a detailed list of everything in your current location. For instance, if you're in Rosie's folder and type dir, once you press the enter key, you'll see subfolders like documents, pictures, and videos. Using the dir command is like having a quick peek inside to see what's available. Next, we have the cd command. Now, think of your computer's file system as a giant filing cabinet with countless drawers and folders. The cd, or change directory command, is like your key to open these drawers and folders. Using cd, you can move into different folders or go back to previous directories, allowing you to access and manage files within those directories. For example, if you type the command cd documents in the CLI, it's like saying, "Take me to the documents folder." Here, we move away from the folder labeled Rosie and towards the documents folder, which is inside it. We call documents, in this case, a subdirectory as it resides inside Rosie's folder. This is also considered a downward movement in the directory structure because you are moving deeper into the hierarchy of folders, from a parent directory, Rosie, to one of its child directories, documents. Conversely, if you type the command cd ... you're telling the system, "Let's go back up one level," similar to stepping out of a subfolder and back into its parent folder. Additionally, you can teleport directly to a specific location in the file system by using an absolute path, such as the command cd /program files. By specifying an absolute path, we can jump directly to the designated folder. No need to take the scenic route through every folder along the way. With dir and cd in your toolkit, you can navigate and explore your computer's file structure like a pro. But wait, there's more. Let's say you want to create a new folder to organize your files. Enter the md command, which stands for make directory, to create, or make, new directories within the file system. You can also use the command mkdir, which does the same thing. For example, type the command md, followed by the name of the directory you wish to create, and voila, the command generates a new folder with that name in the current directory. And with that bit of knowledge, congratulations, you're now a directory creating master. Now, what if you need to remove a folder you no longer need? Meet the rd command, which stands for remove directory, or its twin, rmdir. These commands are your cleanup crew, ready to get rid of empty directories. Remember, they can only delete folders that are completely empty, meaning no sneaky subdirectories or files hiding inside. For our next trick, let's take the backups folder we just created. Now we are going to remove this empty folder using the rd command. To remove it, you simply type rd backups and hit enter. Just like that, the empty backups folder is gone. Easy, right? Now, to wrap things up, let's talk about drive letters. In the Windows operating system, drive letters are like addresses for different storage devices, such as hard drives, SSDs, optical drives, and USB flash drives. Each drive gets a unique letter, like C, D, or E. This system makes it easy to find and manage files across different devices. By default, the main drive, usually where the Windows operating system files are installed, gets the C label. Additional drives or partitions get the next letters in line unless another letter is specifically selected. And there you have it. You now have the basics to navigate and manage files using the Windows CLI. Remember, every great IT professional started right where you are now, learning one command at a time. Keep practicing, don't be afraid to make mistakes, and soon you'll navigate the CLI like a seasoned pro. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Robocopy. The robocopy command, short for robust file copy, is a command line utility used for copying files and directories with a more robust set of features than other available copy commands, such as copy or xcopy. First, it can resume interrupted transfers, picking up where it left off once the connection is restored. This makes it perfect for transferring a large number of files over unreliable connections. Second, it handles dynamic data efficiently, ensuring the destination is always synchronized with the source. Great for environments where files are frequently added or deleted. Third, it can mirror entire directories, making it perfect for backup solutions where an exact copy of the source directory is needed. Think of RoboCopy as the superhero of file copying, designed to handle complex tasks with ease. Suppose you want to copy a directory, called projects, from your local computer to a network share, named projects, located on a device, named server 1. You want to ensure that the copy can resume if interrupted and that it mirrors the source directory. You would use the following command: RoboCopy, followed by the source location, which is /users, /your username, /documents, /projects. This is followed by the destination, //server1, /projects. As for options, we will be using the /mir option, which tells RoboCopy to mirror the source directory to the destination, including all subdirectories and files, as well as delete files in the destination that no longer exist in the source. Next, the /z option will tell RoboCopy to copy the files in restartable mode, which means it can resume the copying process if interrupted. Once you press enter, the process will begin. The copy process will also be accompanied by a detailed output of events. In summary, RoboCopy is the superhero of file copying utilities, offering advanced features that outshine other copy commands, such as copy and xcopy. It's perfect for transferring a large number of files over unreliable connections, as it can resume interrupted processes. Additionally, it excels in dynamic environments, providing the ability to mirror data accurately for backup purposes. So, next time you need to handle complex file transfers, call on RoboCopy, the superhero your files deserve. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. ipconfig. The command line interface comes with a vast array of tools. We just learned how to navigate and manipulate the different file systems of a device. Now, let's explore the other tools the CLI has to offer. In the next several video segments, we will do just that. First up on our journey is a tool that every IT professional should be familiar with: ipconfig. The ipconfig command is a powerful utility used in Windows operating systems to display and manage the network settings of a computer. It provides crucial information about your network interfaces, such as the device's network or host name, IP addresses, subnet masks, and default gateways, helping IT professionals troubleshoot and configure network connections. Alright, let's roll up our sleeves and get cozy with ipconfig. Imagine your computer as a busy office, and the ipconfig command as your go-to office manager who knows everything about the network setup. When you type ipconfig in the command prompt and press enter, you're essentially asking this office manager to give you a detailed rundown of the network status. The most basic use of the command is to type the command by itself. Some of the items we need to know and pay attention to at this point in our studies are the IP address assigned to your network adapters, the subnet masks defining your local networks, and the default gateways, which is the pathway your computer uses to communicate with other networks like the internet. Now, let's delve deeper with ipconfig/all. This command provides even more comprehensive information about your network configuration. When you run ipconfig/all, you get detailed information about each network adapter, including the device's host name, the physical hardware or MAC addresses for each network adapter, DHCP server information, DNS server information, and more. This is incredibly useful for troubleshooting more complex network issues and understanding the complete network configuration. Now, that information might be helpful, but ipconfig is more than just a status report. It can also help you actively manage your network settings. For example, if your computer can't connect to the network, you might need to refresh your IP address. If you are working with a DHCP server, you can do this by typing ipconfig/release, which releases your current DHCP settings, followed by ipconfig/renew, which requests new settings from the DHCP server. Think of this as asking the office manager to reassign your desk to a new location. It can resolve conflicts and get you back online with a fresh start. Another useful feature is ipconfig/flush DNS. DNS, or Domain Name System, is like the Office phone directory, translating website names and host names into IP addresses so you can find and connect to them. Sometimes, this directory gets outdated or corrupted, leading to connection problems. Running ipconfig/flush DNS clears out the old entries, ensuring your computer gets the latest information. It's like updating the Office directory to ensure everyone's extension numbers are current. For more detailed troubleshooting, you can use ipconfig/display DNS to view the current DNS entries cached on your computer. This can help you identify if there are outdated or incorrect entries causing issues. Let's consider a real-world scenario. Suppose you're in an office and a colleague can't access the company's shared files. The first step might be to run ipconfig on their computer to check their network settings. If you find that their IP address is missing or incorrect, you might choose to use ipconfig/release and ipconfig/renew to obtain a new IP address from the DHCP server. If they're having trouble accessing a specific website, ipconfig/flush DNS might help by clearing out any problematic DNS entries. Either way, at least you have one more tool you can use when network issues arise. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Ping. Let's continue our journey through the CLI toolbox and explore another essential tool, ping. The ping command is a network utility used to test the reachability of a host on an IP network. Ping can also measure the round-trip time for messages sent between two devices. It's one of the most fundamental tools for network diagnostics. Imagine you're trying to contact a friend to see if they're home. You send a message and wait for a response. If they reply, you know they're there and how long it took for them to respond. Similarly, ping sends out small packets of data, known as echo requests to a specific IP address and waits for a response, known as echo replies. This process helps determine if the destination host is reachable and how long it takes for the packets to travel to the destination and back. When you use the ping command, you can quickly determine if there is a network connection between your computer and another device. For example, to ping Google's DNS server, you would type ping 8.8.8.8. In this example, the command sends 4 packets to the IP address 8.8.8.8 and receives replies from it. The results show the round-trip time for each packet and a summary of the statistics, including the number of packets sent, received, and lost. A 0% loss indicates a stable connection to the target IP address. The ping command can be particularly useful in various scenarios. For basic connectivity tests, if a user reports they can't access a website or service, the first step is to ping the server to check if it is reachable. If you get replies, the server is reachable, and the issue might be with something other than network connectivity. For latency measurement, the time it takes for the packets to travel back and forth, measured in milliseconds, helps gauge the latency of the connection. High latency can indicate network congestion or issues with the network path. For packet loss detection, if packets are lost during the ping test, it suggests there might be a problem with the network link or the destination server, indicating potential issues like network congestion, faulty hardware, or misconfigurations. The ping command is a simple yet powerful tool that can quickly give you insights into your network's health. By understanding and using ping, you can efficiently diagnose and troubleshoot network connectivity issues, ensuring smooth and reliable communication within your network. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. TraceRT. The TraceRT command, short for traceroute, is a network diagnostic tool used to track the path that data packets take from your computer to a destination host. It shows each router, or hop, along the way, including the time it takes to reach each router, helping identify where delays or failures occur in the network route. Imagine you're sending a letter through the mail, and you want to know every post office it passes through before reaching its final destination. The traceRT command does something similar but for data packets. It sends packets to the destination and records each router, or hop, that forwards the packet along the way. To use the traceRT command, you simply type traceRT followed by the domain name or IP address of the destination you want to trace. For example, to trace the route to google.com, you would type traceRT, google.com and press enter. In this example, the traceRT command shows the route taken by packets to reach google.com. Each line represents a hop, including the round-trip time in milliseconds for each of 3 probes sent to each hop. The IP address or hostname of each router along the path is also displayed, allowing you to identify where any delays or issues might occur. The traceRT command is particularly useful in identifying network bottlenecks. If you experience slow network performance, traceRT can help you pinpoint where the delay is occurring. By analyzing the time taken for each hop, you can identify if a specific router or network segment is causing the slowdown. While the previously learned ping command can tell you if there's a delay, traceRT can show you exactly where the delay is happening. Additionally, it is invaluable for troubleshooting connection issues. If you cannot reach a particular website or service, traceRT can help determine where the connection is failing. By seeing the last successful hop, you can identify whether the issue is within your local network, with your ISP, or further along the path. Unlike ping, which just tells you if the destination is reachable, traceRT provides a step-by-step path to diagnose where the connection stops. Lastly, traceRT helps in understanding network topology. It provides a visual representation of the path data takes through the network, helping you understand the topology and relationships between different network segments and routers. By understanding and using traceRT, you can gain insights into the paths your data takes, identify points of failure or delay, and understand the structure of the networks you interact with. This complements the ping command by providing a more detailed view of the network path and identifying specific points of failure. So, next time you face a network challenge, remember to use traceRT. It's your tool for mapping the journey of your data. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Path ping. The path ping command is a network utility that combines the functionality of ping and traceRT to provide detailed information about network latency and packet loss at each hop between a source and destination. This makes path ping a powerful tool for diagnosing network issues, as it offers more comprehensive insights than either ping or traceRT alone. Imagine you're not only sending a letter through the mail and tracking each post office it passes through but also checking the time taken and potential delays at each stop. The path ping command does just that for data packets. It first traces the route to the destination and then pings each hop along the route multiple times, providing statistics that help identify where packet loss and latency occur. To use the path ping command, you type path ping followed by the domain name or IP address of the destination you want to analyze. For example, to analyze the path to google.com, you would type path ping google.com and press enter. In this example, path ping first shows the route taken by packets to reach google.com, similar to traceRT. It then provides detailed statistics for each hop, including round-trip time and packet loss. This helps pinpoint where delays and packet loss occur along the route, offering more detailed diagnostics than ping or traceRT alone. The path ping command is particularly useful when investigating unstable or intermittent connections, as path ping helps in understanding network performance over time. By analyzing the path and computing statistics for each hop, path ping provides a comprehensive view of the network's health, which is essential for diagnosing intermittent issues that may not be apparent with a simple ping or traceRT test. The path ping command is a versatile tool for network troubleshooting and performance analysis. By understanding and using path ping, you can gain deep insights into the paths your data takes, identify points of failure or delay, and understand the overall health of the networks you interact with. This complements both ping and traceRT by providing a more detailed and comprehensive view of network performance. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Netstat. The netstat command, short for network statistics, is a powerful network utility that provides detailed information about network connections, routing tables, and interface statistics. To better understand this command, imagine you're the manager of a super busy office, and you want to see all the phone calls happening at any given moment. The netstat command provides a similar function for your network, giving you a snapshot of all active connections, listening ports, and network interfaces. To use the netstat command, you simply type netstat in the command prompt and press enter. In this example, the netstat command displays all active connections, including the protocol, be it TCP or UDP, local address and port number, foreign address and port number, and the state of each connection. This information helps you understand which connections are established, waiting, or closing. For more detailed statistics, the -E option provides interface statistics, which includes information about the number of bytes and packets sent and received. This detailed information helps monitor and analyze network performance and detect issues such as packet loss or errors. Let's consider a real-world scenario. Suppose you're a technician troubleshooting a laptop that's experiencing slow internet speeds. The user reports that everything was working fine until recently, and now the connection is sluggish, even though they're not running any new programs. You suspect that some background services might be using extra bandwidth, causing the slowdown. Luckily, you now know about the netstat command, which helps you view and monitor active network connections. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. NSLOOKUP. NSLOOKUP is a command line utility used to query DNS, or domain name system servers, and retrieve information about domain names and IP addresses. It is essential for diagnosing DNS-related issues and verifying that DNS records are correctly configured. DNS functions like the Internet's phonebook, translating human-friendly domain names like example.com into IP addresses that computers use to communicate. The NSLOOKUP command allows you to interact with DNS servers to resolve domain names, check various types of DNS records, and troubleshoot connectivity issues. It can be used to identify whether problems accessing a website or service are due to DNS misconfigurations or other network issues. Imagine you're an IT technician, and a user reports that they cannot access Google's website. They're getting an error saying the site, google.com, can't be found. This kind of issue might be related to DNS problems. To investigate this, you can turn to a trusty tool called NSLOOKUP. First, let's see how NSLOOKUP can be used to resolve a domain name to an IP address. To do this, open the command prompt and type NSLOOKUP followed by the domain name, google.com, and press enter. If you do, the output will look something like this. In this example, NSLOOKUP contacts the DNS server configured on your computer and requests the IP address for google.com. The response shows the IP address, 172.217.5.238, indicating that the DNS resolution is working correctly for this site. Well, assuming the IP address displayed is indeed the address of google.com's web server. The versatility of NSLOOKUP makes it an indispensable tool for any IT professional. Whether you're troubleshooting website accessibility, email delivery issues, or verifying DNS record updates, NSLOOKUP provides the insights you need to diagnose and resolve DNS-related problems efficiently. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. NetUse. The NetUse command is a command line utility used to connect, remove, and configure shared resources like network drives and printers. The NetUse command allows users to map network drives and connect to shared resources easily. Think of it as a way to create a shortcut on your computer that directly links to a folder or printer on another computer within your network. This can be particularly useful in office environments where multiple users need to access shared files or printers. By using NetUse, you can set up these connections quickly and efficiently. For example, suppose you want to connect to a shared folder named Project, located on a device named Server 1. You can map this shared folder to a drive letter on your local device, let's say the drive letter Z, by typing netuse z:// server1 /project. Once the command is executed, drive Z will appear in your device, and you can access the contents of the shared folder, named Project, as if it were a local drive on your computer. The netuse command is useful in several ways. It simplifies access to shared resources, making it easy for users to find and use files and printers located on other computers within the network. Additionally, it helps in maintaining a consistent work environment by allowing network drives and printers to be reconnected automatically every time a user logs in. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. NetUser. The NetUser command is a command line utility used to manage user accounts on a computer or domain. In simple terms, the NetUser command lets you add, modify, and delete user accounts on your Windows system. Think of it as a tool to help you create new users, change passwords, and configure account settings without needing to navigate through various menus and windows. This command is particularly useful for system administrators who need to manage multiple user accounts efficiently. Now, a quick note: don't confuse NetUser with NetUse. That would be rather embarrassing. Let's see an example of how the NetUser command works. Suppose you want to create a new user account named John, with the password CompTIA123. You can do this by opening the command prompt with administrative privileges and typing NetUser John, CompTIA123 /add. Then you would press enter and execute the command. This command creates a new user account, named John, with the specified password. If you need to change the password for John, you can use a similar command. NetUser John new password 456. This changes the password for the user account, John, to new password 456. If you want to delete the user account, you can do so with the command NetUser John /delete. Once you execute this command, the user account John will be removed. In summary, the NetUser command is a powerful tool for managing user accounts on Windows systems. By mastering this command, you can streamline user account management, enhance security, and ensure that all users have the appropriate access to resources. Just don't forget, NetUser is for managing user accounts, while NetUse is for managing network connections. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Hostname. The hostname command is a simple yet important tool used to display the hostname of your computer. The hostname is a unique name assigned to a computer on a network, making it easier to identify and communicate with other devices within the network. Imagine you're in a room full of people, and each person has a unique name. These names make it possible to address and communicate with specific individuals directly. Similarly, in a network, each device is given a unique hostname to distinguish it from others. The hostname command helps you check the name of your device. To use the hostname command to display the current hostname, you simply type hostname in the command prompt and press enter. In this example, desktop-1234 is the hostname of the computer. This command quickly tells you the unique name assigned to the device, which is especially useful in network environments where you need to identify or differentiate between multiple devices. This is the same hostname that is provided using the ipconfig command, but wasn't this a heck of a lot easier? Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. WinVer. The WinVer command, short for Windows version, is a simple command designed to display the current version of the Windows operating system installed on your computer. Basically, it helps you find out which version of Windows you're using, including details such as the version number, build number, and the edition of Windows. Knowing your Windows version is important for troubleshooting issues, ensuring compatibility with software, and following specific instructions for updates or configurations. Suppose you need to check your Windows version because a new software application requires a specific version of Windows to install. To use the WinVer command, open the command prompt and type WinVer and press enter. A window will then pop up displaying the information about your Windows version, including the version number, build number, and edition. Imagine you are trying to install a new application that requires Windows 11 version 22H2 or later. Given the example behind me, Do we meet that requirement? If you know the answer, leave a comment. In summary, the WinVer command is a quick and easy way to check the current version of your Windows operating system. It provides essential information such as the version number, build number, and edition, which can be crucial for troubleshooting and determining software compatibility. By using the WinVer command, you can ensure that your system meets the necessary requirements for various applications and updates, helping you maintain a smooth and functional computing environment. Exam Objective 1.5 Given a scenario, use the appropriate Microsoft command line tools. Who am I? The Who Am I command is a simple yet powerful tool used to display the username of the currently logged in account. This command helps you quickly identify who is actively using the system, which is especially important when managing permissions or troubleshooting access issues. Imagine you're working in a shared office where multiple people use the same computer. Each person logs in with their own account, which determines what they can access and what actions they can perform. The Who Am I command acts like a quick ID check, telling you exactly which user account is currently active. To use the Who Am I command to display the current user, you simply type Who Am I in the command prompt and press Enter. In this example, desktop-1234 \administrator is the current user. The first part, desktop-1234, represents the name of the local computer, while administrator is the username. The Who Am I command is used to quickly identify the currently logged-in user. It displays both the computer or domain name and the username, helping you understand who is actively using the system. This is especially useful when troubleshooting permissions, verifying access, or confirming whether you are logged in with the correct account. Exam Objective 1.5 Given a scenario, use the appropriate Microsoft command line tools. Disk part. The disk part command is a command line utility used to manage disk partitions on a computer. To put it another way, the disk part command lets you create, delete, and modify disk partitions. Think of it as a powerful tool that helps you organize and manage your computer storage. With disk part, you can resize partitions, assign drive letters, and format volumes, among other tasks. This command is especially useful for system administrators and advanced users who need to perform complex disk management operations. Now, this may be a bit beyond the scope of the CompTIA A Plus, Core 2 exam, but I think it would be fun to dive into an example to see how disk part works. Suppose you want to create a new disk partition on a hard drive or volume. Here's how you can do it. Step 1. Open the command prompt with administrative privileges and start by typing the command, diskpart. Step 2. Once diskpart is running, you will want to list all the disks to identify the one you want to work with. This is accomplished by typing list disk. Step 3. Select the disk where you want to create the new partition. Suppose it's disk 1. Then you would type select disk 1. Step 4. Create a new primary partition. To do this, type create partition primary. Step 5. List the partitions to confirm your new partition has been created. This requires the command list partition. Step 6. Format the new partition to prepare it for use. The new partition needs a file system. To format a file system, use the command format fs equals ntfs quick. And the partition will be given an NTFS file system. Step 7. Assign a drive letter to the new partition. I think we will use the letter T in this example. Therefore the command here will be assign letter equals T. Now, the new partition is ready to use and will appear with the drive letter T. The diskpart command is invaluable for managing disk partitions. It provides detailed control for setting up new disks, resizing partitions, and preparing drives for various operating systems. In capable hands, it is also useful for troubleshooting storage issues, optimizing disk usage, and managing complex disk configurations. Exam Objective 1.5 Given a scenario, use the appropriate Microsoft command line tools. Format. The format command, while it has a few functional overlaps with the previously discussed diskpart command, serves a more focused purpose. While diskpart primarily manages disk-related tasks like creating, deleting, and resizing partitions. The format command is designed for erasing data and setting up a new file system on a disk. More specifically, the format command can wipe a disk clean and set it up so that it can store files. Think of it like clearing and organizing a new storage area. Before you can use the area to store items efficiently, you need to remove any old clutter and set it up properly. The format command does this for your disks by erasing existing data and creating a file system structure that your computer can use to read and write files to. If you want to wipe and set up a USB drive, making it ready to store new files, you can use the format command. Imagine you have a USB drive labeled as Drive E, and you want to format it using the NTFS file system. Here's what you do: open the command prompt and type this command, format E://fs:/NTFS. Once you run this command and follow the prompts, the USB drive will be wiped clean and set up with the NTFS file system. Just remember, formatting will erase any data currently on the drive. In summary, while DiskPart provides comprehensive disk management capabilities, format is the go-to command for the specific task of preparing disks by erasing data and setting up a new file system. This makes it particularly useful for repurposing disks, installing new operating systems, and changing file systems, ensuring your storage is clean and ready for use. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. Check disk. Alright, let's jump into yet another disk management tool. Check disk. Check disk is a command line utility used to check the file system of a volume for logical and physical errors. Simply put, it helps identify and fix problems with storage devices, such as bad sectors, lost clusters, and directory errors, which can cause system slowdowns, crashes, and data corruption. By running check disk, a user can potentially recover readable information from bad sectors, ensuring data integrity and improving overall system performance. Additionally, using check disk as part of routine maintenance can prevent disk errors from accumulating, thereby maintaining the reliability and efficiency of the computer. To run a basic check on the C drive, you would type chk, dsk, c:, and then press enter. In this output, the checkdisk command performs 3 stages: examining the basic file system structure, examining file name linkage, and examining security descriptors. It then reports the status of the file system. If errors or bad sectors were found, they would be listed, and additional parameters would be required to fix them. Otherwise, it will report that it found no problems and no further action is required. The check disk command is particularly useful in several scenarios. If a computer is running slowly or experiencing frequent crashes, check disk can identify and fix underlying disk issues causing the problem. When files become corrupt or inaccessible, check disk can help recover the data and repair the file system structures. Regularly running check disk as part of a maintenance schedule can prevent disk errors from accumulating and causing larger issues. By incorporating check disk into routine maintenance, you ensure the health and integrity of your hard drives, leading to improved system performance and reliability. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. SFC. The SFC command, short for System File Checker, is a command line utility used to scan and repair protected system files on a Windows computer. The command helps you ensure that your important system files are intact and not corrupted. Think of it as a health check for your computer's vital files. When you run the SFC command, it scans your system files for any issues. If it finds any corrupted or missing files, it can replace them with the correct versions. This is particularly useful when you encounter error messages about missing or corrupted system files. To use the SFC command, you need to open the command prompt with administrative privileges. Then, in the command prompt window, type sfc/scan now and press enter. This command will start the system file checker and begin scanning all protected system files. If any issues are found, SFC will attempt to repair them by replacing the corrupted or missing files with the correct versions. The SFC command is a valuable tool for maintaining the integrity of your system files. By scanning and repairing corrupted or missing files, It helps resolve various issues that can affect the stability and functionality of your computer. However, there are potential problems to be aware of. If there are underlying hardware issues, such as a failing hard drive, the command might not be able to resolve all problems. In such cases, further troubleshooting such as running the check disk command or possibly replacing faulty hardware may be necessary. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. GP Update. The GP Update command is a command line utility used to refresh group policy settings on a computer. Now, you may remember discussing group policy briefly when we covered Windows operating system features. Or maybe you already forgot. Regardless, I will give you a little refresher. In simple terms, group policies are a way for network administrators to control the working environment of user accounts and computer accounts. Group policy settings dictate various configurations, such as security settings, installed applications, and user interface options. When these settings are updated, the changes do not take effect immediately. That is where the GP Update command comes in. This command forces the computer to apply the latest group policy settings right away, without waiting for the next automatic refresh. Suppose an administrator has made changes to the group policy settings on a domain, such as enforcing a new password policy. To apply these new settings immediately on a computer, you would use the GP Update command. More specifically, this is accomplished by opening the command prompt and typing gpupdate /force and pressing enter. This command tells the computer to immediately refresh and apply all the latest group policy settings, ensuring that any changes made by the administrator are enforced right away. The GP Update command is a handy tool for refreshing group policy settings on a computer, ensuring that any changes made by network administrators are applied immediately. This command is essential for quickly enforcing new policies and configurations without waiting for the next scheduled refresh or system restart. By using GP Update, you can ensure that all group policy changes take effect right away, maintaining a secure and well-configured computing environment. Exam Objective 1.5. Given a scenario, use the appropriate Microsoft command line tools. GP Result. The GP Result command is a command line utility used to display the resultant set of policy, or RSOP information for a user or computer. Plainly put, GP Result helps you see which group policy settings are applied to a user or computer. Group policy is a tool used by network administrators to manage and configure operating systems, applications, and user settings. For example, an administrator might use group policy to enforce password complexity rules, deploy software, or set specific desktop backgrounds across all computers in an organization. Understanding which policies are applied is crucial for a few reasons. First, it helps troubleshoot issues. If a user is experiencing problems, such as not being able to access certain resources or applications behaving unexpectedly, knowing the exact policies applied can provide insight into whether the problem is configuration related. Second, it helps verify that configurations are correctly enforced. Administrators need to ensure that the policies they set are actually being applied to the intended users and computers. If policies are not being enforced as expected, it could lead to security vulnerabilities or inconsistent user experiences. The GP Result command provides a detailed report showing all the policies that are in effect for a specific user or computer. This report includes information about the policies applied, the source of the policies, and any filters that might affect policy application. Having this comprehensive overview helps administrators maintain control over their network environment and ensures that all configurations align with organizational policies. Suppose you want to generate a report to see which group policy settings are applied to the current user and computer. Simply open the command prompt and type GP Result /R. The /R option stands for report, and when you use it, GP Result generates a summary report that is displayed directly in the command prompt window. This report includes detailed information about the group policy settings that are currently applied to both the user and the computer. It shows the policies in effect, the source of these policies, and any filtering that might impact their application. The GP Result command is a useful tool for displaying the resultant set of policy, or RSOP information for a user or computer. It provides a detailed report that helps in troubleshooting issues or verifying that policies are correctly enforced. By using GP Result, you can quickly see which policies are in effect, making it easier to manage and configure network settings efficiently. This command is essential for IT professionals who need to ensure that group policy settings are applied as intended. Exam Objective 1.5 Given a scenario, use the appropriate Microsoft command line tools. Command cheat sheets. Navigating the world of command line utilities can feel like learning a new language. With so many commands and options to remember, it's easy to feel overwhelmed. But don't worry, even the most seasoned IT professionals sometimes need a little help. Fortunately, Windows has a built-in feature that acts as your personal cheat sheet, making it easier to understand and use these commands effectively. If you ever find yourself stuck or wondering what a particular command does or how to use it, you can type the command name followed by a / and a question mark. For most Windows commands, this will bring up a detailed cheat sheet containing all the information you need. It's like asking Windows to explain the command to you. This feature is incredibly helpful because it provides you with the correct command syntax, a list of all available options and parameters, and detailed usage instructions. This ensures you have everything you need to use each command correctly and effectively. Suppose you just learned about a new command, like shutdown, but are not quite sure how to use it. You can open the command prompt and type shutdown / ? And with a single press of the Enter key, you will be shown a help menu with all the details about the shutdown command. So next time you come across a command that you're unsure about, remember to use the / option. This handy feature transforms your command line experience into a manageable, user-friendly process, providing you with a comprehensive cheat sheet that details everything you need to know about the command. Whether you're troubleshooting an issue, configuring a new setup, or simply expanding your command line skills, this built-in help ensures you're never lost or overwhelmed. Embrace this special command option, and let it guide you through the complexities of Windows commands with confidence and ease. Exam Objective 1.6 Given a scenario, configure Microsoft Windows settings. Control Panel. Welcome to Exam Objective 1.6. It is now time to gain some knowledge about the various Microsoft Windows settings, starting with Control Panel, a central hub and trusty sidekick for any Windows user. If Windows were a bustling city, the Control Panel would be its city center, where you can manage everything from user accounts to basic system settings. Now, before you roll your eyes and think, not another tool to remember, let me assure you that the Control Panel is your friend. Compared to some of the more advanced tools we covered in previous objectives, like Performance Monitor or the Registry Editor, the Control Panel is the friendly neighbor who always has a cup of sugar to lend. It's less complex and more intuitive, making it perfect for quick adjustments without needing a deep dive into the more technical aspects of the operating system. Now that you understand what Control Panel is, let's look at how to access it. To open Control Panel using the Windows Run dialog box, press the Windows key plus the letter R. Once the Run dialog box opens, type Control and click OK. This command launches Control Panel. After opening Control Panel, you will be presented with a collection of applets, or small programs, that let you configure various aspects of the Windows operating system. Think of it like a Swiss Army knife for your computer. You can change settings for hardware and software, manage user accounts, and even control the look and feel of Windows. It's all about giving you control over your environment. Looking a bit closer, you'll find numerous categories within the Control Panel, with each category housing specific applets. As you click around, some selections will take you deeper into the Control Panel, while other selections will open an applet in a separate window. You may even be directed towards Windows settings, but we will talk more about that later in this objective. As for the next several video segments, we will look at some of these applets and discuss some of the things they can do. Exam Objective 1.6 Given a scenario, configure Microsoft Windows settings. Internet Options. Our next topic takes us into the Internet Options applet. This Control Panel utility is your command center for everything related to your internet connection and browsing experience. So let's dive in and explore this applet and its functionalities. Before I begin, if you are following along with your own Windows device and your control panel looks a bit different, try adjusting your view settings. I am currently using the large icons view. Now, when you open Internet Options, you'll be greeted with several tabs, each designed to give you control over different aspects of your Internet experience. Here's a quick rundown. The General tab is your starting point. It lets you manage your browsing history and customize your browsing tabs. You can also use this section to clear your browsing history and cache, which is particularly useful if you're troubleshooting browser issues, like experiencing outdated images while browsing websites. This tab also allows you to manage your search settings and appearance options, like colors and fonts, giving you a personalized browsing experience. The Security tab is all about keeping you safe. You can adjust the security levels for different internet zones, such as the internet, local internet, trusted sites, and restricted sites. It's like setting up different levels of fortifications based on the trustworthiness of the site you're visiting. Higher security levels can protect you from malicious content, but might restrict the functionality of certain websites. On the Privacy tab, you can manage your privacy settings, including cookie management, pop-up blockers, and location services. Want to keep those cookie monsters at bay? This tab is your shield. You can adjust the privacy slider to block all cookies, block only third-party cookies, or allow all cookies based on your comfort level with website tracking. The Content tab lets you control content-related settings. You can manage certificates and handle autocomplete settings. This tab also allows you to manage forms and passwords, so your browser can autofill information for you. The Connections tab is where things get interesting, especially when it comes to proxy settings. This tab allows you to set up and manage your internet connections, whether it's dial-up, VPN, or LAN settings. Under LAN settings, you can configure your proxy server. A proxy server acts as a middleman between your computer and the internet, which can enhance security and manage bandwidth. This is particularly useful in corporate environments where monitoring and filtering internet traffic is necessary. You can also set up VPN connections to securely access remote networks. The Programs tab is all about managing your internet programs and add-ons. You can set your default web browser, manage add-ons, and control how other programs connect to the internet. This tab acts as a central point for all your internet software. Also, if you use multiple browsers, you can specify which one should handle certain types of links and file associations. Lastly, the Advanced tab is a treasure trove of advanced settings. Here, you can tweak various browser settings, enable or disable features, and restore defaults if things go awry. It's the place for those who like to fine-tune every aspect of their internet experience. So whether you're tweaking security settings, managing privacy, or setting up a proxy server, the Internet Options applet is your gateway to a more personalized and secure browsing environment. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Devices and printers. Our next stop on the control panel tour is Devices and Printers. This is the location where you can see and manage all the devices connected to your computer, from printers and scanners to external hard drives and monitors, as well as a few other items sprinkled in between. When you open Devices and Printers in Windows 10, you will be taken deeper into the Control Panel utility, where you will see a list of icons representing your devices. Each icon provides a quick visual of what's connected to your system. This utility makes it easy to add, remove, and troubleshoot devices. Now, some of you may have noticed that the highlighted printer icon here is grayed out. This means that it is not currently available for use. This typically happens for a few reasons. It could be a permissions issue, where only an administrator has access to those settings. Alternatively, the device might not be fully installed or connected. For instance, if your printer is offline or has a driver issue. Now, let's focus on what happens when you right-click on a printer. Right-clicking on your printer icon opens up a menu with several options. First, there's See What's Printing. This option opens the print queue, where you can view and manage current and pending print jobs. You can pause, restart, or cancel print jobs from this window. Next, we have Set as Default Printer. If you have multiple printers, this option allows you to set one as your default. The default printer is the one that will be automatically selected when you print from any application and is designated by the green circle with a check mark inside. Then, there's Printing Preferences. This option lets you customize your print settings. You can choose paper size, orientation, print quality, and other preferences specific to your printer model. Another useful option is Printer Properties. This opens a more detailed settings menu where you can configure various aspects of your printer. Here, you can change the printer name, adjust ports, and manage driver settings. It's also where you'll find printer sharing and security options. If you're having issues with your printer, you'll want to use Troubleshoot. This option starts a troubleshooting wizard that attempts to diagnose and fix common problems, such as connectivity issues or driver conflicts. Lastly, there's Remove Device. If you no longer use the printer or it's causing issues, you can remove it from your system. This option uninstalls the printer drivers and removes the printer from the devices and printers list. Now, if you're using Windows 11, things look a little different. Instead of opening directly into the Devices and Printers window of Control Panel, selecting this option will typically redirect you to the Bluetooth and Devices section of the Windows Settings utility. From here, you can still manage many of your connected devices, such as Bluetooth devices, printers, and other peripherals. However, this interface is more streamlined and doesn't show the same classic layout we just explored. If you need access to the classic Devices and Printers control panel view in Windows 11, you can still get there. First, select Devices from the Bluetooth and Devices menu in Windows Settings. Then scroll down and select More Devices and Printer Settings. This will open the classic Devices and Printers window within the control panel. So regardless of whether you're using Windows 10 or Windows 11, you will still have access to the tools needed to add a new device, troubleshoot an issue with an existing device, or adjust a device's settings. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Programs and Features. In this video segment, it is time to explore the control panel's Programs and Features utility. In Windows, this is where you go when you want to manage all the software installed on your computer. Whether you need to uninstall a program, make changes to existing software, or repair an application, Programs and Features has you covered. When you open Programs and Features, you'll see a straightforward interface that lists all the programs installed on your computer. The main pane displays each program's name, along with additional details like the publisher, installation date, size, and version number. This information helps you quickly identify which programs are installed and how much space they occupy. From here, you can perform several actions to keep your system running smoothly. First up, there's Uninstall. If you have software that you no longer need or that's causing issues, you can select it from the list and click Uninstall. This will remove the program from your computer, freeing up space and potentially resolving conflicts with other software. Next is Change. Some programs offer the option to change or modify the installation. This could include adding or removing specific features within the software. For instance, if you have a Microsoft Office suite installed, you might choose to add a component like Excel if it wasn't installed initially. Then there's Repair. If a program is not working correctly, selecting Repair can fix missing or corrupted files. This option is especially useful for troubleshooting without completely uninstalling and reinstalling the software. Now, let's talk about the link located in the top left of the window pane, labeled Turn Windows Features On or Off. Clicking this link opens a new dialog box with a list of optional Windows features that you can enable or disable. Imagine you need to run a legacy application that requires an older version of .NET Framework. Instead of downloading and installing it manually, you can check the box next to the .NET Framework version you need and Windows will take care of the rest. Or, if you want to save resources, you might disable features like Internet Explorer or Windows Media Player if you don't use them. So, whether you're uninstalling a program, modifying an existing installation, repairing a broken application, or enabling and disabling Windows features, Programs and Features gives you the tools you need to manage your software effectively. Keeping your system clean and properly configured is a key part of maintaining performance and stability. So, the next time you run into a problematic application or just want to clean up unused software, head over to Programs and Features and take control of your software environment. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Network and Sharing Center. The Network and Sharing Center is a control panel utility that acts as a central hub for all things related to network connectivity on your Windows computer. It provides a comprehensive overview of your network status, connections, and settings, allowing you to manage and troubleshoot your network environment efficiently. When you open the Network and Sharing Center, you'll be greeted by a clean, intuitive interface. At the top, you'll see your active network connections, indicating whether you're connected to the internet and which network you're currently using. This overview helps you quickly understand your connection status at a glance. Now, before we get distracted by the many features available here, let's head over to the link on the top left, labeled Change Your Adapter Settings. Clicking on this link opens a new window displaying all your network adapters, such as Bluetooth, Ethernet, and Wi-Fi connections. This window is where you can manage the hardware and software that enables your computer to connect to various networks. From this window, you can perform several crucial actions, such as enabling and disabling individual adapters. If you need to temporarily disconnect from a network, you can right-click on the adapter and select Disable. This is useful if you want to ensure no network activity occurs during certain tasks. To reconnect, simply right-click the adapter again and select Enable. You can also configure network adapter properties by selecting Properties. This opens up a window where you can access and modify various well-known network settings, such as IP addresses, DNS servers, or more advanced settings like quality of service or network adapter priority metrics. To wrap up, the Network and Sharing Center is your go-to tool for managing network connections and troubleshooting issues. With its intuitive interface and powerful features, you have everything you need to maintain a smooth and reliable network experience. So, the next time you face a network hiccup, head to the Network and Sharing Center and take charge of your connectivity. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. System. Alright, our next stop in the control panel tour is the System utility. This is where you can view and manage key aspects of your computer's hardware and operating system settings. In this video segment, I will break down what happens when you select System from the control panel, explain its overall purpose, and walk through a couple use case scenarios. When you select System from the control panel, you'll be taken to the About section of the System tab in the Windows Settings app. Here, you'll see a summary of your system specifications, including storage, installed RAM, processor type, and the device name. You'll also find information about your Windows operating system specifications if you scroll down a bit. The overall purpose of this system utility is to provide a central location for viewing detailed information about your computer's hardware and operating system. It also offers quick access to tools for managing system performance, configuring hardware settings, and troubleshooting issues. Since there is so much we can do here, let's walk through a basic change just to give you an idea of this utility's inner workings. Suppose you've purchased a second monitor and want to extend the Windows desktop to the new screen. Here's how you can do it using the System utility. From the Main System tab, select Display in the navigation pane. This will navigate you to the Display Settings section within Windows Settings. Here you will see your monitors represented as numbered rectangles. You can click Identify to see which number corresponds to each physical monitor if you are not sure which is which. Just to the right of Identify, you have yet another box. Clicking this will give you a drop-down menu. This drop-down menu will provide you with multiple options to control how your displays will behave, including duplicate these displays, extend these displays, show only on one, and show only on two. If you choose duplicate these displays, your desktop will appear the same on both screens. This is useful for presentations or when you want both monitors to show identical content. Selecting Extend these displays allows you to spread your desktop across both monitors. This gives you more workspace, letting you drag windows from one screen to the other, which is ideal for multitasking. The Show Only options allow you to use just one monitor at a time. For example, you might choose to display only on your external monitor when working at a desk, or only on your laptop screen when you're on the go. Now, display settings are just one example of how the system utility allows you to quickly adjust and customize your computer to meet your needs. Let's look at another common scenario. Imagine you're presenting an important project to a client, and notifications keep popping up on your screen. These alerts can be distracting and interrupt your workflow. To prevent this, you can enable Do Not Disturb using the system utility. From the System settings, navigate to Notifications. Once you are in the Notifications section, you will find the option to turn on Do Not Disturb. Enabling this setting will silence notifications so they don't appear on your screen or play sounds. You can also customize this feature further by setting automatic rules, such as turning on Do Not Disturb during certain hours or when you're using specific applications. This helps ensure that interruptions are minimized when you need to stay focused. As you can see, whether you're extending your display for better productivity or silencing notifications to stay focused, the system utility gives you the tools to tailor your computer to your environment and workflow. Whether you're managing display settings, configuring hardware, or controlling system behavior like notifications, the system utility provides a centralized place to adjust how your computer looks, sounds, and performs. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Windows Defender Firewall. For this video segment, let's dive into one of the most critical guardians of your Windows environment, Windows Defender Firewall. This built-in host-based software firewall is like the mighty bouncer standing at the doorway to your computer, ensuring that only the right data packets get through while kicking the unwanted ones to the curb. When you click on Windows Defender Firewall within Control Panel, you will be instantly transported into the command center of your system's security operations. The first screen you land on is the Windows Defender Firewall overview. This dashboard provides a quick summary of your firewall status for different network profiles. Each profile will show whether the firewall is on or off, providing an instant status check of your system's protection. On the left-hand side, a navigation pane offers several key options to manage your firewall settings. The Allow an app or feature through Windows Defender Firewall option lets you create exceptions for specific applications, ensuring they can communicate through the firewall without hindrance. The Turn Windows Defender Firewall on or off option enables you to toggle the firewall settings for each network profile, giving you control over your system's security depending on the environment. If you ever need to revert to the original configurations, Restore Defaults resets all settings back to their default state. The Advanced Settings option is where you can dive deeper into configuring detailed rules and monitoring network activity, while Troubleshoot My Network guides you through diagnosing and resolving common firewall-related network issues. For those seeking more advanced control, clicking on Advanced Settings opens the Windows Defender Firewall with Advanced Security. This powerful tool allows you to manage inbound and outbound rules, create connection security rules to enforce secure communications, and monitor active connections and firewall rules. You can also enable security logging to record firewall activity, which is invaluable for troubleshooting and analyzing security incidents. By taking a bit of time to explore and understand this built-in host-based software firewall, you can gain a comprehensive understanding over your firewall settings, ensuring that your computer remains secure against unwanted intrusions while allowing necessary communications to proceed unhindered. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Mail. Let's dive into our next essential utility in the control panel, Mail. This tool is particularly useful for those managing email accounts, profiles, and data files in Microsoft Outlook. Whether you're a professional juggling multiple email accounts or an individual who wants to keep their emails organized, the Mail utility is your go-to solution. To access the Mail utility, just click the Mail icon to open the Mail applet. Once opened, you will notice that this applet is divided into three main sections: email accounts, data files, and profiles. Each section serves a unique purpose in managing your email configuration. The Email Accounts button allows you to add, remove, and manage your email accounts. This is where you set up new email addresses, configure existing ones, and adjust their settings to ensure smooth email communication. The Data Files section is where you manage the files that store your email messages, calendar events, and other Outlook data. This is crucial for backing up your emails or moving them to a new computer. By clicking Data Files, you can see the list of data files currently used by your email client and add or remove them as needed. This ensures that your important email data is securely stored and easily accessible. The Profiles section is particularly useful if you have multiple users on the same computer or need to manage different email configurations. By clicking Show Profiles, you can create, delete, or manage profiles, allowing you to switch between different sets of email accounts and settings easily. This feature is handy for separating work and personal emails or for troubleshooting email-related issues by testing with a new profile. So whether you're setting up a new email or managing multiple profiles for different aspects of your life, the Mail utility has got you covered. So, go ahead and keep those inboxes organized and your emails flowing. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Sound. Next up on our control panel adventure is the Sound utility. This tool is used for managing all the audio aspects of your Windows system. Whether you're a music enthusiast, a gamer, or just someone who needs their alerts and notifications to be audible, the Sound utility is your gateway to audio bliss. When you click on Sound within the control panel, the Sound applet window opens, presenting you with 4 main tabs: Playback, Recording, Sounds, and Communications. Each tab offers a variety of settings to ensure your audio experience is exactly how you want it. The Playback tab shows a list of all the available playback devices on your system, such as speakers, headphones, and Bluetooth audio devices. Here, you can set your default playback device, configure settings for each device, and even test your audio to make sure everything is working correctly. Switching over to the Recording tab, you'll find a similar list, but this time it's for your input devices, such as microphones. This tab allows you to set up your default recording device, configure its settings, and test the input to ensure your voice is captured loud and clear. The Sounds tab is where you can customize the various sounds that Windows uses for events like notifications, alerts, and system messages. You can choose from a list of preset sounds or even browse your computer to use custom audio files. This tab is perfect for personalizing your system to make it truly yours. Finally, the Communications tab provides settings for how Windows should handle audio during communication activities, like phone calls or video conferences. You can set Windows to automatically adjust the volume of other sounds when it detects communication activity, ensuring you can hear and be heard clearly. So whether you're configuring playback devices, setting up recording equipment, customizing system sounds, or adjusting communication settings, the Sound utility ensures that your audio experience is top-notch. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. User Accounts. This video segment will be dedicated to the User Accounts utility, a vital tool for managing who gets to do what on your Windows device. Whether you're setting up new users, managing passwords, or adjusting account types, this utility helps you keep control over your system's access and security. When you click on User Accounts within the control panel, you will be taken to the User Accounts section. From here, you'll see several options, such as change account name, change your account type, manage another account, and more. These features allow you to customize user accounts to meet individual needs while helping keep your system secure and well organized. To walk through a few of these features, the Change Account Name option allows you to rename an existing user account, making it easier to identify. For example, you might rename an account from guest to visitor to better reflect its purpose. Change your account type lets you switch between standard user and administrator accounts. Standard users have limited access, making them ideal for everyday tasks, while administrators have the ability to make system-wide changes and install software. Because of this, administrator access should only be granted to trusted users to help maintain system security. Manage another account is where you can view and control all user accounts on the system. From here, you can add new users, modify existing accounts, or remove users who no longer need access. You can also reset passwords and configure parental controls, making this a central location for account management. By using these utility, you can effectively manage user accounts, ensuring that each user has the appropriate level of access while keeping your system secure and organized. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Indexing options. Next on our control panel tour is indexing options. This is a powerful feature that optimizes search performance on your Windows system. Whether you're constantly searching for documents, emails, or other files, indexing can significantly speed up the process by cataloging the contents and properties of these files. To access indexing options, open the control panel and give indexing options a click. This will open the indexing options applet. This applet will immediately display all the locations that Windows is currently indexing or cataloging. These locations typically include your personal files, email, and offline files. The goal is to make search operations, performed in the Windows search bar, Windows File Explorer, the Start menu, an email client, or by Cortana, faster and more efficient by creating an index of all these files and their properties. One of the primary features here is the ability to modify indexed locations. By clicking on the Modify button, you can add or remove locations from the indexing list. For example, if you have a new folder where you frequently store documents, you can add it to the indexed locations to ensure it's included in future searches. Conversely, if there's a folder you don't want to be indexed, perhaps an application folder or a directory with sensitive information, you can easily exclude it. To do this, simply uncheck the folder in the list of indexed locations. This helps keep your searches relevant and efficient. By carefully managing what gets indexed, you can ensure that your searches are both fast and relevant. Whether you're adding important new folders to be indexed or excluding unnecessary ones, indexing options provides you with the control you need to customize your search functionality. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Administrative tools. Continuing on with Control Panel, we now come to Administrative Tools. This is essentially a collection of advanced utilities designed for system administrators and power users to manage, monitor, and troubleshoot various aspects of the Windows operating system. Whether you're managing disks, configuring services, or analyzing system performance, Administrative Tools offers a suite of powerful features to get the job done. In Windows 10, this section is labeled Administrative Tools within the control panel. However, in Windows 11, Microsoft has renamed this collection to Windows Tools and shifted its visibility slightly within the interface. While the name has changed, the functionality remains the same. Within this section of Control Panel, you'll find a variety of powerful tools such as Event Viewer, Task Scheduler, Services, Computer Management, Performance Monitor, and more. Each of these tools is designed to help you monitor system activity, manage resources, and troubleshoot issues at a deeper level. Now, many of these tools were already covered earlier in this course under Exam Objective 1.4, so you should already be familiar with how they work and when to use them. Just remember that Administrative Tools, or Windows Tools in Windows 11, provides a centralized location to access all of these utilities in one place, making system management more efficient. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. File Explorer options. Next, let's take a look at File Explorer options. This is where you can configure how files and folders are displayed and how File Explorer behaves overall. These settings are especially useful when you're troubleshooting issues, managing files, or working in environments where file visibility and accuracy are critical. When you open File Explorer options, you'll be presented with a small dialog box that contains several tabs across the top, including General, View, and Search. Each of these tabs groups together related settings that control different aspects of how File Explorer looks and behaves. The General tab focuses on everyday functionality, such as how File Explorer opens and how files and folders are accessed. The View tab provides more advanced display settings, allowing you to control visibility and layout options. The Search tab, which we won't focus on here, is used to configure how searches are performed within File Explorer. At the bottom of the window, you'll also find options to apply changes, restore defaults, or confirm your selections. This layout makes it easy to navigate between different settings and customize File Explorer based on your needs. Let's now take a closer look at some of the specific settings within File Explorer options that are important for the exam. First, we have View Hidden Files. This setting is found under the View tab and controls whether hidden files and folders are visible. By default, Windows hides certain files to protect system integrity. When you enable Show Hidden Files, Folders, and Drives, these items become visible in File Explorer, usually appearing slightly faded compared to regular files. This is especially useful during troubleshooting. For example, application data folders, configuration files, and certain system directories are often hidden. Without enabling this setting, you may not even realize those files exist. However, it's important to use caution when working with hidden files, since modifying them incorrectly can impact system performance or stability. Next is Hide Extensions for known file types. This setting determines whether file extensions are displayed at the end of file names. When enabled, a file like document.txt will appear simply as document. While this may look cleaner, it can also hide important information. Disabling this option will display the full file name, including its extension, such as .exe or .pdf. This is critical for both troubleshooting and security. For example, a malicious file could be named report.pdf.exe, and if extensions are hidden, it may appear to be a harmless PDF file. For this reason, many IT professionals prefer to keep file extensions visible at all times. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Power Options. For our next topic, let's take a closer look at Power Options. This section of the control panel allows you to control how your computer uses energy and balances performance with power consumption. These settings are especially important for laptops, where battery life is critical, but they also apply to desktops when managing performance and system efficiency. At the core of Power Options are power plans. A power plan is a collection of hardware and system settings that control things like CPU performance, screen brightness, and sleep timing. The three most common plans are Balanced, Power Saver, and High Performance. The Balanced plan is the default on most systems. It automatically adjusts performance based on what you're doing, increasing power when needed and reducing it during idle periods. The Power Saver plan reduces system performance to conserve energy. This might dim the display, slow down the processor, and put the system to sleep more quickly. This is ideal for extending battery life on portable devices. The High Performance plan keeps the system running at higher performance levels at all times. This is useful for demanding tasks like video editing or gaming, but it will consume more power and generate more heat. Now that we understand power plans, let's click on the link labeled "Choose what the power buttons do" in order to view a few more settings. From this section, you can control how your system responds when you press the power button, press the sleep button, or close the lid on a laptop. These settings are separated into two columns: on battery and plugged in, allowing you to configure different behaviors depending on whether the device is running on battery power or connected to a power source. Starting at the top, we have when I press the power button. This setting determines what happens when you physically press the power button on your device. You can configure it to shut down, sleep, hibernate, or do nothing. For example, in an office environment, you might set this to sleep for quick access later, while on a shared or public system, you may prefer shut down for added security. Next is when I press the sleep button. Not all systems have a dedicated sleep button, but if they do, this setting allows you to define its behavior. Typically, this is set to sleep, allowing the system to quickly enter a low-power state. However, you can also configure it to hibernate or do nothing depending on your needs. Below that is when I close the lid. This setting is specific to laptops and is commonly used in real-world scenarios. You can configure the system to sleep, hibernate, shut down, or do nothing when the lid is closed. For example, if you're using a laptop with an external monitor, keyboard, and mouse, you might choose do nothing so the system continues running even when the lid is closed. On the other hand, if you're trying to conserve battery life while traveling, setting it to sleep or hibernate would be more appropriate. As you move further down, you'll see the shutdown settings section. This area allows you to control which power options are available in the start menu. Options like sleep, hibernate, and lock can be enabled or disabled, giving you control over what users can access from the power menu. You'll also notice the option turn on fast startup. Fast startup is a feature that helps your system boot more quickly after a shutdown. It works by saving system information to a file, similar to hibernation, allowing Windows to load faster the next time it starts. While this can significantly improve startup times, it can sometimes cause issues with updates, hardware changes, or dual boot systems, so it may need to be disabled during troubleshooting. Now, let's briefly revisit some key terms. Sleep, also known as suspend, places the system into a low-power state while keeping your current session stored in RAM. This allows you to resume your work almost instantly. However, because RAM still requires power, the system will continue to use a small amount of battery. Standby is an older term that is often used interchangeably with sleep. In modern versions of Windows, sleep mode has effectively replaced standby, but you may still see the term referenced in documentation or exam questions. Hibernate, on the other hand, saves your current session to the hard drive and completely powers off the system. When you turn the computer back on, your session is restored exactly as you left it. Since no power is used while the system is off, hibernate is ideal for longer periods of inactivity, especially on laptops where conserving battery life is important. Next, let's take a look at USB Selective Suspend. USB Selective Suspend is a power-saving feature that allows Windows to turn off individual USB ports when they are not in use. Instead of keeping all USB devices powered at all times, the system can temporarily suspend a specific device, such as a mouse, keyboard, or external drive, until it's needed again. This helps conserve energy, especially on laptops, and can extend battery life during periods of inactivity. However, this feature can sometimes cause issues. For example, a USB device may appear to disconnect or become unresponsive, particularly after the system wakes from sleep. In these cases, disabling USB Selective Suspend can often resolve the problem. To access this setting, select a power plan you wish to change. Next, select Change Advanced Power Settings. In the window that appears, expand USB Settings, and then USB Selective Suspend setting. From here, you can enable or disable the feature for both on battery and plugged-in configurations. Finally, let's take a look at how we can manage power settings from the CLI with the Power Config command. The Power Config command is a powerful tool that allows you to view and modify power settings directly from the command line interface. This is especially useful in administrative or enterprise environments where you may need to configure multiple systems quickly. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. Ease of access. Our final topic in our control panel tour is ease of access. This utility is used for customizing your Windows system to meet the needs of users with various disabilities. Whether you're setting up accessibility features for yourself or configuring a computer for someone else, ease of access provides numerous tools to enhance usability. To start working with the Ease of Access utility, open the Control panel, locate Ease of Access, and select it. This will take you into the Ease of Access Center, which serves as the main hub for configuring accessibility features in Windows. Once inside, you'll notice the layout is designed to guide users from basic tools to more advanced customization options. At the top of the window, you'll see a section labeled Quick Access to Common Tools. This area provides one-click access to some of the most frequently used accessibility features, allowing you to quickly enable them without navigating through multiple menus. These tools include magnifier, narrator, on-screen keyboard, and high contrast. Each of these is designed to support different accessibility needs. For example, magnifier allows you to zoom in on portions of the screen, making text and images easier to see. Narrator reads text aloud, which is helpful for users with limited vision. The on-screen keyboard provides a way to type without a physical keyboard, and high contrast adjusts the display's color scheme to improve visibility. Moving down the window, you'll find the Explore All Settings section. This is where you can access more detailed configuration options and tailor the system to specific user needs. For instance, use the computer without a display includes settings designed for users with little or no vision, such as enabling screen readers and audio descriptions. Make the computer easier to see provides additional visual customization options, including adjusting text size, improving contrast, and enabling visual alerts for system sounds. You'll also find use the computer without a mouse or keyboard, which focuses on alternative input methods. This includes tools like speech recognition and on-screen input, allowing users to interact with the system in ways that don't rely on traditional hardware. Together, these tools allow you to customize how you see, hear, and interact with your system, making Windows more accessible and easier to use for a wide range of users. In addition to the control panel interface, these accessibility features can also be found within the Windows Settings app, under Accessibility. While the layout may differ, the tools and overall functionality remain the same, giving you multiple ways to access and configure these features based on your preference. Exam Objective 1.6, given a scenario, configure Microsoft Windows settings. To wrap up Exam Objective 1.6, we will be taking a look at the Windows Settings utility. To access this tool, simply click on the Start menu, select the gear icon, and voila! You're there. This centralized hub is designed to cater to an array of system adjustment needs, offering a user-friendly interface that makes system management as smooth as silk. Now, before I put one more tool in our ever-growing toolbox, I think now is a perfect time to do a bit of toolbox organization and give each tool category a bit of context, along with a side-by-side comparison. Picture this: you're an IT professional with a toolbox filled with various instruments, each suited for different levels of expertise and needs. At the top of the complexity scale, we have the CLI, or Command Line Interface. This is best suited for coding enthusiasts or IT administrators who revel in the power and flexibility of text commands. The CLI is the most granular tool, perfect for those who want to dive deep into the system's inner workings. Next up are the Windows Administrator tools, less complex than CLI but still quite detailed. These tools are a sweet spot for administrators and advanced users, offering significant control with a more user-friendly graphical interface. Then we have the Windows Control Panel. This is less complex than our administrative tool set and is suitable for both administrators and standard users. Finally, we arrive at Windows Settings, the least complex of them all, and the main topic of this video segment. Designed with the end user in mind, it's straightforward and perfect for everyday tweaks and adjustments. As an additional note, regardless of the tools you select, with time and experience, you will notice certain configuration options will require certain tools, regardless of their complexity level and inherent overlaps. With that said, let's take a closer look at each subsection of Windows settings. Starting at the top, we have System. This section is where you manage core system settings such as display, sound, notifications, power, and storage. Many of the settings we covered earlier, like display configuration and power options, can also be found here. Next is Bluetooth and devices, which replaces the older devices category from Windows 10. This is where you manage connected hardware such as Bluetooth devices, printers, and peripherals. Some advanced device management options still redirect you to Control Panel, specifically devices and printers, showing that overlap between the two interfaces. Moving down, we have Network and Internet. This section allows you to configure network connections, including Wi-Fi, Ethernet, VPNs, and proxy settings. While most common tasks can be done here, advanced configurations, like adapter settings, may still link back to the control panel's network and sharing center. Next is Personalization, where you can customize the look and feel of your system. This includes themes, backgrounds, colors, lock screen settings, and taskbar configurations. Then we have Apps, which is used to manage installed applications. From here, you can uninstall programs, set default apps, and manage optional features. This overlaps with programs and features in the control panel, although more advanced uninstall or modification options may still redirect you there. Next is Accounts, where you manage user accounts, sign-in options, and account settings. This includes Microsoft accounts, local accounts, and access control. While most account management is handled here, some advanced settings may still reference the control panel's user accounts section. Below that is Time and Language, which allows you to configure date and time settings, region, and language preferences. This aligns with the date and time settings found in the control panel, though most functionality is now centralized here in Windows 11. Next is Gaming, which includes settings for Xbox Game Bar, screen captures, and game mode. These features are designed to enhance performance and make it easier to record or monitor gameplay. For example, Xbox Game Bar provides an on-screen overlay for quick access to tools, Captures lets you manage screenshots and recordings, and Game Mode helps prioritize system resources while gaming. Then we have Accessibility, which is also known as ease of access in the control panel. This is where you configure features like narrator, magnifier, captions, and input assistance tools. As we covered in an earlier video segment, these tools are designed to make Windows easier to use for a wide range of users. While the layout in Windows settings is more modern, the core functionality remains consistent with what you'll find in the control panel. Moving on to Privacy and Security, this section combines privacy controls and security settings. Here, you can manage app permissions, location settings, camera and microphone access, and Windows security features. Finally, we have Windows Update, which is where you manage system updates, view update history, and configure advanced update settings. From here, you can check for updates, pause updates if needed, and review previously installed updates. This section ensures your system stays secure and up to date with the latest features, bug fixes, and security patches. Exam Objective 1.7, given a scenario, configure Microsoft Windows networking features on a client desktop. Workgroup versus Domain. To kick off Exam Objective 1.7, let's dive into the world of Windows networking, where we'll cover the essentials of configuring Microsoft Windows networking features. This journey will take you through several key network concepts from a software perspective. To start, we'll focus on workgroups and domains, two fundamental networking models used in Windows environments. Imagine you're in a small office with only a few computers that need to communicate and share resources, but without the need for a central server. This is where a Windows workgroup comes into play. A workgroup is a simple, peer-to-peer network model that allows computers to share files and printers without centralized management. Each system manages its own users and permissions, making this setup ideal for home networks or small businesses where simplicity is key. As a general guideline, Microsoft recommends keeping workgroups to around 20 devices or fewer to maintain efficiency. Now, let's look at the alternative, domains. A domain is a more structured and scalable networking model. In a domain environment, one or more servers, known as domain controllers, manage users, computers, and security settings centrally. This allows administrators to control access, enforce policies, and manage resources across the entire network from a single location. Domains are commonly used in medium to large organizations where centralized management and security are essential. Now that we've defined both, let's compare them. At a high level, both workgroups and domains allow computers to communicate and share resources across a network. However, their similarities largely end there. When it comes to management, workgroups are decentralized, meaning each computer is responsible for managing its own users and resources. In contrast, domains use centralized management through domain controllers, allowing administrators to manage the entire network from one place. From a security standpoint, domains provide a higher level of security. They use centralized authentication and can enforce security policies across all devices. Workgroups, on the other hand, rely on local accounts and permissions, which can be harder to manage consistently across multiple systems. Scalability is another major difference. Workgroups are best suited for small networks with a limited number of devices, while domains are designed to scale to hundreds or even thousands of systems. So, if you're working with a small network and want a simple, low-maintenance setup, a workgroup is a great choice. But if you need centralized control, stronger security, and the ability to scale, a domain is the better solution. Exam Objective 1.7, given a scenario, configure Microsoft Windows networking features on a client desktop. Shared resources. Whether you're in a small office or a large enterprise, sharing resources between devices can make everyday tasks much more efficient. Instead of transferring files manually or connecting to a single machine, users can access shared files, drives, and printers across the network with ease. This level of convenience is made possible through technologies like file servers, mapped drives, and shared printers. Let's start with file servers. A file server is a system that stores and manages files, so multiple users can access them over a network. In a workgroup, a file server can be any computer that shares its folders with others. This creates a decentralized environment where each machine controls its own shared resources. This setup works well in small offices or home networks where simplicity and ease of configuration are priorities. In a domain, file servers are centralized and managed by administrators. This allows for more precise control over access through permissions, ensuring that only authorized users can access sensitive data. Domain-based file servers also support advanced features such as backups, redundancy, and remote access, making them ideal for larger environments. Next, we have mapped drives. A mapped drive is essentially a shortcut that assigns a drive letter to a shared folder on a network. This allows users to access network resources just like they would a local hard drive, without needing to manually browse or enter a network path each time. Mapped drives are commonly used in both workgroup and domain environments. In a workgroup, users typically map drives manually. In a domain, administrators can automatically map drives for users using tools like group policy, ensuring everyone has access to the correct resources without additional setup. Overall, mapped drives make accessing shared folders faster, easier, and more efficient, especially in environments where network resources are used regularly. Now let's talk about printers, which are another commonly shared resource in most IT environments. Sharing printers allows multiple users to print without needing direct access to the device. There are two primary types of printer sharing: locally connected printers and network printers. A locally connected printer is physically attached to a computer, typically using a USB connection. In a workgroup environment, this printer can be shared so other users on the network can print through a host computer. This is a common setup in smaller environments where one printer serves multiple users. To share a locally connected printer, open Devices and Printers in the Control panel, right-click the printer, select Printer Properties, and then enable the option to share the printer. As for a network printer, this is connected directly to the network, rather than to a single computer. This allows users to send print jobs directly to the printer from their own devices without relying on a host system. In a workgroup, network printers simplify access by allowing each device to connect directly to the printer. In a domain, network printers are typically managed centrally. Administrators can deploy printers using tools like group policy, assign access to specific users or groups, and monitor usage across the organization. This centralized approach makes managing multiple printers across departments much more efficient. Exam Objective 1.7, given a scenario, configure Microsoft Windows networking features on a client desktop. Local OS firewall settings. On a Windows desktop, the local operating system firewall is known as Windows Defender Firewall. Understanding how to configure this firewall, along with managing restrictions and exceptions, is essential for maintaining both a secure and functional network connection. In this video segment, we'll explore these concepts and walk through a practical scenario to reinforce your understanding. Firewalls serve as your first line of defense against cyber threats. They monitor and control incoming and outgoing network traffic based on predefined security rules. A local OS firewall, like Windows Defender Firewall, is built directly into the operating system and provides essential protection for your device. Some key features include profiles, inbound and outbound rules, application restrictions and exceptions, and port management. Windows Defender Firewall operates using 3 profiles: domain, private, and public. Each profile can have its own rules and configurations, allowing flexibility based on the type of network you're connected to. The domain profile is used in enterprise environments when connected to a domain network. The private profile is intended for trusted networks, such as your home or office. The public profile is designed for untrusted networks, like those in coffee shops or airports, where stricter security is required. Inbound rules control the traffic coming into your computer. For example, you might create inbound rules to allow traffic from trusted sources or block traffic from unknown or potentially malicious systems. These rules are critical for protecting your system from external threats. Outbound rules manage the traffic leaving your computer. These rules determine how applications and services communicate with external networks, including the Internet. While most outbound traffic is allowed by default, you can create rules to block or restrict specific applications, ports, or destinations. This is especially useful in business environments where controlling data flow and enforcing security policies is important. Application restrictions and exceptions provide additional control. Application restrictions allow you to block or limit network access for specific programs, which can help prevent malicious software from communicating externally. Exceptions, on the other hand, allow trusted applications to bypass firewall restrictions so they can function properly, such as web browsers or email clients. Another important aspect is port management. This involves allowing or blocking traffic through specific ports. Since many services rely on designated port numbers, controlling port access helps regulate which services can communicate over the network. For example, you might allow traffic on port 80 for web traffic while blocking unused or potentially vulnerable ports. Now, let's walk through a quick scenario. Imagine you are working on a project that requires connecting to a remote database server operating on TCP port 1433. Network traffic to the database is being allowed out, but no traffic is being allowed back in on this port. This issue might be related to your firewall settings blocking the database connection. To fix this issue, we will create a new inbound rule to allow inbound traffic on TCP port 1433. To do this in Windows Defender Firewall, right-click on Inbound Rules and select New Rule. This will launch the new Inbound Rule wizard. Since our issue is with traffic related to a specific port, choose Port and click Next. Here we will select TCP and enter 1433 in the specific local ports field. Now click Next. On the next step, choose Allow the connection and click Next. Now select when the rule applies. For this example, we will select all 3 profiles. Then we will click Next one more time. To wrap up, provide a name for the rule and click Finish. You should now see your new rule listed, and the connection should be allowed. Understanding how to configure and manage your local OS firewall is essential for maintaining both security and usability. By properly controlling inbound and outbound traffic, managing application access, and configuring ports, you can ensure that your system remains protected while still allowing necessary network communication. Exam Objective 1.7. Given a scenario, configure Microsoft Windows networking features on a client desktop. Client network configuration. CompTIA A Plus, Core 1, is where networking is discussed in detail, but Core 2 has us covering various networking elements, including IP addressing schemes, static versus dynamic addressing, subnet masks, default gateways, and DNS settings from a software perspective. So if the mere mention of networking still gives you chills down your spine, don't worry, I will provide a brief overview of these topics before we attempt to input any network configuration settings into the Windows operating system. First up is to define what an IP address is. IP stands for Internet Protocol, and an IP address is a unique numerical identifier assigned to every device connected to a network. Within this definition, the keyword is assigned, as an IP address is logically assigned, can be changed, and even reassigned as needed. Currently, there are two versions of IP addresses in use: IPv4 and IPv6. IPv4, which stands for Internet Protocol version 4, is the older and more widely adopted version. An IPv4 address identifies a device in an Internet Protocol version 4 or an IPv4 network. It is worth noting that IPv4 addresses use a specific type of notation called dot decimal notation. Dot decimal notation is a way of displaying a big number in manageable chunks. In the case of an IPv4 address, each address is 32 binary digits long. This is a bit difficult to understand, so let's group this 32 binary digit address into different containers that are separated by dots. This will create 4 sets of 8 binary digits, also known as octets. Next, we will convert each octet from binary to their decimal value equivalents, resulting in a dot decimal notation that is much easier to read. With this dot decimal notation, each octet can range from 0 to 255, providing us with over 4.2 billion numerical combinations. IPv6 addresses are considerably longer than an IPv4 address, at 128 binary digits long. IPv6 addresses also use a different addressing scheme. IPv6 addresses include 8 groups of 4 hexadecimal digits, separated by colons. Each group of 4 hexadecimal digits can also be called a hextet. Next, let's explore how IP addresses are assigned to devices. There are two main methods: static and dynamic. A static IP address is manually assigned to a device and remains constant over time. This is often used for servers, printers, or other devices that need a persistent, unchanging address in order to be consistently located by other devices. On the other hand, dynamic IP addresses are automatically assigned by a service called DHCP, which stands for Dynamic Host Configuration Protocol. With dynamic addressing using DHCP, a device receives an IP address from a DHCP server when it connects to the network. This dynamic addressing using DHCP allows for efficient assignment and use of IP addresses while also preventing addressing conflicts, where 2 or more devices are assigned the same IP address. Regardless of the method used, you won't be surfing the internet and visiting your favorite websites without the correct IP settings for your particular environment. A subnet mask is used to divide an IP network into smaller subnetworks, or subnets. The process of subnetting improves network performance and security by segmenting larger networks into smaller, more manageable subnets. This allows for better control of network traffic. Think of subnetting as creating VIP sections in your network club, keeping the crowds manageable and the party going smoothly. Now, for many of you, this might be the first time hearing about subnets, and that is okay. You will definitely get an earful once you progress on to Network Plus. So for now, just have an idea of what a subnet is and what a subnet mask might look like. As for the binary math that goes with this topic, just leave that for later. A default gateway, in the context of a computer network, is a router or networking device that connects a local network to the internet or other networks. It acts as a doorway, allowing your computer or other network devices to send or receive data from outside the local network. The function of a default gateway is straightforward, yet vital. When a device on your network wants to access a website, stream a video, or download a file from the internet, it sends that request to the default gateway, as long as it knows where to find it. Next, we have DNS, or Domain Name System, which is used for translating human-readable domain names, like domain.com, into IP addresses that computers can understand. When configuring DNS settings, you can specify primary and secondary DNS servers. The primary DNS server is queried first, and if it fails to respond, the secondary DNS server is used. Proper DNS configuration ensures that your network devices can resolve domain names and access internet resources efficiently. DNS is essential for web browsing, email, and any application that relies on domain name resolution. Think of DNS as the network's phonebook. It helps your devices find each other without awkward introductions. Now that we got those pesky networking details out of the way, let's work through a possible real-life problem. Imagine a scenario where a user cannot access any web pages at all but can ping the local host, the gateway, and known IP addresses on the internet and receive a response. This indicates that while the network connection itself is functioning, the DNS settings might be at fault. When the DNS is not working correctly, users may be able to reach websites by entering their IP addresses directly, but cannot resolve domain names to IP addresses, which is essential for accessing websites through URLs. Additionally, if a user selects a web search provider and a different website opens, it might indicate a redirect or a corrupt DNS record. So do you think you are ready to set up and configure a network adapter on a Windows device? I bet you are more ready than you think. But just to make sure, we can walk through it together. First, head over to Control Panel and click on the Network and Sharing Center. On the left side, click Change Adapter Settings. Next, right-click on the network adapter you want to configure, and select Properties. This will open up the Properties dialog box. There are many network settings that we can adjust here, but we will only concern ourselves with the Internet Protocol version 4, or IPv4 settings at this point in our journey. With that said, give that option a click. We will then be presented with a dialog box specific to our IPv4 settings. Now, let's take a closer look at this dialog box. This is essentially your control panel for configuring IP settings on a Windows client. Here's what you'll find and what each option means. IP address is where you enter the IP address you want to assign to the device interface. For example, you might enter 192.168.1.100 for a device on a local area network. The subnet mask helps define the IP address range of the network. When in doubt, just look for the 255. It's usually a dead giveaway. Default gateway will specify the IP address of your router, which acts as the gateway to other networks, including the Internet. For instance, you might enter 192.168.1.1. Whatever you do enter, make sure it is the actual address of the default gateway, or you will be stranded in your local network. Preferred DNS server will be your primary DNS server. This server is used first to resolve domain names. Oftentimes this will match your default gateway, as many routers come with a built-in DNS server. The alternate DNS server will be your backup DNS server, which is used if the primary server is unavailable. Personally, I like to use Google's public DNS server, located at 8.8.8.8.8 as my alternate DNS server of choice. Now imagine you're setting up a small office network, with a mix of static and dynamic IP addresses. The office has a router serving as the default gateway, DNS server, and DHCP server, all in one, that is charged with assigning IP addresses dynamically to most devices. However, the Office file server needs a static IP address for consistent access. To accomplish this, you would configure the file server with a static IP address, subnet mask, default gateway, and DNS settings to ensure it's always reachable at the same address. These settings can be viewed on the left. For the dynamic IP addresses, you would ensure that all other devices are set to obtain an IP address automatically from the DHCP server. This setup simplifies network management, as you don't need to manually assign IP addresses to every device. This also prevents IP conflicts with other DHCP-assigned devices, and makes it easy to add or remove devices from the network. Keep in mind, it is still possible to have an IP address conflict between a statically assigned device and a dynamically assigned device in some situations. You could also end up with an IP address if you configure a device for dynamic assignment and the DHCP becomes unreachable. Those are the addresses that begin with 169.254. Exam Objective 1.7. Given a scenario, Configure Microsoft Windows networking features on a client desktop. Establish network connections. Establishing a network connection can take many forms. In this video segment, we will crack open the networking floodgate, just a little, and explore some of the various connection types we can set up within our Windows operating system. Additionally, I will keep my explanation super simple, and illustrate these configuration options using the network and internet utility, accessible through Windows settings. Let's start with wired connections. A wired connection uses an Ethernet cable to connect your computer directly to a network, such as a router or switch. This type of connection is known for being fast, stable, and highly reliable, since it is not affected by wireless interference, signal loss, or environmental obstacles. Because of this, wired connections are commonly used in office environments, data centers, or any situation where a consistent and uninterrupted connection is important. Unlike Wi-Fi, which can fluctuate based on signal strength, a wired connection provides steady performance, making it ideal for tasks like file transfers, video conferencing, online gaming, or accessing shared network resources. Within Windows settings, the Ethernet section allows you to view your connection status, confirm whether you are connected to a network, and access important network details such as your IP address, subnet mask, default gateway, and DNS settings. You can also configure options like setting the network as public or private, and manage advanced settings if needed. Overall, wired connections are the go-to choice when reliability and performance are the top priority. Next up is wireless, also known as Wi-Fi. Wi-Fi allows your device to connect to a network without the need for physical cables by using radio signals to communicate with a wireless router or access point. This is the most common type of connection for laptops, tablets, and mobile devices because it provides the flexibility to move around while staying connected. Wi-Fi networks are typically secured using a password, also known as a passphrase, which helps prevent unauthorized access. Once connected, your device can communicate with other devices on the network and access the internet. Within Windows settings, the Wi-Fi section allows you to view available networks, connect to a network by entering the correct credentials, and manage your saved, or known, networks. You can also configure settings such as automatically connecting to trusted networks, forgetting networks you no longer use, and viewing network properties like signal strength and security type. While Wi-Fi offers convenience and mobility, its performance can vary based on several factors. Signal strength, distance from the router, physical obstacles like walls, and interference from other wireless devices can all impact speed and reliability. Moving on, we have wireless, wide area networks, also known as cellular connections. This type of connection uses a mobile carrier to provide internet access, much like how your smartphone connects when you're not on Wi-Fi. Some laptops come with built-in cellular capabilities, including a SIM card slot or embedded SIM, while other devices can connect through external options like USB cellular adapters. This makes wireless, wide-area networks especially useful when you're on the go, working remotely, or in areas where Wi-Fi is unavailable or unreliable. It provides flexibility and mobility, but it's important to keep in mind that cellular connections often come with data limits, speed restrictions, or additional costs depending on your service plan. Within Windows settings, cellular settings are located under the cellular subsection of Network and Internet. And from here, you can manage your connection status, view signal strength, monitor data usage, and configure options such as metered connections and data roaming. These settings give you control over how and when your device uses cellular data. One important detail to remember is that this section will only appear if your device has the required cellular hardware, such as a built-in cellular adapter or SIM support. If your device does not support cellular connectivity, this option simply will not be visible in Windows settings. Next, we have the VPN, or Virtual Private Network. A VPN creates a secure, encrypted connection between your computer and another network, typically over the internet. This is commonly used in business environments to allow users to securely access internal company resources while working remotely. When you connect to a VPN, your data is sent through an encrypted tunnel, which helps protect it from being intercepted. It also allows your device to appear as if it is on the same network as the remote system, even if you're physically located somewhere else. Within Windows settings, the VPN section allows you to add and manage VPN connections. To set one up, you'll typically need information such as the VPN provider, server address, connection type, and your login credentials. Once configured, you can connect and disconnect from the VPN directly within this section. VPNs are especially useful when using public networks, like those in airports or coffee shops, where security risks are higher. They are also commonly used to enforce secure access policies in corporate environments. Overall, a VPN provides both security and remote access, making it an essential tool in modern networking. Last up, we have proxy settings. A proxy server acts as an intermediary between your computer and the internet. Instead of your device connecting directly to a website or service, your request is first sent to the proxy server, which then forwards the request on your behalf and returns the response. This setup is commonly used in business and organizational environments for security, monitoring, and content filtering. For example, a company might use a proxy to block access to certain websites, log user activity, or enforce internet usage policies. Within Windows settings, the proxy section allows you to configure how your device connects through a proxy server. You'll typically see options for automatic setup, where settings are provided by the network, and manual setup, where you enter details like the proxy server address and port number. Proxy settings are often configured automatically in corporate environments, but in some scenarios, you may need to manually enter or adjust these settings to access internal resources or specific websites. Overall, proxy servers provide an additional layer of control and visibility over network traffic, making them an important component in many enterprise networks. Exam Objective 1.7. Given a scenario, configure Microsoft Windows networking features on a client desktop. Public versus private network. When you connect your Windows device to a network, Windows automatically classifies it as either a private or public network. This classification impacts how your device interacts with other devices and the level of security applied to your connection. Understanding the differences and knowing how to manage these settings effectively is crucial for maintaining both connectivity and security. A private network is one you trust, like your home or office network. When a network is set as private, Windows assumes you know and trust the other devices on the same network. This private network setting enables features like network discovery and has less restrictive firewall settings for inbound and outbound traffic. On a private network, having network discovery enabled allows your device to see other devices on the network and vice versa. This makes it easy to share files, folders, and printers, enhancing collaboration and convenience within the trusted environment. In contrast, a public network is one you don't trust, such as a coffee shop, airport, or any other public Wi-Fi hotspot. Windows assumes the network is insecure and restricts your device from being discoverable by others. This setting is more restrictive to protect your device from potential threats. On a public network, your device is hidden from other devices on the network, reducing the risk of attack. File and printer sharing is disabled to prevent unauthorized access to your resources, and Windows Firewall applies stricter rules to safeguard your device. For those of you who might not understand what network discovery is, don't worry, I got you covered. Network discovery is a feature that allows your Windows device to find other devices and be found on a local network. This is particularly useful in a private network setting, where collaboration and sharing are essential. When network discovery is enabled, your device can see and communicate with other devices, making file and printer sharing straightforward. This feature is automatically turned on in private networks but is disabled in public networks for security reasons. When network discovery is enabled, your computer sends out broadcast messages to announce its presence and listens for similar messages from other devices. This allows devices to detect each other and establish connections for sharing resources. For example, if you want to share a printer on a private network, Network discovery will let other devices see and connect to that printer without needing to configure a network path to each device manually. And that most likely brings up yet another question. What is a network path? And to understand network path, we will need to talk about yet another item, the Universal Naming Convention, or UNC. Now, that may sound like a big rabbit hole to go down, but it will only take a second to cover these items. So let's get to it. UNC is a standard for identifying shared resources such as files, folders, and printers across different devices within a network. The format of a UNC path is / server name / shared folder, where server name is the name of the computer or server where the resource is located, and shared folder is the name of the shared resource. Alternatively, the server name in a UNC path can also be an IP address. For example, /192.168.1.101 shared folder would access the shared folder on a device with the specified IP address. UNC paths allow users to access network resources directly, without needing to map network drives, providing a straightforward way to connect to shared content across the network. Now, to wrap up exam objective 1.7, we have one more topic to cover, and that is metered connection. This option is great for managing data usage on your desktop, laptop, or tablet, especially on limited data plans. A metered connection is one where data usage is tracked and possibly limited, such as a cellular connection, mobile hotspot, or a pay-per-use Wi-Fi network. By setting a connection as metered, you can prevent Windows from automatically downloading updates and other data-heavy tasks that could quickly consume your data allowance. Setting a connection as metered is particularly beneficial if you're using a mobile data plan with limited bandwidth or a pay-as-you-go internet service. When a network is designated as metered, Windows takes a more conservative approach to data usage. This means that while essential security updates will still be downloaded, other updates and large files won't automatically download. Additionally, some apps may behave differently, prioritizing tasks that require less data. For instance, syncing services like OneDrive will switch to manual syncing to avoid excessive data consumption. Exam Objective 1.8 Explain common features and tools of the Mac OS desktop operating system. Mac OS applications. We finally made it through the maze of Windows settings, tools, and shortcuts, and just when you thought we'd never see the light of another operating system, surprise! We're stepping out of the world of Windows and taking a short detour into Apple's Mac OS. Now, while Mac OS may look very different on the surface, many of the core concepts are actually quite similar. You still install applications, manage files, and configure settings. Except, this time, it will be performed in a way that's a bit more streamlined and, in many cases, a bit more simplified. For this video segment, we're going to focus on how Mac OS handles applications, from installation to uninstallation, along with the key file types you'll need to recognize for the exam. When diving into the Mac OS world, you'll quickly notice that Apple takes a very controlled and consistent approach to software installation. Unlike Windows, which supports a wide range of installer types and formats, Mac OS primarily relies on three main file types. These are .dmg, .pkg, and .app files. Understanding how each of these works will make it much easier to navigate application management on a Mac system. First up, we have the .dmg file. Think of a .dmg file as a digital version of a physical disk, like a CD or DVD. When you double-click a .dmg file, it mounts to your desktop as a virtual drive. Once mounted, a new window will open, typically displaying the application along with a shortcut to the applications folder. In many cases, installing the app is as simple as dragging the application icon into the applications folder. This drag-and-drop installation process is one of the most recognizable features of Mac OS and is a big reason why users often find it easy to install software. After installation, the mounted DMG stays on your desktop until you eject it. This step is often overlooked, but it's good practice to eject the DMG once you're done, just like removing a physical disk. Next, we have the .pkg file. This type of file is more similar to what you might be used to in Windows. When you open a .pkg file, it launches an installation wizard that guides you through the setup process step by step. During this process, you may be prompted to agree to licensing terms, choose an installation location, or enter administrator credentials. .pkg files are typically used for more complex applications or system-level software that needs to install components in multiple locations across the operating system. Because of this, PKG installers are often used for things like drivers, enterprise applications, or software that integrates deeply with the system. Finally, we have the .app file. This represents the actual application itself. While it appears as a single file, it's actually a bundled package that contains all the resources the application needs to run, including executable files, libraries, and configuration data. One of the biggest advantages of this format is its simplicity. To install an application, you can often just drag the .app file into the applications folder, and you're done. When it comes to uninstalling, the process is just as straightforward. In most cases, you can remove an application by dragging it to the trash. There's no need for a dedicated uninstall wizard like you would typically see in Windows. That said, some applications may leave behind small configuration or preference files, usually stored in library folders. For exam purposes, just remember that Mac OS keeps the uninstall process simple, even if a few leftover files may remain behind the scenes. Now, let's talk about the App Store. Apple's App Store serves as a centralized platform for discovering, installing, and updating applications. It's built directly into Mac OS and works very similarly to the App Store on an iPhone or iPad. From here, you can browse categories, search for specific applications, read reviews, and install software with just a few clicks. It provides a very user-friendly way to manage applications without needing to download files from external websites. One of the biggest advantages of using the App Store is automatic updates. Apps installed through the App Store are kept up to date in the background, which helps improve performance. Another important benefit is security. Apps available in the App Store are reviewed by Apple before being published, reducing the risk of installing malicious or unreliable software. This makes it one of the safest ways to install applications on a Mac system. Overall, Mac OS takes a very streamlined and user-friendly approach to application management. Whether you're installing software using a .dmg file, running a .pkg installer, dragging a .app into your applications folder, or downloading apps directly from the App Store, the process is designed to be simple, consistent, and efficient. And once you understand how these pieces fit together, working with applications in Mac OS becomes second nature. Exam Objective 1.8 Explain common features and tools of the Mac OS desktop operating system. Mac OS system folders. Now that we've covered how applications work in Mac OS, let's take a look behind the scenes at where everything actually lives. This brings us to system folders. Think of system folders as the organizational backbone of the operating system. Just like you might organize files into folders on your desktop, Mac OS uses a structured set of directories to store applications, user data, and system files. Understanding these locations will help you better navigate the system and troubleshoot issues when they arise. So let's walk through the key folders you need to know for your CompTIA exam. First, we have the /applications folder. This is where all installed applications are stored. When you install an app by dragging it into the applications folder, this is the location it's being placed into. It serves as the central hub for launching and managing applications on the system. You can think of this as similar to the Program Files directory in Windows. It's where your software lives, and it's accessible to all users on the system. Next is the /users folder. This folder contains a separate home directory for each user account on the system. Each user gets their own space to store personal files, settings, and preferences. Inside each user's home folder, you'll find familiar directories like Documents, Downloads, Desktop, and Pictures. This keeps user data organized and separated, which is especially important on systems with multiple users. Now let's talk about the /library folder. This folder stores system-wide resources that applications rely on to function properly. This includes things like configuration files, application support files, fonts, and system extensions. Unlike the Applications folder, which stores the apps themselves, the Library folder stores the supporting files that help those apps run correctly. Next is the /System folder. This is one of the most critical folders in Mac OS. It contains the core operating system files that keep everything running. These are essential system components, and they are tightly controlled by the OS. In modern versions of Mac OS, this folder is protected, meaning users typically cannot modify its contents. This helps maintain system stability and security by preventing accidental or malicious changes. Finally, we have /users/library. This is the user-specific library folder, and it's a big one for troubleshooting. While the main library folder we discussed earlier applies to the entire system, this version is specific to each individual user. This folder is located inside each user's home directory, keeping user-specific data separate from the rest of the system. It stores user-specific preferences, application settings, caches, and other configuration files. One important detail is that this folder is hidden by default, so you won't normally see it unless you specifically navigate to it. So, to tie it all together, Applications is where your apps live. Users is where user data is stored. Library supports applications with shared resources. System contains the core operating system files. And users/library stores user-specific settings and configurations. Understanding these folders gives you a clearer picture of how Mac OS is organized and makes it much easier to manage files, troubleshoot issues, and navigate the system with confidence. Exam Objective 1.8 Explain common features and tools of the Mac OS desktop operating system. Mac OS Apple ID. When navigating the Apple ecosystem, one of the first things you'll encounter is the Apple ID. This is a central and critical component of how Apple devices function. Think of your Apple ID as a passport that grants you access to nearly every Apple service and feature, similar to how a Microsoft account is used within Windows. At its core, an Apple ID is an account used to authenticate your identity across Apple services. It allows you to access features like the App Store, iCloud, iMessage, FaceTime, and more. When you create an Apple ID, you provide an email address, set a password, and configure security options. From that point forward, this account becomes your digital identity within the Apple ecosystem, linking your devices, applications, and data together. Because of this tight integration, Apple IDs also play a major role in device security. Now, this may sound convenient, and it is, but it can also introduce challenges, especially in corporate environments. For example, Apple devices often use a feature known as activation lock, which ties the device directly to the Apple ID that was used to set it up. If a device is lost or stolen, this is a great security feature because it prevents unauthorized users from accessing or resetting the device. However, let's place that into a real-world business scenario. Imagine a company purchases a fleet of Apple devices and allows employees to sign in using their personal Apple IDs. At first, everything works fine. But when an employee leaves the company, their Apple ID remains tied to the device. Now the company has a problem. Because of activation lock, the device cannot be reset or reused without the original Apple ID credentials. If the company does not have access to that account, the device can become completely unusable. In other words, a security feature designed to protect the device can end up locking out the organization that owns it. So how do organizations prevent this from happening in the first place? This is where corporate restrictions and centralized management come into play. In enterprise environments, companies avoid this issue by using tools designed to control how devices are configured and used from the very beginning. One of the most important of these tools is something called a management profile. A management profile is used to apply corporate restrictions and configurations to an Apple device. This is typically deployed through a mobile device management, or MDM solution. With a management profile in place, an organization can control a wide range of settings on the device. This includes enforcing security policies, restricting certain features, configuring network settings like Wi-Fi or VPN, and even preventing users from signing in with personal Apple IDs. Management profiles also allow IT administrators to remotely manage devices, push updates, install applications, and, if necessary, remotely wipe a device to protect company data. This ensures that the organization maintains full control over its devices, even when they are assigned to individual users. Exam Objective 1.8 Explain common features and tools of the Mac OS desktop operating system. Mac OS best practices. When it comes to maintaining a Mac OS system, the best practices are remarkably similar to those for any other operating system. Whether you're a dedicated Mac user or someone who regularly switches between platforms, these principles remain constant and are essential for keeping your system secure, stable, and running at peak performance. Let's walk through the key areas you need to focus on. First up, let's talk about backups. Backups are your first line of defense against data loss, and this is no different on Mac OS than it is on Windows or Linux. The most popular tool for this on a Mac OS device is Time Machine. Time Machine is a built-in feature that automatically creates backups of your entire system. Time Machine is designed to be simple and reliable. Once you connect an external drive and enable it, it begins creating regular backups in the background. These backups include your files, applications, and system settings, giving you a complete snapshot of your system over time. One of Time Machine's standout features is versioning, which allows you to go back and restore previous versions of files. This is especially useful if a file was accidentally modified or deleted. In the event of a system failure, hardware issue, or even a ransomware attack, Time Machine allows you to restore your system to a known good state with minimal downtime. Next, we have antivirus software. There's a common misconception that Mac OS doesn't need antivirus protection, but that's simply not true. While Mac OS is designed with strong security in mind, it still faces threats like malware, phishing attacks, and malicious downloads. That said, Mac OS does include built-in antivirus and security features that provide a solid first line of defense. Two of the most important are Gatekeeper and XProtect. Gatekeeper helps protect your system by ensuring that only trusted applications are allowed to run. When you download an app, Gatekeeper checks whether it comes from an identified developer or the App Store. If the app fails this check, Mac OS will warn you or block it entirely, helping prevent potentially harmful software from being installed in the first place. XProtect operates behind the scenes as built-in anti-malware protection. It automatically scans files and applications for known malware signatures, and it updates silently in the background to stay current with emerging threats. This means your system is continuously being monitored without requiring manual intervention. In addition to these, Mac OS also includes tools like Malware Removal Tool, which can automatically remove certain types of malware if they are detected. Even though these protections are built in, they still rely on being up to date. Apple regularly updates these security definitions as part of system updates, so keeping your Mac OS updated ensures that these built-in defenses remain effective. Now let's move on to updates and patches. Apple regularly releases updates to Mac OS that include security patches, bug fixes, and performance improvements. These updates often address newly discovered vulnerabilities, making them a critical part of maintaining system security. Mac OS makes it easy to stay current. You can configure your system to automatically download and install updates, or you can manually check for them through system settings. Regardless of the method, the goal is to ensure your system is always running the latest version to minimize exposure to known threats. Building on this, let's talk about something newer that you may see on the exam, called Rapid Security Response, or RSR. Rapid Security Response is a feature introduced by Apple to deliver important security fixes more quickly, without requiring a full system update. Instead of waiting for a major update release, Apple can push smaller, targeted security updates directly to your system. These updates are designed to address critical vulnerabilities as soon as they are discovered, helping protect your device in real time. In many cases, RSR updates install automatically and may not even require a full system restart. This allows Apple to respond faster to emerging threats, reducing the window of exposure and improving overall system security. Exam Objective 1.8 Explain common features and tools of the Mac OS desktop operating system. Mac OS System Preferences. When it comes to customizing and managing your Mac OS experience, System Preferences is your command center. This is where you can tweak everything from your display settings to privacy controls, ensuring your Mac works just the way you like it. Let's walk through some of the key sections you'll encounter in System Preferences and what they allow you to do. First up is Displays. This section lets you adjust the resolution, brightness, and color settings of your screen. You can also tweak the refresh rate, adjust multiple display settings, and if you ever find yourself squinting at your screen, there's a handy option to scale text and icons to a more comfortable size. Next, let's move on to Networks. This section is crucial for managing how your Mac connects to the internet and other networks. Here, you can add, remove, and prioritize Wi-Fi networks, configure VPN connections for secure browsing, and manage Ethernet settings if you're using a wired connection. You can also set up advanced options like DNS servers or proxies, which might be required for accessing certain networks or enhancing your security online. The Networks section ensures that you stay connected wherever you are, whether at home, in the office, or on the go. Moving on to Printers and Scanners, this section lets you manage all your printing and scanning devices. Adding a new printer or scanner is straightforward. Your Mac often automatically detects connected devices, but you can manually add them here as well. Once your devices are set up, you can manage print queues, configure print settings, and even share your printer with other users on the network. If you're working with a scanner, you'll find options to customize scan settings, such as resolution, color mode, and file format. This ensures that your scanned documents come out just the way you need them. Privacy is another critical section in System Preferences, and it's all about controlling what data your apps and services can access. Here, you can manage permissions for location services, contacts, calendars, photos, and more. This is also where you can control your advertising settings and manage which apps have access to your microphone or camera. Ensuring that your privacy settings are configured correctly is key to protecting your personal information and keeping your data secure. Next, let's explore accessibility. This section is designed to help users with disabilities better interact with their Mac device. Whether you need to adjust display settings for better visibility, enable voice control, or set up assistive technologies like switch control, accessibility options provide a wide range of tools. You can also customize how your keyboard, mouse, and trackpad behave, making it easier for users with different needs to navigate and use their Mac effectively. For instance, you can enable zoom to enlarge portions of the screen or use VoiceOver to have text read aloud. Accessibility ensures that your Mac device can be tailored to fit your specific needs, making technology more inclusive and user-friendly. Finally, we circle back to Time Machine, which we discussed earlier. In System Preferences, Time Machine allows you to set up and manage your backup preferences. You can choose which disk to back up to, exclude specific files or folders from being backed up, and control how often backups occur. This section also lets you manually start a backup if needed, or review previous backups to restore files or your entire system. Time Machine is a crucial tool for ensuring your data is safe, and this is where you can fine-tune how it operates to best meet your needs. Exam Objective 1.8 Explain common features and tools of the Mac OS desktop operating system. Mac OS features. Once you work your way past Mac OS system preferences, you'll find a rich set of features designed to make your experience more efficient, secure, and intuitive. Let's take a tour of some of the standout features that every macOS user should be familiar with, especially for those users preparing for the CompTIA A Plus Core 2 exam. One of the most powerful productivity features in macOS is the ability to create multiple desktops, also known as spaces. Imagine having several different workspaces, each dedicated to different tasks, one for your email, another for web browsing, and a third for a specific project. With multiple desktops, you can create and manage these spaces easily, helping you keep your work organized and your screen clutter-free. To help you navigate through these spaces, macOS offers Mission Control. This feature gives you a high-level view of all your open windows, applications, and desktops. With a swipe up on your trackpad or a press of the Mission Control key, you can see everything at a glance. You can even drag windows between desktops or create new ones on the fly. It's like having a personal control center that lets you manage your workflow with ease. Keychain is macOS built-in password manager. It securely stores your passwords, account information, and even credit card details, so you don't have to remember them all. Keychain uses encryption to protect your data and can autofill your credentials in Safari and other apps. This makes logging into websites and applications a breeze, while also ensuring that your sensitive information is kept safe. When it comes to finding anything on your Mac, Spotlight is your go-to tool. Spotlight lets you search for files, apps, documents, emails, and even information from the web. And that is just the beginning. Spotlight can also do calculations, convert currencies, and even give you the latest news. It's a powerful feature that keeps everything you need at your fingertips. iCloud integrates your Mac with the broader Apple ecosystem, allowing you to store files, photos, and other data in the cloud. This ensures your data is accessible from any Apple device, whether it's an iPhone, iPad, or another Mac desktop. It also includes built-in services like iMessage for synced messaging across devices and FaceTime for audio and video calls directly from your Mac. Overall, iCloud keeps your data, communication, and files connected across all your devices for a seamless experience. macOS is designed with gestures that make navigating your system smooth and intuitive, especially if you're using a trackpad. With simple swipes, pinches, and taps, you can switch between desktops, zoom in on documents, open Mission Control, and more. These gestures make interacting with your Mac more dynamic and can significantly speed up your workflow once you get the hang of them. The Finder is the default file manager in macOS. It's where you'll spend a lot of your time browsing files, organizing documents, and managing apps. Finder gives you easy access to all the files on your Mac and any connected drives, making it simple to drag and drop, rename, or delete files. With features like Quick Look, you can also preview files without opening them. The dock is a customizable bar at the bottom of your screen that provides quick access to your favorite apps, open windows, and minimize documents. It serves as a convenient shortcut to essential tools like Finder, Trash, and other frequently used applications, enhancing your workflow efficiency. Continuity is a feature that allows your Apple devices to work together seamlessly. If you use a Mac alongside an iPhone or iPad, Continuity lets you move between devices without interrupting your workflow. For example, with AirDrop, you can quickly transfer files, photos, and other content between nearby Apple devices without needing cables or external storage. Then there is Continuity Camera, which allows you to use your iPhone's camera for tasks on your Mac, such as using it as a camera for FaceTime, with the video appearing directly on your laptop. You'll also find additional features like Handoff, Universal Clipboard, Universal Control, and Sidecar, all designed to extend functionality across your devices. Disk Utility is a powerful tool for managing your Mac's disks and volumes, including tasks like formatting, repairing, and resizing partitions. This utility is essential for setting up new drives, troubleshooting disk issues, and performing tasks such as resizing a partition on your internal storage without data loss. File Vault is a Mac OS disk encryption feature that uses AES-128 encryption to secure your startup disk and protect your data from unauthorized access. When enabled, File Vault automatically encrypts everything on your drive, ensuring that only you can access your data, even if your Mac is lost or stolen. Terminal provides access to the command line interface, allowing advanced users to execute commands, run scripts, and configure system settings. Terminal is a powerful tool for those who prefer direct control over their system, offering capabilities beyond what's available through the graphical interface. Force Quit is a feature that allows you to close an application that has stopped responding or is frozen. If you encounter the spinning rainbow cursor, often called the beach ball of death, Force Quit enables you to close the unresponsive app without rebooting your entire system, helping you regain control quickly. Exam Objective 1.9 Identify common features and tools of the Linux client desktop operating system. Root account. As we continue exploring operating systems, it's time to shift our focus to the Linux operating system. In Linux, the command line environment plays a much more central role in everyday tasks. While graphical interfaces do exist, much of what you do in a Linux system revolves around the command line. Before we jump into commands, let's take a moment to understand the environment we're working in. The Linux command line interface, or CLI, is made up of two key components, the terminal and the shell. The terminal is the application you open. It's the window or interface that allows you to type commands, and it serves as a text-based interface for the user. Think of it as the doorway into the Linux command line environment. When you launch a terminal, you're opening a space where you can directly interact with the operating system using text-based input instead of clicks and menus. The shell, on the other hand, is the program that actually processes the commands you type. It takes your input, interprets it, and tells the Linux operating system what to do. So in simple terms, the terminal is where you type, and the shell is what does the work behind the scenes. For example, when you open a Linux terminal window, you are typically interacting with a shell, like Bash, which stands for Born Again Shell. Bash is the default shell on many Linux systems and is responsible for understanding the commands you enter and executing them. Think of Bash as the translator between you and the Linux operating system. You type a command into the terminal, Bash interprets that command, and then the Linux operating system responds with the result. Now that we understand how the Linux terminal and shell work together, let's shift our focus to the main topic of this video segment, the root account. The root account is the most powerful user account in a Linux system. It is often referred to as the superuser because it has unrestricted access to all files, commands, and system resources. In other words, the root account can perform any action on the system without limitation. With this level of access, the root account has full control over the entire system. It can modify system files, install or remove software, manage users, and change critical configurations. Because of this, the root account is not meant for regular, day-to-day use. Instead, most users operate under standard accounts with limited permissions and only access root-level privileges when necessary. This approach helps maintain system stability and security by reducing the risk of accidental changes or misuse of powerful system-level commands. Exam Objective 1.9 Identify common features and tools of the Linux client desktop operating system. Administrative commands. Now that we have covered what the root account is, the next question becomes, how do we actually use those elevated privileges safely? This is where two important Linux commands come into play, and those are sudo and su. Let's start with sudo, because this is the method you'll use most often. The sudo command stands for superuser do, meaning it allows you to perform a task with superuser, or root-level privileges. The sudo command allows you to run a single command with elevated privileges without fully switching to the root account. Think of it like temporarily borrowing administrative access just long enough to complete a specific task, and then immediately returning to your normal user account. For example, if Jane needs to install software on a Linux system, she might type a command like sudo apt install, followed by the package name. After entering her password, the command runs with elevated privileges, but Jane remains logged in as herself. This is important because it limits how long elevated access is active, helping reduce the risk of accidental changes to critical system files. In many Linux environments, access to sudo is controlled through permissions, meaning only authorized users are allowed to run commands with elevated privileges. This adds an extra layer of security and accountability. Now let's look at SU. The SU command stands for switch user, and it allows you to switch from your current user account to another user account. Using SU is more like stepping completely into another user's role. For example, if Jane types SU Bob and enters Bob's password, she is now operating as Bob. This means she can access Bob's files and run commands based on Bob's permissions. At this point, Jane is no longer operating as herself. She has fully switched into Bob's account and will remain in that session until she exits. Now let's take it a step further. If Jane types SU root and enters the root password, she is now fully operating as the root user, with unrestricted access to the entire Linux system. This is extremely powerful because every command she runs now has full system access. However, this also comes with greater risk. Since she remains in the root session, it becomes much easier to accidentally make changes that could impact the entire system. Because of this, in most modern Linux environments, sudo is preferred, as it provides better security and control by limiting how and when elevated access is used. Exam Objective 1.9 Identify common features and tools of the Linux client desktop operating system. File management commands. As we continue working within the Linux operating system, let's shift our focus to another essential skill: managing files from the command line interface. In this video segment, we'll walk through a set of common file management commands that allow you to navigate, organize, and control files directly from the Linux CLI. Let's start with two commands that help you understand where you are and what's around you, which are pwd and ls. The pwd command stands for Print Working Directory, and it shows you your current location within the Linux file system. Think of it like checking your GPS to see exactly where you are. When you run pwd, the system returns the full file path of your current directory, helping you stay oriented as you move through the system. Next, we have the ls command, which is used to list the contents of a directory. This allows you to see the files and folders located in your current directory. If you want to view hidden files as well, you can use ls-a. In Linux, hidden files begin with a period, so this option reveals files that are normally kept out of sight. Now that you know where you are and what's inside a directory, let's talk about moving and copying files. The mv command is used to move files from one location to another. It works much like a cut and paste operation. In addition to moving files, mv can also be used to rename them. For example, if Jane wants to move a file and rename it at the same time, she can use mv followed by the source file and then the destination path with the new file name. The cp command, on the other hand, is used to copy files. This allows you to duplicate a file while keeping the original intact. For instance, if Jane wants to create a backup of a file, she can use cp followed by the source file and the destination directory where the copy will be placed. Next, let's talk about removing files. The rm command is used to delete files from the system. Think of it as the Linux version of the delete key, but with one major difference: there is no recycle bin. Once a file is removed using rm, it is permanently deleted. Because of this, it's important to use this command with caution. Now let's move into permissions and ownership, which are key concepts in Linux. In a Linux system, every file and directory has both permissions and an owner, and these determine who can access or modify that file. The chmod command is used to modify file permissions. It controls three basic types of access: read, which allows a user to view the contents of a file; write, which allows a user to modify the file; and execute, which allows a file to be run as a program. These permissions are applied to 3 different groups: the owner of the file, the group associated with the file, and others, meaning everyone else on the system. Permissions can be set using numerical values, such as 744, or by using symbolic options like plus or minus to add or remove specific permissions. At this point in your learning journey, the key takeaway is that the chmod command is used to control who can access and interact with a file. Don't worry too much about the specifics just yet. Now let's look at chown, short for change owner. The chown command is used to change file ownership, allowing you to assign a file or directory to a different user or group. For example, if Jane wants to transfer ownership of a file to Bob, she can use chown followed by Bob's name and the file name. After running the command, Bob becomes the new owner of that file. Ownership is important because the owner typically has the highest level of control over a file, including the ability to modify its permissions. Finally, let's look at 2 commands used for searching, which are find and grep. The find command is used to locate files within the file system. You can specify a starting directory and search for a file by name, which makes it especially useful when you're not sure where a file is stored. For example, if Jane is trying to locate a file somewhere within her home directory, she can use the find command to search through all subdirectories and return the full path to any matching results. This makes find a powerful tool for navigating large file systems where manually searching would take too much time. Now let's look at grep. The grep command is used to search within files. Instead of locating files themselves, grep looks inside files and allows you to search for specific words or patterns within text. For example, if Jane is reviewing a log file and wants to find every instance of the word error, she can use grep followed by the keyword and the file name. The command will return only the lines that contain that word, making it much easier to quickly identify relevant information. Together, find and grep are often used to locate files and then search within them, making them essential tools for troubleshooting and working with large amounts of data in a Linux environment. Exam Objective 1.9 Identify common features and tools of the Linux Client Desktop Operating System. File System Commands. As we continue working within the Linux operating system, let's now shift our focus to file system commands. These commands are used to manage how storage devices are checked, accessed, and connected to the system. In this video segment, we'll focus on 2 key commands, fsck and mount, both of which play an important role in maintaining and accessing storage. Let's start with fsck. The fsck command stands for File System Check, and it is used to scan and repair file systems. Think of it as a diagnostic tool that examines a disk for errors and attempts to fix any issues it finds. Over time, file systems can develop problems due to improper shutdowns, power failures, or underlying disk issues. These problems can lead to things like corrupted files, missing data, or inconsistencies in how data is stored. When this happens, fsck can be used to identify and repair those issues, helping restore the integrity of the file system. It's important to note that fsck is typically run on unmounted file systems to prevent further damage. Running it on an active file system could cause data loss or corruption. In many cases, the Linux operating system will automatically run fsck during startup if it detects that a file system was not properly shut down or may be in an inconsistent state. Now let's look at the mount command. The mount command is used to attach a file system to a specific location in the Linux directory structure, so it can be accessed by the operating system. In Linux, storage devices such as hard drives, USB drives, and network shares are not automatically available for use. Instead, they must be mounted to a directory, known as a mount point, before their contents can be accessed. Think of mounting like connecting a storage device to the system and assigning it a location within the file system. Once the device is mounted, its files and folders become accessible just like any other directory. For example, a USB drive might be mounted to a directory such as /mnt/USB. After mounting, users can navigate to that location and interact with the files on the device. This process is important because it allows Linux to organize all storage devices into a single unified directory structure, rather than assigning separate drive letters like you would see in Windows. It's also worth noting that when a device is no longer needed, it should be properly unmounted before removal. This helps ensure that all data has been written correctly before removal, preventing potential data corruption. Exam Objective 1.9 Identify common features and tools of the Linux Client Desktop Operating System. Package management. At some point, every system needs new software, updates, or even the occasional cleanup of programs that are no longer needed. In a Linux operating system, all of this is handled through something called package management. Package management is how software is installed, updated, and removed in a Linux system. Instead of downloading programs from a website like you might in other operating systems, Linux uses package managers to handle software in a more organized and secure way. In this video segment, we'll focus on two commonly used package managers, apt or apt, and dnf. Let's start with the apt command, which is used on many Debian-based Linux systems to install, update, and remove software packages from centralized repositories. Think of a repository as a trusted online source where software is stored. When you use apt, your system connects to this source, downloads the software, and installs it for you. There are 3 core commands you should be familiar with. To install new software, you can run sudo apt install, followed by the package name. To refresh the list of available software from the repository, you can run sudo apt update. And to upgrade the software currently installed on the system, you can run sudo apt upgrade. Now let's look at dnf. The dnf command accesses another package manager used on various Linux systems, like Red Hat Linux, to install, update, and remove software packages. It performs the same core functions as apt, but it is used on different Linux systems, meaning the command you use depends on the Linux environment you are working in. While the command name is different, the overall process remains the same. The system connects to a repository, downloads the requested software, and installs any required dependencies automatically. There are 3 core commands you should be familiar with. To install new software, you can run sudo dnf install, followed by the package name. To refresh and update the software on the system, you can run sudo dnf update. And in some environments, you may also see sudo dnf upgrade, which performs a similar function by applying available updates. Just like apt, dnf is designed to simplify software management by handling both the installation process and any supporting components needed for the software to run properly. Exam Objective 1.9 Identify common features and tools of the Linux Client Desktop Operating System. Network commands. When working in a Linux operating system, there will be times when you need to test connectivity, troubleshoot network issues, or gather information about how your system communicates with other devices. This is where network commands come into play. In this video segment, we'll walk through some of the most common Linux network commands and how they are used. To begin, the IP command is used to view and manage network settings. It provides information such as your IP address, network interfaces, and routing details. For example, running a command like IP address show will display the IP addresses assigned to your system's network interfaces. This is especially useful when verifying network configurations or troubleshooting connectivity issues. Once you understand your system's network configuration, the next step is testing connectivity, which is where the ping command comes in. You may remember this command from earlier when we covered Windows command line tools, and the concept works in a very similar way here in the Linux CLI. The ping command is used to test communication between your system and another device on a network by sending small packets of data and waiting for a response. If the target responds, it confirms that communication is working. If there is no response, it may indicate a network issue. For example, running ping google.com allows you to test whether your system can reach an external website. If you need to go a step further and see how data is traveling across the network, the traceroute command can help. You may remember a similar command from earlier when we covered Windows, called traceRT, and traceroute serves the same purpose here in the Linux CLI. Traceroute is used to track the path that data takes from your system to a destination, showing each step, or hop, along the way. Each hop represents a device, such as a router, that the data passes through on its way to the final destination. This is especially useful for identifying where a network issue may be occurring. If communication fails or becomes slow, traceroute can help pinpoint where, along the path, the problem is happening. In addition to connectivity, it's also important to understand how domain names are translated into IP addresses, which is where the dig command comes into play. You may remember a similar tool from earlier when we covered Windows, called NSLOOKUP, and dig serves the same purpose here in Linux. The dig command is used to query domain name system, or DNS servers, allowing you to retrieve information about domain names and their corresponding IP addresses. For example, running dig example.com will return detailed DNS information. Within the output, the most important section to focus on is the answer section, where you can see the IP address associated with the domain. This is helpful when troubleshooting name resolution issues and confirming that a domain is resolving correctly. To round things out, the curl command is used to transfer data between your system and a server. It is commonly used to test connectivity to websites or APIs and verify that a service is responding. Unlike ping, which only checks basic connectivity, curl attempts to communicate with a web service and retrieve actual data, giving you a clearer picture of whether that service is working properly. For example, running curl https://example.com will attempt to retrieve data from that website. If the request is successful, the server will respond with content, such as HTML from a web page, or even data from a database, confirming that the service is reachable and responding correctly. This makes curl especially useful when troubleshooting web-based services, as it allows you to verify not just that a connection exists, but that the server is actively returning data. Exam Objective 1.9 Identify common features and tools of the Linux Client Desktop Operating System. Informational commands. As you continue working within the Linux operating system, it's important to be able to quickly view system information and monitor what's happening behind the scenes. This is where informational commands come into play. In this video segment, we'll walk through several commonly used commands that help you gather information about your system. Up first, the cat command gives you a quick way to display the contents of a file directly in the terminal. It provides a simple and efficient way to view text without opening a separate application. For example, if Jane wants to check the contents of a file named notes.txt, she can run cat, followed by the name of the file, notes.txt. With this command, the contents of the file will be printed directly in the terminal. This is especially useful for quickly reviewing configuration files or log data. For our next command, we have top. Top gives you a live view of what your system is doing in real time, allowing you to monitor performance as it happens. The top command displays continuously updating system performance information, including CPU usage, memory usage, and a list of active processes. Because the data refreshes automatically, you can watch how your system responds in real time as applications open, close, or consume resources. This makes top especially useful when troubleshooting performance issues or identifying processes that may be using excessive CPU or memory. If you're looking for a quick snapshot instead of a live view, the PS command is the next tool to know. The PS command, short for process status, provides a static list of the processes currently running on the system at the moment the command is executed. For example, running PS AUX will display detailed information such as process IDs, CPU usage, memory usage, and the command that started each process. Unlike top, this output does not update automatically, making it useful when you want a quick, one-time view of system activity or need to capture process information for troubleshooting or documentation. Shifting from processes to storage, the du command helps you understand how disk space is being used. The DU command, short for disk usage, is used to estimate how much space files and directories are consuming. For example, running du-h will display file sizes in a human-readable format, making it easier to identify large files or directories that may be taking up significant space. This is especially helpful when trying to free up storage, as it allows you to pinpoint exactly where space is being used. For a broader view of your system's storage, the df command provides a summary of available and used disk space. The df command, short for disk-free, shows how much space is used and available across each mounted file system. Running df-h presents this information in a human-readable format, allowing you to quickly determine how much storage remains. While du helps you identify where space is being used, df gives you a high-level view of the entire system, making the two commands very useful when used together. To close out this video segment, we have the man command. The man command is your go-to resource when you need more information about a command. Short for manual, man is the built-in help system in Linux, providing detailed documentation directly within the terminal. By running man followed by a command name, such as grep, you can view information about how that command works, including its syntax, available options, and usage examples. This makes man an incredibly useful tool when you're learning new commands or need a quick reference without leaving the command line environment. Exam Objective 1.9 Identify common features and tools of the Linux client desktop operating system. Text editors. A text editor is a tool used to create, view, and modify plain text files within an operating system. In a Linux environment, text editors play an important role in everyday tasks, as they are commonly used to edit configuration files, write scripts, and make quick changes directly from the command line. Because many system settings in Linux are stored in text-based files, having the ability to open and modify those files is essential for system management and troubleshooting. Unlike word processors, text editors do not include formatting features such as fonts, colors, or styling. Instead, they focus strictly on plain text, making them ideal for working with system files that require precise, unformatted input. One of the most commonly used text editors in Linux is Nano. Nano is a simple, user-friendly, terminal-based text editor that allows you to create, open, edit, and save files directly from the command line. It is designed to be easy to use, making it a great option for beginners who are just getting started with Linux. To open a file using Nano, you can run a command like nano notes.txt. If the file exists, it will open for editing. If it does not exist, Nano will create a new file with that name. Once inside Nano, you can type and edit text just like you would in a basic editor, making it easy to create or modify files directly from the command line. As you work, Nano provides helpful guidance by displaying available commands at the bottom of the screen. These shortcuts show you how to perform common actions such as saving your work, searching within the file, or exiting the editor. This simple layout, along with the on-screen command reminders, makes Nano a very approachable and beginner-friendly text editor. Exam Objective 1.9 Identify common features and tools of the Linux client desktop operating system. Configuration files. Configuration files are text-based files used by the Linux operating system and its applications to store system settings and control behavior. These files determine how the system operates, how services are configured, and how resources such as users, storage, and networks are managed. In Linux, many of the most important configuration files are located in the /etc directory, which acts as a central location for system-wide settings. For this video segment, we will be focusing specifically on configuration files found in the /etc folder. Because these files are written in plain text, they can be viewed using the cat command and edited using command line tools like Nano. This makes them both powerful and flexible, but also something that should be handled with care, since even small changes can directly impact how the system functions. As you begin working with these configuration files, it helps to think of them as the instruction manuals that tell the operating system how to behave behind the scenes. With that foundation in place, let's start with one of the most important configuration files related to user accounts, the /etc/passwd file. This file is one of the core configuration files used to manage user accounts on a Linux system. Each line in this file represents a single user and contains important details such as the username, user ID, group ID, a description field, the user's home directory, and their default shell. At first glance, the structure of this file may look a bit unusual, since each line is separated by colons, but each section serves a specific purpose. For example, the user ID helps the system uniquely identify each user, while the home directory defines where that user's files are stored. The default shell determines what environment the user interacts with after logging in. Because this file is essential for user authentication and system access, it plays a critical role in how users interact with the system. Misconfigurations here can prevent users from logging in or accessing their environment properly. You may also notice a placeholder, represented as an X, towards the beginning of each line. This X indicates that the actual password is not stored in this file. Instead, for security reasons, encrypted password data is stored in a separate file. With that in mind, the next step is understanding where that password data is actually stored, which brings us to the /etc/shadow file. The /etc/shadow file is responsible for storing encrypted password information and account security settings for users on a Linux system. While the passwd file defines user account details, this file is where sensitive authentication data is actually stored. Each line in the shadow file corresponds to a user account and contains several fields separated by colons. These fields include the encrypted password, as well as other password-related settings. At first glance, the encrypted password field may look like a long, complex string of characters. This is known as a password hash, which is a secure representation of the user's password. Instead of storing passwords in plain text, Linux systems store these hashes to help protect user credentials from being easily exposed. Because this file contains highly sensitive information, it is heavily restricted and typically only accessible by the root account. This added layer of protection helps prevent unauthorized access to password data and reinforces overall system security. Misconfigurations or unauthorized changes to this file can impact user authentication, potentially preventing users from logging in. Continuing on, we come to the /etc/hosts file. This configuration file is used to map hostnames to IP addresses locally on a Linux system. While most systems rely on DNS servers to resolve names, this file provides a way to define those mappings directly on the machine. Each line in the hosts file contains an IP address followed by one or more hostnames. When the system needs to resolve a name, it will often check this file first before reaching out to a DNS server. This allows for fast, local name resolution without requiring network communication. Compared to the passwd and shadow configuration files, the format here is much simpler. Each entry directly pairs an IP address with a hostname, making it easy to read and work with. This simplicity makes it especially useful for testing and troubleshooting. For example, administrators can manually map a hostname to a specific IP address to test connectivity or override DNS results. This can be especially helpful when working in development environments or when diagnosing network issues. Because this file can override DNS behavior, incorrect entries can lead to connectivity problems or misdirected traffic, so it should be modified carefully. In addition, if this file is altered maliciously, it can be used as part of a DNS-based attack, redirecting users to unintended or harmful destinations without their knowledge. This makes it important to ensure that only trusted users have access to modify this file and that its contents are reviewed if suspicious network behavior is observed. Next up, we have the /etc/resolve.conf file. This file is used to define the domain name system, or DNS settings for a Linux system. While the hosts file handles local name resolution, this file tells the system which external DNS servers to use when resolving domain names. Each line in this file typically begins with a keyword such as nameserver, followed by the IP address of a DNS server. When a user attempts to access a website, the system will query these DNS servers to translate the domain name into an IP address. Compared to the hosts file, which provides manual, local mappings, the resolve.conf file enables broader network-based name resolution. This allows the system to communicate with external networks and access internet resources. Because DNS is essential for most network communication, incorrect settings in this file can prevent access to websites and other network services. Shifting from networking to storage, we now have the /etc/fs tab configuration file. This file is used to define how storage devices are automatically mounted on a Linux system. Each line in the fs tab file represents a file system and contains several fields that specify details such as the device identifier, the mount point, the file system type, and mount options. These entries tell the operating system how and where to attach storage devices within the directory structure. Compared to earlier configuration files, the format here is more structured, with each field serving a specific purpose. For example, the mount point defines where the file system will appear in the directory tree, while the file system type indicates how the data is organized on the device. Mount options can control behaviors such as read and write access, performance settings, and how the system interacts with the device. This file plays a critical role during system startup, as it is used to automatically mount drives without requiring manual input. If an entry in this file is incorrect, it can prevent a file system from mounting properly. Exam Objective 1.9 Identify common features and tools of the Linux Client Desktop Operating System. Linux OS Components. As we wrap up our look at Linux, let's take a moment to understand a few core components that work behind the scenes to keep the operating system running. These components include the bootloader, the kernel, and systemd, and each one plays a critical role in how a Linux system starts and operates. Rather than thinking of these as isolated pieces, it helps to view them as part of a sequence that takes place every time a system is powered on. From the moment you press the power button to the point where you can log in and begin using applications, these components work together to bring the system to life. To see how the sequence unfolds, let's start at the very beginning with the bootloader, the component responsible for getting everything in motion. The bootloader is a program that runs when a computer is powered on and is responsible for loading the operating system into memory. It acts as the first step in the boot process, taking control after the system firmware completes its initial checks. The bootloader's primary job is to locate the operating system, load the Linux kernel into memory, and then transfer control so the system can continue the startup process. In many Linux systems, the bootloader also provides a menu that allows users to select between different operating systems or different versions of the kernel. Although it typically runs behind the scenes and is not something users interact with regularly, the bootloader plays a critical role in system startup. Without it functioning properly, the operating system would not be able to load, preventing the system from starting. To see how the bootloader works in practice, we can take a look at a configuration file used by a common Linux bootloader called grub. In this example, the file lists different boot options, known as menu entries, that are available when the system starts. Each menu entry represents a way the system can boot, such as using the default kernel or selecting an older version. Once the bootloader loads the operating system into memory, it hands control over to the kernel. The kernel is the core of the operating system. It is responsible for managing communication between software and hardware, allowing applications to interact with system resources such as the CPU, memory, storage, and input and output devices. Suffice it to say, the kernel is constantly working in the background. Every time you open a file, connect to a network, or use a device like a keyboard or USB drive, the request is handled through the kernel. The kernel is also responsible for managing system resources efficiently, ensuring that multiple applications can run at the same time without conflicts. It controls how memory is allocated, how processes are scheduled, and how hardware is accessed. Although users typically do not interact with the kernel directly, it plays a critical role in system stability. If the kernel encounters issues, it can impact the entire system, which is why it is considered the foundation of the operating system. To view information about the kernel, you can use commands like uname. In this example, the -R option displays the current kernel version running on the system. You may also see the -A option used, which provides more detailed information, including the system name, kernel version, and architecture. While you are not expected to memorize these commands, it is helpful to recognize that tools like this can be used to quickly identify the kernel version and system details when troubleshooting. After the kernel has initialized the system, the next component to take over is systemd. Systemd is a system and service manager that initializes the system after the kernel loads and manages system processes and services. It acts as the first process in user space and is responsible for starting everything the system needs to function. Once the kernel has finished its initial work, systemd begins starting essential services such as networking, logging, and user sessions. It ensures that services start in the correct order, especially when certain services depend on others. For example, a network service must be running before a web service can function properly. In addition to starting services, systemd also monitors them. If a service stops unexpectedly, systemd can restart it, helping maintain system stability. Administrators can also use systemd to manually start, stop, or check the status of services when troubleshooting issues. To interact with systemd, you can use the systemctl command. In this example, the status option is used to check the current state of the SSH service. The output shows whether the service is loaded and whether it is currently running. This type of information is useful when troubleshooting services or verifying that critical system components are functioning as expected. Together, these components work in sequence to bring a Linux system to life. The bootloader starts the process by loading the kernel manages communication between hardware and software, and systemd initializes and manages the services that keep the system running. Now, for the CompTIA A Plus Core 2 exam, you are not expected to be a Linux master. Instead, focus on understanding the purpose of these core components and how they work together to support the overall operation of the system. The same goes for all the Linux topics included in Exam Objective 1.9. Just keep things simple, focus on the basics, and you will do just fine come exam day. Exam Objective 1.10, given a scenario, install applications according to requirements. Software requirements. Before installing any application, it's important to understand that software doesn't run in isolation. Every application depends on the system it runs on, which means evaluating system requirements is a critical first step. Rather than jumping straight into installation, a better approach is to confirm that the system can properly support the application. This helps avoid performance issues, failed installations, or unexpected behavior after deployment. When reviewing system requirements, you are essentially making sure the hardware and operating system can handle the application. Starting with the CPU, or Central Processing Unit, this determines how quickly tasks can be processed. Applications such as video editing software, virtualization tools, or data analysis platforms often require multi-core processors with higher clock speeds. If the CPU does not meet the requirement, the application may run slowly or fail to function properly. Next is RAM, which plays a major role in how many tasks the system can handle at once. Basic applications may run smoothly with 8 GB of RAM, but more demanding software such as virtual machines or large-scale applications may require 16 GB or more. Insufficient RAM can lead to freezing, slow performance, or crashes. When working with graphic-intensive applications, you also need to consider the difference between a dedicated graphics card and integrated graphics. Dedicated graphics cards have their own processing power and video random access memory, or VRAM, making them ideal for tasks like 3D rendering, gaming, and video editing. Integrated graphics, on the other hand, share system memory and are better suited for basic tasks. If an application requires high graphical performance, relying on integrated graphics may not be sufficient. Storage requirements are another key factor. It's not just about having enough space to install the application itself, but also accounting for updates, temporary files, and the data the application will generate over time. For example, installing a professional video editing application on Windows 11 may only take a few gigabytes initially, but project files and exports can quickly consume much more space. In some environments, applications may also require external hardware tokens for authentication. An external hardware token is a physical device, such as a USB security key or smart card, that must be connected to the system to verify that the user or device is authorized to run the application. These tokens often work by generating or storing secure authentication data that the software checks before allowing access. Without the required token, the application may not launch at all, which is common in secure or enterprise environments where access needs to be tightly controlled. Finally, always consider application to operating system compatibility. Not all applications are designed to run on every version of an operating system. For example, an application designed for Windows 10 may not function properly on Windows 11 without updates or certain compatibility settings enabled. Verifying compatibility helps prevent installation failures and ensures the application runs as expected. Once you've confirmed the system meets the application requirements, the next step is understanding the impact of installing the application. Starting with the device, new applications can consume system resources such as CPU, RAM, and storage. A high-performance application might slow down other processes or reduce overall system responsiveness, especially on lower-end hardware. From a network perspective, some applications rely heavily on internet connectivity. Cloud-based applications, automatic updates, and synchronization features can increase bandwidth usage. This can affect other users on the network, especially in shared environments. Looking at operations, installing new software can introduce additional maintenance requirements. Applications often need updates, patches, and occasional troubleshooting. This can increase the workload for IT support teams and may lead to downtime if not managed properly. Finally, from a business standpoint, new applications can introduce considerations such as licensing costs, training requirements, and compliance concerns. Users may need time to learn the new software, and organizations must ensure that licenses are properly managed and maintained. By taking the time to evaluate both system requirements and potential impact, you can help ensure that applications are installed successfully and perform as expected, without creating new issues for the user or the organization. Exam Objective 1.10. Given a scenario, install applications according to requirements. Software architecture. Next up in our learning journey, we're going to take a look at 32-bit and 64-bit software architecture. But before we get there, we need to understand the difference at the processor level. A 32-bit processor is designed to handle instructions that are 32 bits in size, while a 64-bit processor can handle 64-bit instructions. That might sound simple, but this difference directly impacts how much data the system can process at once and how much memory it can efficiently use. From there, this creates a chain of compatibility that starts with the processor and trickles down from there. A 32-bit processor can only run a 32-bit operating system. On the other hand, a 64-bit processor can run both 64-bit and 32-bit operating systems. This same relationship carries over to software applications. A 32-bit operating system can only run 32-bit applications, while a 64-bit operating system can run both 64-bit applications and most 32-bit applications. This is important when installing software, because choosing the wrong version can lead to compatibility issues or prevent the application from installing altogether. You may also come across the terms x86 and x64 when working with software. Despite how it sounds, x86 refers to 32-bit architecture, while x64 refers to 64-bit architecture. The naming comes from older processor models, but for exam purposes, just remember x86 equals 32-bit, and x64 equals 64-bit. Now let's connect this to what you'll actually see in a Windows 11 environment. On a 64-bit version of Windows, applications are stored in two separate directories to maintain compatibility. The Program Files directory is used for 64-bit applications. This is the default location for modern software designed to take full advantage of a 64-bit system. The Program Files x86 directory is used for 32-bit applications. The x86 label indicates that these applications were built for a 32-bit architecture. By separating these applications, Windows can apply the appropriate compatibility settings and ensure they run correctly alongside 64-bit software. Understanding this structure is important when installing or troubleshooting applications, especially in environments where both 32-bit and 64-bit software are being used. Exam Objective 1.10. Given a scenario, install applications according to requirements. Distribution methods. Once you've confirmed that a system meets the necessary requirements for an application, the next step is understanding how that software is delivered and installed. This brings us to software distribution methods. Software can be distributed in several different ways, and each method has its own use case depending on the environment and the size of the deployment. Starting with physical media, this includes items such as USB drives, DVDs, or other removable storage devices that contain installation files. While this used to be the primary way software was distributed, it has become less common in modern environments. However, it is still useful in situations where systems do not have reliable internet access or when working in secure environments that restrict downloads. A more modern approach is the use of a mountable ISO file. An ISO file is a complete image of a disk, containing all the files and structure needed for installation. Instead of using a physical disk, the ISO file can be mounted directly, making it appear as if a physical drive has been inserted. Once mounted, you can open the virtual drive and run the installer just like you would from a USB or DVD. This provides the same functionality as physical media, but with greater convenience and flexibility. Another very common software distribution method is the downloadable package. This involves downloading the installation files directly from the internet, typically from a vendor's website or an official application store. Downloadable packages are popular because they provide quick access to the most up-to-date versions of software, including patches and security updates. This method is widely used for everyday applications such as web browsers, productivity tools, and utilities. However, it's important to ensure that downloads come from trusted sources, as installing software from unverified locations can introduce security risks. In larger environments, especially within organizations, software is often installed using image deployment. Image deployment involves creating a pre-configured system image that includes the operating system, applications, settings, and configurations. This image can then be deployed to multiple machines at once, ensuring consistency across all devices. For example, instead of installing applications individually on every computer, an organization can deploy a single image that already includes everything needed. This saves time, reduces errors, and ensures that all systems are configured in the same way. This method is commonly used in enterprise environments, schools, and IT departments where large numbers of systems need to be set up quickly and efficiently. Exam Objective 1.11. Given a scenario, install and configure cloud-based productivity tools. As we close out Domain 1, let's shift our focus to cloud-based productivity tools, which are widely used in both personal and professional environments. Cloud-based productivity tools are applications that allow users to create, store, and collaborate on content over the internet, rather than relying on a single local device. This means users can access their work from anywhere, share files easily, and collaborate in real time. The first cloud-based productivity tool we will cover is email systems. An email system is used to send, receive, and manage messages between individuals and teams. In many environments, email serves as the foundation for communication, especially for more formal or documented interactions. Beyond basic messaging, most modern email platforms also include integrated features such as calendars, contact management, task tracking, and meeting scheduling. This allows users to not only communicate, but also organize their time and coordinate with others efficiently. In a business setting, email systems are often tied to user accounts and organizational directories, making them a central hub for communication and collaboration. Common examples include Microsoft Outlook, Gmail, and Apple Mail. Next is cloud storage, which allows users to store files online rather than locally on a device. This provides flexibility, as users can access their files from multiple devices as long as they have an internet connection. A key concept here is synchronization, often abbreviated as sync. Syncing ensures that files stored in the cloud are automatically updated across all connected devices. For example, if you update a document on your laptop, that same updated version will appear on your desktop or mobile device without needing to manually transfer it. Another important aspect is folder and sharing settings, which allow users to control what content is synced, who has access to it, and what level of permissions they have, such as view-only or full editing rights. This is especially important in collaborative environments where multiple users are working with the same files. Proper configuration of these settings helps prevent issues like broken links or restricted access. Popular examples include OneDrive, Google Drive, and Dropbox. Now let's look at collaboration tools, which are designed to help users work together in real time, regardless of location. These tools are essential in modern environments where teams are often distributed across different locations. Starting with word processing tools, these allow users to create, edit, format, and print text-based documents collaboratively. Multiple users can work on the same document at the same time, with changes appearing in real time. Many platforms also include features such as comments, version history, and track changes, making it easy to review edits and maintain document integrity. Next are spreadsheet tools, which are used to organize, manipulate, and analyze numerical data in a tabular format. These tools support formulas, charts, and data analysis features, and also allow multiple users to collaborate simultaneously. This makes them especially useful for budgeting, reporting, and data-driven decision-making. Presentation tools allow users to combine text, images, videos, and other multimedia elements to create visual slideshows. These are commonly used in meetings, training sessions, and team briefings. Like other collaboration tools, they often support shared editing, allowing multiple users to contribute to the same presentation. Next up, we have video conferencing tools, which enable real-time communication between multiple participants through video and audio calls. These tools often include additional features such as screen sharing, recording, chat functionality, and virtual whiteboards, making them ideal for remote collaboration, training, and presentations. And finally, instant messaging tools allow for real-time text communication between individuals or groups. These are typically used for quick questions, updates, and team coordination without the need for formal emails. Many platforms also support file sharing, group channels, and integration with other tools, making them a fast and efficient way to stay connected. While each of these tools serves a different purpose, they are often used together as part of a connected system. Email, cloud storage, and collaboration platforms all rely on user accounts to control access and ensure the right people can view and edit the right content. To make this work smoothly, there needs to be a consistent way to manage those user accounts across multiple services. This is where identity synchronization comes into play. Identity synchronization is the process of keeping user accounts consistent across different systems and platforms. Instead of creating separate usernames and passwords for each tool, a single account can be used across email systems, storage platforms, and collaboration tools. This allows users to log in once and gain access to everything they need. It improves the user experience by reducing the number of logins required and also helps organizations manage security more effectively by centralizing account control. Building on identity synchronization, the next piece to understand is licensing assignment. Licensing assignment is the process of granting users access to specific applications and features based on a valid software license. In cloud environments, simply having an account is not always enough. The user must also be assigned the appropriate license to unlock the tools they need. For example, a user may be able to sign into a cloud platform, but when they open an application, certain features may be disabled or unavailable. This is often because a license has not been assigned to that user account. Once the correct license is assigned, those features become available immediately, allowing the user to fully access the application. This is commonly managed through an administrative portal, where IT teams can assign, modify, or remove licenses as needed. Licensing assignment is especially important in organizational environments, where different users may require different levels of access. Some users may only need basic functionality, while others may require advanced features based on their role. If a user cannot access a feature or application, one of the first things to check is whether the proper license has been assigned. And just like that, you've wrapped up one of the most expansive sections of the CompTIA A Plus, Core 2 exam. Throughout this domain, you built a strong foundation around operating systems, starting with understanding different OS types and file systems, then moving into installations, upgrades, and real-world considerations like compatibility and end-of-life systems. From there, you worked through Windows additions and features, explored essential tools like Task Manager and the Microsoft Management Console, and even stepped into the command line to gain a deeper level of control. You didn't stop at Windows either. You expanded into Mac OS and Linux, gaining exposure to their tools, structures, and best practices. And to round it all out, you applied that knowledge to installing applications and working with cloud-based productivity tools, which reflects how modern IT environments actually operate. And here's the part you should really take a moment to appreciate. The majority of the learning for this exam is now behind you. Everything you've covered so far builds the core of your understanding, and that foundation is going to make the remaining topics feel much more manageable and allow me, as your instructor, to move a lot quicker. Now we will shift gears into security, where the focus moves from making systems work to making sure they are protected. Great job so far, and let's keep the momentum going. Exam Objective 2.1 Summarize various security measures and their purposes. Physical security. Welcome to the start of Domain 2, where we dive headfirst into the world of security. This domain is all about safeguarding your IT environment from threats, and it's packed with essential knowledge that will not only help you ace the CompTIA A Plus Core 2 exam but also keep your systems secure in the real world. In this video segment, we're focusing on physical security, because no matter how tight your network defenses are, they won't help much if someone can just walk in and take what they want. So, before we jump into the specific tools and techniques, let's quickly define what physical security is. Physical security refers to the measures taken to protect the physical assets of an organization, such as buildings, equipment, and people, from unauthorized access, damage, or theft. Think of it as the layer of protection that guards the actual, physical location where your data and IT systems reside. Without it, even the most sophisticated cybersecurity strategies can be easily compromised. First on the list of physical security devices is the access control vestibule, often referred to as a man-trap. This is a secure entry system with two gateways, only one of which is open at any one time. This is your go-to solution for restricting access to sensitive areas like a data center. Picture it, you step into a small room, the door behind you locks, and now you need to authenticate, whether it's with a badge, a fingerprint, or even a retinal scan, before you can proceed. If everything checks out, you're allowed in; if not, you're stuck until security arrives. This setup is considered the best way to control physical access to critical areas because it ensures that only authorized personnel get through, and there's a clear record of everyone who does. Next on the list is the badge reader. This handy device verifies an individual's identity by scanning their ID badge before granting access to restricted areas. It's quick and efficient, and logs every entry and exit. If something goes wrong, you'll have a record of who was where and when, which is vital for both security and accountability. However, one downside is that a badge can be stolen or lost, potentially allowing unauthorized access. This is why it's important to have additional layers of security to complement the use of badge readers. Video surveillance is another essential tool in physical security. Video surveillance involves using cameras to monitor and record activities in and around a facility, providing real-time observation and recorded evidence of incidents. Strategically placed cameras can deter unauthorized access and provide crucial evidence in the event of a security breach, making them a key component of any physical security strategy. Alarm systems are a security measure that triggers a response when unauthorized access is detected. Whether someone forces a door open or breaks a window, alarms can notify security personnel or even law enforcement in an instant. Paired with motion sensors, which detect movement in areas that should be secure, you have a robust system for detecting and responding to threats. Let's not forget about door locks, which are your first line of defense at any entry point. A door lock is a mechanical or electronic device used to secure a door and restrict access to authorized individuals. These can range from traditional keyed locks to advanced biometric systems that use fingerprints, facial recognition, or iris scans to grant access. Biometric locks are especially secure since they rely on something unique to each individual, making them much harder to bypass than a key or code. But it's not just doors you need to worry about, your equipment should be under lock and key too. Equipment locks are a security device that physically secures equipment to prevent unauthorized removal or theft. Think of them as digital padlocks, easy to attach but tough to remove without the right tools. They're perfect for those high-traffic areas where you can't always keep an eye on your gear. Now let's not forget about the human element. While all the technology in the world is great, there's nothing quite like having a trained security guard on site. Guards are trained professionals responsible for protecting assets, monitoring for suspicious activity, and responding to security incidents. Generally, they provide a level of security that machines just can't match. They are often your first line of defense and your last one too. Finally, let's talk about bollards and fences. Bollards are those sturdy posts you see outside buildings, designed to prevent vehicles from driving into sensitive areas. They're tough enough to stop a truck, yet they don't get in the way of pedestrians or everyday traffic. Fences, on the other hand, are more about keeping out unwanted visitors on foot. A good, high fence with a secure gate can be a great deterrent. On that note, each of the physical security devices we covered serve as a foundation for a secure IT environment, ensuring that your digital defenses have the solid backing they need to be effective. Exam Objective 2.1 Summarize various security measures and their purposes. Physical access security. Whether it is employed staff, a customer, or a visitor, providing the means for them to enter or exit a controlled space can be accomplished using many different technologies. Let's see how we can manage these comings and goings in a secure and efficient way. First up, let's talk about keys. They might be old school, but keys are still a fundamental part of physical security. A key is a mechanical device that physically opens locks, granting access to doors, cabinets, and other secured areas. Despite their simplicity, keys are highly effective and widely used. However, their security is only as good as the control you have over them. Lose a key, and you might need to change the locks. But keys are reliable, easy to use, and don't require batteries or software updates, making them a go-to option in many scenarios. Moving into the modern age, we have key fobs. A key fob is a small electronic device that communicates with a reader to grant access to a secured area. Instead of inserting a physical key, a user simply taps or holds the fob near the reader, which then verifies the credential and unlocks the door if access is approved. These devices are commonly used for building entry systems, office environments, and even vehicle access, making them a convenient alternative to traditional keys. One of the biggest advantages of key fobs is manageability. If a fob is lost or stolen, it can be quickly deactivated within the access control system without needing to replace any physical locks. New fobs can also be issued and configured with specific permissions, allowing organizations to control exactly which areas a user can access. This makes key fobs not only convenient, but also a scalable and secure solution for modern access control systems. Then there are smart cards, which work similarly, embedding integrated circuits that can store and process data, making them more secure and versatile. Smart cards can not only grant access but also store information like digital certificates, making them useful for both physical and digital security. A newer variation of the smart card is the mobile digital key. A mobile digital key is a security credential stored on a mobile device that uses technologies such as NFC or Bluetooth to authenticate a user and grant access to secured systems or physical locations. Instead of carrying a separate badge or card, the phone itself becomes the credential. You may see this used in corporate buildings, hotels, or even for unlocking vehicles. One advantage of mobile digital keys is that access permissions can be managed remotely, updated quickly, or revoked if needed, making them both convenient and secure. Now, let's get into the cool stuff: biometrics. Biometrics use unique physical characteristics to verify identity, adding a layer of security that's tough to beat. There are several types to consider. One such type is a retina scanner. These scanners use the unique pattern of blood vessels in your eye to verify your identity. It's like having a personal, built-in barcode that's almost impossible to replicate. Fingerprint scanners are more common and use the unique ridges and patterns on your fingertips for identification. These are found everywhere from smartphones to high-security buildings. Palm print scanners take fingerprint scanners a step further by scanning the entire palm, capturing even more unique features than a fingerprint alone. This makes it an excellent option for environments where top-level security is needed. Facial recognition technology, often abbreviated as FRT, identifies a person by analyzing unique facial features such as the distance between the eyes, the shape of the jawline, and other distinct characteristics. This is commonly used in smartphones and security systems for quick, hands-free authentication. Voice recognition technology verifies identity based on the unique characteristics of a person's voice, such as tone, pitch, and speaking patterns. This is often used in call centers and virtual assistants to authenticate users without requiring physical interaction. All of these biometric systems are powerful because they rely on something that can't be easily lost or stolen. Next, let's discuss an often overlooked, yet still very important security measure: lighting. Good lighting is more than just a way to see where you're going, it's a physical security tool. Well-placed lighting can deter unauthorized access by making it harder for intruders to hide in shadows. Motion-activated lights, for example, can startle would-be intruders and alert security staff to unexpected movement. Finally, we have magnetometers, which is just a fancy name for metal detectors. Magnetometers detect the presence of metal by sensing the magnetic fields generated by metallic objects, making them ideal for security checkpoints where you need to ensure no unauthorized items, like weapons, are being brought into a controlled area. They're common in places like airports, government buildings, and even some large corporate offices. So, whether you're using a traditional key, a smart card, or a retina scanner, the goal is always the same: secure the premises and keep everyone safe. Each of these technologies has its place in the security landscape, offering different levels of protection and convenience. Exam Objective 2.1 Summarize various security measures and their purposes. Logical security. Logical security refers to the measures used to protect systems, data, and digital resources from unauthorized access through software-based controls. While physical security protects things you can touch, logical security protects what happens inside the system, such as who can sign in, what resources they can access, and what actions they are allowed to perform. At its core, logical security is about controlling access. It helps ensure that authorized users can reach the resources they need, while unauthorized users are blocked. This can involve verifying identities, assigning permissions, enforcing password requirements, encrypting sensitive information, and monitoring activity for suspicious behavior. In many ways, logical security acts as a digital gatekeeper. Logical security is not one single tool or setting, but a collection of protections that work together to reduce risk. A user may be required to authenticate before accessing a system, permissions may restrict what files they can open or modify, and monitoring tools may help detect suspicious activity. Each of these controls contributes to protecting systems and data from misuse or compromise. Logical security is especially important because many threats are not physical in nature. Cyberattacks, unauthorized logins, insider misuse, and accidental data exposure often target weaknesses in logical controls rather than locked doors or physical barriers. That is why organizations rely on these protections to help preserve confidentiality, integrity, and availability of information. In practice, logical security shows up almost everywhere in IT, from logging into a workstation, to accessing a shared network folder, to using cloud applications protected by layered authentication. Many of the security mechanisms used in modern environments build on this foundation, making logical security a core concept for both the exam and real-world administration. Exam Objective 2.1 Summarize various security measures and their purposes. Least privilege. Principle of least privilege is the practice of giving users or systems only the permissions they absolutely need to perform a task or job function, and nothing more. The idea is simple. If access is not required, it should not be granted. This helps reduce risk in several ways. If a user account is compromised, an attacker would only have access to the limited resources tied to that account, rather than unrestricted control of a system. It also helps prevent accidental mistakes, such as a user deleting files or changing settings they were never supposed to modify in the first place. A common example of least privilege would be a standard employee account versus an administrator account. Most users do not need the ability to install software, modify system-wide settings, or create other user accounts, so those elevated privileges are typically reserved for administrators. By limiting powerful permissions to only those who truly need them, organizations reduce their attack surface. You may also see least privilege tied to role-based access, where permissions are assigned based on a person's responsibilities. Someone in accounting may have access to financial systems but not server administration tools, while a help desk technician may have password reset permissions but not full domain control. In this way, access is based on job function rather than giving every user broad permissions. This principle applies not only to users, but also to applications, services, and processes. For example, a service account used by an application may only be granted access to a specific database it needs to function, rather than broad access across an environment. Ultimately, least privilege is about reducing unnecessary access before it becomes a security problem. It is one of the most fundamental security practices you will encounter, and it supports many other security models you will study later. Exam Objective 2.1 Summarize various security measures and their purposes. Access Control Lists. Access control lists, often abbreviated as ACLs, are a set of rules that specify the rights or privileges granted to users or systems. Put another way, ACLs are used to manage and regulate what users, groups, or processes are allowed to do when interacting with system resources. Building upon least privilege, ACLs help enforce those permission decisions. If least privilege answers the question how much access should someone have, an ACL helps define exactly what that access looks like. It can determine whether a user can read a file, modify a folder, execute a program, or be denied access altogether. A common example can be found in an NTFS file system, where an ACL may allow one user to view a document but prevent them from changing or deleting it. Another user, perhaps a manager or administrator, might have broader permissions on that same resource. This granular control helps ensure sensitive data is only available to authorized users. ACLs are not limited to files and folders either. They can also be used with network resources, shared drives, printers, and even network devices to permit or deny traffic based on defined rules. In that sense, ACLs can help control both access to data and access across a network. You can also think of ACLs as one practical way organizations implement least privilege. Rather than giving broad access by default, administrators can assign permissions deliberately based on need. That helps reduce accidental changes, insider misuse, and unauthorized access. In practice, ACLs are powerful because they allow permissions to be customized at a very granular level, helping organizations protect resources while still allowing users to do their jobs efficiently. Exam Objective 2.1 Summarize various security measures and their purposes. Zero Trust Model. The Zero Trust Model is a security approach based on the idea of never automatically trusting any user identity, device, or connection, even if it originates from inside the network. Instead, access requests must be continuously verified before access is granted. Traditionally, many networks operated on a trust model where users inside the network perimeter were often assumed to be safe. Zero Trust challenges that assumption. It treats every access request as potentially untrusted and requires verification based on factors such as identity, device health, location, and the resource being requested. As this visual here suggests, zero trust can apply across many parts of an environment, including users, endpoints, data, applications, infrastructure, and networks. Rather than assuming trust in any one area, each access request is evaluated before access is allowed. A core idea behind zero trust is often summarized as never trust, always verify. A user may successfully sign in, but that does not necessarily mean unrestricted access is granted. Additional checks may be required before reaching sensitive systems, and access may be re-evaluated during a session. Zero trust is often associated with three guiding principles. First, verify explicitly, meaning access decisions are based on multiple factors such as identity, device health, and other contextual information. Second, use least privileged access, limiting users to only the access they need. Third, assume breach, meaning systems are designed with the understanding that threats may already exist and should be contained. This model works closely with concepts you have already seen, particularly least privilege and access control lists. In this way, zero trust is not one single product, but a broader security strategy built from multiple controls working together. Ultimately, zero trust helps reduce the risk of unauthorized access, account compromise, and lateral movement by requiring continuous verification rather than assuming trust has already been earned. Exam Objective 2.1 Summarize various security measures and their purposes. Multi-factor authentication. When accessing digital systems, we often encounter prompts asking for credentials. Using just one authentication factor, like a password, to verify your identity is known as single-factor authentication, often abbreviated as SFA. This straightforward process verifies your identity using only one piece of evidence. However, as security needs have evolved, so have authentication methods. Multi-factor authentication, or MFA, requires two or more forms of authentication from different authentication factors to verify identity. MFA can involve a combination of elements such as something you know, like a password, something you have, such as a token or mobile device, something you are, like a fingerprint or retina scan, and in some cases, even somewhere you are, based on location. By requiring more than one authentication factor, MFA significantly enhances security because even if one factor is compromised, additional barriers remain in place. Before looking at individual MFA methods, it helps to understand the idea of a one-time password or passcode, often abbreviated as OTP. An OTP is a code that can be used only once, usually during a login or verification process. Unlike a traditional password, it expires after use or after a short period of time, reducing the risk of reuse by an attacker. You might encounter OTPs in many forms throughout modern authentication, whether delivered by email, SMS text message, voice call, or generated by an authentication device or application. The key idea is that the code is temporary and single-use, making it much harder for an attacker to capture and reuse successfully. One MFA method in use today involves email tokens. With this option, a code or verification link is sent to your email address as a second step in authenticating. After entering your password, you may be prompted to retrieve the code from your email inbox and enter it before access is granted. Even if someone knows your password, they would also need access to your email account to complete the login. This makes email-based authentication a practical second factor, particularly in environments where dedicated authentication tools may not be deployed. Next, there are hardware tokens, sometimes called hard tokens. A hardware token is a physical device used as part of an MFA system that generates a unique, time-sensitive code the user enters during sign-in. Some hardware tokens have a small display that continuously shows changing codes, while others may be inserted or tapped to authenticate. Because the token is something the user physically possesses, it represents the something you have factor in MFA. Another common MFA method is an authenticator application. An authenticator application is a software-based authentication tool installed on a device that provides a second factor of authentication, often by generating time-based one-time passwords or approving login requests through push notifications. Many authenticator applications function as a soft token, meaning they provide the capabilities of a hardware token through software rather than requiring a separate, dedicated physical device. This makes them scalable, convenient, and widely used in modern environments while still supporting strong authentication practices. One function often provided by an authenticator application is generating a time-based one-time password, or TOTP. A TOTP is a type of OTP that changes automatically after a short interval, giving the user a constantly rotating verification code. Because the code quickly expires and a new one replaces it, there is only a small window in which it can be used, helping reduce the risk of interception or reuse. Some authenticator applications may also support push notifications, where instead of typing a code, the user simply approves or denies a login request from the authenticator application directly. That can make authentication faster for the user while still providing a strong second factor. SMS tokens are another MFA method, where a one-time passcode is sent to a user's mobile phone via text message. After entering a password, the user receives the code by SMS and must enter it to complete the authentication process. Because the code is temporary and typically expires quickly, it provides an added layer of protection beyond a password alone. This is a familiar MFA method for many users because it is simple to implement and widely supported, especially for consumer services such as banking or online accounts. It also reinforces the something you have authentication factor, since access to the user's mobile phone is required to receive the token. Even if an attacker knows the password, they would still need access to that device to complete the login. And for one more MFA method, we have voice call authentication. This works similarly to SMS-based authentication, but instead delivers the one-time passcode through an automated phone call. The user answers the call, listens to the code, and then enters it into the system. In some cases, voice call authentication may be used as an alternative when text messaging is unavailable or as a backup authentication method. In practice, MFA strengthens security by requiring more than one form of proof before granting access. Whether through email, tokens, authenticator apps, SMS, or voice calls, the goal is the same: to make unauthorized access far more difficult, even if a password is compromised. Exam Objective 2.1 Summarize various security measures and their purposes. SAML. Security Assertion Markup Language, often abbreviated as SAML, is an open standard used to exchange authentication and authorization data between systems. It allows a user to sign in once and access multiple related systems without needing to log in again for each one. SAML works by passing authentication information, often called an assertion, between two main parties. One system, known as the identity provider, is responsible for verifying the user's identity. This is where authentication takes place, using methods such as passwords or multi-factor authentication. Another system, known as the service provider, relies on that verification and grants access to its resources without requiring the user to log in again. Instead of prompting for credentials, the service provider trusts the information it receives from the identity provider. SAML is commonly used in environments where users need access to multiple applications, especially cloud-based services. Instead of logging in separately to each system, the user begins by requesting access to a resource, such as a web application. If the user is not already authenticated, that request is redirected to a centralized system known as the identity provider. The identity provider then presents a login screen, where the user enters their credentials. This is where authentication actually takes place, and it may include methods such as passwords or multi-factor authentication. Once the credentials are verified against an authentication database, the identity provider generates a SAML response, confirming that the user has been successfully authenticated. That SAML response is then sent back to the original service provider, which trusts the identity provider's verification. Based on that trusted response, the service provider grants access to the requested resource. From the user's perspective, this process feels seamless, even though multiple systems are communicating behind the scenes. This is why a user might log in once and then gain access to email, file storage, and other business applications without being prompted to enter credentials again. Each service provider relies on the same trusted authentication process, rather than requiring its own separate login. It is important to understand that SAML is not the login itself, but the markup language that securely communicates the result of the login between systems. It allows different applications to trust a centralized authentication process rather than each system managing its own separate credentials. This centralized approach improves both security and usability by reducing the number of credentials users need to manage, which helps minimize password fatigue and the risk of weak or reused passwords. At the same time, authentication is handled consistently through a trusted source, allowing organizations to enforce stronger security policies, such as multi-factor authentication, across all connected systems rather than configuring them individually. Exam Objective 2.1 Summarize various security measures and their purposes. Single sign-on. How often do you find yourself juggling multiple accounts, each with its own unique username and password? This can quickly become cumbersome and difficult to manage. That is where single sign-on comes in. Single sign-on, commonly referred to as SSO, is a user authentication service that allows a user to use one set of login credentials, like a username and password, to access multiple applications. Think of it as a master key that unlocks several doors, eliminating the need to carry a separate key for each one. So, how does single sign-on work? Well, when you first log into an application that uses single sign-on or SSO, the system checks if you've been authenticated by the central SSO solution. If you haven't, it prompts you to log in. Once you provide your credentials, the SSO system validates them against a central database. Upon successful validation, the SSO system issues a token, a kind of digital stamp of approval. This token is then used for subsequent authentication requests during that session. As you navigate to another integrated application, instead of asking for your credentials again, the system requests the SSO solution to verify the token's validity. If the token is recognized and still valid, the second application grants you access without requiring another login. This process of token verification repeats for all integrated applications, ensuring a smooth and uninterrupted user experience. Now, that makes things much easier, doesn't it? And if you work in a corporate environment, using SSO is also likely to reduce the number of help desk tickets due to users forgetting their passwords. Now, if you're thinking this sounds a lot like SAML, you're not wrong. SSO describes the experience of logging in once and gaining access to multiple systems, while SAML, on the other hand, is one of the technologies that helps make that experience possible by securely passing authentication information between systems behind the scenes. So, while SSO is what the user experiences, SAML is often part of how it actually works. Exam Objective 2.1 Summarize various security measures and their purposes. Just-in-time access. Just-in-time access is a security approach that provides users with elevated permissions only when they are needed, and only for a limited amount of time. Instead of having constant access to sensitive systems or administrative privileges, users are granted access temporarily, just long enough to complete a specific task. This approach builds directly on the principle of least privilege. Rather than permanently assigning high-level permissions to a user account, just-in-time access ensures those permissions are only available when absolutely necessary. Once the task is complete or the allotted time expires, the elevated access is automatically removed. For example, an IT administrator may not have full administrative rights all the time. Instead, when they need to perform a system update or troubleshoot an issue, they can request elevated access. That access is granted for a short window, allowing them to complete the task, and then it is revoked. This reduces the risk of misuse, whether accidental or malicious. Just-in-time access also aligns closely with the zero trust model. Since access is never assumed to be permanent or unrestricted, every request for elevated privileges can be evaluated and approved based on current conditions. This helps limit the potential impact of compromised accounts by reducing how long sensitive access is available. This time-based and task-based approach helps organizations reduce their attack surface by minimizing standing privileges. Instead of leaving powerful access always available, it is granted only when needed and removed as soon as possible, helping maintain tighter control over critical systems. Exam Objective 2.1 Summarize various security measures and their purposes. Privileged Access Management. Privileged Access Management, often referred to as PAM, is a security approach used to control, monitor, and secure access to systems and resources that require elevated permissions. These elevated permissions are typically associated with administrative accounts or accounts that have the ability to make significant changes within an environment. PAM focuses on protecting these high-level accounts because they are often the most targeted by attackers. If a privileged account is compromised, it can provide broad access across systems, making it critical to tightly manage how and when that access is used. Building on this idea, it is not just about protecting privileged accounts, but also about controlling how and when their access is active. This is where the connection to just-in-time access comes into play. While just-in-time access focuses on limiting when elevated access is available, privileged access management ensures that access is properly controlled, approved, and monitored while it is in use. PAM solutions can enforce temporary access, require approval before privileges are granted, and ensure that access is removed once it is no longer needed. For example, a system administrator may request elevated access to perform a task. A PAM system can require approval, grant access for a limited time, and log all actions performed during that session. Once the task is complete, the elevated permissions are revoked, helping reduce the risk of misuse. PAM systems also provide visibility into privileged activity. This may include session recording, auditing, and alerting on suspicious behavior. By tracking how privileged accounts are used, organizations can detect potential threats and respond more quickly. Together, just-in-time access and privileged access management help organizations reduce risk by limiting how long privileged access exists and by maintaining strict control over how it is used. Exam Objective 2.1 Summarize various security measures and their purposes. Mobile Device Management. Mobile device management, often referred to as MDM, is a technology used by organizations to manage, secure, and enforce policies on mobile devices such as smartphones, tablets, and laptops. It allows IT administrators to maintain control over devices that access corporate data, whether those devices are company-owned, or part of a bring-your-own-device environment. MDM serves as a centralized solution for configuring and managing device settings across an organization. Instead of manually setting up each device, administrators can apply standardized configurations to ensure consistency. For example, an organization may require that all devices use encrypted connections for email, enforce screen lock policies, or automatically connect to approved wireless networks. In addition to configuration, MDM plays a key role in enforcing security policies across mobile devices. This can include configuring device security settings, such as requiring multi-factor authentication, and ensuring devices stay updated with the latest operating system patches. Administrators can also manage applications by allowing only approved apps to be installed, helping reduce the risk of malicious or unauthorized software. MDM also provides visibility into device status and location. Devices can be monitored for compliance, ensuring that security settings remain enabled and up to date. If a device falls out of compliance, access to corporate resources can be limited or revoked until the issue is resolved. In some cases, devices can also be located, which is especially useful if they are lost or misplaced. Another critical capability of MDM is remote control of devices. If a device is lost or stolen, administrators can remotely lock the device to prevent access or perform a full wipe to remove corporate data. These actions help protect sensitive information and ensure it does not fall into the wrong hands. By centralizing control, enforcing security policies, and enabling remote management, mobile device management helps organizations maintain visibility and security across all mobile devices that interact with their systems. Exam Objective 2.1 Summarize various security measures and their purposes. Data loss prevention. Data loss prevention, often referred to as DLP, is a set of tools and strategies used to detect, monitor, and prevent the unauthorized transmission or exposure of sensitive data. Its primary goal is to ensure that critical information does not leave an organization's control, whether accidentally or intentionally. DLP focuses on protecting data at rest, in use, and in transit. This means continuously monitoring data as it is stored, accessed, and moved across systems or networks. As data flows through the environment, DLP solutions inspect it using predefined rules and pattern matching to identify sensitive information. These rules may detect things like credit card numbers, personal data, or confidential documents based on known formats, keywords, or data patterns. Once sensitive data is detected, the DLP system can take action based on configured policies. For example, it may block the transmission of that data, prevent it from being copied to external devices, or stop it from being sent outside the organization. In other cases, the data may be encrypted to protect it, or the system may generate an alert to notify an administrator. Some actions may also be logged for auditing and review. This combination of detection, monitoring, and automated response allows organizations to maintain control over how sensitive data is handled, helping reduce the risk of data exposure while still allowing normal business operations to continue. In practice, DLP systems can block or restrict actions that could lead to data exposure, but they also continuously track and analyze how sensitive data is being handled across the environment. For example, when sensitive information is detected, actions such as preventing emails from being sent externally, blocking uploads to unapproved services, or restricting transfers to removable devices can be enforced. These controls help reduce the risk of data leaks caused by human error or malicious activity. DLP systems also provide detailed visibility into data activity through centralized dashboards and reporting. This can include metrics such as the number of findings, the types of sensitive data detected, and how often data is being accessed or shared. By monitoring trends over time and breaking down categories of detected data, organizations can better understand where risks exist. This level of visibility makes it easier to identify unusual patterns, such as spikes in data access or large volumes of sensitive information being handled unexpectedly. With this insight, organizations can respond more quickly to potential security incidents and take action before data is exposed. By monitoring, controlling, and protecting sensitive information, data loss prevention helps organizations reduce the risk of data breaches and maintain control over their most valuable assets. Exam Objective 2.1 Summarize various security measures and their purposes. Identity Access Management. Identity Access Management, often referred to as IAM, is a framework of policies, technologies, and processes used to manage digital identities and control access to resources within an organization. It ensures that the right individuals have the appropriate access to systems, applications, and data at the right time. Building on that idea, once identities are established, IAM is responsible for verifying who a user is and determining what they are allowed to access. This includes managing user accounts, authentication methods, and permissions across systems. Whether it is logging into a workstation, accessing a cloud application, or retrieving sensitive data, IAM plays a central role in controlling access throughout an environment. At first glance, IAM can feel very similar to some of the concepts we have already covered, especially Privileged Access Management or PAM. That is because they both deal with controlling access to systems and resources. But this is where the distinction becomes important. IAM focuses on all users and their access across systems, handling identity creation, authentication, and authorization for everyday access. PAM, on the other hand, narrows that focus to accounts with elevated permissions, such as administrators, and adds an additional layer of control over how that high-level access is granted, monitored, and used. In simple terms, IAM determines who can access what, while PAM focuses on how elevated access is controlled and secured. With that distinction in mind, IAM can be thought of as managing the full lifecycle of user access. This begins when a user account is created, continues as permissions are assigned and adjusted based on job roles, and extends through to when access is removed as responsibilities change or when a user leaves the organization. Throughout this process, IAM ensures that access remains appropriate and controlled. As part of this lifecycle, IAM also supports authentication methods such as passwords, biometrics, and multi-factor authentication to verify identity. Once a user is authenticated, IAM applies authorization rules to determine which resources can be accessed, helping ensure that access is both secure and consistent across systems. By bringing identity management and access control together into a single framework, IAM helps organizations ensure that users can access the resources they need while maintaining strong control over security. Exam Objective 2.1 Summarize various security measures and their purposes. Directory services. When you step back and look at everything we've covered so far, from identity access management to the principle of least privilege, access control lists, authentication methods, multi-factor authentication, authorization, and even privileged access management, there's one question that naturally comes up. How is all of this actually managed and brought together in a real environment? That's where directory services comes in. Now, let's break that term into two parts, starting with the word directory. In this context, a directory is a structured database that stores information about users, computers, and other resources on a network. It keeps track of objects, like usernames, passwords, group memberships, and device details, all organized in a way that can be easily searched and managed. Within this structure, information is often grouped into logical containers such as domains and organizational units. These help organize users and devices based on factors like department, location, or role, making it easier to manage and apply policies across different parts of the organization. Next, the services part is what really brings the directory to life, and one of the most important ways this is done is through something called group policy. Group policy, often implemented through group policy objects, or GPOs, allows administrators to define and enforce rules across users and devices in the network. Instead of configuring settings on individual systems, these policies can be applied centrally and automatically. When a user signs in, the directory service helps authenticate their identity by verifying their credentials. Once authenticated, group policy can then be applied to that user or device, controlling things like security settings, access permissions, and system behavior. This is where everything we've discussed starts to connect. The directory holds the information, such as users, groups, and devices, and GPOs use that information to enforce policies like least privilege, apply access control rules, require multi-factor authentication, and manage privileged accounts. By using group policy, administrators can ensure that security settings are consistent across the entire environment. Whether it's restricting access, enforcing password policies, or controlling system configurations, everything can be managed from a central location and applied automatically. This centralized approach not only improves security, but also makes large environments much easier to manage and maintain. At the end of the day, the directory is the organized collection of information, and the services are what use that information to control access and enforce security. Together, directory services provide the structure, consistency, and centralized control needed to manage users and resources in a real-world network. Exam Objective 2.2. Given a scenario, configure and apply basic Microsoft Windows OS security settings. Defender Antivirus. Windows Defender Antivirus, now commonly referred to as Microsoft Defender Antivirus, is a built-in security feature in Windows that provides real-time protection against viruses, malware, ransomware, and other threats. It operates continuously in the background, scanning files, downloads, applications, and system activity to help prevent malicious software from compromising the computer. While it is integrated into Windows security, Defender Antivirus functions as its own dedicated antivirus component within the overall security suite. Most of the time, Microsoft Defender Antivirus manages itself automatically, but it is still important to understand how to activate, deactivate, and update it. There may be situations where real-time protection needs to be temporarily disabled, such as when troubleshooting software conflicts or installing another antivirus solution. However, because Defender Antivirus helps actively protect the system from threats, disabling it should only be done when absolutely necessary. To manage Microsoft Defender Antivirus settings in Windows 11, begin by opening Settings and selecting Privacy and Security. From there, select Windows Security, followed by Virus and Threat Protection. This section provides access to scan options, protection history, threat information, and Defender Antivirus settings. Within the Virus and Threat Protection area, you will see an option labeled Manage Settings. Selecting this option allows you to enable or disable features such as real-time protection using an on-off toggle. Real-time protection continuously monitors the system for suspicious activity and scans files as they are opened, downloaded, or executed. If this protection is disabled, the system becomes more vulnerable to malware and other threats, so it should be turned back on as soon as possible. Another important part of Defender Antivirus is keeping its virus definitions up to date. Virus definitions are databases of known threats that allow the antivirus software to recognize and respond to malware. As new threats are discovered, Microsoft regularly releases updated definitions to improve protection against the latest attacks. In most cases, these updates are downloaded automatically through Windows Update. However, there may be times when you want to manually check for updates, especially if a system has been offline for a period of time, or you suspect the definitions may be outdated. To manually update Defender Antivirus definitions, return to the Virus and Threat Protection section and locate the option to check for protection updates. Performing these updates helps ensure the system can recognize and defend against even the newest forms of malware. Exam Objective 2.2. Given a scenario, configure and apply basic Microsoft Windows OS security settings. Defender Firewall Management. In this video segment, we will cover Defender Firewall. This is another built-in Windows security feature designed to help protect a system from unauthorized network access. While antivirus software focuses on detecting and stopping malicious files or software, the firewall focuses on monitoring and controlling network traffic. It acts like a security checkpoint for your computer, deciding which network connections are allowed in or out based on configured rules and security settings. We have already discussed firewalls earlier in the course, but now the focus shifts to managing Microsoft Defender Firewall directly within Windows 11. This includes activating and deactivating the firewall, understanding basic port security concepts, and controlling which applications are allowed to communicate through the network. By default, Microsoft Defender Firewall is enabled in Windows 11, and in most situations it should remain enabled to help protect the system. However, there may be times when it needs to be temporarily disabled, such as when troubleshooting connectivity problems or testing network configurations. To manage the firewall in Windows 11, begin by opening Settings and selecting Privacy and Security. From there, choose Windows Security, followed by Firewall and Network Protection. Inside this area, you will see separate firewall settings for different network profiles, including domain, private, and public networks. Selecting one of these profiles allows you to enable or disable the firewall using an on-off toggle. Each profile is designed for different network environments. For example, a public network profile is typically more restrictive because it is intended for less trusted environments such as public Wi-Fi. Just remember, disabling the firewall reduces protection against unauthorized access and should only be done temporarily when necessary. Once the firewall is enabled, one of its key jobs is controlling access through ports. Ports are communication channels used by devices and applications to send and receive network traffic. Different services use specific port numbers. For example, DNS commonly uses port 53, HTTP uses port 80, HTTPS uses port 443, and Remote Desktop Protocol, or RDP, uses port 3389. Port security helps reduce risk by allowing only the network traffic that is actually needed. The fewer open ports a system has, the fewer potential entry points exist for attackers. For example, imagine a technician needs to remotely troubleshoot a web server using Remote Desktop. Even if the server is online and reachable, the connection will fail if port 3389 is blocked by the firewall. In that situation, a firewall rule would need to be created or adjusted to temporarily allow inbound RDP traffic through port 3389. Once the troubleshooting session is complete, closing the port again helps reduce unnecessary exposure. Another important firewall function is application security. Some applications require network access in order to function properly, but unrestricted access can create security risks. Microsoft Defender Firewall allows administrators and users to control which applications are permitted to communicate across the network. To manage this in Windows 11, return to the Firewall and Network Protection section and select Allow an app through Firewall. This area displays a list of installed applications and features that can communicate through the firewall. From here, applications can be allowed or blocked, and separate permissions can be configured for private and public networks. This helps ensure that only trusted applications are allowed to send or receive network traffic, reducing the risk of unauthorized communication or malware activity. Exam Objective 2.2. Given a scenario, configure and apply basic Microsoft Windows OS security settings. Users and groups. For our next video segment, let's talk about users and groups in Windows. Whether it is a personal computer at home or a device connected to a corporate network, properly managing user accounts is an important part of both security and functionality. Different account types are designed with different levels of access, helping ensure that users can perform the tasks they need while reducing the risk of accidental changes or unauthorized activity. When creating a user account in Windows, there are two primary account options: a Microsoft account or a local account. A Microsoft account connects the user to Microsoft's online ecosystem and cloud-based services. This allows features such as OneDrive cloud storage, Microsoft Store access, password recovery, and synchronization of settings across multiple Windows devices. For example, desktop settings, browser bookmarks, saved passwords, and even Wi-Fi profiles can follow the user from one Windows device to another when signed in with the same Microsoft account. While Microsoft accounts focus heavily on cloud connectivity and synchronization, local accounts take a much more device-centered approach. A local account exists only on the specific device where it was created and does not rely on Microsoft's online services. Because of this, settings and files are not automatically synchronized to the cloud. Some users prefer local accounts because they provide a more traditional offline experience and keep account data limited to the device itself. In environments where privacy or isolated systems are important, local accounts are still commonly used. Once accounts are created, Windows uses different account types and permission levels to control what users are allowed to do. One example is the guest account, which is designed for temporary access with very limited permissions. A guest user can typically perform only basic tasks, such as browsing the web or accessing shared files, but cannot install software or make system-level changes. This makes the guest account useful for situations where short-term access is needed without giving the user the ability to significantly modify the system. The most common account type is the standard account. Standard users are intended for normal day-to-day activities such as browsing the internet, running applications, and managing personal files. However, they are restricted from installing many applications or changing important system settings. This helps balance usability with security by giving users enough access to perform regular tasks while reducing the risk of accidental or unauthorized changes. Next is the power user role. Power users have more permissions than standard users and can install software or adjust certain system settings, but they still do not have full administrative control. This role acts as a middle ground between a standard account and an administrator account. While it is less common in modern versions of Windows, it is still important to recognize for exam purposes. At the top of the permission hierarchy is the administrator account. Administrators have full control over the system, including the ability to install and remove software, manage user accounts, configure settings, and make system-wide changes. Because this is the highest level of access, administrator privileges should be limited to only users who truly require them. Properly managing administrator accounts is an important part of maintaining system security. Building on these permission levels, Windows also includes an important security feature known as User Account Control, or UAC. User Account Control is a Windows security feature that helps prevent unauthorized system changes by requiring approval before administrative actions occur. Whenever an application attempts to install software, modify important settings, or perform other system-level changes, UAC generates a prompt requesting confirmation. Even users who are already signed in with an administrator account will still receive these prompts before major changes are allowed. This additional layer of verification helps reduce the risk of malware silently making changes in the background and also helps prevent accidental modifications by the user. This connects directly to another feature you will commonly encounter in Windows, known as Run as Administrator. Sometimes a task requires elevated permissions even though the user is normally operating with standard-level access. In those situations, a user can right-click an application and choose Run as Administrator to temporarily launch that program with elevated privileges. Rather than giving permanent administrative access to everything on the system, this approach allows administrative permissions to be used only when necessary, helping maintain a more secure environment overall. Exam Objective 2.2 Given a scenario, configure and apply basic Microsoft Windows OS security settings. Windows Login Options. When it comes to securing your system, the login options can be quite diverse. Windows offers several ways to log in, each with varying levels of security and convenience. In this video segment, I'll walk you through the different login methods available and where to find them in the Settings menu. To access your login options, go to the Settings and select Accounts. Then scroll down and select Sign-in Options. From here, you'll be able to set up or modify any of the following methods to secure your device. First on the list is facial recognition, which Windows has dubbed Windows Hello Face. Facial recognition is a convenient, hands-free login option available through Windows Hello. Using an infrared camera, this method scans your face to securely unlock your device. It's quick and highly secure, offering seamless access without the need to type anything. You can set this up in the sign-in options by selecting Windows Hello Face and following the prompts to register your face. Next, we have fingerprint authentication, another Windows Hello feature. This method lets you unlock your device by placing a finger on a fingerprint reader. To set it up, go to Sign-in options, select Windows Hello Fingerprint, and follow the prompts by placing your finger on the reader repeatedly until the setup is complete. This is a fast and secure way to log in, ensuring that only you can access your system. A personal identification number, or PIN, is a simpler alternative to a password, and it's unique to your device. Unlike a password, a PIN stays local to your machine and cannot be used on other devices or online services, making it a bit more secure in certain contexts. To set it up, go to Sign-in options, select Windows Hello PIN, and create your PIN. A security key is a physical device that provides an additional layer of protection. When logging in, just insert the key into your device. It's an excellent option for those seeking enhanced security, as it requires both the physical key and your presence. You can set this up under Sign-in options by selecting Security Key and following the steps to pair the key with your device. The password remains the most traditional login option. It's widely used, but it's also one of the most vulnerable methods due to the risk of weak or reused passwords. To maximize security, always use strong, unique passwords for each device. You can also update or change your password by selecting the password option in Sign-in options. For a more creative login option, you can set up a picture password. This method allows you to choose an image and draw a series of gestures on it, such as circles or lines, which you then use to unlock your device. It's less common but provides a fun, personalized way to log in. You can set this up in Sign-in options by selecting Picture Password and following the steps to configure your gestures. As you can see, Windows offers a wide variety of login options, from biometric methods like facial recognition and fingerprint to more traditional choices like a PIN, password, and even a picture password. You can also add an extra layer of security with a security key. Each option provides different levels of protection, so choose the method that best suits your needs and preferences for both convenience and security. Exam Objective 2.2. Given a scenario, configure and apply basic Microsoft Windows OS security settings. NTFS versus share permissions. When managing files and folders in a Windows environment, you will need to understand the difference between NTFS permissions and share permissions. Both play a role in determining who can access and modify your data, but they apply in different contexts. Let's dive into what each type of permission does, and how they work together to control access. NTFS permissions control access to files and folders on locally stored drives, formatted with the NTFS or New Technology File System. These permissions dictate what users can do with the files and folders, whether they're on a local machine or shared over the network. NTFS permissions apply no matter how a file or folder is accessed, making them particularly important for data security. The basic NTFS permissions include read, allowing users to view the contents of a file or folder, but not modify it, write, giving users the ability to modify and save changes, read and execute, which enables users to view and execute files, list folder contents, allowing users to see the names of files and subfolders within a folder, modify, which combines read, write, execute, and delete capabilities, and finally, full control, granting users complete authority over files, including the ability to modify permissions. In contrast to NTFS permissions, share permissions control access to files and folders shared over a network. These permissions are applied to shared folders and determine what network users can do when accessing these folders remotely. The basic share permissions are read, allowing users to view and open files but not modify or delete them; change, which grants users the ability to read, modify, and delete files; and full control, which gives users the highest level of access, including managing share permissions. It's important to remember that share permissions apply only when accessing resources over the network. If files or folders are accessed locally, only NTFS permissions come into play. When both NTFS and share permissions are in place, the most restrictive permission between them will apply. For example, if a user is accessing a file remotely and has full control through share permissions but only read access when it comes to NTFS permissions, they will only be able to read the file. In addition to permissions, files and folders in Windows have attributes that control how they behave. Common attributes include read-only, which allows files to be viewed but not modified, and hidden, which hides files from normal view unless the option to display hidden items is enabled. These attributes add an extra layer of control, beyond basic permissions. Another important concept is inheritance, which simplifies permission management. When you set permissions on a folder and have inheritance enabled, those permissions are automatically inherited by all subfolders and files within that folder. This is helpful for managing large folder structures because it eliminates the need to manually apply permissions to each file or subfolder. For instance, if you have a folder with read permissions, any new subfolder created within it will inherit the same read permission. Understanding the differences between NTFS permissions and share permissions is crucial for managing file security in a Windows environment. NTFS permissions apply both locally and over the network, while share permissions control access for remote users. When both are used, the most restrictive permissions will take precedence. Combine this with file attributes and inheritance, and you have a powerful set of tools to fine-tune access and ensure the security of your data. Exam Objective 2.2. Given a scenario, configure and apply basic Microsoft Windows OS security settings. Data at rest encryption. Before diving into encrypting file system, BitLocker, and BitLocker to go, it is important to briefly discuss a related security concept known as data at rest encryption. While data at rest encryption is listed in Exam Objective 2.7, these Windows security technologies are all direct examples of it in practice. Because of that, it makes much more sense to introduce the concept now, alongside the tools that actually implement it within Windows. With that said, imagine a calm, serene lake with the sun setting in the background. The stillness of the water is reminiscent of data at rest in the world of information technology. Simply put, data at rest refers to data stored on devices like computers or servers, not actively being used or transmitted. More specifically, it is the files and documents that sit quietly on your storage drive. However, this stillness doesn't guarantee safety. That's where data at rest encryption comes in. The first type of data at rest encryption we will discuss is file-level encryption. Additionally referred to as file-based encryption or file folder encryption, this method is distinct in its approach to data protection. Instead of encrypting an entire storage medium or device, file-level encryption zeroes in on individual files or directories, encrypting them directly through the file system. One commonly used tool for this type of encryption is encrypting file system, which is built into Windows. Encrypting file system, or EFS for short, allows you to encrypt specific files or folders on an NTFS formatted drive, providing a layer of security without needing to encrypt the entire drive. To encrypt a single folder, you simply right-click the folder, select Properties, and then select the Advanced tab. This will open another window. From here you just check the option for Encrypt Contents to secure data, and voila, you have just enabled EFS. Once encrypted, only users with the correct decryption key or access rights can view or modify the files, ensuring that sensitive data remains protected even on a shared system. While file-level encryption protects specific files or folders, disk-level encryption, also known as full disk encryption, offers a more comprehensive solution. Think of disk-level encryption as a protective shield that covers the entire storage device, whether it's your computer's hard drive or an external disk. If your goal is to protect everything on your device, from system files to personal data, disk-level encryption is the ideal choice. To understand why disk-level encryption is so important, consider the example of a stolen laptop. Because of their portability, laptops are prime targets for theft. But often, the true value for the thief isn't the device itself, it's the data stored inside. This could include anything from personal photos to sensitive business documents or financial information. Without encryption, a skilled thief could easily access this data by removing the hard drive and connecting it to another device, leading to privacy breaches or financial loss. One of the most commonly used tools for this level of protection in Windows is BitLocker. BitLocker encrypts the entire drive, ensuring that everything, from the operating system to personal files, remains secure. It works by scrambling the data on the disk, making it unreadable to anyone without the correct decryption key. This level of encryption provides peace of mind, particularly for users who store sensitive information on their devices. A key point to remember is that if the system undergoes significant changes, such as a major repair, OS reinstallation, or even certain BIOS updates, you may be required to use a recovery key to regain access to the encrypted data. This recovery key is essential because, without it, even the rightful owner can be locked out of their own data. Therefore, it's crucial to store this recovery key in a safe, accessible location, to avoid being permanently locked out of your encrypted system. For portable storage, we also have BitLocker to Go, which extends BitLocker's powerful encryption capabilities to removable devices like USB drives. This ensures that sensitive information transferred using USB drives remains secure, even if the drive is lost or stolen. Users can easily protect their data by encrypting the entire USB drive with BitLocker to Go, requiring a password or recovery key to unlock it on any device. Data at rest encryption plays a significant role in securing information that's not actively in use. File-level encryption, through tools like EFS, protects specific files and folders, while disk-level encryption, using methods like BitLocker, safeguards entire storage devices. Whether it's protecting individual files or ensuring that an entire system is secure, encryption is a powerful defense against unauthorized access. And for portable devices, let's not forget about BitLocker to Go, which ensures that sensitive data remains encrypted and safe, even when stored on USB drives. Together, these methods provide a robust solution to keep your data safe, no matter where it rests. Exam Objective 2.2. Given a scenario, configure and apply basic Microsoft Windows OS security settings. Active Directory. Active Directory environments begin with the concept of a domain. A domain is a network model where one or more servers, known as domain controllers, centrally manage users, computers, security settings, and other network resources. Rather than configuring every computer individually, administrators can manage systems from a centralized location, making administration more efficient and consistent across the organization. At the center of this environment are the domain controllers. Domain controllers are servers responsible for handling authentication, authorization, and directory-related services within the domain. When a user signs in, the domain controller verifies their credentials and determines what resources they are allowed to access. Domain controllers also help enforce security policies and maintain consistency across systems joined to the domain. This centralized management is made possible through Active Directory, often abbreviated as AD. Earlier in the course, we discussed directory services as the systems responsible for storing, organizing, and managing information about users, devices, and network resources. Active Directory is one of the most common real-world implementations of that concept in Windows environments. More specifically, Active Directory is a directory service developed by Microsoft that helps organize and manage resources, users, and devices within a domain. Before a computer can fully participate in this centralized environment, it typically needs to join the domain. Joining a domain connects the computer to Active Directory and allows centralized authentication and management to take place. This process is commonly performed when a new device is first being configured for use within an organization. Once joined, users can sign in using domain accounts rather than accounts that exist only on the local device. Administrators can then apply security settings, policies, and configurations from a centralized location instead of managing each system separately. Before diving further into Active Directory management, it is important to understand the concepts of objects and attributes. In Active Directory, nearly everything that can be managed within the network is considered an object. This includes users, computers, printers, shared folders, and security groups. Each object contains a collection of attributes, which are pieces of information associated with that object. For example, a user object may contain attributes such as a username, password, department, email address, and assigned permissions. One of the most common objects within Active Directory is the user object. A user object represents an individual user within the domain and stores the information needed for authentication and authorization. When the user signs in, Active Directory checks the credentials stored within the user object and determines what resources the user is permitted to access. As the number of objects within a domain grows, organization becomes increasingly important. This is where organizational units, commonly referred to as OUs, come into play. Organizational units are containers within Active Directory used to organize users, computers, and other objects into logical groups. For example, an organization may create separate OUs for departments such as accounting, human resources, or IT. This structure simplifies administration and allows policies or configurations to be applied to specific groups of users or devices. Closely tied to organization is the use of security groups. Security groups allow administrators to assign permissions to multiple users at once rather than configuring access individually for each user. For example, members of an accounting security group may automatically receive access to shared folders, printers, or applications needed for their role. This approach improves efficiency and helps support the principle of least privilege by assigning access based on responsibilities rather than individual manual configuration. Once users and computers are organized within OUs and security groups, administrators can begin applying centralized configurations through group policy. Group policy allows administrators to deploy settings and enforce rules across computers and users within the domain. These policies can control password requirements, desktop settings, security configurations, software restrictions, and many other aspects of the Windows environment. Instead of manually configuring every computer, administrators can manage these settings centrally through Active Directory. Building on centralized management, administrators can also assign login scripts to users. A login script is a script that automatically runs when a user signs into the domain. These scripts are commonly used to map network drives, connect printers, configure environment settings, or automate setup tasks. This helps provide a more consistent experience regardless of which domain-connected computer the user signs into. Another commonly configured feature within Active Directory environments is the use of home folders. A home folder is a centralized network location assigned to an individual user for storing personal files and data. Because the folder is stored on a network server rather than the local computer, users can access their files from multiple systems within the domain while also benefiting from centralized backups and management. Closely related to home folders is folder redirection. Folder redirection allows specific user folders, such as documents, desktop, or pictures, to be redirected from the local computer to a network location. This helps protect user data by storing it centrally rather than only on the local device. It also allows users to maintain access to their files regardless of which domain-connected computer they use. Together, these Active Directory features provide centralized management, streamlined administration, and consistent security enforcement across Windows domain environments. Exam Objective 2.3 – Compare and contrast wireless security protocols and authentication methods. Wireless encryption. In this video segment, we will explore the evolution of wireless encryption standards used to secure Wi-Fi networks. As wireless networking became more common, stronger security protocols were needed to protect data from interception and unauthorized access. Over time, these technologies evolved to address weaknesses in earlier standards and improve protection against modern attacks. Let's move through these technologies in the order they developed, starting with some of the earliest wireless security standards and working toward the most secure options used today. We will begin with Wired Equivalent Privacy, commonly known as WEP. WEP is an outdated wireless security protocol that was originally designed to provide wireless networks with security comparable to traditional wired networks. At the time, it represented an important step forward for wireless security, but significant weaknesses were eventually discovered. WEP relied on static encryption keys and weak initialization vectors, which made it vulnerable to attack. Because of these flaws, WEP is now considered highly insecure and should never be used on modern wireless networks. To perform encryption, WEP relied on RC4, which stands for Rivest Cipher 4, named after its creator Ron Rivest. RC4 is a stream cipher encryption algorithm that encrypts data one piece at a time as it is transmitted. RC4 was initially popular because it was lightweight and efficient, making it suitable for early wireless hardware with limited processing power. However, weaknesses in how WEP implemented RC4 allowed attackers to capture wireless traffic and crack encryption keys in a relatively short amount of time. To improve upon the weaknesses of WEP, Wi-Fi Protected Access, or WPA, was introduced. WPA is a wireless security standard developed as a more secure replacement for WEP. Rather than relying entirely on static encryption methods, WPA introduced several improvements aimed at strengthening wireless security while still remaining compatible with much of the existing wireless hardware already in use at the time. One of the primary technologies used by WPA was Temporal Key Integrity Protocol, commonly referred to as TKIP. TKIP is an encryption protocol that dynamically changes encryption keys during communication. This was a major improvement over WEP and RC4 because attackers could no longer rely on a single static key. TKIP also introduced integrity checking features to help detect tampering of transmitted data. Even with these improvements, WPA and TKIP were still considered temporary solutions because weaknesses were eventually discovered as attack methods advanced. This led to the development of Wi-Fi Protected Access 2, commonly known as WPA2. WPA2 is a wireless security standard that improved wireless protection by introducing much stronger encryption methods. WPA2 provided significantly better security than both WEP and WPA, making it the recommended standard for wireless networking for many years. The primary encryption technology used with WPA2 is AES, or Advanced Encryption Standard. AES is a strong block cipher encryption algorithm, widely used for secure communications across many different technologies, not just wireless networking. Unlike RC4, which encrypts data as a stream, AES encrypts data in fixed-size blocks, providing much stronger protection against attacks. Because of its strength and reliability, AES remains widely trusted and used today. As wireless security continued to evolve, Wi-Fi Protected Access 3, or WPA3, was introduced to further strengthen wireless protections and improve resistance against modern attack techniques. WPA3 is the latest wireless security standard and is designed to provide stronger protection against modern threats while improving overall wireless security. It includes several security enhancements intended to better protect both personal and enterprise wireless environments. One of the key technologies introduced with WPA3 is simultaneous authentication of equals, or SAE. SAE is a WPA3 authentication method designed to improve resistance against password guessing and brute force attacks. SAE replaces the older pre-shared key authentication process used in WPA2. When comparing these wireless security technologies overall, the progression becomes clear. WEP with RC4 is outdated and insecure. WPA with TKIP improved security but was still only a temporary solution. WPA2 with AES became the long-standing secure standard for wireless networking, while WPA3 with SAE now provides the strongest protections available for modern Wi-Fi environments. Exam Objective 2.3 Compare and contrast wireless security protocols and authentication methods. Wireless authentication. Picture this: you're trying to connect to a wireless network, and it hits you with a prompt for a username and password, or maybe just a password. Ever wonder why? Well, the network wants to make sure you're really you. It's a process called authentication. Think of it like the bouncer at a club asking for your ID. Authentication is how the wireless network checks, who are you? And makes sure only the right people get access. So, how do wireless networks work their magic? They use what's known as an authentication factor, which is fancy talk for the method that proves you're legit. These factors can be something you know, like a password, something you have, something you are, or even somewhere you are. Now, let's break it down and check out some of the most common ways in which wireless networks decide whether to let you in. For starters, there are two main types of wireless authentication: personal and enterprise. Personal authentication is what most of us are familiar with. It's the classic Wi-Fi password, also known as a passphrase, pre-shared key, or PSK. You've probably done this 100 times. The network requires you to enter a password before connecting. Once you're in, the network assumes everyone with that password is trusted. It's simple and effective for home networks or small setups, but it's not ideal for larger organizations where tighter security is needed. For those scenarios, we would use enterprise authentication. Enterprise authentication uses a more complex setup. Instead of just a password, it relies on specialized protocols to manage individual user access. This is where authentication methods like Radius, CompTIA A Plus, and Kerberos really shine. These methods don't just ask for a simple password, they require a username and password combo and sometimes more. These credentials are then verified by an authentication server. Actually, let me take a second to break down these enterprise authentication methods a bit more. Radius, short for Remote Authentication Dial-In User Service, is a protocol that handles authentication, authorization, and accounting for users who connect to a network. It acts like a middleman that talks between the network and a central database of authorized users. When someone tries to log in, Radius checks if their username and password are on the list, then grants or denies access based on the result. It's commonly used in larger organizations to centrally manage network access. Terminal Access Controller Access Control System Plus, or CompTIA A Plus for short, is a proprietary protocol, developed by Cisco, that is used for authenticating and controlling access to network devices, such as routers and switches. It provides more granular control than Radius by separating authentication, authorization, and accounting. CompTIA A Plus not only verifies who you are but also determines what actions you're allowed to perform. This makes it useful for managing access to network infrastructure and keeping detailed logs of what each device is doing. CompTIA A Plus is often used in Cisco environments for managing administrative access to network devices, but third-party implementations of this authentication method do exist. Kerberos is a network authentication protocol that uses tickets to verify user identities. When you log in, Kerberos gives you a ticket that proves your identity. You can then use this ticket to access multiple services on the network without having to re-enter your credentials. It's like getting a pass that allows you to move freely within the network, making Kerberos a good choice for environments with multiple systems. Now, let's talk about multi-factor authentication, or MFA, which is where things get extra secure. MFA adds another layer of verification on top of the basic username and password. Whether you're using a personal Wi-Fi password or enterprise methods like Radius, CompTIA A Plus, or Kerberos, you can still apply MFA. This ensures that even if someone gets hold of a password, they still need that second piece of verification to access the network. Exam Objective 2.4 Summarize types of malware and methods for detection, removal, and prevention. Types of malware. When it comes to malware, think of it like that one friend who crashes your party uninvited, devours all your snacks, and leaves behind a total mess. But instead of crumbs, malware leaves a trail of chaos throughout your system. Before we break down the different types of malware, let's start with a simple definition. Malware is malicious software designed to damage, disrupt, steal information from, or gain unauthorized access to a computer system. Some malware focuses on destruction, some focuses on spying, and some simply wants to use your system for the attacker's benefit. With that foundation in place, let's explore some of the most common malware types you are expected to recognize for the CompTIA A Plus Core 2 exam. First up, we have viruses. A virus is malware that replicates by attaching itself to clean files or programs. When the infected file is opened or executed, the virus activates and spreads further throughout the system. Much like a biological virus, its primary goal is replication and infection. Viruses can corrupt files, damage operating systems, slow system performance, and spread to additional devices if left unchecked. Next, we have Trojans. A Trojan is malware disguised as legitimate software, tricking the user into installing it voluntarily. Unlike a virus, a Trojan does not self-replicate. Instead, it relies on deception to gain access to the system. Once installed, a Trojan may steal information, create backdoors, download additional malware, or give attackers remote access to the device. It is essentially malware hiding behind a disguise, pretending to be something trustworthy. Some malware focuses specifically on remaining hidden, which brings us to rootkits. A rootkit is malware designed to conceal its presence while providing unauthorized access to a system. Rootkits often embed themselves deep within the operating system, allowing attackers to manipulate system processes while avoiding detection by traditional security tools. Because they operate so close to the core of the operating system, rootkits can be extremely difficult to detect and remove. Another increasingly common threat is fileless malware. Unlike traditional malware that installs files onto a storage drive, fileless malware operates primarily in system memory, often using legitimate system tools such as PowerShell or Windows scripting utilities to carry out malicious actions. Because little or no malicious code is written directly to disk, fileless malware can be much harder for traditional antivirus software to detect. Instead of leaving obvious files behind, it abuses trusted system processes already present on the computer. Ransomware is like a digital hostage taker. It infiltrates a system, encrypts files, and demands payment, often in cryptocurrency, in exchange for restoring access. The behavior of ransomware is simple but devastating. It locks users out of their own data. Even if the ransom is paid, there is never a guarantee that the attacker will actually restore the files. This is why secure backups are one of the most important defenses against ransomware attacks. Some malware focuses less on destruction and more on surveillance. Spyware is malware that secretly monitors user activity and collects information without the user's knowledge. This can include browsing habits, login credentials, personal information, or financial data. Spyware often operates quietly in the background for long periods of time, making it especially dangerous because users may not realize they are being monitored. One specific type of spyware is stalkerware. While spyware is generally designed to secretly collect information from many potential victims, stalkerware is more focused on monitoring a specific individual without their knowledge or consent. Stalkerware may track text messages, phone calls, GPS location data, browsing activity, or even microphone and camera usage. While some monitoring software is marketed for parental controls or employee monitoring, stalkerware is often associated with abusive or malicious surveillance. Like other forms of spyware, It attempts to remain hidden while continuously gathering information about the victim's activity. Another specialized form of spyware is a keylogger. A keylogger is malware that records every keystroke a user types, allowing attackers to capture usernames, passwords, messages, and other sensitive information. Some keyloggers are software-based, while others exist as physical devices placed between a keyboard and a computer. Because physical keyloggers operate outside the operating system, traditional antivirus software may not detect them at all. A boot sector virus targets the boot sector of a storage device, which is the area responsible for helping the operating system start during the boot process. Because this malware infects such a critical part of the system, it can be extremely persistent. Even reinstalling the operating system may not fully remove the infection if the boot sector itself remains compromised. Next, we have cryptominers, sometimes referred to as cryptojacking malware. Cryptominers secretly use a system's resources to mine cryptocurrency for an attacker. Instead of directly stealing files or locking data, cryptominers steal computing power. Infected systems often become unusually slow, noisy, or overheated because the malware continuously consumes system resources in the background. Another category worth mentioning is a potentially unwanted program, commonly referred to as a pup. Unlike traditional malware, pups are not necessarily designed to directly damage or compromise a system. Instead, they are programs that users may not realize they installed or may not actually want on their device. These programs are often bundled with free software downloads and may install browser toolbars, display excessive advertisements, change browser settings, or collect usage data. While pups are not always outright malicious, they can still negatively affect system performance, create privacy concerns, and introduce additional security risks. Some pups may also make it difficult to remove them or may continuously prompt users to install additional software. Because of this, security tools often flag pups as suspicious even if they are not classified as full malware. As you can see, malware comes in many forms, each designed with different goals and behaviors. Some malware spreads aggressively, some steals information quietly, and others focus on remaining hidden for as long as possible. Understanding these differences is important not only for the exam, but also for recognizing suspicious behavior and protecting systems in real-world environments. Exam Objective 2.4 Summarize types of malware and methods for detection, removal, and prevention. Malware removal tools. Now that we've explored the different types of malware, it's time to shift our focus towards something just as important: detecting, removing, and preventing these threats. In this video segment, we will look at a variety of security tools and methods that help defend systems against malware in both home and enterprise environments. Let's begin with the Windows Recovery Console. The Recovery Console is a specialized recovery environment used to troubleshoot and repair Windows systems when the operating system cannot start normally. Because this environment operates outside the main Windows installation, most malware and third-party software are not loaded during startup. This makes it especially useful when dealing with severe malware infections, corrupted system files, or ransomware attacks that prevent normal booting. From the Recovery Console, technicians can access tools such as Startup Repair, System Restore, Command Prompt, Safe Mode options, and even operating system reinstallation tools. Once the system is accessible again, one of the first tools commonly used is antivirus software. Antivirus software is designed to detect, prevent, and remove malicious software, particularly known threats such as viruses. Antivirus tools scan files and monitor system activity for suspicious behavior. They compare files against databases of known malware signatures and can quarantine or remove infected files before damage occurs. However, antivirus software is not perfect. New malware variants are constantly being created, which is why keeping antivirus definitions updated is extremely important. While antivirus software traditionally focuses on viruses, anti-malware software casts a wider net. Anti-malware tools are designed to detect and remove many different types of malicious software, including spyware, ransomware, Trojans, and potentially unwanted programs. In modern environments, the terms antivirus and anti-malware are often used interchangeably because many security suites now combine both functions into a single platform. As threats became more advanced, security tools evolved beyond traditional antivirus software. One example is endpoint detection and response, commonly referred to as EDR. EDR is a security solution that continuously monitors endpoint devices for suspicious activity and security threats. Rather than simply scanning files for known malware signatures, EDR tools analyze system behavior in real time. This allows them to detect unusual activity such as unauthorized privilege escalation, suspicious PowerShell commands, or ransomware-like encryption behavior. EDR solutions also provide visibility into attacks, helping security teams investigate and respond more quickly when a threat is detected. Building on this concept, some organizations use Managed Detection and Response, or MDR. MDR is a security service in which a third-party provider actively monitors and responds to security threats on behalf of an organization. While EDR provides the tools and visibility, MDR adds human expertise and around-the-clock monitoring. This is especially useful for smaller organizations that may not have dedicated cybersecurity staff available 24 hours a day. With MDR, security analysts actively investigate alerts, respond to incidents, and help contain threats before they spread. Security monitoring has also expanded beyond individual endpoint devices, leading to extended detection and response, commonly referred to as XDR. XDR is a security platform that collects and correlates security data across multiple systems and technologies. Rather than focusing only on endpoints, XDR combines information from endpoints, firewalls, email systems, cloud environments, servers, and networks into a centralized platform. This broader visibility helps security teams identify attacks that might otherwise appear unrelated when viewed individually. In many ways, XDR helps connect the dots across the entire environment. Another important layer of protection is the email security gateway. An email security gateway is a security solution that filters incoming and outgoing email traffic to block malicious messages and reduce email-based threats. Since phishing emails remain one of the most common ways malware enters an organization, email security gateways play a major role in prevention. These systems can scan attachments for malware, block suspicious links, filter spam, and detect impersonation attempts before the message ever reaches the user's inbox. With security software in place, another important layer of protection is the software firewall. A software firewall monitors and controls incoming and outgoing network traffic on a device. By filtering traffic, firewalls help block unauthorized access and prevent malware from communicating with external systems. Proper firewall configuration can significantly reduce the attack surface exposed to attackers. Even with strong security tools in place, technology alone is never enough to fully protect a system or network. User education remains one of the most effective defenses against malware infections and security threats. Employees and users should be trained to recognize suspicious behavior, avoid unsafe downloads, practice safe browsing habits, and understand the importance of following security policies. After all, even the most advanced security system can still be compromised by a single careless click. One area of user education that deserves special attention is anti-phishing training. Since phishing remains one of the most common methods used to deliver malware, users must learn how to recognize suspicious emails and messages before interacting with them. Anti-phishing training teaches users how to identify fake login pages, verify senders, recognize suspicious links or attachments, and avoid social engineering tactics designed to trick them into revealing sensitive information. By helping users spot these warning signs early, many malware infections can be prevented before they ever begin. Sometimes, however, malware infections become so severe that traditional removal tools are no longer effective. Certain threats, particularly rootkits or deeply embedded boot sector malware, may compromise critical system components to the point where complete operating system reinstallation becomes necessary. Reinstalling the operating system provides a clean environment by fully replacing compromised system files. While this is often considered a last resort, it is sometimes the only reliable method of completely removing persistent malware infections. As you can see, malware defense involves far more than simply installing antivirus software. Modern security relies on layered protection, combining prevention, monitoring, detection, response, user awareness, and recovery strategies. From traditional antivirus tools to advanced solutions like EDR, MDR, and XDR, each layer plays a role in helping organizations defend against constantly evolving threats. Exam Objective 2.5 Compare and contrast common social engineering attacks, threats, and vulnerabilities. Social engineering. Are you good at getting people to do what you want? If so, you are probably a natural when it comes to social engineering. So what is social engineering and how does it apply to IT? Well, to put it plainly, social engineering is the act of manipulating individuals into divulging confidential information or performing actions that compromise security. This often involves exploiting human trust or emotional responses to gain unauthorized access to sensitive data or systems. Or, as I like to call it, hacking the human. If you are not already aware, all the firewalls, encryption, and multi-factor authentication in the world can't save you if someone tricks you into willingly handing over your keys. One of the most common forms of social engineering is phishing. Phishing is an attack where fraudulent communications, usually emails, are designed to appear as though they come from a legitimate source. Attackers often impersonate banks, online stores, coworkers, or service providers in an attempt to trick users into clicking malicious links or revealing sensitive information. For example, an email might claim your account has been compromised and urge you to reset your password immediately. Unfortunately, the provided link often leads directly to a fake login page controlled by the attacker. Email security filters and anti-phishing training can help reduce the risk of falling victim to these attacks, but users should still carefully inspect unexpected messages before clicking anything. While many phishing attacks are sent out broadly in the hope that someone takes the bait, some attacks are much more targeted. This brings us to spear phishing. Spear phishing is a highly targeted phishing attack customized for a specific individual, department, or organization. Attackers often research their targets beforehand, gathering details such as names, job roles, coworkers, recent projects, or company activities to make the message appear more believable. A spear phishing email might reference a real coworker, current project, or internal company event to build trust and increase the chances of the victim falling for the attack. Taking things even further, we have whaling. Whaling is a specialized form of spear phishing that specifically targets high-profile individuals such as executives, CEOs, or financial officers. Since these individuals often have access to sensitive information or financial authority, attackers put extra effort into crafting convincing and personalized messages. Imagine a CEO receiving what appears to be an urgent request from the chief financial officer to approve a large wire transfer immediately. When large amounts of money or highly sensitive data are involved, the whales become prime targets. Attackers do not limit themselves to email either. Sometimes they move their scams directly to your phone through smishing. Smishing is a social engineering attack carried out through SMS text messages. Much like phishing emails, smishing messages attempt to create urgency or fear to trick users into clicking malicious links or revealing sensitive information. You might receive a text claiming there is suspicious activity on your bank account or that a package delivery failed and needs immediate attention. Different delivery method, same bait. Another growing variation is QR code phishing. In this type of phishing attack, malicious QR codes are used to redirect users to fraudulent websites or malware downloads. Since QR codes automatically open links on mobile devices, users may not always see the full URL before visiting the site. Attackers may place fake QR codes on flyers, emails, restaurant tables, parking meters, or even over legitimate QR codes in public places. One quick scan can send a user straight to a malicious website without them even realizing it. If email, text messages, and QR codes were not enough, attackers may also attempt to manipulate victims through voice communication. This is known as vishing. Vishing is a type of phishing attack performed through phone calls or voice messages. Attackers often pretend to be technical support, banks, government agencies, or other trusted organizations. For example, someone might call claiming there is a virus on your computer and offer to help fix the issue. In reality, they are trying to steal information or gain remote access to the device. One of the best defenses against phishing is to independently verify the caller by hanging up and contacting the organization directly, using an official phone number. Social engineers also rely heavily on impersonation. Impersonation occurs when an attacker pretends to be someone trusted in order to gain access to information, systems, or physical locations. This could involve posing as a coworker, delivery driver, IT technician, manager, or even law enforcement. The attacker's goal is to exploit trust and convince the victim to lower their guard. Many social engineering attacks become much more effective once the attacker successfully convinces the victim they are legitimate. Sometimes attackers skip the digital tricks altogether and attempt physical access instead. One example is tailgating. Tailgating is a physical security breach where an unauthorized person follows an authorized individual into a restricted area without that person's knowledge. Picture someone carrying a box walking closely behind an employee entering a secure office building. The employee never realizes the attacker slipped in behind them, allowing the unauthorized person to bypass security controls, such as badge readers or keycards. Sometimes a moment of distraction is all an attacker needs to gain physical access. Another physical social engineering tactic is shoulder surfing. Shoulder surfing occurs when an attacker physically watches someone enter sensitive information such as passwords, PINs, or access codes. This commonly happens in crowded areas like coffee shops, airports, public transportation, or ATM machines. Something as simple as glancing over someone's shoulder while they type can reveal valuable information to an attacker. And finally, if you thought social engineers were sneaky before, wait until you hear about dumpster diving. Dumpster diving is a social engineering technique where attackers search through trash or discarded materials to find sensitive information. Attackers may search for invoices, passwords, sticky notes, printed emails, network diagrams, or anything else containing useful information. To a social engineer, yesterday's trash can easily become tomorrow's security breach. Properly shredding sensitive documents before disposal is one of the simplest ways to defend against this type of attack. As you can see, social engineering attacks come in many forms, but they all share one thing in common: they target people rather than technology. Whether through email, phone calls, text messages, QR codes, or even face-to-face interactions, attackers rely on trust, urgency, fear, and distraction to achieve their goals. Understanding how these attacks work is one of the most effective ways to recognize suspicious behavior and avoid becoming the next victim. Exam Objective 2.5: Compare and contrast common social engineering attacks, threats, and vulnerabilities. Threats. According to CompTIA, a threat is anything that has the potential to cause harm to a system, network, or data. These threats come in many forms, from attacks that overwhelm systems to attackers who secretly intercept communications or exploit vulnerable software. We have already covered one major category of threats through social engineering, but now it is time to focus on some of the more technical attacks IT professionals may encounter in the real world. Let's begin with a denial of service attack, commonly referred to as a DOS attack. A DOS attack is an attack designed to make a system, server, or network resource unavailable to legitimate users. One of the most common methods involves flooding a server with an overwhelming amount of traffic or requests until it can no longer respond properly. Imagine trying to order food at a restaurant where thousands of fake customers suddenly rush through the door all at once. The employees become overwhelmed trying to take orders, answer questions, and serve people who are not even real customers. Meanwhile, legitimate customers are left waiting outside because the restaurant no longer has the resources or capacity to serve them properly. A DOS attack works in a very similar way. The attacker overwhelms the target system with so many fake requests that legitimate users can no longer access the service normally. Now, if a DOS attack is one attacker causing trouble, then a distributed denial of service attack, or DDoS attack, is the same chaos multiplied across many devices. In a DDoS attack, multiple systems work together to overwhelm the target simultaneously. These attacking devices are often part of a botnet, which is a network of compromised systems infected with malware and remotely controlled by an attacker. The compromised systems, commonly called zombies, may belong to completely unsuspecting users who have no idea their devices are participating in the attack. By spreading the attack across many systems worldwide, DDoS attacks become much harder to block and far more disruptive. Another network-based threat is the evil twin attack. An evil twin attack occurs when an attacker sets up a rogue wireless access point designed to imitate a legitimate Wi-Fi network. The fake wireless network often uses a nearly identical network name, or SSID, to trick users into connecting. Once connected, the attacker may monitor traffic, capture credentials, or redirect users to malicious websites. Public places like coffee shops, airports, and hotels are common locations for evil twin attacks because users are often searching for available Wi-Fi networks without verifying their legitimacy. Next up is the zero-day attack, which is one of the more dangerous threats security professionals face. A zero-day attack exploits a software vulnerability before the software vendor or developers have had an opportunity to release a fix or patch. The term zero-day refers to the fact that developers have had 0 days to address the vulnerability. Because no official fix exists yet, attackers can sometimes exploit these vulnerabilities successfully before defenders even realize the weakness exists. Moving on, we have spoofing. Spoofing is an attack where an attacker disguises themselves as another person, device, or service by falsifying information. This could involve fake email addresses, forged IP addresses, fraudulent websites, or other deceptive tactics. The goal is to trick users or systems into believing the communication is legitimate. Whether it is a fake bank website or an email pretending to come from your manager, spoofing is all about deception and misdirection. Spoofing often plays a major role in another attack known as an on-path attack, formerly called a man-in-the-middle attack. In an on-path attack, an attacker secretly positions themselves between two communicating parties to intercept, monitor, or even modify the communication. Imagine trying to have a private conversation while someone secretly listens in and occasionally changes parts of the message before passing it along. Attackers may steal credentials, capture sensitive information, or inject malicious content into the communication without either side realizing what is happening. Some attacks focus specifically on authentication systems. One example is the brute force attack. A brute force attack is an authentication attack where the attacker systematically guesses every possible combination of letters, numbers, and symbols to uncover a password. Rather than relying on trickery, the attacker simply depends on persistence and computing power. Weak passwords can often be cracked surprisingly quickly with this method, especially if account lockout protections are not in place. A dictionary attack works similarly to a brute force attack, but uses a more targeted approach. Rather than trying every possible combination, the attacker uses a precompiled list of commonly used passwords, words, and phrases. Since many users still choose predictable passwords, such as password 123, dictionary attacks can be very effective against weak password practices. Not all threats originate from outside an organization. Some of the most dangerous threats come from trusted individuals within the organization itself. This is known as an insider threat. An insider threat occurs when an employee, contractor, or business partner misuses legitimate access to systems or data. Sometimes the actions are malicious and intentional, while other times they result from carelessness or negligence. Since insiders already possess authorized access, they can often bypass security measures more easily than external attackers. A modern threat closely related to social engineering is business email compromise, commonly referred to as BEC. A business email compromise attack occurs when attackers compromise or impersonate a trusted business email account in order to manipulate employees into transferring money or revealing sensitive information. These attacks often target executives, payroll departments, or financial staff. For example, an attacker might impersonate a company executive and send an urgent request for a wire transfer. Because the message appears to come from someone trusted, victims may comply without realizing they are communicating with an attacker. Another increasingly dangerous threat is the supply chain attack, sometimes referred to as a pipeline attack. In a supply chain attack, attackers compromise a trusted third-party vendor, software provider, or service used by the target organization. Rather than attacking the organization directly, the attacker exploits the trust relationship between the organization and its suppliers. In many cases, attackers look for the weakest link in the chain, targeting a smaller or less secure vendor as an easier entry point into a much larger organization. For example, malicious code may be inserted into a legitimate software update distributed to thousands of customers. Because the update appears trustworthy and comes from a known vendor, organizations may unknowingly install the malware themselves. This makes supply chain attacks especially dangerous because the malicious software often arrives through systems and services that organizations already trust. Now let's get a bit more technical with structured query language injection, commonly known as SQL injection. SQL injection is an attack where malicious SQL code is inserted into application input fields in an attempt to manipulate a database. An attacker may exploit vulnerable login forms or web applications to bypass authentication, retrieve sensitive information, modify records, or even delete data entirely. Since databases often store highly sensitive information, SQL injection attacks can be extremely damaging if successful. One of the best defenses against SQL injection is input validation. By ensuring users can only enter expected types of data into form fields, organizations can reduce the likelihood of malicious code being executed against the database. Last up, we have cross-site scripting, commonly abbreviated as XSS. Cross-site scripting is an attack where malicious scripts are injected into trusted websites. These scripts are then executed within the browsers of other users visiting the site. These scripts may steal cookies, session tokens, or other sensitive information. In some cases, attackers may even trick users into performing actions they never intended to perform. Cross-site scripting often works by taking advantage of poor input validation on websites. If a web application improperly handles user input, attackers may be able to inject malicious JavaScript or other scripts into web pages viewed by others. Just like SQL injection, proper input validation can play a major role in defending against cross-site scripting attacks. Exam Objective 2.5 Compare and contrast common social engineering attacks, threats, and vulnerabilities. Vulnerabilities. A vulnerability is a weakness or flaw in a system, network, or application that can be exploited to gain unauthorized access or cause harm. Or to put it another way, these are the gaps in security that attackers actively look for. In this video segment, I'm going to highlight some of the most common security vulnerabilities that often go unnoticed. And hopefully, by the end, you'll have a solid understanding of how vulnerabilities work, why they matter, and what steps you can take to address them. First up on our list of common vulnerabilities, we have non-compliant systems. A non-compliant system is one that doesn't meet the necessary security policies or industry standards. Think of it like a factory that's missing key safety protocols. Eventually, something is going to go wrong. In IT, non-compliance could mean improper configurations or possibly the use of unauthorized applications. These systems are sitting ducks for attackers. Thus, ensuring compliance with organizational policies and regulatory requirements is crucial to reducing risk and keeping systems safe. Next, let's talk about unpatched systems. Whether you're working with an operating system, business software, or even your favorite computer game, security patches are released regularly to address vulnerabilities that have been identified. These patches help fix bugs, improve performance, and most importantly, close security gaps that hackers can exploit. When these updates are not applied, systems are left exposed to known exploits, making them easy targets for attackers. Now we can move on to unprotected systems. These are devices running without essential security measures like antivirus software or a firewall. Think of antivirus as your system's immune system, constantly scanning for malicious software. When detected, the antivirus works to neutralize and remove the threat before it can cause any damage. On the other hand, a firewall acts as the gatekeeper for your network. It monitors incoming and outgoing traffic, deciding what's allowed to pass through based on predefined security rules. Without a firewall, your system is wide open to unauthorized access. Without both antivirus protection and a firewall in place, your system is vulnerable to everything from malware infections to hacking attempts. Another major vulnerability is using end-of-life operating systems. When an OS reaches the end of its life, the manufacturer stops providing updates, including those critical security patches. End-of-life systems are prime targets for attackers because they know that no new defenses are being rolled out. If your system is running an end-of-life OS, it's time to plan for an upgrade to ensure ongoing protection. Finally, let's talk about allowing employees to use their own devices at work. While this can boost productivity and flexibility, it also introduces significant security risks. These personal devices might not have the same level of security as company-managed devices. Without strict security policies and proper configuration, these employee-owned devices can open doors to malware, data leaks, and unauthorized access to the network. Exam Objective 2.6, given a scenario, implement procedures for basic small office, home office, malware removal. Malware removal steps. When it comes to malware removal, having a structured process is extremely important. Think of it like solving a mystery. First, you investigate the clues, isolate the problem, clean up the damage, and finally put safeguards in place to help prevent the issue from happening again. Jumping randomly from one step to another can make the situation worse, so following a consistent process helps ensure nothing important gets missed. For this exam objective, CompTIA breaks the malware removal process into 10 distinct steps. And trust me, CompTIA absolutely loves asking questions about these steps and their order on the exam. Especially step number 2, quarantine. So are you ready to walk through the 10 steps to successful malware removal? Great, let's get to it. Step 1 is to investigate and verify malware symptoms. This is where you put on your detective hat and look for signs that malware may be present. Symptoms might include unusual pop-ups, system slowdowns, unauthorized changes to settings, browser redirects, disabled security tools, or strange network activity. Of course, not every issue automatically means malware. Sometimes a failed update or hardware problem can cause similar symptoms. The goal here is to verify whether malware is actually responsible before moving forward with remediation. Once malware has been confirmed, step 2 is to quarantine the infected system. Quarantining involves isolating the affected device from the network to prevent the malware from spreading to other systems or communicating with external attackers. This usually means disconnecting the system from Wi-Fi, unplugging the Ethernet cable, or disabling network access entirely. Think of it like placing the infected system into isolation while you prepare for cleanup. If the infection appears severe enough, powering the system off completely may also be appropriate until remediation can begin. Step 3 is to disable System Restore in Windows. This step is specific to Windows operating systems because System Restore is a Windows recovery feature that creates restore points, containing system settings and configuration information. While System Restore is normally helpful, malware can accidentally become stored inside these restore points. If System Restore remains enabled during cleanup, Windows could later restore the malware along with the system files. This would be like deep cleaning your entire room only to press a magic button that dumps all the trash back onto the floor. Disabling System Restore temporarily helps ensure the infection is not unintentionally reintroduced later. Step 4 is to remediate the infected system. Remediation is the actual process of removing the malware and repairing any damage it caused. Depending on the situation, this could involve deleting malicious files, removing suspicious programs, repairing corrupted settings, or using specialized malware removal tools. The exact remediation steps vary depending on the type and severity of the infection. Once remediation begins, step 5 is to update anti-malware software. Security software is only effective if it recognizes the latest threats. Malware definitions and detection engines must be updated before running scans so the software can identify the newest malware variants. Running outdated anti-malware software against modern threats is a bit like using a 10-year-old wanted poster to identify today's criminals. Step 6 focuses on scanning and removal techniques. One common approach is booting into safe mode, which loads only essential Windows services and prevents much of the malware from automatically running. Another option is using a pre-installation environment, which allows technicians to scan and repair the system outside the normal operating system. These approaches can make stubborn malware much easier to remove because the malicious processes are not actively running during the cleanup. Unfortunately, some infections are so severe that cleanup is no longer reliable. That brings us to step 7, reimage or reinstall. In some situations, particularly with rootkits, boot sector malware, or heavily compromised systems, the safest solution is to completely reinstall the operating system or restore the system from a known clean image. While this is generally considered a last resort, it provides the highest level of confidence that the malware has been fully removed. After the system has been cleaned, step 8 is to schedule scans and run updates. Automated scans help continuously check for future threats, while regular operating system and software updates patch security vulnerabilities attackers may try to exploit. This step shifts the focus from cleanup to long-term prevention. Step 9 is to re-enable System Restore in Windows and create a new restore point. Like the earlier step involving System Restore, this step is specific to Windows operating systems. Once the system is confirmed clean, System Restore can safely be turned back on. Creating a fresh restore point gives the user a clean recovery snapshot to fall back on in the future if problems occur again. Finally, step 10 is to educate the end user. Even the best security tools cannot fully protect users who constantly click suspicious links, download unknown software, or ignore warning signs. Teaching users about phishing attacks, suspicious attachments, risky websites, strong passwords, and safe browsing habits helps reduce the likelihood of future infections. In many cases, a few minutes of user education can prevent hours of future malware cleanup. If there is one thing worth memorizing from this topic, it is the order of these malware removal steps. CompTIA frequently tests not only the steps themselves, but also understanding why they occur in a specific sequence. By following this process in the correct order, technicians can safely contain malware, remove infections effectively, restore system stability, and help prevent future compromises. Exam Objective 2.7, given a scenario, apply workstation security options and hardening techniques. Password best practices. If you are following along with the exam objectives in hand, you may notice that this video segment begins our exploration of Exam Objective 2.7. You may have also noticed that I am starting this objective with this video segment on password considerations and best practices. That is because we already covered data at rest encryption earlier in Exam Objective 2.2, while discussing BitLocker, BitLocker to go, and encrypting file system, commonly referred to as EFS. If you would like a refresher on those topics, feel free to jump back to that section before continuing on here. With that quick clarification out of the way, let's turn our attention to password considerations and best practices. Passwords serve as a primary method of authentication, but surprisingly, many individuals often overlook their significance. Some might attribute this to complacency, while others simply might not be aware of the importance. Fortunately, there are established password policies and best practices that guide users in creating robust passwords, ensuring enhanced protection for both personal and professional data in our digital landscape. First and foremost, why are good password practices so essential? Think of passwords as the keys to your digital home. Just as you wouldn't want a flimsy lock on your front door, you wouldn't want a weak password guarding your personal and professional data. Strong password practices ensure that your digital doors remain locked against potential intruders. Now, let's look into some key password policies, which are designed to fortify our digital security. To kick things off, I will start with a well-known policy, the password length policy. This policy is an uncomplicated yet vital aspect of digital security. At its essence, this policy determines the minimum and maximum number of characters that a password should contain. Picture this in terms of a physical safe. Just as a physical safe might have a combination code of varying lengths, a password has its own length criteria. The analogy runs deeper when you consider the security implications. For a physical safe, a longer combination, with more numbers or sequences to guess, naturally becomes more challenging for a thief to decipher. Similarly, in the digital realm, a longer password inherently possesses more potential combinations of characters. This increased variability makes it exponentially harder for malicious actors to guess or use brute force attack methods against your password. In close relation to password length, a password complexity policy is also common practice. This policy emphasizes the need for a diverse mix of characters in your password. It recommends using a combination of uppercase letters, lowercase letters, numbers, and special characters. Such a varied composition not only ensures your password's uniqueness but also strengthens its defense against typical hacking methods. A password with this mix is much harder for hackers to guess or breach using brute force techniques. It's also crucial to avoid using dictionary words in your password, regardless of their length. Hackers often use dictionary attacks, where they methodically test variations of common dictionary words to decipher passwords. By incorporating a variety of character types and steering clear of standard dictionary words, you substantially lower the chances of falling victim to password guessing attacks. Next, we have the password history policy. This policy's primary objective is to deter users from reusing old passwords while also promoting new unique passwords. By monitoring and remembering your past passwords, the system can ensure that when you're prompted to update your password, you're guided towards crafting a new and unique one. This proactive approach to password management is designed for mitigating risks. For example, if an old password was ever compromised, ensuring it's not reused eliminates the chance of that particular password from becoming a recurring security weak point. In a nutshell, the password history policy serves as a protective measure, encouraging users to consistently renew their passwords, thereby enhancing their overall digital security. Our next policy, the password expiration policy, complements the previously discussed password history policy by setting an expiration date on your passwords, ensuring they don't remain static for too long. This forces users to refresh their passwords at regular intervals, reducing the time a potentially compromised password can be exploited. Much like regular maintenance on machinery or software, changing your passwords regularly is essential to keeping your digital security strong. This consistent cycle of change also reduces the window of opportunity for malicious actors to exploit a possibly compromised password. Now, let's talk about the password lockout policy. Have you ever mistyped your password several times and got locked out of your account? Well, that is this policy at work. The primary purpose of the password lockout policy is to hinder unauthorized users from endlessly guessing your password. The policy works in a straightforward manner. After a set number of incorrect login attempts, the account gets locked and remains inaccessible for a certain time or until an admin unlocks it. This strategy not only stops hackers in their tracks but also signals potential unauthorized access attempts to administrators. Beyond password policies, additional practices further enhance our digital security. One key practice is setting a BIOS or UEFI password. These passwords add a critical layer of security before the operating system even starts, preventing unauthorized users from accessing the system's core settings located in the BIOS or UEFI of the system. Having this type of password in place can block actions like enabling or disabling hardware components or even enabling hardware virtualization. So be sure to set up a BIOS or UEFI password if you want to ensure that only authorized individuals can make such changes. Another important practice is to change the default administrator's user account and password. Many systems, including routers and network devices, come with a default admin account and password, which are well known to attackers. Changing this default password reduces the risk of unauthorized access and adds an additional layer of defense. Lastly, we have multi-factor authentication, or MFA. By enabling MFA, you require users to provide not only a password but also a secondary form of authentication, like a fingerprint, facial recognition, or a code sent to their phone. This added step makes it exponentially harder for attackers to access your accounts, even if they manage to get hold of your password. Together, these password best practices work to create a robust defense against unauthorized access, protecting your personal and professional data in today's digital landscape. Exam Objective 2.7. Given a scenario, apply workstation security options and hardening techniques. End-user best practices. When it comes to keeping your data and devices secure, it's not just about passwords. Good security also includes a few end-user best practices. That is why this video segment will have us exploring some key habits and tools that every end user should implement for a more secure IT environment. One of the easiest ways to enhance security is by enabling a screensaver lock. A timeout or screen lock ensures that after a period of inactivity, your computer automatically locks, returning the user to the login screen. This is particularly helpful if you step away from your computer but forget to manually log out. In Windows 11, you can set this up by accessing your lock screen settings within the Windows Settings utility. Just make sure that the screensaver is configured to require a password when the computer wakes up from sleep or resumes after a period of inactivity. By using this simple feature, you ensure that your session remains protected, and no one can access your device without re-entering the appropriate password. Another key best practice is to always log off or lock your computer when it's not in use. The quickest way to do this is by using a key combination. For Windows, you can press the Windows key plus the L key to instantly log out as a user. This prevents anyone from accessing your system while you're away, even for a short time. It's a quick, simple action, and does not rely on a wait timer, like the screensaver lock. Securing your physical devices is just as important as securing your data. Laptops, for instance, are highly portable, making them easy targets for theft. Whether you're at home, in the office, or traveling, always ensure your laptop is stored securely when not in use. Consider using physical locks, security cables, or carrying your laptop in a bag that doesn't draw attention. Additionally, if your laptop contains sensitive data, ensure it's encrypted or secured with tools like BitLocker or FileVault. Finally, protecting your personally identifiable information and passwords is crucial. Never store passwords in plain text, whether on your computer or written down. Instead, use a password manager to generate and securely store complex passwords. Also, be cautious about where and how you share personally identifiable information, both online and in person. The more careful you are with your sensitive information, the less likely it is to be compromised. By incorporating these simple, end-user best practices, you can greatly reduce the risk of unauthorized access and keep your data safe. These habits are essential for every end user, regardless of the device or system they use. Exam Objective 2.7, given a scenario, apply workstation security options and hardening techniques. Account management. We've already covered password best practices to ensure your passwords are strong enough to withstand attack, and we dove into end-user best practices to help secure and protect devices. Now, we're moving into account management best practices, because what good is a strong password if everyone has unrestricted access once they get inside? In this segment, we'll focus on controlling access, limiting unnecessary exposure, and tightening overall system security. First things first, let's talk about restricting user permissions. Not everyone needs access to everything, and that's where the principle of least privilege, which we discussed earlier, comes into play. This principle ensures that users only receive the access necessary to perform their specific tasks and nothing more. By limiting permissions, you reduce the risk of unauthorized access, accidental changes, and malware spreading into sensitive areas of the system. While making sure users only have access to what they need is a great start, managing access does not stop there. Permissions alone are not enough to fully secure a system. This is where restricting login times comes in handy. Limiting when users can log in adds another layer of protection. Imagine your system as a building with office hours. Outside those hours, no one should be wandering around inside. By setting login windows, such as restricting weekend or overnight access, organizations can reduce the chances of unauthorized access attempts occurring during off hours when fewer people are monitoring the environment. Building on the concept of reducing unnecessary access, it is also important to disable the guest account. The guest account is a bit like leaving a spare key under the doormat. Convenient? Maybe. Secure? Not exactly. Guest accounts are designed to provide temporary access with limited permissions, but if left enabled unnecessarily, they create an additional entry point attackers may attempt to exploit. Disabling the guest account helps ensure that every user accessing the system has a properly managed and authenticated account. Another important best practice is disabling unused services. Operating systems and applications often include background services that may not actually be needed in a particular environment. Every running service represents another potential attack surface that could contain vulnerabilities or be exploited by attackers. By disabling services that are unnecessary, organizations reduce the number of opportunities attackers have to gain access or abuse system resources. Think of it like locking unused doors in a building. If no one needs that entrance, there is no reason to leave it open. While controlling accounts and services is important, securing the system also involves preventing malicious software from automatically executing. This is where disabling autorun becomes valuable. Autorun is a Windows feature that can automatically launch programs when removable media, such as USB drives, are connected. While convenient, this can also create a major security risk. Imagine plugging in an infected USB drive and having malicious software launch immediately without warning. By disabling autorun, users gain control over what executes on the system, helping block malware from automatically spreading through removable devices. So, to bring it all together, strong account management involves restricting user permissions, limiting login times, disabling unnecessary guest access, turning off unused services, and preventing automatic execution of files through features like autorun. Together, these practices help reduce attack surfaces, improve system security, and keep your environment locked down tighter than Fort Knox. Exam Objective 2.8, given a scenario, apply common methods for securing mobile devices. Mobile device security. When it comes to securing mobile devices, many of the same hardening techniques used on workstations still apply. After all, modern smartphones and tablets are essentially pocket-sized computers carrying enormous amounts of personal and professional data. Emails, banking apps, saved passwords, company files, photos, and even authentication apps often live on these devices. That makes mobile security incredibly important because losing control of your phone can sometimes be just as damaging as losing control of your workstation. A great place to begin is with screen locks, which act as the first line of defense against unauthorized access. Mobile devices support several different screen lock methods, including facial recognition, fingerprint authentication, PIN codes and passphrases, pattern locks, and swipe gestures. While all of these methods provide some level of access control, they do not all offer the same level of protection. Facial recognition uses the device's camera and biometric scanning technology to identify the authorized user based on facial features. Fingerprint authentication works similarly by scanning and recognizing the user's fingerprint. Both methods are considered secure and convenient because they rely on biometric characteristics unique to the individual user. PIN codes and passphrases rely on something the user knows rather than something they physically are. A strong passphrase generally provides more protection than a short PIN because it is typically longer and more complex. Pattern locks offer moderate protection by requiring users to trace a specific pattern across the screen, while simple swipe locks provide very little real security and should not be used to protect sensitive information. Building on screen security, mobile devices should also enforce failed login attempt restrictions. This security feature limits the number of incorrect login attempts allowed before the device temporarily locks the user out, requires additional authentication, or in some cases performs a device wipe. These restrictions help defend against brute force attacks where attackers repeatedly attempt different PINs or passwords until they eventually guess correctly. Another important layer of mobile security is device encryption. Mobile device encryption ensures that the data stored on the device remains unreadable without the proper authentication credentials. Even if someone physically steals the device, the stored information remains protected. On many modern smartphones and tablets, encryption is enabled automatically behind the scenes as part of full device encryption. This protects everything stored on the device, including applications, messages, photos, files, and saved account information. Of course, securing the device itself is only part of the equation. Software vulnerabilities also need constant attention, which brings us to patch management. Patch management involves keeping both operating systems and applications updated with the latest security fixes and improvements. Operating system updates are especially important because they often patch newly discovered vulnerabilities attackers may attempt to exploit. However, application updates are equally important since outdated apps can also contain serious security flaws. Ignoring update notifications for weeks at a time might feel convenient, but from a security perspective, it is a bit like leaving your front door unlocked because you did not feel like turning the key. In addition to updates, mobile devices often rely on endpoint security software for additional protection. This can include antivirus software, anti-malware tools, and content filtering solutions. Antivirus and anti-malware applications help detect and block malicious apps, suspicious behavior, and known threats before they can compromise the device. Content filtering adds another layer of protection by restricting access to harmful or inappropriate websites and online content. In business environments, content filtering may also help enforce acceptable use policies and reduce exposure to phishing sites or malicious downloads. If a device is ever lost or stolen, locator applications can become incredibly valuable. Features such as Find My iPhone or Find My Device allow users to locate their devices using GPS and internet connectivity. These tools may also provide additional options such as remotely playing a sound, locking the device, or displaying its last known location. Sometimes the missing phone is not stolen at all. It is just hiding in the couch cushions, conducting a covert operation against your sanity. But if recovery is not possible, remote wipe capabilities become extremely important. Remote wipe allows authorized users or administrators to erase the contents of a lost or stolen device remotely. This helps prevent sensitive data from falling into the wrong hands. In corporate environments, remote wipe features are especially important because mobile devices may contain company emails, files, authentication tokens, and other confidential information. Another important protection mechanism involves remote backup applications. Services such as iCloud or Google Drive allow users to back up mobile device data securely to the cloud. These backups help ensure that contacts, photos, files, settings, and applications can be restored if the device is lost, damaged, wiped, or replaced. Backups provide an important safety net, because even the best security practices cannot always prevent accidents, theft, or hardware failure. At the end of the day, securing a mobile device is really about building layers of protection. If one security measure fails, another is there to help keep the device and its data protected. A strong screen lock might stop unauthorized access, encryption helps protect stored information, updates patch security holes, and tools like remote wipe and backups help limit the damage if the device is lost or stolen. And considering how much personal and professional information lives on mobile devices today, that level of protection is not optional anymore. These devices may spend most of their time in your pocket, but from a security standpoint, they should be treated with the same level of care as any workstation or server. Exam Objective 2.8. Given a scenario, apply common methods for securing mobile devices. BYOD versus corporate-owned. Mobile devices have become deeply integrated into modern workplaces. Employees use smartphones and tablets to check email, join meetings, access cloud services, communicate with coworkers, and manage business applications from almost anywhere. But with that convenience comes an important question for organizations: should employees use company-provided devices, or should they use their own personal devices for work? This brings us to the concept of BYOD, which stands for Bring Your Own Device. A BYOD policy allows employees to use personally owned devices, such as smartphones, tablets, or laptops, to access company resources and perform work-related tasks. Many employees appreciate BYOD because they can use devices they are already comfortable and familiar with, while organizations may save money by not purchasing hardware for every employee. Of course, convenience almost always comes with trade-offs, especially in cybersecurity. Personal devices may not follow the same security standards as company-managed devices. Some users may delay updates, install risky applications, use weak passwords, or disable security settings entirely. This creates additional risk because company data may now exist on devices the organization does not fully control. Separating personal data from corporate data can also become complicated, raising privacy concerns for both the employee and the organization. The alternative approach is using corporate-owned devices. In this model, the company purchases, configures, and manages the devices issued to employees. Because the organization owns the hardware, it has much greater control over how the device is configured and secured. Corporate-owned devices are often pre-configured with approved applications, encryption settings, password requirements, and other security controls before the employee even powers the device on for the first time. This is where profile security requirements become especially important. Organizations often establish security requirements that devices must follow before they are allowed to access company resources. These requirements may include strong passcodes, device encryption, automatic screen locks, antivirus software, operating system updates, and restrictions on certain applications or settings. In many environments, if a device does not meet the required security standards, it may be blocked from accessing company email, files, or internal systems altogether. To help enforce these security standards consistently, organizations commonly use configuration profiles. Configuration profiles are collections of settings and restrictions that can be automatically applied to mobile devices. Rather than manually configuring every device one setting at a time, administrators can deploy a profile that applies Wi-Fi settings, VPN configurations, password policies, email accounts, encryption requirements, and application restrictions all at once. Think of configuration profiles like a pre-built security template that helps ensure every device follows the organization's rules from the start. Of course, applying and managing all these settings across dozens, hundreds, or even thousands of devices manually would quickly become a nightmare. That is where mobile device management, commonly referred to as MDM, comes into play. We covered MDM earlier in Exam Objective 2.1, but it fits naturally into this discussion because it plays such a major role in both BYOD and corporate-owned environments. MDM allows administrators to remotely manage, monitor, and secure mobile devices from a centralized platform. Through MDM, organizations can deploy configuration profiles, enforce password requirements, require encryption, manage applications, and ensure devices remain compliant with security policies. Administrators can also block unauthorized applications, push security updates, and verify that devices meet required security standards before granting access to company resources. One particularly important MDM feature is remote wipe capability. If a device is lost, stolen, or compromised, administrators can remotely erase company data from the device to help prevent sensitive information from falling into the wrong hands. In BYOD environments, some MDM solutions even support selective wipes, allowing only company data to be removed while leaving the user's personal photos, messages, and apps untouched. MDM solutions may also help track device compliance by ensuring devices stay updated, encrypted, and protected with required security settings. If a device falls out of compliance, such as having outdated software or disabled security features, access to company resources can be restricted until the issue is corrected. As you can see, securing mobile devices in a business environment is not just about the device itself. It is about balancing security, usability, privacy, and control. Organizations want employees to stay productive and connected, but they also need to make sure sensitive company data does not end up exposed because someone downloaded a sketchy app at 2 a.m. Whether a company chooses BYOD, corporate-owned devices, or a mix of both, tools like configuration profiles and MDM help keep security standards consistent across the environment. In today's workplace, mobile devices are no longer optional extras. They are full-fledged endpoints on the network, and they need to be managed and secured accordingly. Exam Objective 2.9 Compare and contrast common data destruction and disposal methods. When it comes to getting rid of old hard drives or storage devices, simply dragging files to the recycle bin and calling it a day is definitely not enough. Even deleting files or performing a quick format can leave recoverable data behind. Whether you are disposing of a single personal drive or managing an entire room full of retired company hardware, properly destroying or sanitizing data is critical. Otherwise, sensitive information could end up in the hands of someone who should never have access to it. And trust me, you do not want your old tax returns, passwords, or company records becoming part of someone else's treasure hunt. One of the most reliable ways to ensure data can never be recovered is through physical destruction. Physical destruction focuses on damaging the storage media so thoroughly that recovering the data becomes impossible. Let's begin with drilling. Drilling involves physically drilling holes through the hard drive platters or storage components. It is certainly a satisfying method and definitely sends a clear message to the drive, but it is not always the most secure option. If critical sections of the drive remain intact, highly specialized recovery techniques may still recover portions of the data from undamaged areas. A more secure method for traditional hard disk drives is degaussing. Degaussing uses a powerful magnetic field to disrupt or erase the magnetic charges stored on the drive's platters. Since traditional hard drives store data magnetically, this process effectively scrambles the data into unreadable nonsense. However, degaussing is designed specifically for magnetic media and is not effective against many types of solid-state storage. If you want to take things a step further, shredding is an excellent option. In this process, storage devices are fed into an industrial shredder that breaks them into tiny fragments. Once shredded, the pieces are so small and damaged that reassembling the drive for data recovery becomes practically impossible. This method is commonly used by organizations handling large quantities of retired drives because it is both fast and highly effective. And finally, there is incineration. Incineration involves exposing the drive to extremely high temperatures until the storage media is melted or destroyed completely. At that point, data recovery is no longer a concern because there is essentially nothing left to recover. While this method provides an extremely high level of security, it is generally reserved for situations involving highly sensitive or classified data. Of course, not every drive needs to meet a fiery end worthy of an action movie. Sometimes the goal is to recycle or repurpose the drive safely rather than destroy it completely. In these situations, proper data sanitization becomes the focus. One of the simplest methods is standard formatting, commonly known as a quick format. During a standard format, the operating system removes the file references that point to the stored data, making the files appear deleted. However, the underlying data often still remains on the drive until it is overwritten later. This means specialized recovery software may still be able to recover the information. Standard formatting is fast and convenient, but it is not considered secure for sensitive data disposal. A more secure option is erasing or wiping the drive. In this process, the existing data is overwritten with new patterns of data, often zeros, ones, or random information. By repeatedly overwriting the original information, recovering the old data becomes much more difficult. Wiping takes longer than a quick format, but it provides a significantly higher level of security for drives that will be reused or recycled. For situations requiring even stronger sanitization, low-level formatting may be used. Low-level formatting rewrites every sector on the drive, returning it closer to a factory-like state while thoroughly removing stored data. This process is far more intensive than a standard format and is designed to make data recovery extremely difficult, even with advanced recovery tools. When dealing with highly sensitive information, low-level formatting provides a much stronger level of sanitization before repurposing the drive. In many environments, organizations choose to outsource drive destruction or recycling to third-party vendors. This can save time and ensure proper disposal procedures are followed, especially when large numbers of drives are involved. However, organizations must be careful when selecting a vendor because sensitive data is still involved until destruction is complete. This is why certifications of destruction or recycling are so important. A certification of destruction provides documented proof that the storage devices were properly destroyed or sanitized according to established standards. Similarly, certifications of recycling verify that electronic waste was disposed of responsibly. These records are especially important for organizations handling regulated or sensitive data because they help demonstrate compliance during audits or investigations. Speaking of compliance, organizations must also consider regulatory and environmental requirements when disposing of electronic devices. Certain industries are required by law to follow strict rules regarding the handling and destruction of sensitive information, especially when dealing with personal data, healthcare information, or financial records. At the same time, electronic devices often contain hazardous materials that should not simply be thrown into landfills. Proper recycling helps reduce environmental impact while ensuring harmful materials are handled safely and responsibly. Exam Objective 2.10. Given a scenario, apply security settings on SOHO wireless and wired networks. Home router settings. When setting up or securing a small office, home office network, commonly referred to as a SOHO network, proper security settings are extremely important. Your router sits at the edge of your network, acting as the gateway between your internal devices and the internet. In many ways, it serves as the first line of defense against attackers, unwanted traffic, and unauthorized access attempts. A few simple security changes can go a long way toward protecting both your devices and your data. First things first, one of the most important steps is changing the router's default administrator credentials. Most routers ship with default usernames and passwords such as admin or password, and attackers know these defaults very well. Leaving them unchanged is a bit like installing a security system on your house but leaving the front door wide open. Changing the default credentials immediately helps prevent unauthorized users from accessing the router's management interface and changing network settings. Once the default credentials are secured, another useful security feature is MAC address filtering. MAC filtering allows the router to permit or deny network access based on a device's media access control address, commonly called a MAC address. Every network-enabled device has a unique MAC address assigned to its network interface card. By creating a list of approved MAC addresses, administrators can restrict network access to only trusted devices. While MAC filtering should not be relied upon as the sole security measure, it does provide an additional layer of control over who is allowed onto the network. In addition to MAC filtering, some routers also support IP filtering. IP filtering allows administrators to allow or block traffic based on IP addresses. For example, a network administrator might block a known malicious IP address or restrict certain internal devices from accessing specific internet resources. MAC filtering focuses on devices, while IP filtering focuses on network communication itself. Another critical task is keeping the router's firmware updated. Firmware is the specialized software built directly into the router that controls how the device operates. Manufacturers regularly release firmware updates to patch security vulnerabilities, improve stability, and add new features. Attackers often target outdated networking equipment because known vulnerabilities may already have publicly available exploits. Keeping firmware updated helps close these security gaps before attackers can take advantage of them. Next up is content filtering. Content filtering allows administrators to block access to certain websites, applications, or categories of online content based on defined rules or policies. This can help reduce exposure to malicious websites, phishing attacks, inappropriate content, or even productivity distractions. Whether the goal is protecting children at home or reducing risky browsing activity in a small office, content filtering adds another useful layer of protection to the network. Of course, not all security threats come through the internet. Physical placement and security matter too. Routers should be placed in secure locations where unauthorized individuals cannot easily tamper with them or reset them to factory defaults. In addition, proper placement can also improve wireless security and signal coverage. Placing the router near the center of the building often helps reduce signal leakage far outside the intended coverage area. If your Wi-Fi signal reaches halfway down the street, your neighbors may accidentally discover they have excellent reception. Another setting worth discussing is Universal Plug and Play, commonly abbreviated as UPnP. UPnP is a networking feature that allows devices on the network to automatically discover and configure connections with one another. While convenient, UPnP can introduce security risks because it may allow devices or applications to automatically open ports on the router without the administrator fully realizing it. This can potentially expose internal services to the internet. Unless there is a specific need for UPnP, disabling it is often considered a safer approach. Speaking of exposed services, sometimes organizations intentionally place certain systems in a separate network area known as a screened subnet, also called a DMZ or demilitarized zone. A screened subnet is an isolated portion of the network designed to host systems that must be accessible from the internet, such as web servers or email servers, while still protecting the internal network. Think of it like a fenced-off reception area outside a secure building. Visitors may enter the reception area, but they cannot freely wander into the highly secure sections deeper inside the building. If a public-facing server becomes compromised, the attacker is hopefully contained within the screened subnet rather than gaining direct access to the internal network. Another important security setting emphasized in the current version of the A Plus, Core 2 exam objectives, is configuring secure management access. This focuses on protecting the methods used to access and manage the router itself. Administrators should use secure management protocols whenever possible, such as HTTPS instead of HTTP, or SSH instead of Telnet, since these protocols encrypt management traffic and help protect credentials from being intercepted. It is also a good idea to disable remote management entirely if it is not needed. After all, if attackers cannot remotely reach the router's management interface, that is one less opportunity for them to target your network. Exam Objective 2.10, given a scenario, Apply security settings on SOHO wireless and wired networks. Wireless settings. Whether you are configuring a wireless access point, a wireless router, or an all-in-one SOHO router, there are several wireless security settings that can dramatically improve the security of your network. Wireless networks are incredibly convenient, but convenience can also attract unwanted attention if the network is not properly secured. In this video segment, we will focus on some of the most important wireless security settings you should understand for both the real world and the current CompTIA A Plus, Core 2 exam objectives. A great place to begin is with the SSID, which stands for Service Set Identifier. The SSID is a unique alphanumeric identifier given to a wireless local area network. Or simply put, the name of the wireless network that devices see when scanning for available Wi-Fi connections. It acts as the label that helps users identify which wireless network they want to join. Whether you realize it or not, you probably interact with SSIDs constantly. Every time you see a list of nearby Wi-Fi networks on your phone or laptop, you are looking at a collection of SSIDs. When setting up a wireless network, one of the first security best practices is changing the default SSID. Many routers ship with factory default names that reveal the manufacturer or even the router model itself. Attackers can sometimes use this information to identify known vulnerabilities or default settings associated with that specific device. Changing the SSID helps avoid advertising unnecessary information about the router to anyone nearby. Plus, leaving the default SSID practically screams, "I have never touched my router settings." While discussing SSIDs, another setting you may encounter is disabling SSID broadcast. Normally, wireless routers continuously broadcast the SSID, so nearby devices can easily discover the network. Disabling SSID broadcast hides the network name from the normal list of visible Wi-Fi networks, meaning users must manually enter the network name to connect. This can provide a small layer of obscurity because casual users scanning for networks will not immediately see it. However, it is important to understand that disabling SSID broadcast is not a major security feature by itself. More advanced wireless scanning tools can still detect hidden networks fairly easily. Additionally, hiding the SSID can become inconvenient since every legitimate device must be manually configured with the network information. In other words, it may hide your network from your neighbor looking for free Wi-Fi, but it will not fool a determined attacker. Of course, one of the most important wireless security settings is encryption. Encryption protects wireless traffic by scrambling the transmitted data so unauthorized users cannot easily intercept or read it. Without encryption, information sent across the wireless network may potentially be viewed by others nearby. This is why public open Wi-Fi networks should always be approached carefully, especially when accessing sensitive accounts or transmitting private information. Now, if you are experiencing a bit of déjà vu, that is completely normal because we already covered wireless encryption standards earlier in Exam Objective 2.3, when discussing wireless security protocols and authentication methods. Since encryption settings are also directly configured on wireless routers and access points, they naturally appear again here as part of wireless network configuration. To quickly review, older encryption standards such as WEP and WPA are now considered outdated and insecure. WPA2 replaced these encryption standards and introduced much stronger protection through the use of AES encryption and became the standard wireless security option for many years. Today, WPA3 is considered the most secure wireless encryption standard, currently available for consumer and business wireless networks. WPA3 improves protection against password guessing attacks and strengthens wireless encryption overall. Whenever possible, WPA3 should be used, although WPA2 with AES may still be necessary when supporting older devices that do not yet support WPA3. Another important wireless feature is configuring guest access. Many modern routers support the creation of a separate guest wireless network specifically designed for visitors. Rather than giving guests direct access to the primary network, Guest access allows them to connect to a separate isolated network that provides internet access without exposing internal devices, shared files, printers, or other sensitive resources. This is a much safer approach than simply handing out the main Wi-Fi password to everyone who walks through the door. Properly configured guest networks help improve both convenience and security by separating trusted internal devices from temporary guest devices. Exam Objective 2.10. Given a scenario, apply security settings on SOHO wireless and wired networks. SOHO firewall settings. When setting up a small office or home office network, configuring your SOHO firewall is yet another way to ensure security. The firewall acts as the network's gatekeeper, controlling which data is allowed in and out of the local area network, helping to prevent unauthorized access while allowing legitimate traffic through. In this video segment, we're going to focus on two key firewall settings that directly impact how your SOHO router network handles network traffic. First, we will talk about disabling unused ports. Ports are like virtual doors on your network that allow specific types of data in and out. If a door, or port, is open but not being used, it can become a security risk, as attackers might exploit it to gain unauthorized access. By disabling these unused ports, you're essentially closing those doors, tightening the security of your network and limiting access to only the essential traffic. Once you've explicitly allowed the ports that are necessary for your network's functionality, such as those needed for web traffic or email, it's a best practice to implement a deny all rule for any other ports. This means that only the specified, permitted ports are open, and all other traffic is automatically blocked. By taking this approach, you further reduce the chances of unauthorized access and make your network more secure. One final point: Universal Plug and Play, or UPnP, can automatically open ports. If you want to maintain strict control over which ports are open, you may need to disable this feature to ensure that only your specified ports are allowed. Now, let's move on to port forwarding, which is important when you need to allow external traffic to access a specific service inside your network. Port forwarding, sometimes referred to as port mapping, is the process of redirecting communication requests from one address and port number to another. This occurs when data packets are received by the network gateway. To say it another way, port forwarding allows external devices to connect to a particular service or device within your network by mapping the external port to the internal IP address of the device hosting the service. For example, what if your company hosts a public website on an internal server, but customers need to access it from outside the local area network? If that is the case, then port forwarding would ensure that incoming web traffic is routed directly to the web server inside your network. Exam Objective 2.11. Given a scenario, configure relevant security settings in a browser. Browser downloads. When downloading files through a browser or from the internet, it is important to think about security before clicking that download button. Browsers are one of the primary ways users interact with the internet, which also makes them one of the most common targets for malware, phishing attacks, and malicious downloads. A little caution can go a long way toward keeping your system safe. One of the best security practices is downloading files only from trusted sources. Trusted sources include official vendor websites, reputable software publishers, and well-known platforms. For example, if you need Adobe Reader, it is much safer to download it directly from Adobe's official website rather than from a random third-party download site promising free premium software. Trusted sources greatly reduce the risk of downloading modified installers, malware, or fake applications disguised as legitimate software. Unfortunately, not every website on the internet has your best interests in mind. Downloading files from untrusted sources can introduce significant risk. Untrusted sources may include unfamiliar websites, suspicious pop-up ads, random file-sharing links, or links sent through unsolicited emails or social media messages. Even if the download appears legitimate, it could contain malware, spyware, ransomware, or other malicious code hidden inside the installer. Attackers often disguise harmful files as popular software, games, browser updates, or utility tools in hopes that users will install them without thinking twice. If a website immediately greets you with 12 flashing download now buttons, that is probably not a great sign. Even when downloading from trusted sources, there is still one extra step users can take to verify file integrity, and that is hashing. Hashing is a process that takes the contents of a file and runs it through a mathematical algorithm to create a unique string of characters, known as a hash or checksum. You can think of the hash as a digital fingerprint for the file. If even a single character inside the file changes, the resulting hash value will also change. Software developers often publish the official hash value alongside the download link. After downloading the file, users can generate the file's hash on their own system and compare it to the published value. If the values match, the file is considered authentic and unchanged. However, if the hash values differ, the file may have been corrupted during download or potentially tampered with by an attacker. Another important topic to cover here is browser patching. Browser patching refers to keeping web browsers updated with the latest security fixes, feature updates, and vulnerability patches. Since browsers constantly interact with websites, scripts, advertisements, and downloaded content from across the internet, they are frequent targets for attackers looking to exploit security flaws. Outdated browsers may contain vulnerabilities that allow attackers to execute malicious code, steal information, redirect users to harmful websites, or compromise the system entirely. Browser vendors regularly release updates to patch these security weaknesses as they are discovered. Most modern browsers update automatically, but users should still verify that updates are enabled and applied regularly. Exam Objective 2.11, given a scenario, configure relevant security settings in a browser. Browser plugins and extensions. Browser plugins and extensions are software components that integrate with your web browser to extend its functionality and provide additional features. You may also hear them referred to as add-ons. These tools can enhance the browsing experience by adding features such as ad blocking, password management, language translation, note-taking, productivity tools, and much more. In many ways, plugins and extensions allow users to customize their browsers to better fit their needs. Of course, as with many things in cybersecurity, convenience and risk often arrive together. When installing plugins and extensions, it is always safest to use trusted sources. Trusted sources typically include the official extension marketplaces for browsers such as the Chrome Web Store, Firefox add-ons, or the Microsoft Edge add-ons site. Plugins and extensions hosted through official marketplaces usually go through at least some level of review or screening process before becoming publicly available. While this does not guarantee that every extension is perfectly safe, it significantly lowers the risk of downloading malicious or poorly maintained software. It is also important to pay attention to the permissions requested by a plugin or extension before installing it. Some permissions are perfectly reasonable depending on the tool's purpose. For example, an ad blocker may need permission to read website content in order to block advertisements properly. However, if a simple calculator extension suddenly wants permission to read all your browsing data, control downloads, and manage browser settings, that should probably raise a few eyebrows. Sometimes the biggest warning sign is not what the extension claims to do, but what it wants access to, behind the scenes. Unfortunately, not all plugins and extensions come from trustworthy places. Installing plugins and extensions from untrusted sources can create serious security risks. Untrusted sources may include unofficial websites, suspicious links, pop-up advertisements, or files downloaded directly from random internet sources. Malicious plugins and extensions may secretly collect browsing data, track user activity, inject advertisements, redirect users to harmful websites, steal credentials, or even install additional malware onto the system. Attackers sometimes disguise malicious plugins and extensions as useful utilities, browser updates, or productivity tools, in hopes that users will install them without hesitation. In some cases, the extension may even function normally while secretly performing harmful actions in the background. Because of these risks, users should avoid installing plugins and extensions from unfamiliar sources and should stick to well-reviewed tools from reputable developers whenever possible. Reading reviews, checking download counts, and verifying the developer can also help reduce the chances of installing something malicious. Another topic we need to cover is browser feature management. Browser feature management involves enabling or disabling browser components such as plugins, extensions, and built-in browser features based on security and usability needs. Not every browser feature, plugin, or extension needs to remain enabled all the time. Unused plugins and extensions can increase the browser's attack surface, meaning they create additional opportunities for vulnerabilities or malicious activity. Disabling or removing unnecessary plugins and extensions helps reduce these risks while also improving browser performance in many cases. At the end of the day, plugins and extensions can be incredibly useful, but they should always be approached carefully. Installing them only from trusted sources, reviewing requested permissions, avoiding suspicious add-ons, and managing browser features responsibly all help reduce the risk of turning your web browser into an unexpected security problem. Exam Objective 2.11 Given a scenario, configure relevant security settings in a browser. Password managers. Password managers are essential tools that can significantly improve your online security by helping you create, store, and manage strong, unique passwords for all your accounts. A password manager is a software application that securely stores your login credentials in an encrypted format. It acts like a digital vault, keeping all your passwords safe in one place while allowing you easy access to them when needed. Using a password manager reduces the risk of using weak or reused passwords, which are common mistakes that make accounts vulnerable to hackers. Instead, it allows you to generate complex passwords for each of your accounts, making it harder for attackers to break in, even if one account is compromised. Password managers also eliminate the need to remember multiple passwords since they can automatically fill in your login details for websites and apps. This feature not only boosts your security but also saves time. Beyond password storage and generation, many password managers offer additional features to enhance your security. For instance, they can securely store sensitive information like credit card details, private notes, and even documents. Some password managers will also notify you if a saved password has been exposed in a data breach, prompting you to update it. Others offer secure password sharing, allowing you to share account access safely with family, friends, or colleagues without revealing the actual password. Integrating a password manager into your daily routine can greatly improve both security and convenience. Whether built into your web browser, part of your operating system, or a standalone app, a password manager is a simple but powerful way to manage your digital identity more securely. It encourages good password habits, protects against common cyber threats, and reduces the chances of unauthorized access to your accounts. Exam Objective 2.11 Given a scenario, configure relevant security settings in a browser. Website security certificates. To begin this video segment, let's discuss what a website security certificate is. You can think of a certificate as a digital ID card for a website. Just like you need identification to verify who you are, websites need certificates to prove their authenticity and ensure secure communication. Imagine you're about to enter a secure website. Your web browser checks this certificate to confirm the site's identity, like a virtual handshake, before it establishes a secure connection. These certificates are crucial in safeguarding sensitive data, such as personal information or credit card details, from falling into the wrong hands. So how are certificates acquired? Certificates are issued and managed by trusted third-party entities known as certificate authorities or CAs. These CAs act as digital notaries, verifying the identity and authenticity of a website. When a website owner wants a certificate, they go through a validation process with the CA. The CA will verify the website owner's identity and domain ownership to ensure they are legitimate. Once the validation is successful, the CA issues a digital certificate containing the website's public encryption key and other essential information. When you access a website using HTTPS in the URL, your web browser recognizes this and checks for a valid certificate. If the certificate is valid and trusted, your browser establishes a secure encrypted connection with the website's server. The lock icon you see in the browser's address bar indicates a secure connection. It means your data, such as login credentials or credit card information, is encrypted while being transmitted, making it extremely difficult for hackers to intercept or decipher. But be careful, not all certificates are trustworthy. Let's talk about valid and invalid certificates. A valid certificate is one that has been issued by a reputable CA and is within its validity date range. On the other hand, an invalid certificate raises a red flag. When you encounter an invalid certificate, your browser will display a warning message like, "Your connection is not private," or, "The security certificate presented by this website has expired or is not yet valid." This is a safety measure to protect you from potential threats, such as phishing attacks, data interception, or malware, and it is generally best to avoid proceeding to such a website unless you're certain it's safe. One common issue that might cause a certificate to appear invalid, even though it may be valid, is when a computer's date and time settings are incorrect. If this is the case, it can interfere with certificate validation, making it appear as a certificate has expired or is not yet valid, even though it may be fine. Exam Objective 2.11, given a scenario, configure relevant security settings in a browser. Browser settings. Before we wrap up our study of Domain 2, which is all about security, there is one more area worth exploring, and that is browser settings. Modern web browsers include a wide range of built-in security and privacy features, designed to help protect users while browsing the internet. Many of these settings work quietly in the background, but understanding what they do can significantly improve both security and the overall browsing experience. Let's begin with pop-up blockers. Most of you may already know what a pop-up is, but let's be thorough. In the context of a web browser, a pop-up is a small window that appears over the main browser window, often showing ads, notifications, or forms. While some pop-ups are useful, many are intrusive and can even pose security risks. This is where pop-up blockers come in. They prevent unwanted pop-ups from appearing, making your browsing experience less cluttered and more secure. When enabled, a pop-up blocker scans the page for scripts that try to generate pop-ups and stops them from appearing. You can also adjust your settings to allow pop-ups from trusted websites, ensuring that you don't miss important prompts or notifications when needed. Closely related to pop-up blockers are ad blockers. While pop-up blockers target separate windows, ad blockers focus on advertisements embedded directly into web pages. Ad blockers can improve browsing speed, reduce distractions, and help protect users from malicious advertisements. By filtering out unwanted advertising content, ad blockers can improve both security and privacy. However, it is important to remember that many websites rely on advertising revenue to operate. Some sites may limit access if they detect ad blockers being used. Because of this, some users choose to allow ads on trusted websites they wish to support. As you continue browsing, your browser collects information like your history, cookies, and form data. This can be useful, as it makes browsing more convenient, like autofilling forms or remembering login details. However, storing this data can be risky, especially on shared or public computers, as it could expose sensitive information. Clearing browsing data removes the stored information, reducing the chances of someone else accessing it. Doing this regularly is a good habit to protect your privacy and keep your browser running smoothly. While browsing data includes things like history and cookies, the cache is another important piece of the puzzle. The cache is essentially a temporary storage space where your browser saves copies of websites, images, and other resources to make future visits faster. But over time, cached data can become outdated, causing websites to load incorrectly or even creating security risks if sensitive data is cached. Clearing your cache ensures you're seeing the most up-to-date content and minimizes potential privacy risks. It also frees up storage space, which can improve your device's performance. If you want to prevent your browser from saving any history or data during a session, private browsing mode is the way to go. Also known as incognito mode, this feature stops your browser from storing history, cookies, or temporary files while you browse. This is useful for sensitive activities, like logging into a bank account on a shared computer, since no traces are left behind after you close the session. Keep in mind, though, that private browsing only prevents local tracking. It won't stop your network administrator or internet service provider from seeing your activity. Another common browser feature is sign-in and browser data synchronization. Modern browsers often allow users to sign in with an account and synchronize data such as bookmarks, saved passwords, browsing history, open tabs, and browser settings across multiple devices. This provides convenience by allowing users to move seamlessly between computers, tablets, and smartphones while keeping the same browsing environment. Of course, synchronization also introduces risk. If an attacker gains access to the user's browser account, they may potentially gain access to synchronized passwords, browsing history, and other sensitive information across every connected device. This is why strong passwords and multi-factor authentication are especially important for browser accounts. Next up, we have proxy settings. A proxy server acts as an intermediary between a user's device and the internet. Instead of connecting directly to websites, requests are first sent to the proxy server, which then forwards the request on behalf of the user. Proxies can serve several purposes, including content filtering, monitoring internet usage, improving privacy, and controlling access to websites. In business environments, organizations often use proxy servers to enforce acceptable use policies or inspect outbound traffic for security concerns. Some users also use proxies to help obscure their IP addresses or filter internet content. Finally, let's discuss secure DNS. Normally, traditional DNS requests are sent across networks in plain text, meaning attackers may potentially intercept or manipulate them. Secure DNS improves security by encrypting DNS requests, helping protect users from DNS spoofing, monitoring, and certain types of redirection attacks. Modern browsers may support technologies such as DNS over HTTPS, which encrypts DNS traffic using secure HTTPS connections. This helps improve both privacy and security while browsing the internet. Instead of broadcasting every website lookup across the network in clear text, secure DNS helps keep those requests protected from prying eyes. Exam Objective 3.1. Given a scenario, troubleshoot common Windows OS issues. With this video segment, we're kicking off Domain 3, Software Troubleshooting. You've already made amazing progress, working through the ins and outs of Domain 1 and Domain 2 of the CompTIA A Plus, Core 2 exam objectives. So take a moment to appreciate all the hard work you've put in so far. Go ahead, take a deep breath, and give yourself a well-deserved pat on the back. The great news about Domain 3 is that you'll be building on what you've already learned in Domains 1 and 2, so this section should feel like a breeze. Ready to tackle software troubleshooting with confidence? Great! Let's begin. To get the ball rolling, we will start with the infamous Windows blue screen of death, or BSOD for short. When the blue screen of death appears, it's the system's way of telling you that a critical error has occurred. It usually comes with a stop code that provides clues about what went wrong. This stop code is your starting point for diagnosing the issue, as it can indicate problems related to drivers, hardware, or the operating system itself. To troubleshoot a BSOD, the first thing you should do is make a note of the stop code displayed on the screen. This code can help identify the type of error and guide your next steps. If the issue started recently, try using System Restore to revert the system to an earlier state, undoing any changes that might have caused the problem. Another common fix is to roll back drivers or updates, as outdated or incompatible updates can trigger BSODs. If new hardware or software was added before the BSOD appeared, remove them to see if the error resolves. You should also ensure that all hardware components and cables are properly connected, as loose connections can cause system failures. Running built-in tools like hardware diagnostics, or check disk to check the integrity of the hard drive, and a malware scan can help rule out hardware faults or malicious software as potential causes. Lastly, don't overlook the possibility of overheating as a root cause. To rule this out, ensure that the system's fans and ventilation are working effectively to maintain safe operating temperatures. Moving on, if your system displays a No OS Found message, it's typically due to a boot drive issue. This error suggests that the computer is unable to locate an operating system to start up from. To troubleshoot this issue, first enter the BIOS and verify that the boot drive is recognized. If the drive is not listed, check the physical connections to ensure the drive is properly connected, then try rebooting the system. Next, check the boot order in the BIOS settings to confirm that the correct drive is set as the primary boot device. Additionally, this error can occur if a USB drive or other removable media is left connected during boot, so make sure to remove any unnecessary devices and restart the system. If the issue persists, run a disk diagnostic using tools like check disk to identify and repair potential drive errors. You may also need to use OS Loader repair tools to fix the boot sector or master boot record. If the drive itself has failed, replacing the drive and re-imaging the workstation with a fresh copy of the operating system may be necessary to restore functionality. Now, let's look at general boot issues, which can range from simple glitches to more serious errors like boot manager is missing or the system failing to load altogether. If possible, start troubleshooting by opening the Startup tab in Task Manager and begin to disable startup items one by one, rebooting after each change. This helps identify if a particular program is causing the issue. If that doesn't help or is not possible, load the system into safe mode. This limited environment allows you to run boot logging, which records driver and service loading during startup. Review the log for any errors that could point to driver issues. If you find any problematic drivers, uninstall or update them. If the problem persists, use Windows recovery tools and run startup repair to automatically fix common boot issues, such as missing or corrupted system files. If these steps fail, you may need to check the BIOS settings to ensure the correct boot drive is set. For more severe cases, consider re-imaging the workstation to reinstall the OS and clear any lingering software issues. If the system frequently shuts down unexpectedly or exhibits instability, such as freezing, crashing, or erratic behavior, it could be caused by hardware issues, overheating, or malware. Begin by checking the system event logs for error messages that could provide clues about the root cause. Make sure the system has proper cooling and a stable power supply, as overheating or power fluctuations can contribute to shutdowns and instability. If the issue persists, consider the possibility of malware disrupting processes, corrupting files, or consuming system resources. Run a full malware scan using up-to-date antivirus software and remove any detected threats. After remediating the system, reboot to see if stability is restored. If problems continue, it may be necessary to repair Windows or, in severe cases, re-image the workstation. Re-imaging ensures a clean start by reinstalling the operating system, removing any lingering malware or corrupted files that might be causing the ongoing issues. If the system is experiencing degraded or sluggish performance, it may be due to high CPU usage, limited RAM, or software issues. Start by rebooting the system to clear temporary files and reset memory usage. Next, open Task Manager to view resource utilization, identify any processes consuming excessive resources, and stop or restart those processes as needed. If performance remains slow, consider adding resources, such as increasing the system's RAM, to better handle demanding tasks. Additionally, uninstall unnecessary applications that may be consuming resources in the background. Running a system file check can also identify and repair corrupted system files that may be contributing to performance issues. When the system displays a warning for low memory, it usually indicates a memory leak or excessive resource consumption. A memory leak occurs when an application fails to release memory it no longer needs, causing the system to run out of available memory over time. Start by rebooting the system to clear temporary memory use and monitor background processes in Task Manager. Identify any applications consuming excessive memory, and uninstall, reinstall, or update them to see if that resolves the issue. If the problem persists, consider increasing the system's available memory. You can do this by adding physical RAM to handle more tasks simultaneously or by increasing virtual memory, which allows the system to use part of the hard drive as additional memory. USB controller resource warnings occur when there are conflicts or limitations in the system's ability to allocate resources to connected USB devices. These warnings may arise from too many USB devices competing for limited resources, outdated drivers, hardware limitations, or even using an unpowered USB hub, which cannot provide enough power to all connected devices. To troubleshoot USB controller resource warnings, start by rebooting the system. This can clear temporary conflicts and reset resource allocation. After rebooting, open Device Manager and look for errors or warning symbols related to USB controllers or devices. If issues are found, update the USB drivers to ensure they're compatible and functioning correctly. Next, check whether the system's hardware meets the requirements for the connected USB devices, as older systems may struggle to handle multiple or high-demand USB devices. In such cases, try to reduce the number of connected devices to see if performance improves. Using an unpowered USB hub can also contribute to resource conflicts, so consider switching to a powered USB hub, which provides its own power supply and can better handle multiple devices. If the issue persists, consider adding a separate USB controller card to the system to provide additional USB ports and resources. When Windows services fail to start, it can impact system functions and applications that depend on those services. Start troubleshooting by opening the Services utility, where you can view and manage services. Locate the affected service and try to restart it. If it fails to respond or stops immediately, it could be due to compatibility issues caused by recent updates. If restarting doesn't work, next you can try to roll back recent updates that might be affecting the service. Sometimes updates can conflict with services, leading to failures. Additionally, check if the service has sufficient privileges to run. Some services require administrative rights or specific user accounts to function properly. As a last measure, consider repairing Windows using recovery tools. When applications are crashing frequently, it often indicates software conflicts, corrupted files, or compatibility issues. Start by checking for any recent patches or updates that might have been installed before the crashes began, as they could be introducing conflicts or bugs. To troubleshoot, roll back updates one at a time, testing the application after each rollback to identify if a particular update is causing the issue. If the problem persists, try uninstalling and reinstalling the application to replace any corrupted files or settings. If a user's profile loads slowly, try to determine if the issue is user-specific or system-wide. If it is user-specific, it could be caused by a user profile containing corrupted files, excessive startup programs, or profile misconfigurations. Corrupted files within the user profile can slow down the loading process, as the system may struggle to read or access the necessary data. Similarly, having too many startup programs tied to a user profile can significantly delay the login process, as these programs attempt to launch all at once during login. To address this, first, review the startup items associated with the user's profile. Disabling unnecessary startup programs can improve login times and reduce the load on the system. If this step does not fully resolve the issue, it's likely that the user profile has become corrupted or misconfigured. In this case, rebuilding the Windows profile is often the most effective solution. This process involves creating a new user profile, which eliminates corrupted data and provides a clean slate. The new profile typically results in faster loading times and improved overall performance for the user, as it starts fresh without any lingering issues from the old profile. Finally, let's address time drift, which occurs when the system clock falls out of sync with the real time. While this may sound trivial, it can lead to a variety of issues. The system clock plays a critical role in maintaining the accuracy and integrity of time-dependent processes, such as verifying website certificates, coordinating with authentication servers, and synchronizing with other systems. When time drift happens, it can cause problems like invalid certificates, failed authentication attempts, and errors when connecting to network resources. The most common causes of time drift include network connectivity issues, misconfigured time settings, or interrupted synchronization with a time server. To begin troubleshooting, reboot the system and check that the date and time settings are correct. Pay special attention to the time zone, as incorrect settings here can also cause time-related errors. Persistent time drift may require further action, such as restoring the system to a previous point to undo recent changes that could be affecting the clock. If the issue still isn't resolved, you might need to repair Windows to address deeper system file issues that impact timekeeping. By addressing each of these common symptoms step by step, you can troubleshoot and resolve a variety of Windows OS problems. Of course, this isn't the complete list for every issue you might encounter. Each problem could have its own quirky twists, but these troubleshooting steps will certainly get you started and headed in the right direction. Exam Objective 3.2 Given a scenario, troubleshoot common mobile OS and application issues. Troubleshooting issues on a mobile OS can feel a bit different from dealing with Windows or other PC operating systems, but there are a lot of similarities. In both cases, you're playing detective, identifying symptoms, ruling out possible causes, and applying fixes one step at a time. Just like in Windows, where you might check for updates, look at system resources, or reboot your device as part of routine troubleshooting, mobile troubleshooting follows a similar path. Now, let's break down some common mobile OS issues and discuss appropriate troubleshooting steps to get things back on track. To begin, one common mobile OS issue is when an application fails to launch. Sometimes, no matter how many times you tap on an app, it just won't open. If this happens to you, first try to launch it again. Then if it still doesn't cooperate, a quick reboot of the device can often resolve the issue. Is it still not launching? Then escalate to clearing the application's cache file, or as a final step, reinstall the application altogether. Another frequent issue is when an application fails to close or crashes unexpectedly. Often, a failure to close can be resolved by utilizing the force stop option that is available through the app settings. This force stop option completely shuts down the app and will clear any temporary glitches. As for crashes, these can occur if the app's temporary storage, or cache, becomes cluttered with old data. Clearing the application cache or storage usually resolves these issues, as it removes unnecessary data that may be causing the app to misbehave. After clearing the cache, check if there's an available update for the app, as updates frequently address crash-related bugs. If the problem persists, a device reboot may clear out any residual issues. As a last resort, try reinstalling the app, or, if multiple apps are crashing, perform a factory reset, which restores the device to its original factory settings. Occasionally, you may encounter a situation where an application refuses to update. Typically, this happens because the device is running low on storage, leaving no room for the update. Clearing out unused apps or files to free up storage often solves the problem. If storage isn't the issue and updates still fail to load, try a quick reboot to reset the update process. If all else fails, uninstalling and reinstalling the app would be an appropriate next step. Another common issue users encounter is when an application refuses to install altogether. In many cases, this can happen because the device does not meet the application's minimum requirements, such as the required operating system version, available storage space, or hardware specifications. Sometimes the installation file itself may also be corrupted, especially if it was downloaded from an unreliable source or interrupted during the download process. To troubleshoot the issue, first verify that the device meets the application's system requirements and has enough free storage available. If the application was downloaded from the internet, try downloading it again from a trusted source to rule out file corruption. It is also worth checking whether security settings, antivirus software, or operating system permissions are blocking the installation. And of course, when technology refuses to cooperate for no obvious reason, never underestimate the power of the classic reboot. Sometimes your device simply needs a quick reset before it decides to behave again. Next, updating your device's OS, just like updating apps, can also lead to update failures. To address OS update failures, start by taking a look at available storage space, as devices will need extra room to install update files. Another factor is compatibility. You will often find that older devices may not support the latest OS version, requiring users to stick with the current version. It's also important to connect the device to a stable power source during an update, as a power interruption can disrupt the update process. If the update still won't install after performing these steps, try rebooting the device. And as a last resort, back up your data and perform a factory reset. This will restore the device to its original factory settings, providing a clean slate for the OS update. Another common complaint is when mobile devices become slow to respond. This can often be due to too many background processes running at once. Responsiveness can be improved, and resources can be reclaimed by closing unnecessary apps or performing a reboot. Sometimes, the slowdown can be due to overheating or a low battery, as devices may throttle performance to conserve power or prevent damage from heat. Additionally, malware can impact the device's speed. This can be checked by performing a malware scan with a trusted security app. If none of these steps resolve the slowdown, a factory reset may provide a fresh start. If battery life is an issue, there are a few adjustments that can help. Closing background applications not only frees up processing power, but also conserves battery life. Reducing screen brightness and shortening screen timeout settings can also make a big difference in extending battery life. In cases where battery issues remain even after these changes, a replacement battery may be necessary, especially if the device is older. Sometimes devices experience random reboots, which can be alarming and are often tied to hardware issues. Overheating, low battery charge, or a faulty battery can cause sudden reboots. If you suspect overheating, remove any protective case to improve airflow and give the device time to cool down. If the battery is older and known to have issues, a replacement could solve the problem. In some cases, faulty hardware beyond the battery could be the cause. If all of these suggested fixes have yet to help, a factory reset could once again come to the rescue. When it comes to connectivity issues, each type of connection has its own quirks. Whether you're dealing with weak Wi-Fi signals, Bluetooth dropouts, or trouble completing an NFC payment, a few simple steps can often get things back on track. If you're noticing intermittent connectivity, start by checking for weak signals or signal interference. Moving closer to the router or signal source can help. Also, double-check your network configuration settings. If you have saved networks or custom settings, resetting them may improve stability. For Wi-Fi, the frequency band can also affect connection quality. Many routers and devices support two bands: 2.4 GHz and 5 GHz. The 2.4 GHz band offers a longer range, which is helpful for larger areas, but may be slower if there's interference. Meanwhile, 5 GHz provides faster speeds with a shorter range, making it ideal for smaller spaces. Switching bands based on your location can improve signal strength and stability. With Bluetooth, the quickest fix is often turning Bluetooth off and back on. If that doesn't work, try forgetting the device within the Bluetooth settings, then pair the device again. This resets the connection and often resolves lingering issues. For NFC, which is predominantly used for payment processing, start by ensuring your payment app is up to date, as updates often resolve bugs. Make sure the device is properly aligned with the payment terminal, as misalignment can interfere with transactions. Also, make sure NFC is enabled, as it is often disabled by default. Finally, if connectivity issues persist, double-check that airplane mode is off. When airplane mode is enabled, it disables all wireless connections, including Wi-Fi, Bluetooth, cellular data, and NFC, all at once. Another common feature-related issue is when the screen doesn't auto-rotate. Auto-rotation allows the screen to adjust its orientation as you turn the device from portrait to landscape. This function relies on built-in sensors like the accelerometer and gyroscope to detect the device's position. If the screen won't rotate, start by checking that auto-rotate is enabled, then consider a sensor recalibration. If the screen still won't rotate after calibration, a quick reboot can help refresh the sensors. In rare cases, if auto-rotation remains unresponsive, a factory reset might be necessary to restore full functionality. And there you have it. Troubleshooting mobile OS issues doesn't have to be a mystery. With these steps, you'll be prepared to handle common problems like application crashes, connectivity issues, and more. Remember, while each issue may have varied troubleshooting steps, a quick reboot can often work wonders. And if all else fails, a factory reset can give your mobile device a fresh start. Exam Objective 3.3 Given a scenario, troubleshoot common mobile OS and application security issues. In the last video segment, we focused on tackling common mobile OS problems. Now, let's dive into mobile security issues. Our mobile devices are powerful, handy, and unfortunately, prime targets for malware, spyware, and other nasty threats. From app spoofing to data leaks, the security risks are real. So let's explore these concerns, learn how to spot warning signs, and troubleshoot these issues like a pro. Let's begin by looking at some of the common security concerns that make mobile OS security a challenge. Understanding these risks is crucial for protecting both the device and its data, whether the device is being used personally or within a business environment. One major concern involves unofficial application stores. Most mobile devices are designed to download apps through official application marketplaces such as the Google Play Store or Apple App Store. These official stores typically perform security reviews, malware scanning, and verification checks before applications are made available to users. While these protections are not perfect, they significantly reduce the risk of downloading malicious software. However, some users choose to install applications from unofficial app stores or third-party websites instead. On Android devices especially, this often involves downloading APK files directly from the internet rather than through the Google Play Store. To briefly explain, APK stands for Android Package Kit. It is the file format Android uses to distribute and install applications. Under normal circumstances, the Play Store handles the installation process automatically behind the scenes while also performing security checks. But when applications are downloaded from unofficial stores or random websites, those built-in protections can be bypassed entirely. Users may turn to unofficial application stores to access apps that are region-restricted, modified, unavailable through official channels, or still in beta testing. Unfortunately, these unofficial sources can also distribute malicious applications disguised as legitimate software. Malware hidden inside these apps may steal personal information, monitor activity, install additional malicious software, or compromise the device entirely. Because of these risks, downloading applications from official app stores is generally considered the safest approach. While unofficial application stores may occasionally provide access to legitimate apps, they also significantly increase the chances of installing harmful or unverified software. If an app store looks like it was designed in 5 minutes and promises free premium everything, that should probably set off a few alarm bells. Next up, we have developer mode. Many mobile operating systems include a special setting known as developer mode, which is designed primarily for software developers and advanced users. Developer mode provides access to additional tools and settings used for debugging applications, testing software, monitoring system behavior, and connecting the device to development tools on a computer. While these features can be incredibly useful for app development and troubleshooting, enabling developer mode can also reduce some of the device's built-in security protections. Certain settings available within developer mode may allow apps to bypass restrictions, enable USB debugging connections, or permit the installation of software from unofficial sources. If misused, these features could create additional opportunities for attackers or malicious applications to compromise the device. For everyday users, developer mode is usually unnecessary and is best left disabled unless there is a specific reason to use it. It is a bit like unlocking a hidden control panel filled with advanced switches. Very useful if you know exactly what you are doing, but potentially risky if you start flipping random settings just to see what happens. Moving on, we have root access for Android and jailbreaking for Apple iOS. These are both modifications that allow users to access the device's root or core system files, effectively unlocking the device's full potential. Although it sounds exciting, this process bypasses critical security layers and makes the device more susceptible to malware and unauthorized access. In professional settings, this is a big no-no. For that reason, many companies rely on MDM, or mobile device management systems, to prevent employees from rooting or jailbreaking their devices, ensuring that these modifications don't pose a security threat to the company. Another risk is installing unauthorized or malicious applications. These are typically low-cost or free versions of popular apps offered by shady sources to avoid paying for the legitimate versions. Often, these apps are designed to mimic the look and feel of real apps but may come with hidden malware. Just note that unauthorized apps can harm devices by tracking user activity, stealing data, or allowing hackers to control the device remotely, so be careful. Closely related to unauthorized or malicious applications is application spoofing. This is when a malicious app imitates the name, look, or features of legitimate apps to trick users into downloading it. Common signs of application spoofing include slightly misspelled app names or a ton of fake, 5-star reviews that often sound too good to be true. Even if an app is on an approved store, it's wise to check the developer's name for legitimacy, especially if the app is unfamiliar. Security-conscious users know that some imposters can slip through App Store defenses, so a bit of caution goes a long way. Now that we've covered security concerns, let's move on to the warning signs and common symptoms of mobile OS security issues. These symptoms, or clues, can help you identify when something's off with a device, indicating that further investigation is needed. High on the list of warning signs is high network traffic. If your device suddenly starts using more data than usual, it may have a fraudulent app running in the background. This is a classic sign of a compromised device. Malware types like spyware, adware, or botnet software often stay hidden while consuming data to transmit information. To troubleshoot, check your device's data usage to identify any suspicious or unfamiliar apps consuming excessive data, and if found, uninstall them immediately. Next, running a security scan with antivirus software can help detect hidden threats. Additionally, restricting background data for non-essential apps can further secure your device against unauthorized data usage. Keeping in line with high network traffic, be on the lookout for data usage limit notifications, as these can indicate a potential security issue. If your device hits its data cap and suddenly can't access emails or the internet, though calls and texts still work, a compromised application may be using data in the background, or malware could be generating high data use to overload your device. To troubleshoot, start by reviewing your data usage. Check for apps with unusually high data consumption. You should also uninstall any suspicious apps, as they may be using data without permission. Next, update your OS and apps to close security gaps, and run a security scan with a trusted mobile antivirus. If issues persist, perform a factory reset to clear harmful apps. Just be sure to back up any important data first, as this will erase all personal files. Another common symptom to look out for is degraded or sluggish response times. If the device feels unusually slow, it could be a result of malware quietly using up system resources. Once malware becomes embedded on your device, it can consume memory, processing power, and even battery life, leading to a device that feels like it's constantly lagging or struggling to keep up. You might notice extended load times, delays when switching apps, or even difficulty handling basic tasks like opening messages or browsing the web. These signs can all indicate that malicious software is running in the background, draining resources, and potentially collecting sensitive information. To troubleshoot, begin by restarting the device, as this can temporarily halt malware processes and free up resources. Next, review running apps and processes in your settings. Suspicious or unfamiliar applications consuming significant memory or CPU might be to blame. Uninstall any unfamiliar or recently installed apps that seem suspicious, as malware often hides in seemingly legitimate programs. Updating the operating system and applications is another key step, as it closes security gaps that malware may exploit. Running a security scan with a trusted mobile antivirus can help detect and remove malicious software. If these steps don't resolve the issue, a factory reset may be necessary to restore the device to its original settings and eliminate the malware. Again, remember to back up your data first. If you are experiencing limited or no internet connectivity, this can indicate a security issue as well. Common causes of this issue include malware that has altered network settings, disabled essential system services, or is interfering with the firewall. In some cases, malware may cause excessive background data usage, blocking normal internet access. Additionally, DNS corruption or redirection attacks can also contribute to connectivity issues by rerouting URL requests to malicious sites. To troubleshoot, start by restarting both your device and router to refresh the connection. Review network settings, including DNS and proxy configurations, and reset them to default if you notice unfamiliar entries. Ensure your OS and apps are updated to close security gaps that malware could exploit. Run a security scan with a trusted antivirus to identify potential infections. Switching to a trusted DNS server may also help. As a last step, if connectivity problems continue, a factory reset may be required to remove embedded malware. Another telltale sign of malware is fake security warnings. These warnings usually come with aggressive pop-ups, urging users to download a security app or antivirus tool, which is in fact malware disguised as protection software. The scare tactics are designed to create a sense of urgency, prompting users to take immediate action without verifying the legitimacy of the warning. Once downloaded, this malicious software can cause even more harm, from data theft to further infection of the device. To troubleshoot, start by closing any suspicious pop-ups without clicking on them. Uninstall any recently added or unfamiliar apps, especially security apps you didn't intentionally install. Then run a security scan with a trusted antivirus app to detect and remove malicious software. As a last resort, perform a factory reset to remove any embedded malware. Unexpected application behavior is another major warning sign. If an app suddenly starts opening on its own, showing bizarre graphics, crashing all the time, or freezing for no reason, it might be more than just bug-ridden code, it could be malware. Sometimes, these oddities happen when malware is hiding in an app, or when the app itself is designed to worm its way into your device's controls. This type of malware may snoop around your data, monitor your activities, or even try to gain system-level access. If you haven't already noticed, the troubleshooting process for all these issues is pretty similar with just a few tweaks. You might even be able to guess what's coming next, but just to be thorough, here's the troubleshooting breakdown once again. To troubleshoot your possessed app, start by closing it if it's currently open and acting strangely. Uninstall any unfamiliar or recently installed apps that you didn't intentionally add, as they could be causing the issue. After removing any suspicious apps, restart your device to ensure no residual processes are running. Run a security scan with a trusted antivirus to check for any embedded malware. Also, make sure your OS and all apps are updated. And if these attempts at an app exorcism don't do the trick, consider a factory reset to remove deeply embedded malware. Lastly, one of the most alarming signs of malware is when personal files or data is leaked or shared without your permission. If you notice that photos, contacts, messages, or other sensitive information has been accessed or shared without your authorization, it could indicate a serious data breach. This can occur if malware is actively harvesting data from your device or if compromised credentials have allowed someone unauthorized access to your accounts. In either case, it's a clear warning that your security has been breached and immediate action is required. To troubleshoot and secure your data, start by changing passwords on affected accounts, replacing them with strong, complex, unique passwords. Enabling multi-factor authentication, MFA, wherever possible, adds an extra layer of protection by requiring an additional verification step, even if a password is compromised. Next, review account activity to check for unauthorized logins or suspicious actions, such as login attempts from unfamiliar locations or devices. If you find any, log out of all active sessions immediately. Run a security scan on your device using a trusted antivirus or anti-malware app to detect and remove any malicious software that might be collecting or sharing your data. Additionally, revoke app permissions for any apps that don't need access to your personal files, particularly photos, contacts, and messages. And finally, ensure that OS and app updates are installed to protect against vulnerabilities that malware might exploit. The symptoms we've discussed are just a few you may encounter, but new vulnerabilities are always emerging. Therefore, the best approach is to stay alert, keep your security tools up to date, and never underestimate the creativity of malicious actors. With a proactive approach, you can keep your mobile devices secure and respond quickly to any new threats that come your way. Exam Objective 3.4, given a scenario, troubleshoot common PC security issues. Welcome to our last stop in Domain 3, Software Troubleshooting. In this video segment, we will dive into PC security issues. Like before, we'll go through the most common symptoms, explore likely causes, and walk through troubleshooting steps to help secure your system. First up, let's discuss network access issues. If a user can't connect to a network, start by checking the network cable connection. Sometimes the smallest issues, like a loose or disconnected cable, can be the culprit. If the physical connection is fine, take a look at firewall settings, as they may be blocking access due to security rules. Also, check IP configurations and network drivers. These components play key roles in maintaining secure network access, and a simple misconfiguration can often disrupt connectivity. Next, let's talk about OS update failures. An unpatched system isn't just inconvenient, it's a security risk. Failed updates can happen due to network issues, corrupted update files, or even malware interference. If you experience this type of failure, start by clearing the update cache to remove any corrupted files, and ensure the network connection is stable. Additionally, since some malware is designed to block updates intentionally to keep your system vulnerable, run a malware scan to ensure nothing is interfering with your ability to perform updates. Now onto a bigger red flag: altered files. If users report files that are missing, renamed, changed, encrypted, or suddenly inaccessible, it is often a sign of malware activity, such as ransomware or a virus. Ransomware is particularly severe because it encrypts files and prevents users from accessing them unless a ransom is paid. In many cases, users may still see the files listed on the device but receive error messages or access denied prompts when attempting to open them. Meanwhile, viruses can also corrupt, delete, modify, or damage files entirely, leading to data loss or application instability. Both types of malware have serious implications for data security and system integrity. Start by running a comprehensive malware scan using reliable antivirus or anti-malware software to identify and contain the threat. If ransomware is detected, avoid engaging with ransom demands, since paying does not guarantee file recovery and only encourages further attacks. For missing, inaccessible, or encrypted files, restoring from secure backups is often the safest recovery option. Situations like this serve as a powerful reminder of why maintaining regular backups is so important. Because when malware decides to hold your files hostage, a good backup can quickly turn a disaster into an inconvenience instead. Now that we've covered altered files, let's shift to alerts and notifications. Alerts can come in many forms, and while some serve a legitimate security purpose, others are either annoyances or outright threats. To troubleshoot effectively, it's essential to understand the differences between desktop alerts, unwanted notifications, false antivirus alerts, and random browser pop-ups. Each type of alert has unique characteristics, and knowing how to respond to each can help you better protect your system. Let's break down each type so you'll know exactly what you're dealing with when one of these threats comes knocking. First, let's talk about desktop alerts. These usually take the form of user account control, or UAC alerts, which are security prompts that ask for confirmation when you make a system change or install software. UAC acts as a gatekeeper, double-checking that you're aware of changes that might affect system settings or security. If you're installing a new program or adjusting settings, a UAC alert is doing exactly what it's supposed to, keeping your system safe by ensuring you authorize any major changes. One key point to watch out for with regards to UAC prompts is unknown publishers. When a UAC alert appears for software from an unfamiliar or unverified publisher, take a moment to double-check before granting permission. Unknown publishers can sometimes be a red flag for malware or unwanted software, so it's always wise to research the program or source if you're unsure. In these cases, when in doubt, it's safer to cancel the installation and verify the program's legitimacy first. Next, we have unwanted notifications within the OS, which usually take the form of push notifications. These come from applications, websites, or even adware. Think of them as digital junk mail, with alerts ranging from offers and updates to warnings designed to make you click. Some are legitimate, but many are generated by adware or malicious software. To tackle these, run a full antivirus scan and consider using anti-adware tools to remove unwanted programs cluttering your notifications. Now we will move into some more risky territory and address fake antivirus alerts. These are scams designed to trick users into thinking their system is infected. They'll often display alarming messages urging immediate action, which often leads to malware being installed, disguised as a legitimate security tool. If you see these kinds of alerts, run a full antivirus scan immediately to identify and remove any rogue programs. It is also beneficial to educate other users on these scams so they can recognize and avoid them too. In addition to OS-related symptoms, we also have browser-related symptoms. These can present in many different ways, such as browser pop-ups. If browser pop-ups are appearing randomly and frequently, adware or a browser hijacker is likely at play. Run a full antivirus scan to identify and remove any malicious extensions or unwanted programs causing these disruptions. And remember, avoid clicking on unfamiliar links or pop-ups, as these can direct you to harmful sites or install additional unwanted software. Another browser-related security issue involves certificate warnings, a critical security feature in your browser. These warnings often appear due to expired certificates, misconfigured websites, or even an out-of-sync system clock. If you encounter a certificate warning, the safest course of action is to navigate away from the site immediately and exit the browser to clear the session. Also, don't forget to check the system's date and time settings, as incorrect settings can trigger false certificate warnings. While certificate warnings focus on trust and website identity, browser performance issues can sometimes point to security problems as well. If the browser suddenly becomes unusually slow, freezes frequently, crashes, opens excessive tabs or pop-ups, or takes far longer than normal to load websites, malware or unwanted browser extensions could be the cause. In some cases, adware, spyware, or malicious plugins may be quietly running in the background, consuming system resources and interfering with normal browser operation. To troubleshoot degraded browser performance, start by closing unnecessary tabs and restarting the browser. Next, clear the browser cache and browsing data to remove temporary files that may be slowing things down. It is also a good idea to review installed plugins and extensions, disabling or removing anything suspicious or unnecessary. Running a malware scan can help identify hidden threats that may be impacting browser performance. And of course, making sure the browser itself is fully updated is also important, since outdated browsers can suffer from both performance and security issues. If your browser suddenly sounds like it is preparing for takeoff every time you open a web page, it may be time for a little troubleshooting. One last browser-related symptom to look out for is redirection, which occurs when your browser unexpectedly takes you to an unintended URL. This is often caused by malware or unauthorized alterations to the host's file. To address this issue, start by verifying the URL in the browser's address bar is correct. Then, follow this action up by checking the host's file for unauthorized entries. If you are not familiar with the host's file, don't worry, I will cover that next. The host's file is essentially a local directory for your computer that functions as a simple plain text file, mapping domain names to IP addresses. Before reaching out to a DNS server, your computer checks the host's file to see if there's already a known IP address for a specific website. Typically, the host's file is used in network administration to manage local network resources, but it can also become a target for attackers. By modifying the host's file, malicious actors can map, and therefore redirect, legitimate website URLs to harmful IP addresses, leading unsuspecting users to phishing sites, malware downloads, or other threats. To safeguard against unauthorized changes, it is a good idea to regularly review the host's file, restrict its permissions, and ensure users understand its role in network security. As we wrap up Domain 3, remember that PC security issues are critical topics for both the exam and real-world troubleshooting. Spotting symptoms and understanding the root cause of an issue can save a system from major damage and keep personal data secure. And with that, congratulations on completing Domain 3. Stay sharp, and be sure to keep these skills handy as you move forward in your CompTIA A Plus, Core 2, learning journey. Exam Objective 4.1, given a scenario, implement best practices associated with documentation and support systems information management. Ticketing systems. In this video segment, we're stepping into the world of documentation and support systems for information management, an essential aspect of any IT role. This segment is also kicking off Domain 4, Operational Procedures. To start, let's explore the concept of a ticketing system. Imagine you're running an IT help desk. Issues come at you from all directions: my printer's not working, my computer's freezing, how do I reset my password? This constant stream of requests can be overwhelming. A ticketing system helps manage and organize these service requests, ensuring nothing falls through the cracks. Each ticket represents an individual issue, creating a clear record that allows you and your team to track, manage, and resolve issues efficiently. With a ticketing system, every ticket has a unique ticket identifier. This identifier, which is quite often a numerical value, eliminates confusion when issues are similar or involve multiple departments. Alongside the ticket ID, user information, like the name and contact details, and device information, such as the specific PC or printer in question, provide context, enabling technicians to zero in on the affected user and device quickly. This is then followed by ticket details, which hold critical information on the individual issue. These ticket details include severity or priority levels, indicating the urgency of the issue. For instance, a printing problem may be low priority, but if the CEO's laptop won't boot before a big meeting, that's a high-severity issue. Tickets also have categories to help teams quickly identify the type of problem, whether it's a software issue, hardware failure, or network issue. If the problem is complex, the ticket might need to be escalated. Most IT help desks will have escalation levels for this, where issues are routed to more experienced technicians or even other departments when needed. Having this type of escalation in place ensures that no one wastes hours on a problem they're unequipped to handle. Communication is also a key component to a functional ticketing system. Each ticket will include text fields for an issue description, progress notes, and an issue resolution, as well as the ability to attach files for additional documentation. The issue description should be clear and concise, detailing the symptoms of the issue. As for progress notes, these are like breadcrumbs, recording every action taken. These notes are crucial when handing off an issue or escalating it, as they let the next technician pick up right where the previous one left off. Then there is the issue resolution section, which explains how the issue was resolved, providing closure and a valuable reference if the same issue pops up again. Finally, we reach the topic of knowledge bases, the true IT treasure trove. A knowledge base is a self-serve library of information, packed with articles that answer common questions or provide detailed solutions to previously encountered issues. IT teams often build these knowledge bases from tickets they've already resolved, manufacturer documentation, or just solid research. With a knowledge base, both techs and end users can find answers to known problems, saving time and frustration. Exam Objective 4.1 Given a scenario, implement best practices associated with documentation and support systems information management. Asset management. Let's jump into asset management with a quick overview of what it is and why it matters. In IT, asset management is all about tracking and managing every piece of technology in the organization, keeping an eye on devices, software licenses, warranties, and even who's using what. Why does this matter? Well, when you know exactly what assets are on hand and how they're used, it's easier to prevent unnecessary spending, troubleshoot issues, and even boost security. In other words, asset management isn't just keeping a list, it's about having an organized system that empowers you to respond quickly and strategically to any situation. At the heart of asset management, there is usually a configuration management database, commonly abbreviated as a CMDB. A CMDB is a centralized database used to store and organize information about an organization's IT assets and their relationships to one another. Think of it as the brain of the IT environment. The CMDB contains information such as asset details, warranty status, software licenses, assigned users, network information, and much more. Whether an administrator needs to check who is assigned a specific laptop, verify software licensing compliance, or track the warranty status of a server, the CMDB provides a centralized location for quick and organized access to that information. Now that we know the value of a central database system, let's talk about what populates it. The most obvious being an inventory list of assets. This list is like a catalog for every piece of IT equipment, from desktops and laptops to network gear and software licenses. This list should be constantly updated to reflect the real-time status of each asset, whether it's newly purchased, reassigned, or ready for retirement. With a detailed inventory list, you can quickly access the specifics of any device, making it easier to budget, plan upgrades, or troubleshoot issues. The inventory list is the foundation of every effective asset management system, giving IT teams a reliable snapshot of the tools at their disposal. Next, imagine walking into a storeroom filled with identical laptops. How do you know which one belongs where? Asset tags and IDs solve this puzzle. Each device gets a unique identifier, often as a barcode, QR code, or RFID tag, linked to its profile in the database. This means a quick scan reveals everything about the device, its model, who's using it, purchase date, and maintenance history. Tags and IDs make locating and identifying devices fast and foolproof, ensuring every asset is always accounted for. Proper asset management should also account for a device's lifespan. The procurement lifecycle is all about understanding when a piece of equipment was purchased, how long it's expected to last, and when it should be replaced. By tracking this lifecycle, you can budget, plan, and make effective decisions. Therefore, the procurement lifecycle allows you to stay proactive when upgrading, maintaining, and replacing tech assets. Zeroing in on the purchase portion of the procurement lifecycle, we come to warranties and licensing. A warranty is essentially a promise from the manufacturer to repair or replace a product if it encounters specific issues within a set period. This protection can be a lifesaver, as it keeps repair costs low and ensures that devices are kept in optimal condition without extra expenses. Imagine needing a repair only to discover the device is still under warranty. That's a win. By tracking warranties, you avoid unnecessary expenses and ensure every device is serviced cost-effectively. Licensing is just as essential, as it keeps software usage above board. Licenses specify the legal terms for using software, defining how and where it can be used. Tracking licenses ensures software compliance and prevents penalties from unauthorized or expired usage. Keeping track of both warranties and licenses lets you focus on problem solving instead of red tape. Finally, we have assigned users. This step matches every device that is in use to a designated user responsible for it, creating accountability and aiding in security. By having assigned users, if a device is misplaced, you know who to check with. Assigning users to devices also helps you manage access, prevent unauthorized use, and ensure that each asset is used as intended. Exam Objective 4.1, given a scenario, implement best practices associated with documentation and support systems information management. Types of documents. In IT, documentation is just as important as the technology itself. Without proper documentation, troubleshooting becomes harder, onboarding turns chaotic, and critical procedures can quickly become inconsistent. Good documentation keeps teams organized, improves communication, strengthens security, and ensures that important processes are performed correctly every time. In this video segment, we will explore several common types of documents that organizations rely on every day to keep operations running smoothly. Let's begin with incident reports. An incident report is a document used to record details about unexpected events that impact systems, security, or operations. These reports help organizations track problems, investigate what happened, and prevent similar incidents from happening again in the future. An incident report typically includes information such as the date and time of the incident, affected systems, description of the incident, actions taken, and the final resolution. For example, if ransomware infected several workstations, the incident report would document how the infection was discovered, what systems were impacted, how the threat was contained, and what corrective actions were performed afterward. Next up, we have standard operating procedures, commonly abbreviated as SOPs. SOPs are a set of step-by-step instructions for performing a routine activity. These procedures help ensure that IT staff members follow the same process each time a task is completed, reducing errors and improving efficiency. One common example of an SOP would be a software package custom installation procedure. In many organizations, software installations are not always simple processes. Certain applications may require custom settings, security configurations, license activation steps, mapped network drives, or additional dependencies. A custom installation SOP documents each step required to properly install and configure the software so every technician performs the installation the same way. This improves consistency while reducing configuration mistakes and troubleshooting headaches later on. Now let's move into onboarding documentation. When a new employee joins an organization, there are usually many tasks that need to be completed before they can begin working effectively. Having an onboarding checklist helps ensure nothing gets overlooked during the setup process. This checklist may include creating user accounts, assigning permissions, configuring email access, setting up multi-factor authentication, issuing devices, installing required software, and providing access to shared resources. By following a standardized onboarding checklist, organizations can improve security, maintain consistency, and help new employees get up and running much faster. After all, showing up on day one without access to anything is usually not the best first impression. On the opposite side of onboarding is offboarding. When employees leave an organization, it is critical to remove access to systems and company resources quickly and properly. Having an offboarding checklist helps ensure this process is completed consistently and securely. Common offboarding tasks include disabling user accounts, revoking VPN access, collecting company devices, removing access to shared resources, resetting passwords for shared accounts, and recovering software licenses. Proper offboarding reduces the risk of unauthorized access after an employee departs and helps protect sensitive company data from lingering accounts that were forgotten during the transition. Last up, we have service level agreements, often abbreviated as SLAs. An SLA is a formal agreement that defines the level of service expected between parties. These agreements help establish expectations for response times, system availability, support responsibilities, and performance standards. Internal SLAs are agreements between departments within the same organization. For example, an internal SLA may state that the IT department must respond to help desk tickets within 4 hours or restore critical systems within a specific timeframe. These agreements help ensure departments understand service expectations and accountability. External or third-party SLAs involve agreements between an organization and outside vendors or service providers. For example, a cloud provider may guarantee 99.9% uptime for hosted services, or a hardware vendor may promise replacement parts within 1 business day. These agreements become especially important when organizations rely heavily on external providers to support critical business operations. Exam Objective 4.2. Given a scenario, apply change management procedures. Change management is a structured process used to plan, review, approve, implement, and document changes within an organization's IT environment. In the world of IT, change is unavoidable. Systems get upgraded, software gets patched, hardware gets replaced, and security vulnerabilities constantly need attention. Without a proper change management process in place, even a simple modification can accidentally create downtime, security issues, or widespread disruption. In other words, one poorly planned quick fix can quickly become everyone's weekend problem. At the center of the change management process is the change request form. This document acts as the blueprint for the proposed change and helps ensure that every important detail is reviewed before implementation begins. A properly completed change request form improves communication, reduces misunderstandings, and helps organizations manage risk more effectively. One of the first sections included in a change request form is the purpose of the change. This explains why the change is being proposed in the first place. The purpose may involve fixing a problem, improving security, increasing performance, supporting business growth, or meeting compliance requirements. Clearly defining the purpose helps stakeholders understand the value and necessity of the change before approving it. Closely tied to the purpose is the scope of the change, which defines exactly what systems, applications, devices, or processes will be affected. Scope is important because it establishes the boundaries of the change and prevents confusion later in the process. A clearly defined scope helps avoid scope creep, where additional tasks slowly get added until a small change somehow turns into a full-blown infrastructure overhaul. Another topic emphasized in the current version of the A Plus Core 2 exam objectives is change type. Not every change carries the same level of urgency or risk, so organizations often categorize changes into different types. A standard change is a routine, low-risk change that follows a well-established process. These changes are commonly repeated and usually pre-approved because the risks are already understood. Installing approved software updates on workstations each month would be one example. A normal change is a non-routine change that requires formal review and approval before implementation. These changes may involve higher risk, greater complexity, or broader impact on systems and users. An emergency change is a change that must be implemented immediately to address a critical issue, such as a major outage or serious security vulnerability. Emergency changes often move through the approval process more quickly, due to the urgency of the situation. Once the purpose, scope, and change type are defined, organizations perform a risk analysis. Risk analysis involves identifying potential problems the change could create, and evaluating how severe those risks may be. This may include concerns such as service outages, compatibility issues, security vulnerabilities, or business disruptions. Organizations often assign a risk level such as low, medium, or high, to help determine how carefully the change should be reviewed and tested. The higher the risk level, the more planning, testing, and oversight are usually required before implementation moves forward. Even with careful planning, things do not always go according to plan. That is why organizations create a rollback plan. A rollback plan outlines the exact steps required to reverse the change and restore systems to their previous state if problems occur. Think of it like an emergency exit route. Hopefully you never need it, but you definitely want it available before things catch fire. Alongside the rollback plan is the backup plan, which serves a different purpose. While the rollback plan focuses on undoing the change itself, the backup plan ensures that critical data, system configurations, or virtual machines can be restored if data becomes corrupted, lost, or damaged during implementation. Backups provide an additional layer of protection and are especially important before major upgrades or infrastructure changes. Another important step is identifying the responsible staff members involved in a proposed change process. Everyone should know their role before implementation begins. Some team members may handle backups, others may perform the implementation itself, while another group may monitor systems afterward for issues. Clearly assigning responsibilities helps reduce confusion and improves accountability during the change process. Once all planning and documentation is complete, the change request moves to the Change Advisory Board, commonly referred to as the CAB. The CAB is a group of stakeholders, managers, and technical experts responsible for reviewing proposed changes. Their job is to evaluate risks, ensure the change aligns with business goals, and decide whether the change should be approved, denied, or modified before moving forward. Once the change request has been reviewed and approved by the Change Advisory Board, the process can move into sandbox testing. A sandbox is a controlled, isolated testing environment designed to safely evaluate changes before they are introduced into the live production environment. Think of it as a practice field where IT teams can test changes without risking damage to real systems, users, or business operations. Sandbox testing allows administrators to identify unexpected problems, compatibility issues, or performance concerns before implementation begins. Teams may run simulations, stress tests, or functionality checks to confirm the change behaves as expected under realistic conditions. Because the sandbox environment is separated from production systems, any mistakes or failures remain contained, preventing disruptions to live services. This testing phase gives organizations an opportunity to catch issues early, reduce risk, and build confidence before moving forward with implementation. Once testing is successfully completed, the change moves into the implementation phase. This is where the approved modifications are finally applied to the live production environment. During implementation, teams follow the documented procedures carefully while monitoring systems for unexpected behavior or failures. Timing also plays a major role in successful implementations. Most organizations schedule changes during maintenance windows, which are predetermined periods where downtime or service interruptions are considered acceptable. These windows are often scheduled during evenings, weekends, or other low-usage periods to minimize disruption to users and business operations. On the flip side, organizations may also establish change freezes. A change freeze is a designated period where non-essential changes are temporarily prohibited. Businesses commonly implement change freezes during major holidays, end-of-quarter financial processing, or other critical business periods where stability is especially important. Nobody wants a surprise outage during Black Friday because someone decided it was the perfect time to quickly update the server. After implementation, organizations often perform a peer review. During peer review, another technician or administrator reviews the completed change, implementation steps, configurations, commands, or documentation to ensure everything was performed correctly. A second set of eyes can help identify mistakes, overlooked issues, or security concerns that may have been missed during implementation. Peer review improves accuracy, strengthens accountability, and helps reduce the likelihood of hidden problems remaining in the environment. Once the peer review is complete, the process shifts toward end-user acceptance. This phase focuses on verifying that the change works properly in the live environment and meets the needs of the users affected by it. End users may test applications, confirm workflows still function correctly, or provide feedback about performance and usability. If issues are discovered, adjustments can be made before the change is considered fully complete. Finally, it never hurts to conclude your change process by documenting lessons learned. This step involves reflecting on what worked well, identifying what didn't go as planned, and determining how similar changes can be improved in the future. These insights are invaluable for strengthening future projects, enhancing processes, and reducing the likelihood of repeating a mistake. Exam Objective 4.3 Given a scenario, implement workstation backup and recovery methods. Imagine the nightmare of losing all your critical data in the blink of an eye. From cherished photos to vital business files, the mere thought of it can make anyone feel uneasy. That is where backups come in and provide you a little digital insurance. But not all backups work the same way, and choosing the right one depends on your needs. Let's break down the 4 main types of backups, which are full, differential, incremental, and synthetic, in a way that's simple to understand. A full backup is exactly what it sounds like. It creates a complete copy of everything on your system. Imagine it as taking a snapshot of your entire digital world, including files, applications, and settings. This snapshot becomes the foundation for all other backups. Here's why it's important. If something goes wrong and you need to restore your data, a full backup has everything in one place, ready to go. You don't need to search for pieces or combine data from different backups. It's fast and simple when it comes to recovery. However, creating a full backup takes time and requires a lot of storage space because you're copying everything. For this reason, full backups are usually done less frequently, and are often paired with other, more efficient backup types to save time and storage space. After you've created a full backup, you have the option to let differential backups take over in order to save time and storage space. Unlike a full backup, which copies everything, a differential backup only records the changes made since the last full backup. If you've added new files or updated existing ones, the differential backup captures those changes. The first difference you will encounter is when you go to restore your data. If you have elected to use differential backups, you will now need 2 things: the last full backup and the most recent differential backup. While this process is straightforward, it's not as simple as restoring from a full backup alone. Remember, a full backup contains everything in one place, making restoration a single-step process. With a differential backup, you must retrieve and combine data from 2 sources, adding a bit of complexity to the recovery process. The trade-off for this added recovery step is efficiency during backup creation. Differential backups avoid copying unchanged data, focusing only on new or modified files. However, as time passes, differential backups can grow larger because they continuously accumulate all changes since the last full backup. For example, a differential backup made 5 days after a full backup includes changes from days 1 through 5, making it larger than a differential backup taken after a single day. For these reasons, differential backups are an excellent choice when frequent full backups aren't practical, but simplicity in recovery remains important. While not as fast to restore as a full backup, they strike a balance between storage efficiency and ease of recovery, offering a middle ground between full backups and our next type, incremental backups. If differential backups are known for striking a balance, incremental backups push efficiency even further. Like the differential backup type, incremental backups start with a full backup. However, instead of tracking all changes since the last full backup, incremental backups only record the changes made since the last backup of any type, whether it was full, differential, or incremental. Imagine a daily backup routine. On Sunday, you perform a full backup. On Monday, an incremental backup saves only the changes made since Sunday. On Tuesday, it saves only the changes made since Monday, and so on. Each incremental backup is smaller and quicker to create because it only captures the most recent changes, making it highly efficient in terms of storage and time. The downside? Restoring from incremental backups is more complex. To recover your data, you'll need the full backup as well as every incremental backup made since. Think of it like assembling a puzzle, where every piece must fit together perfectly to recreate your data. This complexity makes incremental backups better suited for systems where changes occur frequently. Storage efficiency is critical, and recovery speed is less of a priority. Incremental backups shine when you want to minimize backup time and storage usage, but their trade-offs in recovery complexity mean they require careful management to ensure all pieces are accounted for when restoring your data. If incremental backups are all about maximizing efficiency, synthetic backups take things a step further by combining the best of full and incremental methods. Synthetic backups start with a full backup, just like any other method. However, instead of relying solely on incremental backups for changes, synthetic backups merge the data from incremental backups into a single, fully restorable backup file. Think of it this way: rather than manually piecing together all the changes from incremental backups during recovery, the synthetic backup does that work for you ahead of time. It essentially creates a new, up-to-date full backup without the need to recopy all your data. This process happens automatically during the backup routine, reducing the strain on your network and saving you from a tedious recovery process. The major advantage of synthetic backups is how they simplify recovery. Like a full backup, everything you need is in one place, making the restore process fast and straightforward. However, because synthetic backups use incremental backups to build new full backups, they significantly reduce the time and resources needed to create them compared to starting from scratch. Synthetic backups are particularly useful in environments where minimizing network impact is important, such as businesses with large amounts of data or limited bandwidth. However, they require more advanced backup software and careful configuration, making them more common in enterprise environments. Now, creating backups is only half the battle. At some point, those backups may actually need to be restored. This is where recovery methods come into play. One recovery option is an in-place recovery, sometimes referred to as an overwrite recovery. In this approach, the backup data is restored directly over the existing files or operating system on the original device. This allows the system to return to a previous working state without changing locations or hardware. While convenient, administrators must be careful because the existing data on the system may be overwritten during the process. Another recovery method involves restoring data to an alternative location. Instead of restoring directly back to the original system, the backup is restored somewhere else, such as another drive, server, virtual machine, or workstation. This approach is especially useful when the original system has failed completely, when administrators want to test the recovery process safely, or when investigators need to preserve the original system for forensic analysis. Sometimes it is also just nice to recover your files somewhere safe before trusting the problem device again. Of course, no matter which recovery method you choose, there is one very important question you should always ask yourself. Will the backup actually work when you need it? That is where backup testing comes into play. Think of backup testing as giving your safety net a practice run before you rely on it during a real fall. Backup testing is the process of verifying that your backups are complete, accessible, and restorable. Without regular testing, you could be left with a false sense of security. Imagine going to restore your data only to discover that a critical backup was corrupted, incomplete, or improperly configured. What a nightmare that would be. So, how often should you test your backups? The frequency of backup testing depends on how often your data changes and how critical it is to your operations. For personal data or small-scale backups, testing once a month might suffice. In professional environments, especially where data is critical, testing should happen more frequently. The goal is to ensure that your backup process is functioning correctly and your recovery plan can be executed smoothly. Once you've decided how to back up your data, the next question is where to store it. On-site backups, stored locally, offer speed and convenience. Restoring from a local source is typically faster, and you have direct oversight of the backup process and data. However, on-site backups are vulnerable to physical damage from unforeseen disasters like fires or floods and can also be targets for theft. Additionally, the limited capacity of physical storage devices can pose challenges as data grows. Off-site backups, such as cloud storage, address many of these vulnerabilities. Cloud backups provide accessibility from virtually anywhere with an internet connection, scalability to meet your changing storage needs, and protection against localized disasters. However, they come with their own challenges. A stable internet connection is essential, and there are ongoing subscription costs to consider. While cloud providers prioritize security, no system is entirely immune to breaches, making it critical to choose a trusted provider. For the best protection, many organizations use a hybrid approach, combining on-site backups for quick recovery and off-site backups to safeguard against catastrophic events. This strategy ensures data is both accessible and secure, no matter what challenges arise. After deciding where to store your backups, the next step is organizing those backups in a way that balances accessibility, redundancy, and storage management. This is where GFS, or the grandfather, father, son backup rotation comes into play. GFS is a structured backup rotation scheme that organizes backups into 3 levels, labeled grandfather, father, and son. It works in tandem with full, differential, and incremental backups, providing a framework for when backups are created, and for how long they are retained. In this hierarchy, son backups are created most frequently and capture changes from the most recent activity. These backups are replaced regularly to keep storage requirements manageable. Father backups are created less frequently and provide a broader snapshot of your data, retaining changes over a longer period. Finally, grandfather backups are created the least frequently and preserved for the longest duration, acting as an archive of your data over time. GFS ensures that you always have multiple recovery points at different intervals. If you need to recover something recent, a son backup will typically have the necessary data. For changes or files that are further in the past, a father or grandfather backup can step in. This tiered system reduces the risk of data loss, as older backups can serve as a fallback if a newer one is unavailable or corrupted. One of the main advantages of GFS is its ability to optimize storage space while maintaining sufficient redundancy. Instead of keeping every backup indefinitely, GFS prioritizes the most recent backups for quick access and retains higher-level backups less frequently for long-term protection. This makes it a versatile strategy suitable for both on-site and off-site storage solutions, offering a reliable safety net for your data no matter where it resides. To wrap things up, I will talk briefly about the 3-2-1 backup rule, which provides a simple yet highly effective guideline for structuring your overall backup strategy. This rule ensures your data remains secure by emphasizing redundancy, diversity, and geographic separation. According to the 3-2-1 rule, you should always have 3 copies of your data, the original and 2 backups. At least 2 of these copies should be stored on different types of media, such as an external hard drive and cloud storage, to reduce the risk of simultaneous failure. Additionally, one of these backups should be stored off-site, ensuring your data is safe from local disasters like fires, floods, or theft. The beauty of the 3-2-1 rule lies in its adaptability. For example, you could keep 1 copy on your computer, another on an external hard drive stored locally, and a third in the cloud. This approach helps protect your data from hardware failures, natural disasters, and even ransomware attacks, providing a comprehensive safety net that's both practical and effective. Now that you have learned about backup types, backup testing, backup locations, GFS, and the 3-2-1 rule, I want you to know this. It's not about picking just one method, it's about layering them together to create a fortress of redundancy and recovery options. That way you never have to experience the nightmare of losing critical data. Exam Objective 4.4, given a scenario, use common safety procedures. Safety procedures play a significant role in the IT industry, just as they do in any other industry. Therefore, we will take a look at some common safety-related issues specific to IT, starting with electrostatic discharge. Electrostatic discharge, or ESD, is the invisible villain of IT work. It is the sudden flow of static electricity between 2 objects with different charges. It happens when static electricity builds up on a surface and then discharges, often damaging sensitive electronic components. To combat ESD effectively, ESD wrist straps are an essential tool. These specialized wristbands are designed to connect you directly to a grounded surface, such as the metal frame of a PC case or a designated grounding point. This connection ensures that any static electricity building up on your body is safely discharged, preventing you from damaging sensitive electronic components when handled. Complementing these wrist straps are ESD mats, which create a static-neutral workspace. These mats are designed to dissipate static from anything placed on them, providing an added layer of protection against accidental discharges. Together, ESD wrist straps and mats form a robust defense against ESD. However, none of this works without proper equipment grounding, a critical step that ensures your devices and workspace are electrically safe and ready for work before you even touch them. Once the risk of static electricity has been addressed, the next crucial step is proper power handling to ensure safety. Before working on any device, always make sure it is completely disconnected from its power source. This means unplugging the device from the wall outlet or power strip, and, if you're dealing with a laptop, removing the battery if it is detachable. Taking these precautions eliminates the risk of electrical shock and accidental damage to the device. Remember, a device that is fully powered down and disconnected is the only truly safe device to handle during repairs or upgrades. When handling sensitive components, treat them with the utmost care. Components, such as RAM modules or motherboards, are not only delicate but also highly susceptible to damage from mishandling. Always store unused components in anti-static bags, which are specifically designed to shield them from the dangers of electrostatic discharge. Proper storage ensures their integrity until they're ready for use. When it's time to handle these parts, always hold them by their edges, avoiding contact with the circuitry or connectors. This technique minimizes the risk of physical damage and prevents oils or residue from your hands from contaminating the sensitive surfaces. Even trace amounts of natural oils can corrode metal contacts over time, leading to connectivity issues or performance degradation. By following these precautions, you ensure that every component remains in peak condition, ready for smooth installation or testing. Beyond protecting components, staying compliant with government regulations keeps your work professional and above board. Regulations may include health and safety laws, building codes, and environmental regulations that govern the proper disposal methods for electronic waste. Electronic waste, or e-waste, refers to discarded electronic devices and components such as old computers, monitors, hard drives, or batteries. Improper disposal of e-waste poses significant environmental risks, as these items often contain hazardous materials. To stay compliant, IT professionals must follow established guidelines for recycling and disposing of e-waste responsibly. Personal safety should also be a top priority when working with computers and other electronic devices. Once again, start by disconnecting the power before repairing a PC to reduce the risk of electric shock. Additionally, if the device is heavy, use proper lifting techniques to protect yourself, bend your knees, keep your back straight, and lift with your legs, not your back. For extremely heavy items, such as servers, don't hesitate to ask for assistance to avoid unnecessary strain or injury. Electrical fire safety is another critical aspect. Water should never be used to extinguish an electrical fire, as it can worsen the situation. Instead, always have a Class C fire extinguisher nearby, specifically designed for electrical fires, and ensure it is in good working condition. Finally, for tasks like soldering or working in dusty environments, personal protective equipment is key. Safety goggles are essential for shielding your eyes from flying debris, while an air filtration mask prevents the inhalation of harmful particles. Taking these precautions ensures that you stay safe and healthy while maintaining a professional and secure workspace. Exam Objective 4.5 Summarize environmental impacts and local environment controls. With this video segment, we're diving into a topic that doesn't just make you a better IT professional, it makes you a more eco-conscious one too. Managing IT equipment isn't only about keeping things running, it's about making smarter choices that reduce environmental impacts and ensure the longevity of your gear. From properly disposing of outdated devices, to controlling the environment where your equipment operates, and guarding against power issues, These practices are vital for responsible IT management. So let's start with the basics: how we handle and dispose of the tools and materials that power our technology. Many items, like batteries and toner cartridges, or older equipment, like CRT monitors, can't just be tossed into the trash, they require special disposal methods. That's where material safety data sheets come in. Think of a material safety data sheet as the ultimate cheat sheet for handling potentially hazardous materials. A material safety data sheet, or MSDS for short, is a detailed document that provides essential information about the properties of a material, its potential hazards, safe handling and storage requirements, as well as disposal practices. It even includes guidance on dealing with fire risks, explosion dangers, and first aid measures. Whether you're figuring out how to recycle a laptop battery or dispose of an old CRT monitor, a material safety data sheet ensures you're doing it safely and responsibly. Now, let's look at a few real-world examples. Batteries, especially those utilizing lithium-ion technology, can be a ticking time bomb if handled improperly. They can leak toxic chemicals or even catch fire when thrown in the trash. That's why they should always be recycled at certified facilities equipped to handle hazardous waste. Toner cartridges might seem harmless, but they're e-waste too. Many manufacturers offer recycling programs that make it easy to return and process them safely. And don't forget those old CRT monitors gathering dust in the back of the office. They contain harmful materials like lead, so they must go to an e-waste facility to ensure safe and legal disposal. Once you've cleared out the old junk, it's time to turn your attention to the environment in which your current IT equipment resides. Monitoring and controlling environmental factors, such as temperature, humidity, and ventilation, can have a direct impact on hardware longevity. Heat is the enemy of electronics, so keeping your devices cool is essential. In high-demand areas like data centers, proper cooling systems can prevent thermal stress that damages components. Humidity is another environmental factor that can impact IT equipment. Too much humidity, and you risk condensation and corrosion. Too little, and static electricity can wreak havoc on sensitive circuitry. Therefore, maintaining a balance is necessary to preserve the health of your gear. Moving on from temperature and humidity, ventilation is equally as important. Cramming devices together or blocking airflow is a surefire way to shorten the lifespan of IT equipment. Make sure your equipment has room to breathe. Alongside proper ventilation is dust, the silent killer. Dust particles might seem trivial, but they clog fans and vents, leading to overheating. A quick blast of compressed air, or a gentle sweep with a vacuum, designed specifically for use with electronics, can do wonders for your setup. When you properly control environmental factors, such as temperature, humidity, and ventilation, your hardware will thank you, with smoother performance and fewer breakdowns. Next, let's talk about power problems. At this point in our learning journey, we can group power problems into three simple categories: low voltage, high voltage, and no voltage. Low voltage or under voltage events, where the power supply dips below normal levels, can cause devices to underperform, shut down unexpectedly, or even suffer long-term damage. These disruptions come in two forms: sags, which are brief dips, and brownouts, which last longer. The solution? A battery backup, or uninterruptible power supply. This handy device steps in to provide stable power during these dips, keeping your equipment running and your data safe. High voltage or over voltage events, on the other hand, involve too much power flowing through the system. Spikes are sudden bursts, while surges are prolonged and more destructive. Both can fry circuits in an instant. That's why a surge suppressor is a must-have for every setup. It absorbs excess energy and shields your equipment from harm. Finally, we have no voltage events, where power cuts out entirely. A fault might cause a momentary disruption, but a blackout can last much longer and lead to hardware damage or data loss. An uninterruptible power supply is critical here, as it can provide enough power to keep your systems running for a brief period of time. If the blackout occurs for an extended period of time, you may find that your uninterruptible power supply is not enough. At this point, you might need to consider a generator to maintain operations long term. Exam Objective 4.6 explain the importance of prohibited content, activity, privacy, licensing, and policy concepts. Incident Response. Incident response is the structured approach used to manage the aftermath of a security breach, cyber attack, or other IT-related incident. A well-developed incident response process helps organizations contain the damage, preserve important evidence, restore operations more quickly, and reduce the chances of the same issue happening again. It also ensures that the right people are notified, proper procedures are followed, and critical evidence is protected throughout the investigation. And since this is an A+ course, I will keep this topic focused on the core concepts you are most likely to encounter on the exam. One of the most important principles in incident response is maintaining the chain of custody. The chain of custody is the documented record of how evidence is collected, handled, transferred, analyzed, and stored throughout an investigation. In other words, it tracks exactly who had possession of the evidence, when they had it, and what they did with it. This process helps ensure the evidence remains trustworthy and legally admissible. For example, if a compromised hard drive is collected during an investigation, every person who handles that drive should be documented along with the date, time, and purpose of access. If the chain of custody is broken or poorly documented, investigators may no longer be able to prove the evidence was not altered, which can create major problems during legal proceedings or forensic investigations. Once evidence handling procedures are established, the next step is determining who needs to be informed about the incident. Some incidents may only require internal escalation to management or the IT security team. However, more serious situations, such as ransomware attacks, theft of sensitive information, financial fraud, or attacks involving regulated data, may require notifying law enforcement, regulatory agencies, or external cybersecurity specialists. Organizations must also follow any legal or compliance-related notification requirements that apply to the situation. In many cases, quickly informing the proper individuals can significantly improve the overall response effort and help limit the impact of the incident. As the investigation begins, preserving the integrity of the original data becomes extremely important. Rather than directly analyzing the original system or storage drive, investigators will often create an exact copy of the drive, commonly called a disk image. This allows investigators to perform testing, malware analysis, and forensic examination on the copied version while leaving the original evidence untouched. Think of it like making a photocopy of an important document before marking it up with notes and highlights. If investigators accidentally modify the original evidence during analysis, it could compromise the investigation. Working from a copy helps preserve data integrity while still allowing detailed examination of the compromised system. When collecting evidence, investigators must also understand the order of volatility. The order of volatility refers to the sequence in which evidence should be collected based on how quickly the data may disappear. Some forms of evidence are extremely temporary and can vanish the moment a device powers off or reboots. For example, data stored in the CPU cache is among the most volatile because it changes constantly while the system operates. Running processes and information stored in RAM are also highly volatile and should typically be collected early in the investigation process. Less volatile evidence, such as files stored on a hard drive, remains available even after shutdown and can usually be collected later. Understanding the order of volatility helps investigators prioritize evidence collection properly and avoid losing valuable forensic information. After all, you cannot collect evidence that no longer exists. Finally, thorough incident documentation ties the entire response process together. Every action taken during the incident should be carefully recorded, including timestamps, personnel involved, systems affected, evidence collected, tools used, and the actions performed throughout the investigation and recovery process. Good documentation creates a clear timeline of events, improves accountability, supports legal or regulatory requirements, and helps organizations learn from the incident afterward. It also provides valuable reference material if similar incidents occur in the future. In many ways, incident documentation becomes the story of the investigation, showing exactly what happened, how the issue was handled, and what steps were taken to resolve it. Exam Objective 4.6 explain the importance of prohibited content, activity, privacy, licensing, and policy concepts. Software licensing. Before we dive into the different types of software licenses, let's first understand what software licensing actually is. A software license is a legal agreement that defines how software can be used, installed, shared, or distributed. Think of it as the rulebook for using software. It outlines what users are allowed to do, what restrictions apply, and how the software creator protects their intellectual property. These licenses can cover everything from how many devices the software can be installed on, to whether it can be used in a business environment, modified, redistributed, or shared with others. Violating a software license agreement can lead to consequences ranging from disabled features and revoked access to financial penalties or legal action. In short, software licensing helps ensure software is used legally, securely, and according to the developer's intended terms. Let's begin with one of the most widely discussed licensing models, open-source software. With open-source software, the source code is publicly available, allowing users to view it, modify it, and often redistribute their changes. Think of it like a community recipe book where everyone can see the ingredients, improve the recipe, and share their own version with others. This collaborative approach encourages transparency, flexibility, and innovation. Linux distributions are one of the most well-known examples of open-source software in action. On the other side, we have proprietary software, sometimes called closed-source software. With proprietary software, the source code is hidden from the public, and users must purchase or obtain a license to use it legally. Imagine visiting a famous restaurant where the chef guards the recipe like a state secret. You can enjoy the finished product, but you do not get access to how it was made. Proprietary software often includes polished user experiences, centralized support, regular updates, and tighter control over how the software is distributed and used. Windows and Mac OS are both examples of proprietary operating systems. Whether software is open source or proprietary, organizations must ensure they are using valid licenses. A valid license means the software is properly activated, legitimately purchased or obtained, and being used according to the terms of the licensing agreement. Using pirated software, reusing expired licenses, or installing software on more systems than allowed, can violate licensing agreements and create both legal and security risks. Beyond the legal concerns, unlicensed or pirated software is also far more likely to contain malware, backdoors, or tampered code. Saving a few dollars is usually not worth accidentally installing ransomware as a bonus feature. One licensing model you may encounter is the perpetual license agreement. A perpetual license allows the customer to use the software indefinitely, after purchasing it one time. In other words, you buy it once and continue using that version for as long as you want. This type of licensing model commonly involves an upfront payment, and the software is often installed locally on a workstation or server rather than accessed through the cloud. However, while the software itself may never expire, ongoing support, maintenance, feature updates, or newer versions may still require additional maintenance agreements or upgrade purchases. This differs from subscription-based licensing models, which typically involve recurring monthly or yearly fees. Subscription software is often cloud-based, with maintenance and updates included as part of the subscription plan. The major difference is that if the subscription ends, access to the software usually ends as well. With a perpetual license, even if support expires, you generally retain access to the version you originally purchased. Another important licensing distinction involves personal use licenses versus corporate use licenses. A personal use license is designed for individual, non-commercial use. For example, someone may use software at home for personal projects, gaming, or learning new skills. However, using software licensed for personal use inside a business environment may violate the terms of the agreement. A corporate use license, on the other hand, is designed specifically for organizations and professional environments. These licenses often include features such as centralized management, enterprise support, multi-user access, or volume licensing options that allow installation across many systems within the company. Using the proper license type helps organizations remain compliant while ensuring employees have the tools they need to work effectively. Now let's talk about the EULA, or End User License Agreement. The EULA is a legally binding contract between the software creator or publisher and the end user of a software application. This agreement outlines the rules, restrictions, and permissions associated with the software. If you have ever installed software and clicked an I agree button without reading 20 pages of legal text, congratulations, you have accepted a EULA. These agreements often include restrictions on redistribution, copying, reverse engineering, commercial usage, or the number of permitted installations. For example, installing a consumer edition of software intended only for home use onto multiple corporate systems could violate the EULA. Even though most users scroll straight to the bottom faster than they scroll social media, the agreement is still legally enforceable. If the EULA establishes the rules, Digital Rights Management, or DRM, acts as the enforcer. DRM refers to a collection of copyright protection technologies designed to prevent unauthorized use or duplication of digital media. DRM is commonly used with software, movies, music, video games, and streaming services. One example of DRM is HDCP, which stands for High Bandwidth Digital Content Protection. HDCP helps prevent unauthorized copying of protected video and audio content as it travels across HDMI connections. If you connect a device to a display that does not support HDCP, the protected content may refuse to play entirely. In the IT world, DRM plays an important role in helping organizations and content creators protect copyrighted material, enforce licensing agreements, and reduce unauthorized distribution. While DRM can sometimes feel inconvenient to users, it exists to ensure software and digital content are used according to their licensing terms. At the end of the day, software licensing is all about defining how software can legally and ethically be used. Whether it is open source software encouraging collaboration, corporate licensing supporting large organizations, perpetual licenses offering long-term ownership, or DRM protecting copyrighted content, these agreements help balance innovation, protection, and compliance across the digital world. Exam Objective 4.6 explain the importance of prohibited content, activity, privacy, licensing, and policy concepts. Regulated data. Data comes in many forms, each with its own level of sensitivity and required safeguards. Public data is information that can be freely shared without risk, like a company's public website or a restaurant's menu. Private data, on the other hand, is confidential in nature, such as an organization's employee schedule or internal project plans. Finally, we have regulated data, which is subject to strict legal and industry standards due to its sensitivity and the risks associated with its exposure. For this video segment, we will focus on this third category, regulated data, and the measures required to protect it. One significant type of regulated data is credit card information, which is governed by the Payment Card Industry Data Security Standard, abbreviated as PCI DSS. But before we dive into PCI DSS, let's talk about the payment card industry itself. The payment card industry refers to a globally recognized group of organizations that create, manage, and secure credit and debit card payments. This includes banks, card issuers, payment processors, and merchants, all working together to ensure the safe handling of payment information. To protect cardholder data within this ecosystem, the Payment Card Industry Data Security Standard was established. PCI DSS is a set of guidelines designed to secure credit card information during processing, storage, and transmission. These guidelines require measures such as encryption, robust access controls, and antivirus software to prevent unauthorized access or theft. Imagine a retail scenario where customers swipe their credit cards. Behind the scenes, their payment information travels through an encrypted system to ensure its security. This may sound simple, but the IT team plays a critical role in configuring and maintaining these systems to meet PCI DSS requirements. Failing to comply with PCI DSS can lead to fines, legal repercussions, and a loss of customer trust, making adherence essential for any organization handling credit card transactions. Next, let's consider personal, government-issued information, a category that includes highly sensitive identifiers like social security numbers, driver's license numbers, and passport IDs. This type of data is vital for identity verification but is also highly sought after by malicious actors for identity theft and fraud. To protect this data, organizations must implement secure encryption and strict access controls to stored data. For example, a banking institution that stores personal, government-issued information related to their customers' accounts must ensure only authorized personnel can access these details, and that every access attempt is logged and monitored for security and auditing purposes. Now, let's explore personally identifiable information, or PII. This refers to any information that can be used to uniquely identify an individual. Examples of PII include names, addresses, phone numbers, email addresses, or dates of birth. Additionally, the forms of personal, government-issued information we just discussed would also be included in this category. PII is often subject to legal protections and requires careful handling to prevent unauthorized access or disclosure. The mishandling of PII can lead to identity theft, fraud, and regulatory penalties. For instance, an online retailer must encrypt a customer's personally identifiable information when stored in its database and during transmission to protect against breaches. IT teams must also ensure only essential personnel have access to this type of data. Another important type of regulated data is protected health information, or PHI. PHI includes any information about an individual's health status, medical history, treatments, or healthcare services that can be linked to them. Examples of PHI might include medical diagnoses, lab results, and insurance claims. PHI is especially sensitive because it pertains to an individual's personal health. For example, a healthcare provider storing patient records electronically must ensure the data is encrypted, securely stored, and accessible only to authorized personnel. In the United States, PHI falls under the jurisdiction of the Health Insurance Portability and Accountability Act, or HIPAA for short. HIPAA is a U.S. federal law that sets strict guidelines for how healthcare organizations and their IT systems must handle PHI. It requires encryption, secure access controls, and detailed audit trails to ensure compliance. HIPAA violations can have serious consequences, including substantial fines and legal action. For instance, if an employee inadvertently emails unencrypted patient information, it could constitute a breach, exposing the organization to penalties. Therefore, IT professionals must implement systems and training to ensure compliance and protect PHI. Finally, we have data retention requirements, which specify how long specific types of data must be stored, and when it should be securely deleted, to comply with legal and regulatory standards. These requirements vary significantly across industries and jurisdictions, reflecting the diverse needs for record-keeping and data security. For instance, financial institutions are often required to retain transaction logs and customer records for auditing and regulatory review, sometimes for several years. Similarly, healthcare providers must maintain patient records for a mandated period, ensuring continuity of care and compliance with laws like HIPAA. Adhering to proper retention policies is more than just a compliance exercise, it's a critical part of risk management. Retaining data for too long can increase storage costs and create vulnerabilities to data breaches. Conversely, deleting data too early could result in non-compliance penalties or lost evidence in legal disputes. Automated systems can help organizations enforce these policies by securely archiving data for the required period, and then permanently deleting it when no longer needed. By striking the right balance, organizations can minimize risks, optimize resources, and maintain trust with important stakeholders. Exam Objective 4.6 explain the importance of prohibited content, activity, privacy, licensing, and policy concepts. Policy concepts. In the world of IT, technology alone does not keep organizations secure and compliant. Rules, policies, and legal agreements play a major role as well. These policies help define how systems should be used, how sensitive information should be protected, and what responsibilities users have when accessing company resources. From protecting confidential business data to ensuring employees use systems appropriately, these concepts help organizations operate securely, legally, and efficiently. Let's take a look at some of the most common policy concepts you are likely to encounter in IT environments. We'll start with the Non-Disclosure Agreement, often abbreviated as NDA. An NDA is a legal agreement designed to protect confidential information from being shared with unauthorized individuals. In simple terms, it is a promise to keep sensitive information private. Companies often require employees, contractors, or business partners to sign an NDA before gaining access to proprietary data, customer information, financial records, source code, or internal business plans. For example, imagine being hired by a company developing a brand new product that has not yet been announced publicly. The NDA helps ensure employees do not leak information about the product online or share it with competitors. Violating an NDA can lead to serious consequences, including legal action, fines, or termination of employment. Now, in many business relationships, confidential information does not just flow in one direction. Sometimes both parties need to exchange sensitive information while working together. This is where the Mutual Non-Disclosure Agreement, or MNDA, comes into play. While a standard NDA usually protects information shared by one party, an MNDA protects confidential information shared between both parties. This type of agreement is common when two organizations collaborate on a project, partnership, or business negotiation. For example, imagine two technology companies working together on a software integration project. Both organizations may need to exchange proprietary code, internal documentation, or business plans. An MNDA ensures that both sides are equally responsible for protecting the confidential information being shared. In other words, everyone agrees to keep each other's secrets safe. Of course, protecting sensitive information is only part of maintaining a secure workplace. Organizations also need clear rules defining how employees are expected to use company technology resources. This brings us to the Acceptable Use Policy, commonly called an AUP. An AUP is a set of rules that define how an organization's computer network, website, or other technology resources can be used. This policy explains what users are allowed to do and, just as importantly, what they are not allowed to do. For example, an AUP may prohibit installing unauthorized software, visiting malicious websites, sharing passwords, mining cryptocurrency on company systems, or using company devices for illegal activities. Some organizations may also include rules regarding social media usage, generative AI tools, or handling sensitive customer information. Before receiving access to company resources, employees are often required to read and acknowledge the AUP to confirm they understand the organization's expectations. Beyond internal company policies, organizations must also comply with various legal, regulatory, and industry requirements designed to protect sensitive information and maintain security standards. These regulatory and business compliance requirements vary depending on the industry. For example, healthcare organizations may need to comply with HIPAA regulations to protect patient information, while businesses handling credit card transactions may need to follow PCI DSS requirements. Compliance requirements help ensure organizations handle data responsibly and follow established security practices. One common compliance-related feature users encounter is a splash screen. A splash screen is a notification or warning message displayed before accessing a system, application, or network. These messages often remind users that the system is for authorized use only, that activity may be monitored, or that unauthorized access is prohibited. While many users quickly click past these messages without reading them, splash screens serve an important legal and compliance purpose by informing users of monitoring policies and acceptable use expectations before access is granted. Exam Objective 4.7 Given a scenario, use proper communication techniques and professionalism. Communication and professionalism aren't just soft skills, they're the backbone of successful interactions in IT support. Whether you're troubleshooting a device or guiding a customer through a tricky issue, how you communicate can shape their entire experience. Let's explore the key elements of professional behavior and effective communication. Professionalism starts with how you present yourself. Whether your workplace calls for formal attire or business casual, your appearance should align with the environment. Dressing appropriately not only shows respect but also boosts your credibility, right from the start. Equally important is the language you use. Keep your communication clear and simple. Avoid technical jargon, acronyms, or slang that might confuse the customer. Tailoring your language to your audience ensures they feel included in the process, not left behind. A positive attitude can make all the difference during a support call or meeting. Even if the issue is complex or the customer is frustrated, remaining optimistic and confident reassures them that you're capable of resolving the problem. It's not just about what you say, but also how you say it. Listening actively is another cornerstone of great communication. Let the customer explain their concerns fully before jumping in with solutions. Taking notes, making eye contact, and waiting for them to finish speaking shows that you value their input and are genuinely interested in helping. Cultural sensitivity also plays a role in professionalism. Using appropriate professional titles and showing respect for cultural differences fosters trust and ensures smoother interactions. A little awareness goes a long way in making customers feel comfortable. Punctuality is a simple yet powerful way to show respect for your customer's time. Arriving on time or starting a scheduled session as planned sets the tone for a professional interaction. If something unexpected comes up and you're running late, let the customer know as soon as possible with a quick message or call. This proactive approach not only helps manage their expectations but also demonstrates reliability and courtesy, turning a potential inconvenience into a display of your professionalism. While engaging with customers, distractions must be minimized. Phones should be silenced, and personal calls or social media should be avoided during work hours. Of course, emergencies are an exception, but even then, it's essential to communicate your priorities clearly. When handling difficult customers or situations, professionalism means staying calm and composed. Avoid arguing or becoming defensive. Instead, apologize or show empathy, and if the issue escalates beyond your scope, involve a manager. It also helps to clarify customer statements by asking open-ended questions and restating their concerns to ensure mutual understanding. And remember, what happens in a customer interaction stays there. Never disclose details of your interactions on social media or elsewhere. Setting clear expectations is another way to build trust. Communicate timelines, provide updates, and document the services you've delivered. If an issue requires a repair or replacement, be sure to offer the appropriate options to the customer. And once the issue is resolved, adding a follow-up to confirm customer satisfaction can provide a personal touch that's often appreciated. Finally, always respect the confidentiality of customer data. When servicing a device, you may encounter private information such as personal photos, financial records, sensitive emails, or even passwords saved in the browser. It's essential to handle this data as if it were your own, carefully, respectfully, and without intrusion. Exam Objective 4.8 Explain the basics of scripting. The idea of scripting might sound complex, but at its core, it's all about creating scripts, which are small, efficient programs that automate tasks or control other software. A scripting language is a lightweight programming language designed specifically for this purpose, enabling you to craft instructions that your computer can execute step by step. Think of it as teaching your computer to handle those repetitive chores you'd rather not do manually, freeing you up for more important tasks. Now, why bother with scripting? The answer is simple: automation. Imagine having the ability to restart machines across a network without touching a single power button, or remapping network drives with just a few lines of code. Need to install applications on dozens of devices? A script can do that, ensuring consistency and saving time. Automated backups, gathering critical system data, and deploying updates are all common scenarios where scripting becomes your best friend. It's like having a personal assistant who never gets tired, never forgets, and always works with precision. Of course, scripts come in many shapes and sizes, tailored to different operating systems and environments. Windows users will recognize .bat files, perfect for simple command line tasks, or .ps1 files, a PowerShell favorite for managing configurations and gathering data. If you've worked with older systems, you might have encountered .vbs files, though their popularity has decreased over time. On the Linux and Mac OS side, .sh files are the heroes of automation, handling everything from permissions to updates. As for web-based tasks, there's .js, the file extension for JavaScript. And for those who love versatility, .py files bring Python into the mix, capable of everything from automation to data analysis. As you can see, each file type has its own strengths, making scripting language truly adaptable. While scripting is an incredibly powerful tool that can simplify tasks and boost efficiency, it must be used with caution. Running a script, especially one from an unverified source, can unintentionally introduce malware, which may compromise your system by executing harmful actions. Even scripts created with good intentions can cause problems if they are poorly written. For example, a script that isn't properly tested might inadvertently change system configurations, overuse resources like memory or CPU, or even lead to crashes that disrupt operations. Exam Objective 4.9, given a scenario, use remote access technologies. As we continue exploring operational procedures, we now turn our attention to remote access technologies. These tools allow IT professionals to remotely connect to systems, troubleshoot issues, manage devices, and support users without needing to physically sit in front of the machine. Whether supporting a remote employee, managing a server across the country, or helping a user fix an issue from another office, remote access technologies play a major role in modern IT environments. One of the most common remote access tools is Secure Shell, often abbreviated as SSH. SSH creates a secure, encrypted command line connection between devices and is especially popular in Linux, Mac OS, Windows, and network administration environments. Rather than interacting with a graphical desktop, SSH allows administrators to type commands directly into a remote system as if they were sitting at the keyboard. IT professionals commonly use SSH to manage servers, configure network devices, securely transfer files, and troubleshoot systems remotely. Because SSH encrypts traffic, it helps protect against eavesdropping, credential theft, and other network-based attacks. If command line interfaces are not your thing, Remote Desktop Protocol, commonly known as RDP, provides a more visual experience. RDP is a Windows-native remote access protocol that allows users to remotely access and control another computer through a full graphical user interface. In many ways, it feels like sitting directly in front of the remote machine. This makes RDP extremely useful for remote administration, software installation, troubleshooting, and helping end users with desktop-related issues. One important thing to remember is that a standard RDP session typically allows only one user to be actively logged in at a time. If a remote user connects through RDP, the person physically sitting at the machine may be logged out or disconnected from the session. While RDP is highly convenient, it also introduces security concerns if improperly exposed to the internet. For that reason, organizations often combine RDP with additional protections such as VPNs, multi-factor authentication, firewalls, or restricted access policies. Another remote desktop technology you may encounter is VNC, which stands for Virtual Network Computing, though the exam objectives may also reference it as Virtual Network Computer. Similar to RDP, VNC allows users to remotely view and control another computer through a graphical user interface. One major advantage of VNC is its cross-platform compatibility, as it works across Windows, Mac OS, and Linux systems. This makes it especially useful in mixed operating system environments. However, unlike SSH, encryption is not always enabled by default with VNC solutions, meaning administrators must carefully configure security settings or pair VNC with secure tunneling methods such as a VPN. Speaking of VPNs, or virtual private networks, these are another major remote access technology covered on the exam. Rather than directly controlling a remote device, a VPN creates a secure, encrypted tunnel between your device and a remote network. This allows users to safely access company resources over the internet as if they were physically connected to the local office network. VPNs are especially important when employees work remotely or connect through public Wi-Fi networks. Without encryption, sensitive company data could potentially be intercepted by attackers. VPNs are often paired with other remote access tools like SSH, RDP, or VNC to add another layer of protection during remote sessions. Moving beyond traditional remote desktop connections, we also have Windows Remote Management, commonly abbreviated as WinRM. WinRM is Microsoft's implementation of a remote management protocol that allows administrators to remotely execute commands and manage Windows systems across a network. Unlike RDP, which provides a full graphical desktop session, WinRM focuses more on remote administration and automation through scripts and command line tools such as PowerShell. This allows administrators to remotely configure systems, manage services, gather information, and automate large-scale administrative tasks without needing to manually open remote desktop sessions on every device. Another remote management technology is SPICE, which stands for Simple Protocol for Independent Computing Environments. SPICE is commonly used in virtualized environments to provide remote access to virtual machines. It allows users to interact with virtual desktops remotely while supporting features like audio, USB device redirection, and high-performance graphics. In many ways, SPICE functions similarly to remote desktop technologies like RDP or VNC, but it is specifically designed to work efficiently with virtual machine environments and virtualization platforms. As organizations continue managing larger numbers of devices, remote monitoring and management tools, commonly abbreviated as RMM, have become increasingly important. RMM platforms allow IT teams to remotely monitor system health, deploy updates, automate maintenance tasks, manage configurations, and receive alerts when problems occur. For example, an RMM platform may automatically notify administrators when a workstation is running low on storage space or when antivirus definitions have failed to update. Many RMM solutions can even remotely install patches, restart services, or run scripts without direct user interaction. These tools allow IT departments to proactively manage systems before users even realize there is a problem. Beyond dedicated administration tools, many organizations also rely on third-party remote access solutions designed for collaboration and support. Screen sharing software allows technicians or coworkers to view another user's screen in real time for troubleshooting or training purposes. Video conferencing software combines screen sharing with voice and video communication to support remote meetings and collaboration. File transfer software enables users to securely exchange files between local and remote systems, while desktop management software provides centralized control over large groups of endpoints within an organization. Of course, regardless of which remote access technology is being used, security should always remain a top priority. Remote access tools create pathways into systems and networks, which means attackers often target them. Weak passwords, exposed remote desktop ports, outdated software, and unencrypted connections can all create serious vulnerabilities. Organizations help reduce these risks by using strong passwords, multi-factor authentication, VPNs, encryption, firewalls, restricted permissions, account lockout policies, and regular software updates. After all, a remote access solution is only helpful if it allows the right people in, while keeping the wrong people out. Exam Objective 4.10 Explain basic concepts related to artificial intelligence. As we wrap up our training course, we arrive at one of the newest topics added to the CompTIA A Plus Core 2 exam objectives: artificial intelligence, commonly abbreviated as AI. AI has rapidly become part of everyday technology, showing up in search engines, chatbots, writing assistants, image generators, customer service systems, security tools, and countless business applications. While AI can dramatically improve productivity and automation, it also introduces important concerns surrounding accuracy, privacy, security, and appropriate use. So, let's finish strong by exploring some of the basic AI concepts every modern IT professional should understand. Let's begin with application integration. AI is increasingly being integrated directly into existing applications and services. Rather than existing as a completely separate tool, AI is often embedded into software users already interact with every day. For example, email applications may use AI to help draft messages, office software may summarize documents or generate presentations, and customer support platforms may use AI chatbots to answer common questions automatically. In cybersecurity, AI may help identify suspicious network activity or detect malware patterns faster than traditional methods alone. Search engines use AI to improve search results, while video conferencing platforms may use AI for live captions, background noise reduction, or meeting summaries. In many cases, users may not even realize AI is operating behind the scenes. It has quietly become part of the tools and workflows organizations already depend on. Of course, just because AI can do something does not always mean it should. This is where AI-related policies become important. Organizations often establish policies that define the appropriate use of AI systems in the workplace. These policies help employees understand what types of information can safely be entered into AI tools, how AI-generated content may be used, and where human oversight is still required. One major concern involves plagiarism. AI systems can generate text, images, code, or other content very quickly, but presenting AI-generated work as entirely original human work may violate company policies, academic integrity rules, or copyright guidelines. For example, copying AI-generated content directly into a school assignment, report, or professional document without review or attribution could create ethical or legal concerns. AI can certainly assist with productivity, but users are still responsible for reviewing, validating, and properly using the output it generates. This brings us to some of the major limitations of AI systems. Despite how impressive AI can appear, it is far from perfect. One limitation is bias. AI systems learn from training data, and if the training data contains bias, the AI may unintentionally produce biased or unfair results. For example, an AI hiring system trained on flawed historical data could potentially favor certain groups unfairly while disadvantaging others. In many ways, AI can inherit the strengths and weaknesses of the data it learns from. Another important limitation is hallucinations. In the context of AI, a hallucination occurs when the AI generates false, misleading, or completely fabricated information while presenting it confidently as if it were accurate. For example, an AI system might invent facts, create fake citations, misstate technical information, or provide instructions that sound convincing but are completely incorrect. This is why blindly trusting AI output without verification can be dangerous, especially in technical, medical, legal, or security-related situations. Just because the AI sounds confident does not mean it is correct. Even AI has moments where it confidently explains something that belongs in a science fiction movie instead of reality. Closely related to hallucinations is the issue of accuracy. AI-generated responses are only as reliable as the data, training, and context available to the system. AI can sometimes provide outdated information, misunderstand questions, or oversimplify complex topics. Because of this, AI should often be treated as an assistant rather than a replacement for human judgment. IT professionals should verify important information, cross-check critical recommendations, and avoid assuming AI-generated output is automatically trustworthy. Finally, let's talk about private versus public AI systems, which introduces important concerns surrounding data security, data sources, and data privacy. As the diagram behind me illustrates, public AI and private AI differ significantly in how they handle information and where that information comes from. Public AI systems are generally accessible over the internet and often rely on massive, uncontrolled data sources gathered from across the web. These systems typically operate using shared cloud-based infrastructure and may process prompts and interactions across large public datasets. While public AI tools are incredibly convenient and powerful, users must be very careful about what information they submit. Sensitive company information, customer data, passwords, financial records, proprietary code, or confidential documents should generally never be entered into public AI systems unless explicitly approved by organizational policy. Once sensitive data leaves your organization and enters a public AI platform, you may lose visibility and control over how that data is stored, processed, or used. Private AI systems, on the other hand, are typically built specifically for an organization and operate with far stricter controls surrounding security, customization, and compliance. Rather than relying heavily on uncontrolled public data sources, private AI systems may be trained using internal company knowledge, workforce experiences, documentation, and approved organizational data sources. This allows organizations to maintain greater control over how information is stored, processed, and protected while also tailoring the AI system to their own operational needs. Private AI environments are often designed with stronger data security measures, stricter access controls, and compliance requirements in mind. Organizations may choose private AI solutions specifically to reduce privacy risks, protect intellectual property, and comply with regulatory requirements surrounding sensitive information. Data sources themselves also play a critical role in AI reliability and trustworthiness. AI systems learn from enormous datasets, and the quality of those datasets directly impacts the accuracy, bias, and reliability of the results generated. Understanding where AI training data originates helps organizations evaluate whether the system may contain biased information, unreliable content, or legal and privacy concerns. After all, if questionable information goes into the AI system, questionable information is probably coming right back out. And with that, you have officially reached the end of this CompTIA A Plus Core 2 training course. From operating systems and security concepts to troubleshooting, operational procedures, and now artificial intelligence, you have covered an enormous amount of material. At this point, the majority of the learning is behind you. Now it becomes about review, practice, repetition, and building confidence for exam day. Keep pushing forward, stay consistent with your studies, and remember, every IT professional started exactly where you are now, learning one concept at a time. Congratulations on completing our CompTIA A Plus, Core 2, complete training course. The commitment and drive you have demonstrated to arrive at this milestone is truly commendable. Whether you started with no prior IT knowledge or you had some previous experience to draw upon, you've journeyed a great distance. Now you stand at the threshold of your next big step towards obtaining your CompTIA A Plus certification. But before you go ahead and book your test, we have a new challenge lined up for you. We've assembled an exclusive practice exam on our channel, packed with 200+ questions meticulously designed to test your knowledge and simulate the format and difficulty of the actual exam. It's essential to remember that repetition is the key to mastery. The more you practice, the more confident you'll feel. Also, as you navigate through our practice exam, be sure to make notes of areas you're unsure about, and feel free to revisit any part of our training course as needed. So are you prepared for our practice exam? Great! Then click on the link to my left to get started. This CompTIA A Plus, Core 2, practice exam will challenge you, gauge your readiness, and move you one step closer to your certification goal. We wish you all the best, and here's to you, passing that exam.